Hi everyone and welcome back to PrepFusion. So today again we will start another portion of R-PYQ series. So today we will cover the differential calculus portion. So in differential calculus we have functions, limits, continuity, differentiability, maxima minima, mean value theorem, Taylor series and partial differentiation. So all these topics we will cover in a single video. This will be a 11-hour video, okay, almost 11 and a half hours video. Now there is an important thing that I wanted to say. This is not like the previous videos where if you had no prior knowledge you can totally watch it. So I will be totally honest with you guys. You need to have bit of prior knowledge to watch this video. First of all, there is a video wavy curve method, okay, that is from me itself, okay. It will be in the playlist, okay. Just above this video, if you go into the R-PYQ series playlist, just above this video will be there. So make sure you watch this video because I will be using the concepts of wavy curve method in my this lecture. Now one more thing is you need to have bit of basic knowledge about derivative. So what is the derivative of sin x, what is the derivative of tan x, so all these things you should know. You should have bit of basic knowledge about limits, but I will obviously explain what is the physical significance of limit. I will explain everything from basics, but I will not tell you that what is the derivative of like cos x or what is the derivative of tan x, okay. So these basic knowledge you should have. So bit of prerequisites are there. So not like too much, but these basic things you should know, then only you will be able to understand, because I will not, like, this is a revision video, right? You don't expect me to explain you the differentiation of tan x. Like, I hope you don't expect me to do that, right? So those are for full course videos. So yeah, I will not explain that. So those things will be covered here, and bit of basic idea you should have about the derivatives and wavy curve method. I hope you will be watching. Other than that, I will be covering everything, every single topic from basics, and we will understand graphically. So I will show you maximum minima. I will not tell you to remember stuff. Of course, there will be formulas, like there will be conditions, mathematical equations, but I will show you graphically how can you understand maximum minima, graphically how can you understand limits, graphically how can you understand continuity, differentiability. So I will try to show you graphically, because our human brain is trained to remember images in a better manner than text, right? So I will tell you graphically how can you do all these things, okay. Mean value theorem also I will show you graphically how is mean value theorem done, like how are they proving the mean value theorem, okay. So yeah, let's start with the first topic, that is functions. Let's start with the R-PYQ for functions, limits, continuity and differentiability. So before starting functions, let us first of all understand what are variables, because we have used variables in linear algebra. I told you that variables are nothing but terms which vary. Constants are the terms which remain constant, they do not vary. So variable will have certain range, like from negative infinity to positive infinity. My x value can take any value, right? Y also can take any value. So there are like the variable is an entity whose value is not fixed. Basically it varies, right? Now there are three kinds of variables: real variables, vector variables and complex variables. So we will study calculus on these three kinds of variables. So in the first two part, right, of calculus, we will discuss about the real variables. We will do calculus on real variables. Then in vector calculus, right, we will do calculus on vector variables, and in complex variable analysis we will do calculus on complex variables, okay. So that's why three chapters are there, and all of these chapters are important, but we will go one by one. First we will study this one, real, vector and then complex. So I hope I don't need to explain what does vector means, what does complex means. I hope those things you already know, so I am not explaining it. Now let's come to functions. A function is defined as a relation between a set of inputs having one output each. So it is a many to one relation, right, where each input is exactly one output. So basically what do I mean? So for a particular input I will get exactly one output. I cannot get multiple output. Like for A I cannot get D and F both. No, that is not possible. For the property of a function is, if I'm giving some input I should get a proper output. So don't worry, we will take few examples, we will understand. Basically there needs to be many to one mapping or one to one mapping. One to one mapping meaning many to one, meaning many inputs can go to same output. That is possible, no problem. But it cannot be one to many. What does one to many mapping mean? These can be asked in MSQ, right? What does one to many mapping means? One to many means for this single input A, the output can go D as well, output can go F as well. But that will be not a function. That is something else. Okay. So a few basic functions I can show you. Like y equals to x. So for every value of x, right, I am getting a y value, correct? For x equals to 1, y will be 1. For x equals to 1, can I get any other value than y equals to 1? There is no possibility. So yeah, this is a proper function. This is a proper function. So I will show you a few graphs there as well. We will see which one is a proper function, which one is not a proper function. Okay, so we will see those examples as well. Now in functions, right, there are, so basically the general representation of a function is y is equals to f of x. Basically it represents that y is a function, f function of x, and it has many to one or one to one mapping. I hope you have understood what does many to one and one to one mapping means. Okay, so calculus again of real variables has two parts: differential calculus, integral calculus. So first of all, in this whole R-PYQ video, we will totally cover the differential calculus. All these topics we will cover, and in the next video we will cover the integral calculus. That is also a very important and very big topic, and questions do get asked from this. Like this one is a bit lengthier, but this is easy. Okay, topic is, this is simple to understand, but this one is bit typical to understand, but it is not that lengthy, but bit difficult. But don't worry, the way I will teach you, you will understand everything. Simple, difficult, you will be able to score full marks. So then there is open interval and closed interval. What do I mean by open interval and closed interval? So open interval are used to represent range. Okay, so open interval means if they are represented by round braces, and closed interval means if they are represented by square braces. Now you will ask me, sir, what does open and close means? Open, like this sign also means belongs, like x belongs to a comma b. What does it mean? It means x lies between a and b. So if I take this example, right, 1 comma 2, so the value of x, right, I am defining the value of x between 1 to 2. So minimum value of x will be 1, maximum value of x will be 2. Is that correct statement? No. So basically value of x will be between 1 to 2, but x can never be equals to 1 or x can never be equals to 2. So x will be, the inequality will be x will lie between 1 to 2 to represent this inequality, right? So we have this notation. But x value can never be equals to 1, it can never be equals to 2. Basically it lies between 1 to 2 but not equals to 1 and 2. So when is it equals to 1 and 2? When we use close brackets. So here, right, I'm using a close bracket. If I'm using a close bracket, that basically means, let's say I'm using a close bracket here. As soon as I will use a close bracket, that means x belongs between 1 and 2, and x can be equals to 2 as well. Close means it is closing that particular point. That's why it is known as close. And open means it is not closing that particular point. We are not into that point. Okay. So that is what it means. So here you see that equal to sign comes if I am doing a close interval. So I hope that is clear. So x lies between a and b, including b but excluding a. Closed means I will include b. Here also x lies between a and b, excluding the points a and b. Okay, so here I am just excluding a. So whenever there will be open brackets, I will exclude that particular point. This is a way just to represent range. That's it. Now let's discuss about domain of a function. All these are important actually. I'm expecting, like, till this date they have not asked some basics like this, but basics, if your basics are strong, right, you will be able to solve the difficult questions. So domain is the set of all possible values which qualify as inputs to a function is known as domain. So this is one simple example. F of x equals to 2x. So what values I can give to x that can give me a proper output? Basically the function will not go undefined. If for any value, if the function goes undefined, then we say that like it is not in the domain. I can take example. So here few examples are there, right? X minus 3. So if x is 2, what will happen? This will be under root of minus 1. Now if I say that y will be real, if they say you that my function is all real, right? Function is all real numbers, y is real number. If we are dealing with real numbers, then can I put x equals to 2 here? No, right? If I put x equals to 2, this will be under root of minus 1, and under root of minus 1 is a complex number, iota, and that is not allowed because y is a real number, y is not a complex number. So x equals to 2 is not allowed. Similarly, x equals to any thing that goes negative here, right, that makes this x minus 3 negative, that is simply not allowed. Okay, so yeah, that is what my domain is. If my y value goes undefined or something, then those values will be not allowed. So for a polynomial, what value can I provide? I can provide any value, right? You can provide infinity, you can provide minus infinity, no problem. Of course, you will not provide imaginary values, you will provide real values. So x can be between, the domain for this first function will be x between minus infinity to plus infinity. Now how do I represent this in our interval? So for infinity, right, infinity is not a value. Infinity is not a value. Infinity is just a feeling, like it is very high value, very high value. I can never exactly touch it, right? Because I can never touch infinity, so that's why it is always represented as in open brackets, open intervals, because I can never touch my minus infinity and plus infinity. It is just a feeling, it is a very high value, I can never touch it, right? So that's why it is always represented in open brackets. For this, what is the domain of x? The domain of x will be x has to be greater than 3, that's it. X has to be greater than 3, and like I can say x has to be greater than 3, that is, or it can be equals to 3 as well, right? If x is equals to 3, this will be under root of 0, that is 0, no problem. So how can I write this? X belongs to 3 close brackets, because it is including the 3 value and it is tending towards infinity. So that's how the domain is defined here as well. Can you tell me what will be the domain of this function? So here what is happening, I can give negative values. I can give x equals to minus 1, I can give x equals to 3, but I cannot give x equal to 2. As soon as I will give x equal to 2, right, there will be problem. This will be 2 upon 0, and 2 upon 0 is actually undefined, and we will try to approximate this value in limits, obviously, that we will study later on. But here 2 upon 0 is undefined, right? 2 upon 0, like anything upon 0 is undefined. So what do I need to do? I need to simply say that x belongs to minus infinity comma plus infinity minus a single number. What is that? Y minus, because I am subtracting, right? That is not included in the range, so that's why minus 2, that's it. That's how you represent. Or sometimes they also represent it like this, that x belongs to any real number minus 2, or sometimes they also represent it like this, x belongs from minus infinity to 2 union 2 to infinity. So here all these three notations are telling the same thing only. Okay, here what does it mean? Basically x can be between minus infinity to 2 but not equals to 2, excluding 2, and here also x can be from between 2 to infinity but excluding 2, right? So we are covering all the values except 2. So this u is nothing but union. So I hope you know what is union, right? Union means include both ranges. Intersection means include only the common range between the two. Okay, now we have another thing named as range of a function. So there are few things about domain. So domain for a square root function will be the inside value of square root always should be greater than or equal to 0, as we can see from here. Domain for any polynomial, linear, quadratic, cubic, like any polynomial function, right? Okay, which has like integer power, it will be real, all real numbers. Domain of an exponential function is all real numbers, basically e raised to power minus x, e raised to power minus x, yeah, e raised to power minus x, e raised to power x. X can take any value, x can be 0 here as well. If x is equal to 0, this will be 1, right? So no problems, x can take any value. Okay, domain of logarithm function is x greater than 0. So basically you always know that log of x, right, x value cannot be negative. I cannot find the negative negative log, I cannot do that, right? X cannot be negative. So this inside of the log function always must be greater than or equals to 0. To find the domain of a rational function y, set the denominator not equal to 0. So make sure your if you have a rational function, your denominator should not be equal to 0. If it is equal to 0, then that value will not lie in the domain of my function. and of course make sure your numerator is some finite value at this particular value. Okay, this we'll come to more about this in limits. Now range. What is range? So range of a function is set of all its outputs. Basically, for what value of inputs, what is the range of my output? Like what is the maximum value that my output will give me, and what is the minimum value? So in this function, right, what is the range? So what was the minimum value of x? 3, right? I cannot go below 3. So for that, what was the y value? 0. And what is the maximum value of x? Infinity. And what is under root infinity? Infinity. Correct. So x can be equals to 0. Sorry, y can be equals to 0 and y can be infinity as well. So that will be my range basically. I hope that part is clear. Now there are a few more things like codomain, right? We don't need to study. Like codomain will be what can go into a function is called domain. What may possibly come out of the function is called codomain. Like it is some possible number that can come out of the function. What actually comes out of the function is range. So mainly we are concerned with range and domain. You can ignore the codomain for now. Okay. So y equals to fx. What does it mean? It means that x is called as independent variable. Basically, it does not depend on anything, right? X can, as I have shown you, x can take any value here, right? Domain of x can take any value, of course, without 3, because with 3 the function will go mad. But x can take any value. Does it depend on anything? No. But y here, if you see, y depends on the value of x. So as x, if x is equal to 3, y will be 0, fixed, right? If x is equal to 4, y will be 1. So y is called as a dependent variable and x is called as an independent variable. So we may assume any value for x independently within the domain of the function. Value of y is obtained by substituting the value of x in the function and hence depends on the value of x. That's why it is called as a dependent variable. Okay. Now there are few more things like graph, and from the graph we will see which of the following cannot be a graphical representation of a function. Okay, which of the following cannot be a graphical representation of a function. So here what have I told you? I have told you that for a single x value, right, I should get a single y. I should not get multiple y's for a single x value. So how do I check graphically? Simply what you do, you just take a vertical line and pass it throughout the x-axis. And if you see that my vertical line is cutting my graph more than once, that means you have, like, that will not be a valid function. So in the first option itself, I can see that I have a vertical line over here, and let's say this is x equals to -1. For x equal to -1, y is this value as well, this value as well. So this is not actually a function. This is not a function. But you will say, sir, I know it is the equation of x square plus y square equals to r square. Yes, you are correct, but this is not a function properly actually. Because if I write my y, right, y will be r square minus x square. Is this correct? No, it will be plus minus r square minus y square. So you will have two functions out of this. Y will be under root r square minus x square, and another function will be y will be minus under root r square minus x square. So individually these are functions, no problem, right? But together I cannot take them. Correct? That is the problem. So this is not a function. Here, is this a function? Yes. If I pass my vertical line throughout the graph, I see it is only cutting once. Trust me, someday they will ask very basic question like this, and 90% of the students will not be able to solve this question, because in everywhere else they will not start from these basic things. They will directly start from differentiation. Okay. So here again, if I pass my vertical line, I see that for same value of x, I am crossing the y value twice. So this is not a function. Here again, if I pass, this is a proper function, right? I am not passing my y value twice. Here, this is again in these values, right? I am getting multiple y values. For simple x value, I am getting multiple y values. So again, this is not a function. That's why this is this is the answer. All these three are the answers. Okay. Now, few standard functions which you have seen since childhood, I want to say to you again, like algebraic and transcendental. So algebraic, those kind of functions which are mostly polynomial. Transcendental are those kind of functions which are actually in series, infinite series. Okay, you can never get the, you can never write it in terms of a finite polynomial. Okay, so trigonometric function, like if you remember that we used to write our sin x equals to x minus x cube by 3 factorial plus x raised to power 5 by 5 factorial minus x raised to power 7 by 7 factorial and so on. Okay, exponential e raised to power x equals to 1 plus x divided by 1 factorial plus x square divided by 2 factorial and so on, right? It will keep on go on, it will be going on till infinity. So it is not finite, so that's why these are called transcendental. Here these are all finite. So polynomial, like this is a very good example, x square plus 3x plus 1, it is finite, algebraic. This will be rational. Rational is also some finite series. Powers function like x raised to power a, this is also something finite series. So all these are algebraic functions. Now we have two partitions of functions. One is known as even and odd functions. What are even functions? For a real valued function f of x, when the output value of f of minus x is same, then it is called even. Like, what do I mean by even function? This function, right, is symmetrical about y-axis. The functions whichever are symmetrical about y-axis are actually called as even function. The property of an even function is, if I integrate from 0 to infinity, right, then this area will be twice of minus if I integrate from minus infinity to plus infinity, that area will be twice of this area. So if you know, great. If you don't know, we will come to this when we will discuss about integration. Okay, so even function basically means that if I replace my x with minus x, right, the function will remain same. Some example, y equals to f of x equals to x square. So here if I replace my x with minus x, what will happen? So this will be minus x of whole square, and I know minus 1 whole square is simply 1, so this will be x square simply. This will not change, this will be x square. And what is the odd function? So odd function is follows the same property, but when I replace my x with minus x, right, your f of x, like, it will become negative. It will be symmetric about the origin, it will be negative. So do I have any function that is symmetric about origin? So y equals to x, I can plot. So y equals to x is a odd function. Like, if you replace x, your x with minus x, this is nothing but minus of f of x, right? So f of minus x is minus of f of x, so it is like a odd function. Okay, here same thing is written. So if you see the graph, right, if you plot the graph of a even function, it will always be symmetric about the y-axis. I have not written it, but it will be symmetric. Yeah, symmetric about the y-axis. So if you draw the graph, it will be something like this: y equals to x square, right? And if you draw the graph of y equals to x, it will be something like this. So it is symmetric about the origin. So yeah, that's about the even and odd function. There are a few properties of even and odd function. Okay, so there is only one function which is both even and odd. What is that? 0. So 0 function is both even and odd. A real valued function f of x is said to be neither even nor odd if it does not satisfy this condition. Okay, for at least one value of x in the domain of the function. So this 2 raised to power x, is this a even function? Is this a odd function? If I replace it with minus x, neither it is equals to negative of f of x or f of x. So this is 1 over f of x. So this function is neither even neither odd. It does not mean that every function has to be either even or odd. It can be neither even neither odd. Okay, now we have this explicit function. An explicit function is an algebraic function where the dependent variable can be explicitly expressed in terms of the independent variable. What do I mean by it? So let's say this function is given, and I can write my independent variable y, I can write my dependent variable y in terms of the independent variable properly. Those kind of functions are called as explicit function. What is an implicit function? So implicit function are those kind of functions which cannot be easily expressed in the form of y equal to f of x, that is my dependent variable cannot be easily be written in terms of your dependent variable, so independent variable, right? So here can you write your y in terms of x? What I can do, I can do y square equals to minus 4 minus 2xy minus x square, but still there is some y, right? So yeah, I can take this y here. If I take this y on this side, this will be, if I take y common, this will be y minus 2x plus 2x equals to minus 4 minus x square. Okay, y plus 2x minus 4 minus x square. So yeah, so I cannot actually write my y in terms of x properly. Here I was able to do it, but if you can try here, like here I was easily able to do it, but you can try here, you will not be able to do. You cannot write your y easily in terms of x. So this is a implicit function. Okay, what is a composite function? So a sorry, like I'm a bit sleepy. So a composite function is the composition of functions combining two or more functions into a single function. What do I mean? So let's say you have x, right, distance x as a function of time, that is t square, and you have distance y as a function of time, that is 3t. Okay, and your u is a function of x and y, x plus 2y. So u is a composite function because x itself is a function of time, y itself is a function of time, right? So your u is a composite function. U, actually I can write my u as a function of, so this is what this I can write as g of or f of xy, right? F of xy. Okay, so this can be written as like I can replace my x and y with their proper values of t, so I can write my u in terms of t. So basically what is happening is u itself is a function of x and y, and x and y, they are functions of t, time. So it is a composite function because it depends, like these are not independent variables, right? That's why basically it contains two or more functions onto a single. So this is also a function, x equals to t square is also a function, y equals to 3t is also a function. So it combines two or more functions. Now there are few standard graphs, like I hope you can see, like this is odd function, this is cubic, right? Square I have already, yeah, square is this one, right? Square will be even. So x raised to power even power will be a even function, x raised to power odd power will always be a odd function. Okay, now what about this one? This is x into y, that is basically like this f of x equals to 1 by x. It is also called as rectangular hyperbola, that is my y equals to 1 by x. So I can cross multiply my x on both sides. I can cross multiply my x on both sides. So this will be xy equals to 1. Okay, so if xy is equals to 1, then yeah, that's very basic, that yeah, you can solve, you will get a graph like this. This will be x equal to 1, y equal to 1. So when x equal to 1, y equal to 1, it is 1. When x equal to minus 1, y is what? Y has to be also minus 1, then only the product will be 1. So that's why when x equals to 1 minus 1, y is also minus 1. So like the graph will be somewhat like this, right? Now these are called as asymptotes, because if your x value increases, right, if your x value increases, y value decrease. If x will increase, y will decrease. So y will try to go towards 0, but I will never be able to actually exactly be equal to 0. When will y be exactly equal to 0? When your x is infinity. But I will I can never reach infinity, right? That's why these are called asymptotes, lines that touch the curve at extreme points. So here the asymptote is at x equal to 0 basically. Although I am showing it with a higher difference, but to show you the significance of asymptote, if I show it here, right, you will not be able to understand. So it is almost going towards 0. And here also, if my y is very high value, right, that means x is very low value. So that's why we are almost very close to origin. X is 0, right? But we will never be able to reach origin, because if I put x equal to 0, this function will be undefined. 1 upon 0 is undefined, infinity, right? Undefined. Similarly here as well. Okay, so these are my asymptotes basically. Okay, so, or also called as extreme points. Now one key point is there regarding y equals to x raised to power m. So any format. So y equals to x is this line. So if my m is greater than 2, right, greater than or equals to 2, then I will always lie above my y equals to, not always lie above my y equals to x line. It will be somewhat, the relation will be somewhat like this. At x equal to 1, y will be always equals to 1. So they will always cross at this point. But beyond this point, this graph will be always at the top. That is x raised to power 2, x raised to power 3, x raised to power 4, x raised to power 2.1. And this graph will always be below. So this is what? This is nothing but square root. X raised to power 1 by 2 is square root. X raised to power 1 by 3 is cube root. So beyond 1, right? Beyond 1, beyond this y equals to x, that is 1 point, the root function is lower value, the square function is higher value, because of course this is increasing, this will not increase at that faster rate. Okay, but before 1, something interesting happens. Before 1, the cube root is dominating and the square root is lower value. Please keep this in mind. This is actually important, because once we will go and find the area, these properties will be used. So be careful. I have to find out the area between these two curves. So in those things you have to understand which graph will be at the top, which graph will be at the bottom. Okay, so why is it so that my cube root or any root is greater for lower values of x, and for higher values of x it is smaller? So we can take a very simple example. Let's take an example of whereby m is 2, right, and x is 0.1. Okay, so what is the y value when my when it is x square? It will be 0.01, that is x 10 raised to power minus 2 whole square. That is 10 raised to power minus 4. And what about y equals to 1 by 2? This will be equals to 10 raised to power minus 2 whole 1 by 2, or I can directly write this as under root of 10 raised to power minus 2. So this will be 1 by 10 basically, so 0.1. So which one is greater actually? You see that this value is greater, right? Under root is greater than the x square. So because it is already less than 1, and if I square it, right, it becomes even lower than the previous value if I square it. But if I do the under root, it becomes higher than the previous value. So that's why under root will always be greater below 1. Now you can take any value greater than 2, you will see the opposite. The effect will be opposite. If I choose x equal to 2, this will be 2 square, that is 4. If I choose here x equal to 2, this will be under root of 2, that is 1.414. Okay, so I hope that part is clear. Why before 1, this graph will be at the top and this graph will be below. Okay, same. Now a few more important points, like under root of minus 1 is I, that is a complex number. That is basically the solution of this equation. What is the solution of this equation? Because we had to find out the solution of this equation. So this was x plus minus under root of I, that is plus minus iota, plus minus iota. Okay, that is the solution for this equation, plus minus iota. Okay, what is cube root of minus 1? Cube root of minus 1 is actually minus 1. We have other solutions as well. That we will study in complex number. Cube root of minus 1 one of the solution is minus 1, because if I do minus 1 whole cube, right, it will be minus 1 into minus 1 into minus 1. So definitely cube root of minus 1 is definitely minus 1. That is one solution. We have other two solutions that will be discussed in your what do you call complex variable. Okay. So there are few more graphs like this graph x raised to power half. Now what is the domain of this? Now here, right, all these had domains, like I can give any value because these were simple polynomials. I can give any values to x. Okay, so what is the domain of this graph? Domain of this particular function will be all real values except 0, right? I cannot give 0 here, that is not possible. And what is the this domain is easy. This, what is the domain of this? Again, same domain, that x can belong to real, but it cannot be 0. And what is the range of this function? Range. So y, what does my y value belong to? So y can go, if you see, y is going towards plus infinity, and lowest value it can go towards 0, right? 0 when x is tending towards infinity. So basically it will never touch 0 because it is also asymptote. It will go from 0 to plus infinity. Okay, that is the range of y. For this graph, what is the range of y? For this graph, what is the range of y? What is the range of y? So the range of y is, so okay, let me domain I have already discussed. Let me discuss the range. Range of y will be like it can be from minus infinity to plus infinity, but it will never include the 0 value. It will not include the 0 value, right? It can be from minus infinity to plus infinity, but it will not include the 0 value. So it will be all real values except 0. Same range actually, all real values except 0. Okay, so yeah, I hope that part is clear. Like my health is not good, so that's why, like, I did not have proper sleep yesterday. That's why I'm yawning a bit, so I'm sorry for that. So yeah, so here we have another function f of x equals to x raised to power half. So y is x raised to power half. So what is the domain for this function? Again, it is simply under root of x, right? And we know domain is x has to be positive, x cannot be negative for real values of y, because we are representing it in a graph of real values of y. So that is the domain. What is the range of my function? Again, range of my function will be from 0 to infinity. Range of my function will be from 0 to infinity, correct? And here, if it is x raised to power 1 by 3, here x can take negative values. So we will only consider the real solution. So x can take negative values. So here the domain can be from minus infinity to plus infinity. Okay, x can be from minus infinity to plus infinity. But here, can you tell me what will be my, like, is it an odd function, even function? So if I plot the graph, right, of a cubic function, you will see the graph will be somewhat like this. So it is actually symmetric about the origin. So this is an odd function. I can prove it to you as well. So we have y equals to x raised to power 1 by 3. So if I replace my x with minus of x, this will be minus of 1 into 1 by 3 into x raised to power 1 by 3. So minus of 1 raised to power 1 by 3 is minus 1 only. So this will be minus x raised to power 1 by 3, which is simply equals to minus of f of x. So f of minus of x equals to minus of f of x. That means it is an odd function. So that's how you can prove a odd or a even function. So now let's discuss about quadratic equations. So it is nothing but a polynomial. Now, I hope you know how to find out the roots of a quadratic equation. I'm not explaining all this. I hope you know what is discriminant and what happens if discriminant is equal to 0. We get perfect square, right? Roots are equal and real. It is a perfect square basically. Okay, and when that happens, when this value goes to 0. If it is greater than 0, roots are real and distinct. If it is less than 0, then this value is less than 0. Basically, anything inside the under root is less than 0. That means roots will be complex because they will never cross my x-axis here. So for these kind of cases, right, roots is complex because they are never crossing my x-axis. So there is no valid solution. That what does root mean? Root means whenever my graph is crossing my x-axis, those are my solutions, right? Whenever it is crossing the x-axis, those are my solutions. So in these two cases, it is never touching. So your solutions are imaginary. That's why they are called complex solutions, imaginary. Now, if discriminant is positive, okay, that means I will get two solutions and two of them will be distinct, real and distinct, that is not equal. So alpha beta. Now there are two types of graphs. One is concave, another one is convex. So this graph is actually called as concave. So remember it like this. So concave will be like a bowl shaped. So this is the standard graph of a quadratic equation. So remember it like this. Concave is nothing but bowl. Your bowl, right? Anything bowl shaped is concave. And convex will be just the opposite of concave. So if concave is like this, convex will be like this. As you can see from here. Here roots are real and distinct. And remember your A, right? Coefficient A is positive. If coefficient A is positive, then what will happen? Then if I put x equal to infinity, this will be infinity. If I put x equal to minus infinity, like what happens if I have three terms, ax square plus bx plus c. Now for very high value of x, can you tell me which term will dominate? This term will dominate. How can you say? So if I take x square common here, right? X square common. If I take here x square common, this will be a plus b by x plus c by x square. Okay. Now if I put my, like x is going towards infinity. If x is going towards infinity, this will be 0, this will be 0, this will be a only. So this will be go, right? If x is infinity, these are all constants. X is infinity, this will be almost equals to 0, only this term will be left. So that's why for higher values of x, this coefficient of x square will dominate. So in the case 1, coefficient of x square is positive. So if x is infinity, this will go towards plus infinity. If x is minus infinity, then also it will go towards plus infinity because it is x squared. Now here my coefficient of a is negative, like something like this, minus 3x square plus 2x plus 6. So now if x is very high value, it will go towards negative. It will go towards negative. Okay, it will not go towards positive, right? If x is like very high value. I hope that part is clear by you. So this is this graph is called as concave upward. This graph is called as convex upward. So don't get confused by this concave downward, convex downward. Okay, remember two things. Just bowl shape will be concave, opposite will be convex. Now by default, as it is upward, that's why it is called concave upward. And sometimes it can also be called as convex downward, opposite. That's how you remember opposite. Just remember this one, that's it. Other things I think you will be able to derive, like in the exam hall if they would have asked you this term. Okay, and if discriminant is 0, that means you will have real and equal roots. Basically this will be 0, right? This plus minus term will be 0. So your roots will be minus b upon 2a, both the roots, minus b upon 2a. So I will have only a single root repeated twice. So it will just touch the x-axis only once. So again, for a greater than 0, a less than 0 graphs, I hope you can understand. And if discriminant is less than 0, that is complex, you will get complex roots. It will never cross my graph. Now this is the graph of a parabola. This is the basic graph of a parabola. Now the most basic graph of a parabola is this one, right? Y equals to x square. So y equals to x square is the most basic graph of a parabola. Now this is also a parabola, but it is the parabola about the x axis. Okay, so here y square equals to 4ax, y square equals to 4ax. Now is this a proper function? No, this is not a proper function, right? Because for single value of x, my y can take two values, right? Let's take an example. Let us assume that y square equals to x. So for x equal to 1, right, y can be -1 or y can be +1. So here y is not a function of x, but I can write x will be a function of y. This I can do, correct? So if I write x equal to y square, so for a single value of y, x is a single value, right? So for y equals to 1, x will be equals to 1. For y equals to -1, x will be equals to 1. So that is fine, like they are mapping to the same value, that is not a problem. But for a single value, I have a 1-to-1 mapping, like x equals to 1 only. X is not +1 minus or something like that. So here, right, this is not a function in terms of x. This graph is a function in terms of y. Similarly here as well. So here, right, it is 4a, where a is negative, then the parabola will be like this. This will be my parabola for when my y is very high value. Basically will either go towards +infinity or -infinity in terms of y. Okay, then x will be +infinity, because infinity whole square is infinity. Okay, so yeah, that is the case over here. Now parabola, I think we have discussed, we can ignore these things. Ellipse is this equation, x square plus y square by a square plus x square. So where if a square is greater than b square, then it is then the x axis will be major axis, because a square is greater, then x also has to be greater value, then only this will be like this ratio will be same, then all, that's why it is called major axis. If a square is less than b square, then it is called as minor axis, and y is called as major axis. Again, right, again this is not a proper function, not a proper function in terms of y as well. If I see, it is not a proper function here. At least in terms of y, I was able to check it, that for a single y value, x value was also single, correct? So yeah, this is not a proper function actually, ellipse. Okay, so but you can break it down in terms of minus and plus under root, then it will be a proper function. Like you can break it down in y, positive half of the y and negative half of the y. Then we have rectangular hyperbola, where this will be the equation. So remember these equations, right? How do they define rectangular hyperbola? How do they define ellipse? Okay, they can ask something like this in the exam. Okay, this can be used basically to find out the differential equation or something, right? To solve the differential equation. So that is the equation of ellipse and equation of rectangular hyperbola. So now we will solve few questions. This modulus will not be there, only these two questions will be there. So pause the video and try to plot the following functions. These two functions, try to plot it. So I will try to plot it. So 2x minus 1, very simple, right? 2x minus 1, how will I plot? So I know like y equals to x was this function, correct? But I have to plot actually y equals to 2x minus 1. So first of all, I will check where my y is going towards 0. When my y is 0, so 2x minus 1 will be 0, that is x will be equals to 1 by 2. So at x equals to 1 by 2, that is plus 1 by 2, y is going towards 0. This is one of the points, correct? And for what value of y, my x is going towards 0. So y equals to 2 into 0, x is 0, right? Minus 1. So for y equals to minus 1, my x is 0. So these two are my points. So I can simply connect these 2 points for forming a straight line. So this will be my graph of y equals to 2x minus 1. Okay, this will be my graph for y equals to 2x minus 1. Okay, now what will be my graph for f of x equals to x into x plus 1 into x minus 1. So this graph is interesting, right? This we will learn in wavy curve method as well how to plot this, but still we can still plot this. Not that difficult actually to plot. So we have to find out the roots of this graph. So for what values of x, my y is going to negative, sorry 0. So at x equal to 0, my y function is going to 0. For x equal to minus 1, my y function is going to 0. For x equal to plus 1 also, my y function is going to 0. Now if I see, if my x is greater than plus 1, if my x is greater than plus 1, let me take 2 into 3 into some positive value. So all this is positive. So for x greater than plus 1, it is going towards positive. So I can draw a wavy curve like this, and don't worry, I will teach you what is wavy curve. I can draw the wavy curve like this, right? So for x greater than plus 1, it is positive. Now if x lies between 1 and 0, let me take 0.5. If I take 0.5 here, this will be 0.5, this will be 1.5, this will be minus 0.5. So this is negative. So for x between 0 and 1, the value of the function is negative. And then again, if x is less than 0, right, let me take minus 0.5. So this is minus 0.5, this is 0.5, this is minus 1.5. So again, minus into minus is positive. So for x less than 0, it is again positive. Okay. And if x is now if x is less than 1, so x is less than minus 1, 0, 1. If x is less than minus 1, this will be negative, let's say minus 2, this will be also negative, this will be minus 1, and this will be again minus 3. So all of them are negative. So negative into negative is negative. So for x less than minus 1, it is negative. So my function will be somewhat like this. If you plot your function, right, you will have three points, critical points, and beyond this critical point, it will go towards positive infinity. Your y will be positive infinity. If I keep on increasing my y value, this will be going towards infinity. But I did not know what sign, whether it was positive infinity or negative infinity. So because from here I can see the sign. And don't worry if you don't understand, I will teach this in wavy curve method in the next few slides. Okay. So this will go towards positive infinity. Now between x equal to 0 and 1, my function is negative. So graph will be somewhat like this. Why? Function is negative, and I know that at x equal to 1 exactly it is 0, and at x equal to 0 as well exactly it is 0. So I will start from 0 and end to 0, and my graph will be negative. Again, before 0, graph will be positive, and again before minus 1, graph will be going towards negative. So if I keep on reducing my x value, so it will go towards negative infinity. So that's how you will plot these graphs. So now let's discuss about few more types of functions. This is an important function known as greatest integer function. This is the symbol for the function. So y equals to this square brackets x. What does it mean? It means greatest integer less than or equals to x. So if I have a function that is y equals to greatest integer of x, so for x equals to let's say 0.3. So going by the definition here, x like basically greatest integer less than or equals to x. So what is greatest integer less than or equals to x? So is 0.3 an integer? No. So what is the greatest integer? 0. 0 is the greatest integer that is less than or equals to x currently, right? So greatest integer of 0.3 will be 0. What will be for x equals to 1? If x is equals to 1, greatest integer of 1 will be 1, because greatest integer less than or equals to x. So 1 is an integer. So yeah, that will be my greatest integer. What will be 0.99? Greatest integer of 0.99, it will be simply 0. Greatest integer less than or equals to x. So is x an integer? No. 0.99 is not an integer. So what is the greatest integer that is less than this value? 0. So greatest integer of 0.99 will be 0. So that's how I represent it in the graph. If you see that we represent 1 as open circle. Why? Because this point is not like when my x is equals to 1, y is not 0, y is 1. That's why we represent a open circle. That means that this point is excluded. If it is closed circle, that point is included. So here it is closed circle, this point is included. So for x, for any value of x that is less than 1, all of them will be 0. But for x exactly equals to 1, it will be 1. Okay, same here as well. For any value exactly equals to 2, it will be 2. For any value less than 2 and greater than 1, it will be 1. Okay, that is what my greatest integer function is. So then we have this modulus function. What is the modulus function? So the modulus function is nothing, basically it makes the mirror image. So if I take the mod, right, whatever is inside this mod, it will make it positive. So modulus function means it will make my function positive. So what do I mean by positive? So modulus of x basically means, let's say I have minus 3. Minus 3 mod is 3. So what if I have minus 3, it will make it 3, right? It will make it positive. If I have mod of 3, what will it be? It will be 3 only. So if I have something negative inside the modulus function, it will make it positive. If I have anything positive inside the modulus function, it will keep it as it is, right? Here 3 was as it is. So if x is negative, it will multiply a negative sign minus 1 and then that will be my output. So same thing is written over here. So modulus of x, when my x is less than 0, that means negative, I will multiply a minus sign to make it positive. If x is equals to 0, it will be 0. And if x is greater than 0, I will not change anything inside the function. Here, did I change anything? No, I did not. So this was simply equals to x. Okay, this was simply equals to x. So x greater than 0 equals to x. So modulus function is an symmetric function for mod of x. So because you will observe that your x, y equals to x was this, right? But whenever my x was negative, I was making it positive. So basically whatever is inside your mod, right, it will always be positive. So if y is equals to mod of x, that means your y value can never be negative. It has to lie above the x-axis. It has to lie above the x-axis. Correct? I hope that part is clear by you. Okay, I think we will plot few functions as well. Yeah, we'll plot this modulus function now. Okay, so what will be modulus of 2x minus 1? So always whatever I told you, whatever is inside the mod, right, equate it with 0. If I equate this with 0, so when this function is less than 0, 2x minus 1, when it is less than 0, when my x is less than half, so whenever your x is less than half, then this function is less than 0. That basically means that it will, whenever, so how can I write my function? So for f of x, I will have 3 definitions. So this will be equals to minus of 2x minus 1 when my x is less than half. Why? Because whenever my x is less than half, this thing will be negative. I can take an example. Let's take x equal to 0. If I take x equal to 0, this will be minus 1. So I have to multiply another negative sign with this to make it positive, because modulus everything comes out to be positive. So that's why there is a negative sign here. Now for x exactly equals to half, this my function will be simply what? Mod of minus 1, sorry, x exactly equals to half, this will be 0, right? For x exactly equals to half, this will be 0. Now for x greater than half, what will be this function? For x greater than half, this function will be simply positive. So I don't need to make any changes. I don't need to make any changes. Okay. So for x greater than half, this will be 2x minus 1. That's it. Okay. So yeah, I hope it is clear by you. These things are clear. So that is what my modulus function is. Can I plot it now? Yes, definitely I can plot it. So I have to break my function down into 3 parts, right? Or what you can do is you can simply plot this function and just take the mirror image about the x-axis as I have done here, right? So I will plot my y equals to x, right? And for whenever my y is positive, I will not change it, but whenever my y is negative, I will just take the mirror image about the x-axis. Okay, there are two ways to solve this, solve this. So I can directly plot 2x minus 1. Do you remember what was my 2x minus 1? 2x minus 1, right? We just plotted. It will be somewhat like this, correct? So whenever my y is negative, right, from this value, this value was x equals to half. So whenever my y is negative, I will just take the mirror image. That's it, and I will just delete this. This will be my modulus of x. So I'm not going too much in depth here because like we have to cover a lot of things, but I hope you understand what is mod of x. Okay, now there is another function that is known as fractional part of x. It is x minus greatest integer of x. Basically it represents what is the fractional part left after the greatest integer part. Just like let's take an example, 0.33. What is the fractional part? 0.33. 1.33. What is the fractional part? 0.33. 2.67. What is the fractional part? 0.67. 3.99. What is the fractional part? 0.99. So how can I actually write this in terms of a function? So we can write it like this, that it will be x minus greatest integer of x. So if I take this first example, right, this one, or let's take this one. So what is x? X is 0.33. What is greatest integer of 0.33? 0. 0, right? Just this, the term that is before 0. So 0.33 minus 0 will be 0.33. As we can see from the graph, it will be 0.33. Again, 1.33. X will be 1.33. Greatest integer of x will be 1. So 1.33 minus 1, that is 0.33. Okay. So 1.33, x equal to 1.33 is somewhere here, right? And y will be 0.33 somewhere here. Okay. So y will be 0.33, x equals to 1.33 will be somewhere here. So this will be my like fractional part. Okay. So basically whatever is after the point, that is my fractional part. Whatever is before my 1, that is my greatest integer. Okay. I hope that part is clear. And there is another function known as signum. But before that, I want to discuss about few things regarding so how can I represent, if my x lies between -1 and 1, how can I represent it in terms of mod? So mod helps me to represent both negative and positive values if it is symmetrical. So I can represent it like this, that mod of x will be less than 1. So this means basically x lies between -1 to 1. How? So if x is equals to, as you can see, if x is equals to -0.5, then also this statement is true. If x is equals to 0.5, then also this statement is true, which is lying inside this range. But if I, let's say, choose x equals to -2, this statement will not be true. So that is anyways outside my range. If x is equals to 2, again not true, outside my range. So that's how you can represent and take help of the modulus function. You can like watch this, like have a read and understand this. That's how I can represent my modulus function, like as a range, as an interval. So modulus function helps us to define intervals as well. Okay, if we have some symmetricity, like union also you can do. I'm leaving it up to you. Now signum function. So signum function is also sometimes called as sigmoid function or sine function. It basically tells me the sign of x. So for x greater than 0, signum function will be 1. For x less than 0, signum function will be -1. Basically it tells me that it is negative value, and for x equal to 0, signum function will be 0. That is what my signum function is equals to simply. And sometimes another definition of signum function is x upon mod of x, where obviously x is not equal to 0. If for x equal to 0, this function will not be defined. For x equal to 0, signum function is 0 only. Okay. So here if we see that, let's take an example. So for x equals to -0.5. So if I choose x equals to -0.5, this will be, top will be -0.5 and the bottom will be +0.5, right? So it is -1. Okay. So signum function can also be written like this. So let's solve few questions like this. We have to plot the graph for the following functions. F of x equals to sine, greatest integer of sine of x. So do you remember how does my sine of x looks like? So sine of x is like this, correct? So greatest integer is nothing but it only represents the greatest integer portion, right? Only the integer portion. So my sin x graph, right, is always between 1 to -1 only for particular values, that is at pi by 2, x equal to pi by 2 and 3 pi by 2, it is exactly equals to integer. Other than that, it is always between 1 and -1, right? So between 0 to pi, my x value, 0 to pi, my y value is between like 0 and 1, okay? So what will happen basically here, if I plot my graph, you can obviously try it out by yourself. If I plot my graph over here, right, so between x equal to 0 to pi by 2, what is happening? Between x equal to 0 to pi by 2, my x value is between 0 to 1, and if it is between 0 to 1, what is the greatest integer? It is something 0 0.1, 0 0.2, 0 0.33, so it will be always 0 between 0 to pi by 2. Now at exactly pi by 2, something interesting is happening. At exactly pi by 2, my value of sin x is exactly equals to 1. So if it is exactly equals to 1, then what can I say is, if it is exactly equals to 1, then greatest integer of 1 is 1. So here I will have a open circle and 1 will be somewhere here, exactly equals to pi by 2. And then again, after pi by 2, what is happening? After pi by 2, again it is like 0.99, 0.98, something like this. So it is somewhat less than 1, 0.99, 0.98. So after pi by 2, again this will be 0 till pi, okay? Now as soon as it will go to something negative, let's say this is the value after pi, this value is minus 0.1, okay, minus 0.1. So if this value is minus 0.1, then this will be what? Exactly at 0, right? Exactly at pi, what is the value of x? Sin x? 0. Just after pi, what does the sin x become? Something negative. So what is the greatest integer of minus 0.1? Go back into the graph, it will be minus 1. Go back into the graph, it will be minus 1. So I will directly shift to minus 1, but exactly equals to pi, it will not be minus 1. But beyond pi, right, it will always remain minus 1. And exactly equals to, when it becomes exactly minus 1, what is the greatest integer of minus 1? Minus 1 only, because it is an integer itself, right? So greatest integer of minus 1 is minus 1 only. So it will go to till 2 pi. Okay, and at exactly equals to 2 pi, what is the value of x? 0. So again this will be a open circle, and I will start from 0. And we know a sine function, right, is a periodic function, so this will just keep on repeating. So if you could not understand, please repeat this portion and just see what is the greatest integer function again. You will be able to solve this. And tell me what kind of graph is sin x, because we have not discussed what kind of graph is sin x. So sin x, right, is an odd function, because if you see, it is symmetrical about the origin. It is not like even, right, because it is not symmetrical about the y-axis. It is not an even function. Now what is the signum of x into x plus 1 into x minus 1? This actually already we have solved. We have already solved this, right? So we had solved this here, that my value, this function, right, was positive after 1 and between minus 1 and 0. So signum function, that will be my signum function only. That function will be my signum function only. So basically my signum function, right, this function tells me the sign. So we know beyond 1 we are positive, so it will always be 1, right? And exactly equals to 1, what is happening? It is 0. The function exactly equals to 1, it is becoming 0, and signum of 0 is 0. So this will be open, and it will be exactly 0 here. So it will be open circle, exactly equals to x equal to 1. And if my x is between 1 and 0, we discussed that it was negative, right? You can go back and check. So if my x is between 1 and 0, it was negative. And what is signum of negative? -1. So here also I will have an open circle, because exactly at x equal to 1 it is 0, correct? And at x equal to 0 again it is 0. So again here I will have open circle, this will be dot, closed circle, right? And below x equal to 0, we discussed between x equal to 0 to x equal to -1, again my function was positive. So again I will have an open circle here, and below x equal to 0 function will be positive, so signum of positive will be +1. It will be +1. Now here again I will reach -1, and at exactly equals to -1 again function will be 0, and below -1, right? Below -1 again the function will be negative. So signum of negative is -1. So that will be the graph, and we have already plotted the graph of modulus. Okay, so these are the graphs basically. So we will discuss, just give me 1 second, we will discuss few trigonometric functions. Okay, we'll discuss few trigonometric functions. First one is a sine function. I hope you have seen a sine function. I will not explain this much. Okay, so there like it is an odd function because it is symmetric about the origin. So what are the zero crossing points for sine of x? It is 0, pi, 2 pi. So these are called as my zero crossing points. Basically it is a integer multiple of pi, or we can say it is even integer multiple of pi by 2. And the range of my function, right? What will be the range of the function? Range of the function will be between -1 to 1. So I can say mod of Lagrange will be between -1 to 1. So you can write -1 to 1. That will be my range. What is the domain of the function? X can take any value. X can take any value from -infinity to +infinity, because this graph will go on forever. And it is also called a periodic function. Why is it called a periodic function? The function which repeats after a certain period, right? That is called as periodic function. Cosine function, it is just shifted by 90, right? So cosine function starts a bit early. So if I shift this peak early, so that will make my cosine function. It is just shifted sign. Cosine is nothing but shifted sign. But here the zero crossing points changes. The zero crossing points here are pi by 2, 3 pi by 2, like this, minus pi by 2, minus minus 3 pi by 2. So these are my zero crossing points. So the zero crossing points changes. So it now becomes odd multiples of pi by 2. Okay, and the range again is same, -1 to 1. Then we have tangent function, tan x. Now tan function is sin x over cos x, right? And if I know for x equal to 0, cos of 0 is 1, sin of 0 is 0. So for x equal to 0, tan x is 0, no problem. But at x equal to pi by 2, what happens? X equal to pi by 2, if you see zero crossing points, it is an odd multiple of pi by 2, right? So the bottom tends to go towards 0. So tan x tends to +infinity, because sine of pi by 2 is +1. So +1 upon 0, almost 0, is +infinity. Okay. Now remember this point, that odd multiples of pi by 2 is not in the domain of this function. Odd multiples of pi by 2 will not be in the domain of this function. Okay. So what is the domain of this function? Domain of this function will be all real numbers except n, 2n plus 1 into pi by 2, where n is any integer. So any real number except odd multiple of pi by 2, because at odd multiples of pi by 2 my cos x goes to 0. So that's why that will not be in the domain of the function. Okay. And so now in this domain it is continuous. So like I will explain what is continuous later on. So basically now what is the period? If you see, the period will be here pi. Previously the period was actually 2 pi for cos and sine function. The period will become pi. So basically from minus pi by 2 to pi by 2 it will follow a certain graph. Then again from a bit after pi by 2 and bit before 3 pi by 2 again it will follow certain graph, because exactly at pi by 2 I cannot comment the value because it will be plus infinity or minus infinity, right? It will be plus infinity or minus infinity. Okay. What are the zero crossing points? The zero crossing points are again even multiple of pi by 2. Wherever my sin x will go to 0, my tan x will go to 0 simply. Okay. Then we have cosec function. Cosec function is reciprocal. Again you can see what is my, now what is the range of this function will be from minus infinity to plus infinity. Of course you cannot touch plus infinity or minus infinity. Cosec function is reciprocal of sine function. So it will be somewhat like this. The function will be somewhat like this. If you take the reciprocal of sine, right, the function will be somewhat like this. Okay. Now okay, one more thing. What is the cos function? So cos function is even. It is not odd because it is not symmetrical about origin. It is symmetrical about the y-axis. That's why cos function is even, sine function is odd. Tan function is also, if you see, it is not symmetrical about the y-axis, right? Because this is negative, this is positive. If it was supposed to be even, this also should have been positive. So it is not even function. It is basically an odd function. It is symmetric about the origin. What about cosec function? So cosec function again is odd because sine itself is a odd function. So cosec function also will be a odd function. What is the domain of cosec function? So again it is 1 by sin x. So I cannot put those values of x for which my x goes to 0. So when does my x goes to 0? X goes to 0 in even multiples of pi by 2. So those values are outside of my domain. Now what is the range? Range will be from, range will include minus infinity to 1 and 1 to plus infinity. Okay, 1 to plus infinity. Minus infinity to 1 and 1 to plus infinity. That is what my range is equals to. Okay. What about my sec function? So sec function again it is inverse of cos x. You can again derive it. It will be again even function. So because it is inverse of a even function, cos itself is an even function. So inverse will also be even function. Cotangent, it is cot. Cot is inverse of tan. Again it will be symmetric about x-axis. It will be odd function and like it will just be the inverse. So these graphs are important. You can go and have a look. So undefined value already I have discussed that 1 by tan at pi by 2, right, is undefined. Okay, at pi by 2 it is actually never defined. Although we say that tan pi by 2 is very infinity, but that is not a proper way to say. So undefined value means the value of that function at that particular value of x is not defined. Oscillatory value means it is finite, like it will be something in plus minus infinity. We cannot exactly say what value it will be. Okay, and plus minus infinity is just a feeling. It is not an exact value, right? Now what is oscillatory value? Oscillatory value is finite but uncertain, like this. So if I put here x equals to 1, this will be cos of 1 upon 0 which tends to cos of infinity. Right? I know the range of cos, right, is always between minus 1 to 1. So definitely I know that output of this function will lie between minus 1 to 1. It will be some finite value, definitely. But what will be the value? It is uncertain. It will just simply oscillate. Like Himanshu sir will teach you in signals. It will oscillate very fast. Near x equal to 1, right? It will oscillate very fast. This will be taught to you in signals. Okay. So cos of infinity, I certainly know that it will be between minus 1 to plus 1. But what will be the exact value? I don't know. It will be, the behavior will be oscillatory. Okay. So trigonometric, now there are few inverse trigonometric functions. Okay, we will discuss about that. Before that, let me discuss about the domain. So domain already we have discussed. What is the domain of sin x? So domain of sin x, right? is from minus infinity to plus infinity. That is the domain of sin x. So x can be like, there is no restriction in domain of sin x. Okay. Now, so basically your x will lie from minus infinity to plus infinity. Now here x for cos x, again x will lie from minus infinity to plus infinity. Okay, and here for cosec x, what is the domain? So for cosec x, right, it is 1 over sin x. So x cannot be equals to pi by 2, sorry, even multiple of pi by 2. No, sorry, not even multiple. Yeah, even multiple of pi by 2. X cannot be equals to even multiple of pi by 2, right? So x will belong to all real values except 2n into pi by 2. These values will be gone, where n is any integer. For sec as well, same thing, but it will be odd multiple of pi by 2 because it is a cos function. For tan as well, now for tan again sin x upon cos x. So again I will restrict my domain with all real numbers except odd multiple of pi by 2, and for cot x it is cos x over sin x. So sin x cannot go to 0, so wherever sin x goes to 0, those will be out of my domain. So this is how you can write a domains, and trust me, no one will teach, like we have, I think we have studied around 1.2 like 1 hours 20 minutes, okay, 1 hours 50 minutes, and no one will teach you all this. No one will teach you all this, right? They expect, in every other institute, they expect that you already know all these things, but I teach you everything from basics. Okay, so now there is few inverse trigonometric functions. So in inverse trigonometric functions, what we do is, when my y is equal to sin x, y is output, x is input. Now I take the inverse. So x is equals to sin inverse of y. So so my x becomes output now, and y becomes input. So what can be the input of this function? So if I write another function y equals to sin inverse of x, what can be the input? What can sin inverse take as input, right? That will define my domain. So remember your x, right? Now this this becomes like, this is your x equal to sin inverse of y. So your x can take any value, right? But what values can you provide in y? Because if I do sin inverse of 2, is this valid? Actually this is not valid. Why? Because let me assume this to be some theta value. Okay, so sin theta equals to 2, right? If I now take the opposite of inverse, sin theta equals to 2, is this valid? No, this is not valid. Sin theta equals to 2 is not valid, right? Because I will never be able to find a proper value of theta for which my sin theta is 2. That is not possible. So what went wrong? So basically you have to choose what can you give as input, right? And this input should be between -1 to 1. That is basically the range of y, because this was expected, right? Sin x can only provide you values between -1 to 1, right? So this time the domain will become range, and the range will become domain will become range, the range will become domain, and the domain will become range. So here what was the domain? Minus infinity to plus infinity. So your x can take any values. But what we do is like we define ourselves for any sinusoid, right? Any sinusoid function we define like this is my domain, minus infinity to plus infinity. But as our function is periodic, what do we say? We define our x between minus pi to plus pi. That's it. Minus pi to plus pi. So if our function is periodic with period 2 pi, so I will say the sin x domain will be between minus pi to plus pi. Why? Because x can take infinite values, right? So when my sin x is equals to let me choose a value pi by 2, or let me choose pi by 4, it is equals to 1 by root 2, right? And sine of, if I am not mistaken, 3 pi by 2, 3 pi by 4, then also it is 1 by root 2. So for both of these values it is 1 by root 2. Okay, so here I was wrong actually. So our domain, right, we will write between minus pi by 2 to pi by 2. Why so? Why so? Because I know my sin x, right, will give out unique values from minus pi by 2 to plus pi by 2, right? So sin x, I know the range is what? From minus 1 to plus 1. So minus 1 to plus 1, I am getting unique values from minus pi by 2 to plus pi by 2. Why? Because there will be problem while defining the domain of inverse trigonometric functions. So that's why I will limit the domain of sin x to pi by 2 to minus pi by 2 to pi by 2, because for those values only I am getting unique values output, right? For those values I am getting unique values, because I will limit my domain, because later on once I will take the inverse trigonometric function, there will be difficulties for me. That's why from this point onwards only I am limiting. So here also for cos also, what is the graph? For cos the graph is like this, minus pi by 2 to plus pi by 2. So for cos I am not getting all values of cos, right? So I have to extend further. So for cos I will go from 0 to pi, because from 0 to pi I am getting 1 to minus 1, right? So for sin x the range will be, the domain will be minus pi by 2 to plus pi by 2. For cos the domain will be 0 to pi. I hope the reason is clear, that I want to cover all my values. My cos x varies from minus 1 to plus 1. So as I want to cover all my values, so I have to choose my domain as 0 to pi, because from between 0 to pi my cos will give as output all my values. Same for cosec. Okay, for cosec again, what will be the unique values? It will be same for cosec as well. It will be same, because cosec is 1 by sine. So whatever is the domain of sine, right, same will be the domain of cos. Okay, except the fact that we have to remove the even multiple of pi by 2. So yeah, automatically even multiple of pi by 2 is automatically removed, right? Only sine 0 will not be in the range, n equal to 0, sine 0 will not be in the range. So I will subtract. So basically my x will belong, right? So also I can write this properly. X will belong, it will include both minus pi by 2 and pi by 2 in this case, and in this case x will belong 0 to pi, and in this case where will my x belong? So x will belong between minus pi by 2 to pi by 2. That is not a problem, but it will not include 0, because at x equal to 0 it is becoming sine 0 and 1 by 0 is undefined. Again for sec is inverse of cos, so it will be same, the domain will be same as cos, but it will exclude pi by 2, because at pi by 2 there is problem, right? At pi by 2 exactly it is going to 0, which is undefined, so it will not be in the domain. Same for tan. Tan is sin x over cos x, right? Sin x over cos x. So for tan, what do I see? If you go into the graph for tan x, you see I am able to cover all my values when my x is between minus pi by 2 to pi by 2. Just the difference is your x should not be equals to minus pi by 2 or plus pi by 2. So x will lie between minus pi by 2 and plus pi by 2, because at pi by 2, right, cos x is 0, at minus pi by 2 also cos x is 0. So domain of x will be between minus pi by 2 to plus pi by 2, excluding minus pi by 2 and plus pi by 2. Same for cot x. Cot x will be similar to the domain of the cos x. Okay, so it will be similar to domain of cos x 0 to pi, excluding 0 and pi, because at 0 and pi sin x will go to 0. So I hope that part is clear. So now if I am taking the inverse, now everything will be sorted. So if I am doing x equal to sin inverse of y, or y equals to sin inverse of x, so what will be my domain of x? My domain of x will be basically x can be between 1 minus 1 to 1. I cannot give anything beyond 1 because I know sine of like sine can never reproduce anything beyond 1. So that's why the x will lie between minus 1 to 1. Okay. Now what is the range? What is the range? So to fix the range, right, that's why we had to do all this, right? We had to do all this. So what will be the range? The range for sine inverse of x will be between minus pi by 2 to pi by 2. Because if I say sine inverse of 1, sine inverse of 1 can be pi by 2 as well. It can be 3 pi by 2 as well. So not 3 pi by 2, sorry. 3 pi by 2 will oh yeah, it will be 3 pi by 2, yeah. 3 pi by 2 as well, or no, it will not be 3 pi by 2. Sorry, it will be pi by 2 as well. It will be 5 pi by 2. Okay, like I can add every 2 pi, right? Basically it will be, I can add any 2 pi with this 2n pi, and it will be equals to my sine inverse of 1, because sine of 90 is 1, sine of this is 5 times 90, 450. Sine of 450 will be 1. Again you can add 360, it will be 1. So there are multiple values, but again I told you, right, I cannot get multiple for a single x value. I should not get multiple y values, right? Otherwise it will not be a function. To mitigate that, we eliminated all the other solutions, only we chose pi by 2 to properly write it as a function. So sine inverse of 1 will be pi by 2. Okay, basically, right, if I have an angle here pi by 2, if I add 360 with it, right, or subtract 360, it does not make any difference, because let's say pi by 2 is here, right? I am adding 360, basically I am rotating a whole circle. That means I am coming back to the same point. So adding or subtracting 360 does not make any difference. But to write it in a proper function definition, that's why we had to choose our range very, very carefully. So these things are actually pretty important. So this will be my graph of y equal to sine inverse of x. So the range will be between minus pi by 2 to plus pi by 2. As you can see, the range of the graph is between minus pi by 2 to plus pi by 2, and the domain of x is between minus 1 to 1. So I cannot go beyond minus 1, less than minus 1, or after 1, right? So the domain will be between these two values. Okay, that is what my y equals to sine inverse of x is equals to. Okay, and what about this y equals to cos inverse of x? Again, the domain is between minus 1 to plus 1, because that is what my cos x, the range of cos x was, right? Range of cos x was minus 1 to plus 1. Now it becomes domain. And what is the range? Range will be the domain of the previous function, right? What was the domain here? What was the domain of cos x? Between 0 to pi. So as you can see here, we are getting between 0 to pi. 0, y equal to 0 to pi. So these are the graphs. You can go through this. I am not going through every single of them. That will take us so much of time. Okay, tan inverse is important. So basically sine, cos, tan. These three functions are very, very important. So please revise this properly. Okay. So let's move on to exponential function. So there are two kinds of exponential function, right? A raised to power x. So a raised to power x, if a is greater than 0, then what will happen? So let's say 2 raised to power x. So for increasing value of x, the value will keep on increasing. If x is less than 0, if a is greater than 1, that is 2 raised to power x, then for increasing value of x, the function will increase. How? So 2 raised to power 2, 2 raised to power 3, you will see that the function keeps on increasing. But if I have a value that is less than 1, right, let's take the value of 0.5. So 0.5 raised to power x. So let's take 0.5 raised to power 1, then 0.5 raised to power 2. So this is nothing but 1 by 2, and this is nothing but 1 by 4. So 1 by 2 is actually greater than 1 by 4. So as I am increasing my power, right, what is happening? The output is decreasing. That is shown here. But at x equal to 0, both of them will be 1, because anything raised to the power of 0 is 1. Okay, so that is the exponential graph basically. Now we have logarithm graph. Okay, now what is the domain what values can I provide to x? Any value. X can take any value, right? X, domain of x is any value. What is the range? Range is also again any value, minus infinity to plus infinity. But if I have a function like this, what is the domain? Domain is any value except x equal to 0, because 1 upon 0 again it is not defined. Okay, so then we have logarithm function. So it is basically like, I hope you know how to take the logs. I am not explaining you. So logarithm is just the inverse of exponential, right? So if I have a exponential like this, a raised to power of x, if I how do I write it in terms of log? That is, my power will be log a base of x. That is the this value, right? So that is what my logarithm function is. So it is nothing but the inverse of power. It is nothing but the inverse of exponential. So in this case, previously, okay, sorry, one more thing I forgot to miss, that here what is the range? Range actually, I told you wrong. It is not minus infinity to plus infinity. It is between 0 to plus infinity, right? 0 will also, it will never touch 0. So because this will always be positive, you choose any number, right? You choose any number, let's say 1, 0, 0.1. If I do square, if I do cube, it will remain positive. Now here I have already told you that a cannot take any value less than 0. Why? Because if I choose a to be minus 1, and if I have a x equals to half, so this becomes square root of minus 1. That is not possible here, right? Because we are talking about real numbers here, and here it is an imaginary number. So that's why we have already limited our a value greater than 0. So that's why inside this log, right, this this a must always be greater than 0. This a must always be greater than 0. So let's now discuss about the logarithm function. So it is nothing but the inverse of the exponential function. So what was my exponential function? My y was equals to a raised to power x. So if I take the log, right, log on both sides, this will be log, I have to take it with respect to a, right? I hope you know logarithm functions. Log of a base, log of base a y, it will be equals to x. So your x will now be a function of y. Okay, so what will happen? Your range and domain will interchange. So for every time you take the inverse, your range and domain basically will interchange. So here what was my domain for this function? Domain x can take any value from minus infinity to plus infinity. The graph was always there. So here the range will be minus infinity to plus infinity. As you can see, the range of y, because now what you do, generally we don't like writing x in terms of y, we like writing y in terms of x. So I will just swap my y and x. Don't get scared, I will just swap my y and x. Okay, because we generally are comfortable writing y in terms of x as the independent variable and y as the dependent. So what is the, so here the domain was from minus infinity to plus infinity, right? This was my domain. Don't look at the domain for this one, this is something else. This I just shown you example. What was the domain for this one? X will belong to minus infinity to plus infinity. So here now that will become my range here. So my y is going from minus infinity to plus infinity. You can see it is, the range of y is minus infinity to plus infinity. So no problems, correct? What about the domain of this function? So the domain of this function will be the range of my previous function. What was the range? So previously, right, I told you a bit, I think I told you wrong. The range will be positive. So here I have written it correctly. Range will be positive. Range will be from 0 to infinity. That will be my range, right? So range will be positive always. So because your I cannot give negative values to my a, right? A cannot be negative. A has to be positive. So if a is positive, if I take the square root of a positive number, if I square a positive number, it will always be positive. If I square a positive number, it will be positive. If I take the square root of a positive number, it will be positive. So the range of this function is positive. So the domain also you can see is always positive. I am always on the positive side of the graph for x. I am not on the left hand side. So range and domain are sorted now. What about, so you can see that's why inside log function we never provide negative values. Because here if it is negative, right, that means this value was negative here, inside log, yeah, x can never be negative, because if this is negative, that basically means my y value here was negative, which is not possible at all, right? And this a value always will be greater than 0 for these reasons. Here also a is greater than 0, a is never less than 0. So I hope now log and this exponential function are done. Now there are few things to check symmetricity, right? Few key points. So if I replace my y with minus y, then we say that, and if the function remains same, then we say the function is graph is symmetrical about x axis. So in y square plus 4ax, what was the graph? Do you remember what was the graph? The graph was something like this, right? So if we replace y to minus y, this will be still the same function, right? This will not change. So we say graph is symmetrical about x axis. If you replace x with minus x, graph will be symmetrical about y axis. Like x square equals to 4ay, the graph will be somewhat like this. Okay, so graph will be symmetrical about the y axis. Now if I interchange my x and y, and still if the function remains same, then graph is symmetrical about the line y equals to x, like this function, right? Rectangular hyperbola. So if I draw the line y equal to x, it is symmetrical about this line, right? This is same, this is same. So these are few properties, and now we have few graphical transformations. Okay, so if I am adding any constant value with my function, right, what will happen? The graph will simply either shift up or down depending on the sign of a. If a is positive, it will shift up. If a is negative, it will shift down. Like, I hope these basic things you can do. Now if I am changing the x value, if I am shifting my x value plus minus a, then either the graph will move on the right hand side or left hand side. If I am doing minus a, then the graph will move left hand side. If I am doing plus a, graph will move on the right hand side. How? So let's take the a value as 1. So previously when there was nothing, right, when it was y equals to f of x, so what was x equal to 0? X equal to 0. So what was y at x equal to 0? It was f of 0. Now y dash, what is y dash at x equal to 0? It is f of x plus a, that is 0 plus 1, that is f of 1. So f of 1 I can see will be, so x equal to 0 is f of 1, so I am early, right? So this will be shifted leftwards. So this was my y equals to f of x graph. From here I can identify what is my f of 1. Let's assume that this is my f of 1, right? So previously my x equal to 0 was 0, y equal to 0. Now my x equal to 0 becomes f of 1. F of 1 is this value. So basically I have to take this point and bring it at this point. So that is nothing but shifting my graph on the left hand side. Shifting this whole thing on the left hand side, that's it. Because this point is supposed to come at x equal to 0, that's why I will shift at left hand side. Okay, so these things you can do obviously. If I multiply negative sign with my function, it will basically reflect my graph about the x axis. Okay, so one example, let's say y is equals to x square. So y equals to x square is this graph, correct? Y equals to minus x square will be just the reflection about the x axis, that's it. Okay, so these are few graphical transformations. These are asked in aptitude, so that's why I am teaching you everything. If I take the negative sign of x, then it will reflect it about the y axis. So similar example is there. So if I take y equals to x, right, and then if I take y equals to minus x, y equal to minus x will be this, y equals to x will be this. So basically I am reflecting about my y axis. Okay, if I am multiplying a scalar constant with my graph, basically it will either scale it upward, like scale the graph, like the points, zero crossing points will not change, it will either stretch or compress the y axis, that's it. Okay, these are few basic graphical transformations. Now if I am multiplying some scalar constant with my x value, then it will stretch or compress the x axis. Okay, so let's say I have example sine of x and sine of 2x. So at x equal to x equal to pi by 4, this value is 1 by root 2. At x equals to pi by 4, this value is pi by 2, actually sine of pi by 2, that is 1. So this value is 1. So basically either like you can perform this experiment like same thing I've done. Either it will compress or stretch the graph. Like we don't have time to go through everything. You can take example values and understand it by yourself. If I am taking the mod, basically I will reflect that whatever is on the positive y side, that will remain. Just whatever is on the negative y side, right, I will reflect it about my y equal to x line, not y equal to x line, sorry, x equal to 0 line. About the x axis I will make it positive. Whatever is positive will remain positive. I will just make the negative positive. That's it. That is the task of a modulus function. So these are just graphical transformation. I'm expecting you take the examples out of it and try to understand each of them, because if I give this more time, right, I will not be able to cover other things, right? We have only 12 hours of window, correct? So another kind of transformation is this one. If I take the modulus of the x, not modulus of f of x, modulus of x. So for modulus of f of x, what did I do? I just made whichever portion was negative, I just made it positive. That's it. Because we know mod of x makes it positive. Now, if I do f of modulus of x, right? If I plot the graph of normal f of x, what we will do? We will simply remove the negative portion, because if it is modulus of x, what will happen? Then inside f, right? Inside f there is the value of x. Now x, this inside value will never be negative, always be greater than 0, because I am taking the modulus, it will always be greater than 0, right? So basically I am removing few negative values of x. So basically I am subtracting domain. So this does not even exist. So this can simply be removed. This portion can simply be removed. Only x, like basically, right? If I put here x equal to -1, this will be what? F of -1, mod of -1, that is 1, and f of 1 is 0. So automatically this point is here only, right? So I cannot put, like, if you put any value, right, that is negative, that graph is gone. So basically you totally remove the left hand side. So remove the left portion of the curve, keeping only the positive right of the y axis, and then reflect it about y axis, keeping the original position intact. So simply what you do is you simply remove this portion. Okay, you first of all remove this portion, because this portion is not there. This portion is not there. So first of all you remove the left portion of the y. Then what you do is you take the mirror image about the y axis. So I have taken the mirror image about the y axis. So what is f of -1? Sorry, what is f of -1? F of -1 is f of mod of -1. So it is f of 1, and f of 1 is 0. So you see f of -1 becomes 0. Again, what is f of -3? F of mod of -3, that is 3, and 3 is 0. So this also becomes 0. So basically what I will do, if I have a modulus inside the bracket of the function, right, then what I will do, first of all I will remove my left hand portion of the y section, then I will take the mirror image over the y axis. In this case, what did we do? Actually what we did was, first of all we remove this positive portion, right? First of all what we did, we just saw which portion was negative, for which my y was negative. This portion was negative, so I just had taken the mirror image throughout this range and removed this negative portion. That's it. Okay, so I know you will ask me, sir, do I have to remember it? No, understand it conceptually, what is happening, why is it happening. Just take few examples and try to do it. You will be able to figure it out. Okay, so now this is the last graphical transformation. If I am multiplying two functions, then one function will behave as envelope. So let's say y is equals to x sin x. So if y is equals to x sin x, so x equals to y is this value, right? Now if I am multiplying sin x, right, what is happening? I will plot the envelope of y equals to x. What is the envelope of y equals to x? So you will plot both y equals to x and y equals to -x. That's how we plot the envelope function. Okay, so y equals to x will be this, y equals to -x will be this, right? Now you will simply plot your sine function in this range. Okay, this is, yeah, you will plot your sine function in this range. So your y, like your sine function, will be between the envelope. That's why it is called envelope, because this is behaving as a envelope. Inside the envelope I have the other function. Okay, so that's what you do. So after x greater than 0, right, like this function is always positive, so the sign will be defined by sin x, right? After x equal to 0, this function is always positive, so something positive into some number, so the sign will be defined by that number, sin x. So that's why here you see the sin x graph is somewhat like this, and the sign is defined by the sin x graph. But before x equal to 0, x itself is a negative number, right? So negative into any number, right? Now the sign will be defined by both of this product. So whenever sin x is negative and this is negative, then my y will be positive. So for x between 0 to minus pi by 2, right, sin x is negative and x is also negative, so multiplication will become positive. So basically, if you are multiplying two functions, I will first draw the envelope, that is y equals to x, y equal to minus x. In this case, what is my envelope? So I can assume this to be my envelope, right? So I will draw that function as my envelope, which is either going to 0. So which function will be my envelope? That is going to 0 at x equal to infinity or x equal to minus infinity. At any value, if it is going to 0, that will be my envelope. Okay? Or okay, here also it is not going to 0. Like basically, not this one. Basically, the function which is non-periodic, because this function was periodic, right? That's why this cannot be my envelope. Envelope will be that function that is non-periodic. Sorry about that. Envelope will be that function that is non-periodic. So e raised to power minus x is non-periodic because it is not a repeating function. So how do I plot the envelope of this? This will be e raised to power minus x and minus of e raised to power minus x. That will be my envelope. So e raised to power plus x is this, minus of e raised to power minus x is this. So this is my envelope, and in this range, basically my sin x will vary. And remember, your exponential is always a positive number, so that's why the sign is decided by the sin x now. Here it was, because x was changing its sign, so it was changing. So I hope now you understand how to plot a product of two functions. Okay. So yeah, now we will discuss about limits. So let's now discuss about limits. So before discussing, like starting our limits topic, I want to start with this particular function. Let's say we have a function x minus 1 divided by 3 into x minus 1. So what you will do is you will say that I will simplify this function and your f of x will become 1 by 3. So the value of the function at x equals to minus 1 also will be 1 by 3, x equals to 0 as well will be 1 by 3, and x equals to 1 as well will be 1 by 3. And you will be wrong, because the moment that you did this, right, you cancelled, you assumed one thing, you assumed this value is not equal to 0. The moment you cancelled, right, you assume this value should not be equal to 0. You cannot cancel something that is equal to 0, as I have told you this as well, right? So let's say I have here 3x square equals to x. So you cannot just cancel x. If you are cancelling x, you are assuming that your x is not 0, because actually what does cancel means? Cancel basically means I am dividing by x on both sides, right? That is what cancel means. So here also cancel basically means that I am dividing x minus 1, I am dividing it with x minus 1. But you must not divide with a number which is equal to 0. That is not allowed. So that's why we say that we take this x on the left hand side and then we take the x common. So this becomes 3x minus 1 equal to 0. Right? From here I get two solutions of x. Same thing here as well. Once that as soon as I am cancelling, things will go wrong, because if I am doing the cancellation, right, so this will get cancelled, that is fine, but I have to check for which values of x this is going to 0. So at x equal to minus 1 and x equal to 0, there is no problem. The value of the function will be 1 by 3 only. Okay, x equals to minus 1 and x equals to 0, value of your function will be 1 by 3. But at x equals to 1, there is a problem. X equals to 1, your denominator is going to 0. So actually what is happening? It is 0 upon 0 format, right? 3 into 0, which is 0 upon 0. So actually it is undefined, because we know any finite value upon 0 is undefined. But what we can do is we can make a good approximation that what is this value approaching to. So limit will help us find out the value of this function at x equals to 1, that is at the points where my function goes undefined. But it will not be the exact value of the function, because of course the actual value of the function is undefined. The function is actually undefined for x equal to 1 because x equal to 1 is not even in the domain of this function. What is in the domain of this function? Range minus 1. So not range, any real number minus 1, right? That is the domain of this function. So I cannot put the value of x equal to 1 here actually. But as you know, we are engineers and we like to do few approximation and we are curious basically. So what can the value of function be around 1? So limit will help us to find out the value of the function near of 1, in the neighborhood of 1. So that is what our limit will help us perform. So limit is actually not the value of the function at x equal to 1. Limit is the value, the to what value does my function approach. That is what my limit will tell me. Okay, so here if you see, right, for any other value other than x equal to 1, the function will always be 1 by 3. Just for this value, right, at x equals to 1, it is undefined, we don't know. So what is the left neighborhood value? What is the value of my function just at the left hand side of my 1? It is equals to 1 by 3. So that is actually called as left hand neighborhood, and this exact value is called as the left hand limit. And what is actually just at the right hand side of my 1? It is, the value is 1 by 3. That is actually called as the right hand neighbor, and this is called as the right hand limit. And we say limit will exist for a function if the left hand limit is equals to my right hand limit. Basically my whatever, if I am approaching from the left hand side, if I am getting the same value as I am approaching from the if I am approaching from the left hand side, if I am getting the same value as I am approaching from the right hand side, right, that means limit of the function will exist. And what will be the value of the limit? This common value, whatever is the common value. If let's say I have a tan inverse graph, right, if you remember I had a tan inverse graph. So the tan graph was somewhat like this. I hope you remember, right? It was a periodic function somewhat like this. So at x equals to pi, it was not defined. So if I am coming from the left hand side of pi, what does my tan x approach to? It approaches to plus infinity. So not pi actually. So this will be pi by 2. Right? If I am approaching from the left hand side of pi by 2, I'm like approximately the value will be very high, plus infinity, right? Approximately, if I'm approaching from here, the graph is plus infinity. But if I'm approaching from the left hand side, the graph value is minus infinity. So if I'm approaching from the right hand side, the value is minus infinity. If I'm approaching from the left hand side, the value is plus infinity. So I am observing that these two values are not same. That is, the left hand neighborhood and the right hand neighborhood are not same. So if they are not same, that means limit will not exist. Limit will not exist. Okay. So we will see all this. So function at left hand neighborhood is 1 by 3. Function at right hand neighborhood is 1. So value of the limit will at x equal to 1 is 1 by 3. Value of the function at x equal to 1 does not exist. So I don't know what is the value of the function at x equal to 1, but I can definitely comment about the limit, because we want to at least we want to show something at this point, right? We don't want to keep it open. It does not look good. So that's why what mathematicians did was they had made a method to tell the value, not the value, tell what my function will approach around x equal to 1. That's it. So this, right, is not the value of the function at x equal to 1. This is the value of the limit. If both the left hand limit and the right hand limit are same, then this will be the value of the limit. Okay. So yeah, these things are there. You can have a read. So basically what we do, we say limit of a function will be limit as x tends to a, not equals to a. We will never put the value exactly equals to a. We will reach our a. So there are a few examples. Where is it? This is done. Yeah. Do I have a function? Yeah. Here I have a function, right? So let's say for this function, right, I have to find out the limits at x equal to 0, 1 and 1.5. So that is limit as x tends to 0 f of x. So basically now for us to calculate, right, the limit, we have to approach from the left hand side and the right hand side. So if I am approaching from the left hand side, right, towards 0, what is the value of the function? It is -1. If I am approaching from the right hand side towards 0, what is the value of the function? 0. So the left hand limit is -1 and the right hand limit is 0. So the left hand limit is not equals to right hand limit. So limit will not exist. Limit does not exist. But does the value of the function exist? Yes. So what is greatest integer of 0? It is 0 only. Right? So yeah, I hope now it is clear that what is the actual definition of the limit. The actual definition of the limit is you will approach that particular value from the left hand side and from the right hand side, and you will see whether they are equal. If they are equal, then you will say limit exists and the value of the limit will be that equal value. If it is not equal, then you will say limit does not exist. As simple as that. So let's check for another value, that is 1.5. So for 1.5, if I am approaching from the left hand side, the value of the limit is 1. If I am approaching from the right hand side, the value of the limit again is 1. So both of them are equal, right? That means limit will exist and that will be equals to 1. Okay. So I hope this part is clear. What is limit, right? So now the limit describes the behavior of function as it approaches a specific point, while the function value is the actual output of the function at that specific point. Functional value at a point has no relation with the limiting value of the point. They may or may not be equal. So as I told you, right, functional value may or may not be equal. So actual output of the function, right, f of 0 was actually 0, right, and left hand limit and right hand limit were different. So they may or may not be equal. Okay, we cannot definitely say regarding the functional value. Functional value is the actual value that I will receive at the output, and limit is just the limiting value if I am approaching from the right hand side and the left hand side for that particular point. Okay, now there are many formats. There are mainly three types of formats. One is determinant format, indeterminate format, and undefined format. So determinant format is in which I don't have any problems to calculate the value. What is 6 upon 2? 3. So 6 upon 2 is, if I assume x, so x will be 3, that is a unique solution. So that's why it is a determinant form, right? Now, what is undefined form? Undefined form is 6 upon 0. So 6 upon 0, if I equate this with x, right, there exists no value of x for which I can get 6. What shall I multiply with x to get 6? No value, because 0 into x will be 0 only, right? So this equation will be never true. So I am not able to get any value of x for this equation to be true. So this is called as the undefined form. So I will never be able to get any solution of x. Now this one is the most interesting one. This we have used in matrix as well, right? So this is like infinite solution, right? 0 upon 0. If the numerator also approaches 0 and the denominator also approaches 0, then it is called as a indeterminate form. There are other types of indeterminate form as well. I will explain. So 0 by 0, if I assume it equals to x, right? So this will be 0 into x into 0. So for any real value of x, right, this will satisfy. So I have infinite solutions of x. So it becomes an indeterminate form. There are infinite solutions of x, right? So these are the three forms. And in limits, mainly what we will do, of course, we will never be able to solve undefined form, but we will try to solve the indeterminate form. Okay, how we will see. So now concept of infinity. So infinity, as I told you, it is just a number. It is not a number, it is a symbol, because in infinity I can never write x equal to infinity, because infinity is not a constant value. It always keeps on increasing, just like our universe. Our universe is always expanding. It is never stationary, right? It is always keeping on expanding. So it is x is tending to infinity is correct way to phrase it. X equal to infinity is wrong. Just like infinity minus infinity is equals to 0, that is wrong, because both of these values are increasing. Okay, I cannot simply just subtract them. Or infinity plus infinity is not 2 into infinity, it is simply infinity, right? Because it is always increasing. So that was about the concept of infinity. Now there are many indeterminate forms. So mainly these are my different indeterminate forms. I think you have studied this during your JEE days, right? 0 upon 0 is the first one that we discussed. Infinity upon infinity is also another indeterminate form, right? So this is nothing but 1 upon 0, right? So 1 can get cancelled. This will become 0 upon 0. So basically all these forms, right, can be converted back into 0 upon 0. So 0 into infinity, What is infinity? Infinity is 1 upon 0, like not exactly equals to, but it is tending to 1 upon 0, right? So again this will be 0 upon 0, again infinity minus infinity, so this is 1 upon 0 minus 1 upon 0, which is again 0 upon 0, right? 1 minus 1 is 0, so 0 upon 0. So again this is a indeterminate format. Infinity into raised to power 0, right? Again, if this is a very high value and this 0 is not exactly equals to 0, this 0 is not exactly equals to 0, this 0 is tending towards 0, right? If it was infinity, any number, constant number raised to power 0, it will always be 1, okay? But this 0 is not exactly equals to 0, it is tending towards 0, okay? So this is also another indeterminate format. Here I have explained how this is indeterminate format. So ultimately your y will come out to be e raised to power 0 upon 0, and 0 upon 0 is a indeterminate format. 0 raised to power 0, again it is an indeterminate format. This, both these zeros are going towards 0, right? Because what will happen, 0 raised to power any number, right, is 0, and 0 raised to power any number raised to power 0 is 1. So there is bit of confusion here, both are tending towards 0, okay? Confusion, will it be 0 or 1? And 1 raised to power infinity, again infinity is infinity and 1 is not a constant number, so 1 raised to power any value k will always be 1, but this infinite, this 1, right, is not constant, it is tending towards 1, it is tending towards 1. So 0.99 raised to power very high value will be, again I cannot comment, so because that value is keeping on increasing, right? Okay, so these are my indeterminate formats. I have explained all this, you can go and see. Now 0 upon infinity, is 0 upon infinity an indeterminate format? No. So 0 upon infinity means very high value, so it is going towards 0 simply, right? So 0 into 1 upon infinity, infinity is basically going towards infinity, so this 1 upon infinity is always 0, right? So 0 into 0 is simply 0, so 1 upon infinity is 0, 1 upon 10 raised to power 4, again 1 upon 10 raised to power 6. So once this value keeps on increasing, I am going towards 0, tending towards 0, right? So that's why 1 upon infinity will always be 0. Infinity upon 0, again this is undefined, because this is some constant, like this is some large number, right? This is not 0 upon 0, this is some large number. So infinity upon 0 is not defined, because what happens is this infinity into 1 upon 0, which is infinity, so infinity into infinity becomes infinity only, which is undefined, right? Infinity plus infinity becomes infinity, undefined. Infinity raised to power infinity, very high value raised to power high value, infinity. 0 raised to power infinity, again this 0 is not exactly equal to 0, it is tending towards 0. So this raised to power very high value, right, you will see like it is approximately tending towards 0 only, actually approximately tending towards 0 only, if I am not incorrect. Yes, approximately it will be tending towards 0. So this is actually determinate, the value of this is 0. This format is determinate, it is not indeterminate, right? What is the value? Value is 0. You keep on increasing this value 1000, 10,000, you will see that as I am tending towards 0, this is going towards 0, right? So this is not a indeterminate format. This is infinity, this is simply infinity, this is infinity, this is infinity, this is going towards 0, okay? Now as I have discussed how to calculate the limits, you will calculate the left hand limit and right hand limit. So that I have told you visually, but mathematically how can you calculate? You have to, if you are approaching from right hand side to point C, so you will write x approaches C plus. How will I replace C plus? I will replace C with C plus h, where h will be a very small number that will be approaching towards 0. So this C plus h will be a number that is greater than C, but by a very small amount. H can be 0.001, 0.00000000001. Okay, so I'm approaching from the right hand side because h is positive, that's why it is called as right hand limit. Similarly, if I want to approach from the left hand side, mathematically how can I write it? It will be c minus h, right? Somewhat lower value than h, so this will be c minus h. So that's how I approach from the left hand side. Okay, h is a, remember h is a small positive quantity. Okay, so now what we will do, first of all, how to calculate limits. Step 1 is to approach from the left hand side and right hand side and check if both of these are equal or not. Okay, so if both of these are equal, then of course limit will exist. So if both of these are equal and both are coming out to be finite, right, then limit will exist. If both are equal and both are coming to be plus infinity, then also limit exists. The value of the limit is plus infinity, right, and limit exists because both are coming out to be equal. If both are equal and both are negative infinity, then also limit will exist. But if one is positive infinity and another one is negative infinity, then limit does not exist. So limit exists at C if both of them are simply equal. That's the bottom line. And if they are not equal, limit will not exist. Or if both are oscillatory around x equal to a, then also obviously limit will not exist. Okay. So there are many ways to solve limits. So this is the first way in which we directly substitute the value of x and do factorization and rationalization. So first of all, you put the value of x equal to 1 here and check whether the function is going undefined, like whether you are getting a indeterminate format or not. First of all, you have to put the value of x and check whether you are getting an indeterminate format or not before even doing this, right? Before calculating right hand limit and left hand limit, first you put value of x, put x equal to c and check whether I am getting an indeterminate format or not. Indeterminate format or not. So here, if I put x equal to 1, this will be 1 square minus under root of 1 divided by under root of 1 minus 1. So this will be 0 upon 0, okay, which is a indeterminate format. So now I will solve. And the thing is, if they are asking you to find the limit and if it's a NAT question, right, then obviously 100% chance that limit will exist. Then only you have to find out the value of the limit, right, because it is a NAT question. So if it's a NAT question, limit will always exist. So you don't need to worry whether I need to check the right hand limit or the left hand limit. You just check any one limit, right hand limit or left hand limit. As limit is existing, so the left hand limit also will be coming out to be same as right hand limit. So if the question is NAT, you just need to find out one of the two limits, right hand limit or left hand limit. You don't even need to do this step, checking 0 by 0 format, because they are already asking you what is the value of the limit. So you know that means limit must exist, then only you will be able to put a value over here, right? So that thing is sorted now. So now let's solve this. So I am getting an indeterminate format. So what I can do, because this denominator is a problem, I can rationalize this denominator, right? I can do some rationalization. Either you can rationalize or you can do factorization. So I will do rationalization. Okay. So if I rationalize, this will be x square minus under root of x into under root of x plus 1 divided by, okay, that will actually not help us out. Yeah, that will not help us out. So rationalization will not help me out. So if I take this under root of x common, right, that is x raised to power half. If I take x raised to power half common, this will be x raised to power 3 by 2 minus 1 divided by x raised to power half minus 1. Okay. So few factors you must remember, right? Few factors. So few properties. One is your a square minus b square. This is actually equals to a minus b into a plus b. Another kind of factor we have, that is a cube minus b cube. This was equals to a minus b into a square minus or plus ab minus plus b square. I also have forgotten, so let me just do this quickly. This will be, if you tend to forget, right, you can always come back. So this will be a cube, this will be plus a square b, this will be plus ab square, this will be minus a square b, yeah, minus ab square minus b cube, yeah, ab square, a square b, yeah, this will be cancelled, yeah, that is correct. So this is the factorization. So that is what I will do. So this is nothing but x raised to power 1 by 2 whole cube minus 1. So a cube minus b cube. Okay. So this will be x raised to power half. So this will be x raised to power 1 by 2 whole cube, right? So this will be yeah, if I break it, it will be a minus b, that is x raised to power 1 minus b into a square, that is x raised to power half whole square, that is 1 plus ab, that is x raised to power half into 1 plus b square is 1 itself, right, divided by x raised to power minus 1. Now you will say that here, because I can calculate left hand limit or right hand limit will exist, so either I can find out limit as x tends to 1 plus or 1 minus, it does not matter. 1 plus meaning I am coming from the right hand side, slightly higher than 1, or 1 minus meaning I am coming from the left hand side. So this time, right, you will be able to cancel it. You will be able to cancel it. Why? Because you are not putting the value of x equals to 1, you are approaching 1. So if I am approaching 1, both of them will give me same value. So I can cancel them, no worries. After you cancel them, then you will find out the value. This will become x raised to power half into x plus x raised to power half plus 1. Now you put the value of x. Right? This is not the value of the function, because the value of the function at x equal to 1 is undefined. Right? We are calculating the limit. So we can do this. Okay? So this will, if I put the value of the x, this will be 1 into 1 plus 1 raised to power half plus 1. So this will be 3. So the limit will come out to be 3. That's it. Okay? Limit, not the value of the function. The limit will come out to be 3. Okay? Mathematically, actually, what we do is we replace our 1 with 1 plus h, where h changes to h is a very small value. So this gets replaced, x gets replaced to h tending to 0, right? So h will be what? So basically this is my x will change to x plus h. So h will be, x will change to x plus h. Yeah, that's it. So x is tending to 1 plus h, like x is going towards 1, it is 1 but it is slightly higher than h, so h will be x minus 1, correct? What do I mean is I am approaching 1 plus. What does 1 plus mean? 1 plus a very small number, 1 plus 0.001 plus 0.0001, right? So I can write this small number to be h, and I can say h is tending towards 0. So if x is tending towards this value 1 plus h, right, then what is h tending to? X minus 1. So so what I will do is I will replace all my x values here, right, with 1 plus h. Like officially that's how you do. You don't do it like this. Okay, actually what you do is you replace all your x values to h. So limit as h tends to 0, and you say that you replace your x with 1 plus h. So this will be 1 plus h x raised to power 1 plus 1 plus h raised to power 1 by 2 plus 1. Then you put h equal to 0. Now if I put h equal to 0, you will get the same answer, but like I hope you get the gist. Like I am doing this directly, but actually the step is this. But in exam, you'll never do all this, right? You'll never do all this. You directly solve, because they will give you NAT. If they are giving you NAT, you directly need to solve. You don't need to calculate the left hand limit or right hand limit. Okay, so like basically, right, if this was my right hand limit, basically 3, what is my left hand limit? So left hand limit in this case, I have to replace my, like it will be 1 minus meaning 1 minus a very small number h. So it will be 1 minus 0.001 or 0.00001. So this is my h basically, correct? So x will be approaching to 1 minus h. So I will replace wherever there is x with 1 minus h, and what is my h approaching to? H is approaching to 0. So I will replace with all these variables x, right? It will be 1 minus h plus 1 minus h raised to power 1 by 2 plus 1. So in this case, you can see if you put the value of h equal to 0, right? You can put, because there is no denominator, I can put the value of h equal to 0. If I put h equal to 0, what is happening? We are getting the same value. So the left hand limit and the right hand limit are same. We'll solve more questions. We'll understand these examples. Okay. So there are a few fundamental theorems of limit. So if I have a function f of x whose limit at as x tends to a exists and it is L, another function I have g of x whose limit as x tends to the same point is M, then the limit of like f of plus minus g of x can be equals to plus minus L plus minus M. What do I mean? So if I have a function, let's say x square and some x plus 1 divided by x, or let's say x x minus 1 divided by x square minus 1, okay, some function like this. If I know the limit of this function at a particular point, and if I know the limit of this function at a particular point, then I can actually calculate the limit of the sum of the function. What is the sum? Sum is this, right? X square plus x minus 1 divided by x square minus 1. So individually, if I know the limits and if I am summing the function, right, I can tell the limit of the function at that at a particular point. That will be basically sum of the individual limits. So it is very simple, right? Simply you will just either add or subtract the limits. So if you know the limits individually, and if you want to find out the limit of the combined function, you will just add or subtract. That's it. If you are multiplying two functions, you can just multiply their limits. That is allowed. So if I have a function f of x equals to x minus 1 divided by x square minus 1, okay, and I have another function f of x equals to x minus 2 divided by x square minus 2. So sorry, g of x. So what will be the and I want to find out the limit of x at 1 f of x plus g of x plus minus g of x. So individually I will find out the limit here. Individually I will find out the limit, and then I will simply either add or subtract depending on the sign. So that will be my limit. So also if I am doing multiplication f of x into g of x and want to find the limit at a particular point x equal to x tending to 1, so that also I can find out if I know the limit here individually and here. So let's assume like here the limit is simply 1, right? You can see the graph, limit will be simply 1. Sorry, it will not be 1, it will be 1 by 2. If I am approaching towards 1, it will be 1 by 2, because this x minus 1 and x minus 1 will be cancelled. Only I will have x plus 1 left in the denominator. So this will be 1 by x, sorry, 1 by 2. Here this will be 1 by, so at around x equal to 1, do I have any undefined point here? No, right? X equal to 1, this function is perfectly fine. So around x equal to 1, this will be actually minus 1 upon minus 1, that is 1. So overall here, right, if I am adding the two functions, overall limit will be half plus minus 1 if I am adding or subtracting. If I am multiplying, overall limit will be half into 1. Simply whatever you are doing with the functions, you can do the same with limits. That is what they are telling. If I am dividing, right, then also this is valid. I can simply divide the limits given that the denominator is not equal to 0. Basically your limit of g of x is not equal to 0. If it is equal to 0, I cannot divide by 0. That is undefined. Okay. Also if I am, let's say, multiplying by a scalar k value, I can take it outside the limit. So this limit is what, half. So what will be the value of the limit 3 times this function? It will be simply 3 by 2, right? Because 3 is just a scalar number, it does not make any difference with this x values. So I can take the 3 outside the limit and then find out the limit individually and then multiply by 3. That is what this property is telling me. So all these properties are useful. This will be used while calculating the limit. So if you have a function to the power of function, and if you know the limit of this function around x equal to a and limit of this function around x equal to a, so this will be basically f of x equal to a will be L, this will be g of x equal to a, this will be m. So this will be L raised to power m. So this can be derived with the help of logarithms. Okay. Remember, this function must be greater than 0. Basically your L must be greater than 0. If your L is not greater than 0, I cannot put a value. I cannot put a negative value in a exponential function, right? I cannot have a negative base in exponential. Now what is f of g of x? F of g of x is basically function. So f of g, this is interesting, f of g of x. So f of g of x is nothing but function inside a function. So let's say I have a function y equals to x square plus 2x plus 1, or y equals to v square plus 2v plus 3v plus 1. Okay, y equals to 3v plus 1, and your v is equals to x plus 1 divided by x minus 1 divided by x square minus 1. Okay, so what will happen? So what is my y as a function of x? So y is a function of v, which is a function of x, right? So y f of v of x, that is what is written over here. Y f of g of x, right, means f of g of x. So that is what my y as a function of v of x. So yeah, so I hope you get the point. Y is a function of v, in which v itself is a function of x. So that's why I can write y as a function of v of x. Okay. So again, there are property that I can individually find out the limit inside. If I have to find out the limit of f of g of x like this, right, what I can do is I can go inside and put the limit. I can go inside this function and find out this value g of x as x tends to a, and that we know the limit for that is m, right? Limit for that is m. So my actual value of the function will be f of m. That's it. So let's, like, what am I talking about? Let's say I have to find out the limit of this y as x approaches 1, right? But here I don't have any x, right? I don't have any x. So what we can do is we can calculate this value of v as x approaches 1, right? What will be it? It will be 1 by 2. It will be 1 by 2, correct? And then I can put this value of v over here, y of v equals to half, and that will be basically my limit as x approaches 1. So because my y is directly not a function of x, right? So first of all, I will see what does my v become when my x is 1, that I will replace here. So that is what they are telling in this particular property. Okay. So there is a note about continuous, we will see. We will see when we will study continuity. So first method for solving limits was rationalization and factorization. Second method is using standard limits. So sometimes in the question they will give you some standard limits which you actually should remember. Okay, like x tends to sin x upon x. This limit actually is equals to 1. How? So if I plot the graph of sin x, right? If I plot the value of sin x upon x, so when x is positive for a very small value, right, when x is very near to 0, my sin x is also very near to 0. Both are very small number, right? Both are very small values. So it will be approximately equals to 1. How? So if x is very small, right? If x is very small, approximately I can approximate my graph as sin x, sorry, as y equals to x. For a very small region, approximately my sin x becomes x. For this region, right, approximately it becomes linear in this region. So sin x becomes x approximately. Okay, when I am very near to origin. How can I prove it otherwise? Like, what is my sin x as a series? Sin x equals to x minus x cube divided by 3 factorial plus x raised to power 5 divided by 5 factorial minus this, and so on. It will keep on, it will go on. Okay, it will go on, right? So when x is very near about origin, right? So let's say x is very small value, 0.001. So your x cube will be even smaller. Can you imagine? This is what? This is 10 raised to power minus 3. If I am taking the cube of this will be 10 raised to power minus 9. So this value will be even smaller, this value will be even smaller. So only this value will be dominating term. So sin x will be approximately equals to x when x is very near to origin, and that is what we are interested to find, sin x upon x. So when x is very near to origin, it is approximately equals to x. So I can replace my sin x as x, and in the bottom also I have x. So ultimately this becomes 1. That's why limit as x tends to 0, sin x upon x is 1. So if it is cleared, put a like in the comments, in the video, right? Put a like in the video, okay? And similarly, tan x upon x also, it will approach towards 1 only. How? So what is tan x? Tan x is nothing but sin x upon cos x into x. Now I have told you, right? This is a function. Let's assume this 1 upon cos x to be a function, right? 1 upon cos x to be a function into sin x upon x. So by the fundamental theorem of limits, I can individually calculate the limit of this function, I can individually calculate the limit of this function, and then multiply both of them together. So what is the limit of this function? What is the value of this function as x tends to 0? Cos 0 is 1. So it is 1 upon 1. So this is 1. So there is no problem, right? So this will be 1. And this value is already, we know, 1. So ultimately, tan x upon x also becomes 1. Okay. Similarly, your sin inverse of x upon x also will be 1. Tan inverse of x upon x also will be 1. Okay. Because your angle also, if you see your degree, y value is also very small, right? Your y value is also very small. So both of them also will be 1. So you have to remember it. How to prove it, I have also shown to you how to prove it, right? Then there is this. This is actually very important. You have to remember it. How will you remember? By L'Hopital rule. So what you will do? First of all, you will write the function, right? And then you will apply L'Hopital. What is L'Hopital rule? That is what we will study in the next few slides. So how will you remember? You will remember the formula. If you tend to forget the formula, right? You first of all you will write, okay, limit as a raised to power x minus 1 by x. What will be the limit? How can I find out the limit? You will use L'Hopital. If everything is gone wrong, you will always use L'Hopital rules. What is L'Hopital rule? That we will discuss in the next few slides. Okay. But if you remember these fundamental limits, right, then it will be helpful for you, these standard limits, because you will be able to solve the question in a much quicker manner. Okay. So limit of this function will be log of a, limit of this exponential will be 1, limit of this will be 1, this will be n raised to power n into a raised to power n minus 1, and this will be 1 by 2. So I am not going into the derivation. Okay, I am not going into the derivation. I think derivation you guys have done it in class 11th. If you have not done it, simply use L'Hopital. I can use L'Hopital to prove each of these results, okay, which we will learn in the next few slides. So let's solve few basic limits. This sin of 4x by x. So you will say, I know sir, sin of x upon x is 1, so this limit will be 1, and you will be wrong. Why? I have told you sin of x upon x, right? Why do we replace sin of x equals to x? But this is not sin of x anymore, this is sin of 4x, right? Sin of 4x upon x. So you don't replace sin of 4x with x. You will replace sin of, let me write sin of y. So you will replace sin of y with y. So what is y? Y is 4x. So you will replace sin of 4x with 4x. Is this clear? You will not replace sin of x with x, right? You will replace sin of 4x with 4x. Okay. So it will be 4x upon x. So this will be 4. 4 will be the answer. Now how else can you do it? So I have given you the format sin of x upon x, right? So if I have here x, this should also be x. So what I will do, I can convert this into this format, sin of 4x upon 4x sin of 4x upon 4x into 4, because actually I had to find out this limit, right? I just multiplied and divided by 4 extra to get to this format. I know this format, sin of mx upon mx, this will be 1. Okay. So ultimately, again multiplying both these numbers, this will be 4. Okay. So like I'm not explaining you each and every step here, right? I'm jumping few steps because my expectation is you know bit of things, you know bit about limits. Okay, that is my expectation. Okay, so how else can you understand it? So again I told you, right, what is my sine of 4x? Sine of 4x will be 4x minus 4x raised to power 3 divided by 3 factorial plus 4x raised to power 5 divided by 5 factorial, and this will minus this, and it will keep on going, right? It will keep on happening, correct? So again, what these all terms can be ignored if x is very low value. If 4x is or x is very low, right, tending towards 0, again higher order terms will be neglected, only this term will be left out, that is 4x. So I will replace my sine of 4x with 4x. That's why I had replaced it with 4x. Okay, so I'm trying to explain each and everything. Okay, it's not like I'm skipping something, but I'm jumping few steps because we have to cover a lot of things. Now what about sine of x 0? So this is nothing but degree. Now remember, the formula that I derived was for the formula when this is in radians. Okay, by default, is if nothing is mentioned, you will always assume whatever is inside sine, it is in radians, right? So first of all, I have to convert this into degrees, sorry, into radians. So I know that my 180 degree is pi radian. I hope you know this, right? So 180, this will be my pi radians, right? 180 will be pi. So basically 2 pi is what? 360 degree, a complete cycle. So 180 will be pi. Okay. So what will be 1 degree equals to? 1 degree will be pi upon 180 radians, right? Not exactly equal, pi upon 180 radians. Now what will be x degree? X degree will be pi into x upon 180. So I will replace my sine of x degree with pi up into x upon 180, right? So this will be sine, sorry, this was my x degree equals to, right? Okay, yeah, that is correct. This was my x degree equals to. So I will replace my x degree with this radian value because we like radian inside sine. So this will be sine of pi into x upon 180 degree, whatever this value is, divided by x. Now can you find out the limit? Again I have to convert it into our format, right? That is sin x upon x. So I will multiply and divide by pi upon 180, correct? So this will be sin x upon x. So this is what, like ultimately we are calculating this value, but I have to reduce it to my actual format, standard limit format. Now I know the value of this limit as x tends to 0, that is equals to 1, and this limit is pi by 180 because it is independent of my x. So actually the limit value will be pi by 180. This will be the answer. So I'm just doing here in rough, I'm not solving it properly, but I hope you get the point, right? My task is to just explain the things, just to revise quickly, right? It is not to solve all the questions. So this is another question. Okay, okay, we went too far. Yeah, this is another question. 15 raised to power x minus 5x minus 3x plus 1 upon sine square x. Kind of an interesting question, right? So we have sine square x. So I know the limit of sine x upon x. So what I can do is if I square this, right? So what will be the limit of sine square x upon x square? It will be 1. It is nothing but sin x upon x into sin x upon x. Okay, sin x upon x into sin x upon x, correct? So yeah, so now, so what I can do is I can multiply and divide by x square. So this term will be sorted, right? So ultimately, because I want to convert this into my standard formats, I don't know what is sin, like, because if I put x equal to 0, right, this will be 0 square. So I have to somehow eliminate this. So this will become sin square x upon x square, sorry, sin square x into x square and of course I have multiplied by x square, so I have to divide by x square as well, right? So to come back to my previous form, so this will be 15 raised to power x minus 5x minus 3 raised to power x plus 1. Okay, so what I can do is, I'm observing something. If I take minus of 5x common, if I take this minus of 5x, like what is this limit? Now again, limit as x tends to 0, so this limit is anyways 1, this is gone, right? Now I have to solve this one. So this one will be what? This one will be, if I take minus of 5x common, right? Or let me take 5x common only, 5 raised to power x, this will be 3 raised to power x. So I hope you know this thing, right? So 15 raised to power x can be written as 3 into 5 raised to power x. This will be 3 raised to power x plus, sorry, not plus, multiply by 5 raised to power x. So all these I am teaching like a class 8 student, right? This class 8 student also knows this. So 3 raised to power x minus 1, then if I take the minus 1 common, this will be 3 raised to power x minus 1, okay, divided by x square. Now this one, right, actually I know the limit of this. What is the limit? A raised to power x upon x, it is log of a, but here I have x square. How can I solve it? I will tell you how can I solve it. So this, right, I can take 3 raised to power x minus 1 common, I can keep it with x, right, and multiply it by 5 raised to power x minus 1, I can keep it with x, okay. Okay, so 3 raised to power x minus 1 divided by x, 5 raised to power x minus 1 divided by x. Okay, so these are my forms basically. Now I can put limit as x tends to 0. So individually I can find out the limits, right? What will be this one? So simply I have just factorized it and I have put 1x divided by this, another x here, so that I know the limit of this. This limit is simply 1 and this limit is simply not 1, sorry, this limit is log base e of a. A is a raised to power x here, right? That is 3, and here this will be log of base e into 5, not into 5, log of base e into 5. So basically this will be ln, so log base e is also called as natural logarithm ln 3 into ln of 5. Okay, I hope this part is clear. Ln 3 into ln of 5, right? So this will be the answer for this question. So you will convert your limits into standard forms and then solve it. Now how to solve infinite upon infinite limits? So you can convert this infinite upon infinite limits to 0 upon 0, or what you can do is, because infinite upon infinite mostly will be a polynomial, so what you will do, you will take the highest power of x common, right, and then divide. So like let's take this example, right? Here what is the highest power in the numerator? N square. So I will take n square common, this will be 1, divided by what is the highest power in the denominator. Now this is a sum of a number, right? This is a sum of a number. So what is the formula for sum of n natural numbers? Because n is equals to 1, 2, 3, that is n into n plus 1 divided by 2. I hope you have studied this during your school. So this will be n into n plus 1 divided by 2. So if I write this in polynomial format, this will be n square divided by 2 plus n divided by 2. Okay, n square divided by 2 plus n divided by 2. So that is my polynomial format here. Okay, so this will be equals to this will now right now I will take the highest power in the denominator common. Numerator is n square into 1, denominator again I will take n square common. This will become 1 by 2 plus 1 by 2n, right? So n square will get cancelled and my limit as n tends to infinity. So now if I put infinity, right, numerator is 1, this is half, if n is tending to infinity, what will 1 by n tend to? 0. So this term will be 0. Okay, this term will be 0, right? So this will be basically 2. 2 will be my answer. Basically what you need to do is, when there is polynomial upon polynomial, if the powers, highest power of both these polynomials are same, if m is equals to n, then you will get a finite value of limit. It can be 0 as well if your a0 is 0, that is also possible. Like you will get a non-zero value of limit. Here as we got limit as 2. If, for example, if let's say, just taking an hypothetical example, if it was n square upon n, and then if I do limit as n tends to infinity, what is the value of the limit? It will be infinity, because the degree of the numerator is higher. So if I cancel the n's, right, still there will be some n left, and if I put now n equals to n tending to infinity, it will be infinity. If hypothetically it was n square upon n cube plus n, hypothetically, now both from the numerator and the denominator you have to take the highest power common. So if I take the highest power common, what will be the value? This will be, right, if I take n square common, this will be n square, this will be 1 divided by n cube. One plus n square. So what is happening? This is gone, still I have 1 by n over here, right? So now if I put n equals to infinity, what will happen? This is 1 upon infinity plus 1 upon infinity. So this is nothing but 0, right? Because I have an infinity in the denominator, right? So limit will be 0. That is what is defined over here. Limit will be 0 if your power of the denominator, that is n, is greater than the power of the numerator. And if your power of the numerator is greater than the power of the denominator, it is not defined, that is basically it is infinity. Like example is shown over here. These are the examples. Okay, you can see the examples. So this was a way to solve this format, infinity upon infinity. And again, if I put here, like let's solve this question. If I put x equals to infinity, this will be infinity whole square plus infinity, that is infinity. Infinity under root is infinity minus infinity. So this becomes a infinity minus infinity situation. So I will not solve it like that. I will do some rationalization. So what I will do is, this is under root x square plus x minus x, right? So I will multiply and divide x plus x minus x. I will multiply and divide by under root of x square plus x divided by x square plus x plus x. Just give me 1 second now. Yeah, so now I will solve it. Okay, now I will solve it. So this will become what? If I factorize it, this will be x square, a minus b into a plus b, that is a square minus b square. So x square plus x minus x square upon under root of x square plus x plus x. This will be, now I can take the highest power common, right? So this will be cancelled, right? This x square will be cancelled. This will become x upon under root of x square plus x plus x. What is the highest power in the numerator? X raised to power 1. What is the highest power in the denominator? So if you are saying x square, you are wrong, because this is in under root, right? So if you take x square common, under root of x square is x. So highest power in the denominator is also 1. So both in the numerator and denominator, highest powers are same, so you will get a non-zero limit, finite non-zero limit. Okay, so this will be equals to, if I take x common, this will be 1. Here if I take x common, this will be x under root 1 plus 1 by x plus 1, right? This will be cancelled. Now you will do, like, I am not writing limit x tends to infinity everywhere, right? I hope that is understood by you, that always you have to write limit x tends to infinity, but I am doing it in rough. Okay, I am doing some revision, that's why I am not writing. So properly, I hope you have studied during your 11 class 10 that how to properly write limit x tends to infinity, all those things. I am not doing because I have a marathon to take, I have to cover a lot of topics. So every time if I keep on writing it, that will just waste my time. So please don't get into the comments and tell me, sir, write here limit x tends to infinity, write here limit x tends to infinity. Don't tell that, okay? We are doing rough because we are just revising. That's all we are doing. Currently, I am not teaching you the whole concept. We are just doing revision, okay? So here, if x is tending to infinity, this will be 1 upon 0, 1 upon infinity, this will be 0. So ultimately, this will become 1 upon under root of 1 plus 0 plus 1. So, sorry, under root of 1 plus 0 plus 1. So, this becomes 1 by 2. So, the limit will be 1 by 2. Okay. So, 1 by 2 will be the answer for this question. So, yeah, I hope that part is clear by you. Yeah, 1 by 2 will be the answer of this question. Yeah, 1 by 2 will be the answer. Okay. So, the next way to solve limits is using series expansion, right? So, these are a few important series that you should remember. I also tend to forget this series, okay, but you should remember actually. So, this 1 plus x raised to power n, right, where n is integer, you can write your series in terms of this, that is nc0 plus nc1 plus nc2. Basically, your 1 plus x raised to power n can be expanded 1 plus n into x plus n into n minus 1 divided by 2 factorial into x square plus n into n minus 1 into, I think here n minus 2 also should be there, right? I forgot to write n minus 2 divided by 3 factorial into x cube and so on. So, like you can expand your 1 plus x like this. So, if anywhere while solving limits this one comes along, so you can do this expansion and do cancellation. There will be some cancellation. So, after cancellation you will be able to solve your limits. Similarly, you can actually expand your e raised to power x in terms of this. How? So, basically we know the expansion for e raised to power x. What is the expansion for e raised to power x? It is 1 plus x square divided by 2 factorial plus x cube divided by 3 factorial and so on, right? So, what I can write e raised to power x? E raised to power x can be written as e raised to power ln of a. So, the few properties of log, I hope you remember that if this and this both are same things. So, these are just properties of logarithm. I am not explaining, but I hope you remember, right? So, e raised to power ln e will cancel, this will be e raised to power x. I hope you remember these things, right? So, this will become e raised to power x ln a. So, here, right, the coefficient of x was 1, that's why here it was only x, but here the coefficient of x is ln a, correct? So, everywhere x comes with ln of a, everywhere x will come with ln of a. Here it was only x, here x came with ln of a, that's it, okay? Similarly, the expansion for log of x is this. Now, log of x is not that important, sometimes it has been asked, okay, sometimes it has been asked, but mostly if you remember the exponential one is enough, and if you remember this one is also good, but this is the most important one, okay? These ones also you can remember. It is just like the binomial series. Here also in log x, right, what happens is there is no factorial in log x, also the signs will alternate. That is the difference between exponential and log. In log we start with x, so there are few differentiating factors, like you have to, like, unfortunately you have to make your own way to remember it. In log there will be alternating signs, we will start with x and there will not be any factorial, it will be simply by 2, by 3, by 4. But in exponential we will start with x raised to power 0, that is 1, then this will be x, this will be x squared divided by 2 factorial plus x cube divided by 3 factorial and so on, okay? So, yeah, I hope that part is clear. Yeah, and what will be log of 1 minus x? Simply you replace your x with minus x in the equation and you will get the expansion for 1 minus x. So why remember these expansions? Because it will help you in solving some limit question. So we will solve few limit question, from there we will see. Okay, but I have told you the expansion for log of 1 plus x, log of 1 minus x, but I have not told you the expansion for log of x. What is the expansion for log of x? So you replace your this, right, x with 1 minus x. Here you replace your x with 1 minus x. Basically you replace your x with 1 minus x in this equation and you will get the expansion for log of x, and mostly this will not be asked, so don't worry, don't take stress. Okay, so only you remember exponential one. Okay, and I hope you can derive this a raised to power x from the exponential one, from this derivation, by putting e raised to power ln a raised to power x, right? So x can come in front, so this will be e raised to power x into ln a. Now what is the expansion of sin x? It is e raised to power ix minus e raised to power minus of ix by 2i, or it is this one. I've told you how to remember. Sine is an odd function, so it will have all odd powers. As sine is an odd function, it has all odd powers and all odd numbers in the denominator. As cos is a even function, so it has all even numbers. It has all even powers and its sign also will be alternating. Don't forget, this sign also will be alternating, right? Both for sine and cos, sines sine coefficients, right? The signs of the coefficients will always be alternating in nature. Okay, and there is another expansion for hyperbolic. In hyperbolic, right, basically your imaginary, this ix becomes simply real, so this becomes real, that's it. So if you ever tend to forget, so whatever have I told you, remember this one, right? If you remember this one, right, you can derive sin x. It will be e raised to power ix minus e raised to power minus of ix divided by 2i. This much you have to remember, right? What is sin x equals to, and this I hope you must have studied somewhere. I hope you have studied this one somewhere, right? At least that is my expectation. Correct? So yeah. So now you will expand e raised to power ix, right? So instead of x, this will be ix, and I is a complex number, imaginary number, right? That is iota. So if I do I square, it will be minus 1. Correct? I hope you have studied complex numbers. So yeah, you will expand this thing. So this will become alternating. So if you ever tend to forget the expansion of sin x, you will derive. But you have to remember this formula. If you ever tend to forget the expansion of sin hyperbolic of x, right? This is sin h of x. You will write this equation, e raised to power x minus e raised to power minus x divided by 2. Basically all the imaginary things are gone. It is only real, right? So then you will put the expansion of e raised to power x, you will put the expansion of e raised to power minus x, and that's it. Okay, same here. So if you ever tend to forget, you can always derive from exponential. So exponential series is the most important series. Now tan x also has a series. No need to remember, right? The expansion will be very difficult, no need to remember. Okay, now I want to discuss a very interesting fact, that limit as x tends to 0, right? It is, yeah, it is very close to 1, but it is something smaller than 1. Why? Because if you replace, what is your sin x? Sin x is x minus x cube divided by 3 factorial and so on. So if I take x common and divide by x, right, it is 1 minus x squared divided by 3 factorial and so on, right? So if x is very small, higher power numbers are almost approximately equal to 0. So only I am left with this 1 minus x square divided by 3 factorial. So for a very, when my x is very small number, right, this will be 1 minus something. So actually my sin x upon x approaches 1 minus. It is 1 only, like it is equals to 1 only, 1 minus h, where h is a very small number, 0.00001. So it is something smaller than 1. So the thing is, this is approximately equals to 1, but if I find out the greatest integer of this function, then things actually become bit different, right? So if they want to give a good question on from limits, right, they will include the greatest integer function. So actually it is something lower than 1, so it is actually 0.9999999 and so on, right? It is not exactly equals to 1. So what is greatest integer of 0.9999990? Right? Because we only take the integer portion, we don't take the fractional part. So if they want to frame a very good question, right, they will include the greatest integer function with sin x upon x. So whenever these kind of situations comes, always break it down into series and see what exactly is your sin x upon x approaching to. So just be careful regarding these things. Okay. So same point for tan x. In tan x, right, tan x, what happens if I do the series expansion, it is something higher than 1, because it is x plus x cube divided by 3 plus 2 raised to by 15 into x raised to power 5. So tan x upon x will be 1 plus x square. So something addition is happening, right? Some sort of addition. So if I am adding, it will be something 1 plus. So greatest integer of this will be like, this will be what? 1.0000000001. Okay. So what is the greatest integer of this? It is 1. So actually limit greatest integer of tan x upon x will be 1. Both of them are approaching 1 only. 0.99999, 1.00001. Both of them are approaching 1. But sin x upon x was slightly lower than 1. Tan x upon x is slightly higher than 1. So if you don't remember this, you can always derive this. But for tan x upon x, you have to remember. How can you remember? You can remember it like this. Tan x upon x will be opposite of sin x upon x. So if sin x upon x is 1 minus, then tan x upon x will be 1 plus. And greatest integer of this is 1, right? I will only take the integer part, I will ignore the fractional part. Okay. So I hope this part is clear. If sin x upon x is 1 minus, right, what will be x upon sin x? It will be 1 plus, right? So basically 1 minus meaning 1.0999. So 1.099 will be something greater than 1, correct? Something greater than 1, right? And x upon tan x will be 1 minus. Why? Because this will be 1 upon 1.0001, which is something less than 1. No need to remember this one, right? This inverse function. I don't feel this will be asked. Just remember this reciprocal and sin x upon x, tan x upon x and its reciprocal. No need to remember this, not important. Okay. So yeah, let's solve few questions. So we have to solve this tan x minus sin x divided by x cube. Now we know our standard form. What was our standard form? Sin x upon x. But I am not able to see my standard format. So when you are not able to see your standard format, what you will do, because in the denominator I have x cube, so I will expand my series till x cube. I will expand my series till x cube. Okay. So at least for tan x, right, remember the series till x cube. So that is x plus x cube divided by 3. At least remember this. Tan x will be equals to x plus x cube divided by 3. At least remember this till this point. And what about the sin x? Sin x is x minus x cube divided by 3 factorial plus x is to the power 5 divided by 5 factorial. This one is simpler to remember, but for tan x, just at least remember till the third power. Okay. So this will be, now if I replace with series, right, this will be x plus x cube divided by 3 minus x plus x cube divided by 3 factorial minus x is to the power 5 divided by 5 factorial. Okay. And this divided by x cube. This, right? Now x limit as x tends to 0. So what is happening? X and x are getting cancelled, right? So okay, I don't even need to expand till 5. X and x are getting cancelled. So only x cube is there. So I can take common x cube and from all the places x cube can be cancelled. Remember, I can cancel x cube because I am not putting x equal to 0. I am tending towards x equal to 0. Always remember it, right? And again, they are asking me the value of the limit. So I am not calculating left hand limit or right hand limit because they are asking me the value of the limit, right? I know my left hand limit will be equals to my right hand limit. So this will be equals to x cube, I can take common, this will be 1 by 3 minus 1 by 6 divided by 1. So this will be 1 by 6 basically. So 1 by 6, is it 1 by 6? Sorry, 1 by 3 minus 1 by 6, right? Okay, 1 by, this will be, oh sorry, okay, so this, both of them are plus, right? Both of them are plus, sorry, this will be plus, right? So this will be 3 by 6, so that is 1 by 2. Okay, so 1 by 2 will be answer. What about here? So again here, right, because again it is not a standard format, because if I divide sin x by x square, it is not a standard format. So what I will do, I will expand till x square, and they have already given me that the limit exists and that is equals to 2, right? So I have to find the value of a and b and c basically, correct? So how will you solve this? So let me break it down, let me break the series, right? So this will be a, what is the cos x series? It is, if you remember, it was 1 plus x square divided by 2 factorial. In cos x, all the even power will be there, and of course sign change will be there. Don't forget, there will be sign change, right? X square divided by 2 factorial, and I will expand till x square. I will not go more than x square because in the denominator I have x square, plus c into sin x. Sin x is what? Sin x is x minus x cube divided by 3 factorial, because I have told you that I will expand till x square only, so I don't need to write the next one, right? I will expand till x square only, because sin x does not have any x square term, it directly has x cube, so I can neglect the higher order terms. This divided by x square has to be equals to 2. So here if I break it down, right, this will be a, like if I break it down, this will be a plus b minus bx square by 2 factorial plus c into x divided by x square. Now the fact is, this a plus b is a constant term, so a plus b divided by this x square minus this x square and x square will be cancelled. Remember, I am not exactly putting x equal to 0, right? I am not doing exactly limit as x tends to 0. Sorry, we are not exactly putting x equal to 0, we are going limit as x tends to 0. So we are finding the limit value. So I can cancel x square out. X is a very small number, so I can cancel those out. So this will be minus b upon 2 factorial, that is 2 only, plus c into x upon x square. So x square will be cancelled. So this will be c upon x, c upon x. Okay. So now if, and this limit is equals to 2, if they are saying that limit exists, if limit exists and limit is equals to 2, if I put here x equal to 0, will this be a valid number? No, this will be some constant upon some constant, let's say some constant 2 upon 0, undefined. This is also some constant 3 upon 0, undefined. What needs to happen? Basically, right, your a plus b must be 0. Then this term will be 0, right? Basically 0 upon a very small number h square, this will be 0. So your a plus b must be equals to 0, then only limit as x tending to 0, very small number, will be 0. Okay, so your a plus b must be equal to 0 and your c also must be equal to 0 only, otherwise limit will not exist, because this will become an undefined format, undefined form, and this is something constant, minus b by 2, right? And so your minus b by 2 will be what? So your a plus b should be 0, c should be equals to 0, and minus b by 2 should be equals to what? Should be equals to the value of the limit, because the limit is this value, right, 2. So all these are gone, these are all 0, right? So only minus b by 2 will be equals to 0. The limit already they have given me, right? So minus b by 2 will be equals to 2. So your b will be equals to minus 4. So if b is minus 4, your a is 4. Okay. A is 4 and your C is 0. These are my ABC values. So you have to think this much. Actually, the method that I will teach you next, right? With that method, you don't have to think much. You don't have to think much. So that is the L'Hopital's method. So let me use the L'Hopital's method here. So if I want to use the L'Hopital's method, first of all, to use the L'Hopital's method, you must get either a 0 by 0 format or a infinity by infinity format or a indeterminate format, right? So here, if I put like every time from now onwards, you will solve the limits, you will solve using L'Hopital's method, right? So if I put here x equal to 0, this will be a, cos of 0 is 1, so a plus b, and this is anyway 0, right? Sin 0 is 0, so that is gone, upon 0. So for limit to exist, this should not be a constant number, right? This also has to be 0, as I have mentioned here as well. So a plus b must be equal to 0 for limit to exist. It must be, then only I will get a 0 by 0 format. So a plus b will be equal to 0. That is my first condition. So I get a 0 by 0 format. As soon as you will get a 0 by 0 format, what you will do? You will differentiate both denominator and numerator. So if I differentiate the numerator, right, this will be b into minus of sin x, right, differentiation of cos x, minus of sin x, plus c into differentiation of a is 0, right, it is a constant number, plus c into cos x, upon differentiation of x square is 2x. Okay. Now if my x, again if I again what am I receiving is, if I put x equal to 0, this will be 0, right, and this will be c. So again c upon 2 into 0 is 0. So again I am getting c upon 0. So this will become undefined, right, if c is a non-zero value. So c also has to be 0. Otherwise this will be some 1 upon 0 undefined. So if it is undefined, limit will not exist, right? But in the question itself they have given me limit exists. So c also has to be 0. So I got two conclusions. C is equal to 0, a plus b equal to 0, right? So again I will get a 0 by 0 format. Again I will derive. So again I will take the differentiation. So this will be, if I take the differentiation, this will be minus of b cos x minus of c sin x upon 2. Okay. So now if my x is, now if I put x equal to 0, what will happen? Now if I put x equal to 0, this will be what? Minus of b into cos of 0 is 1, minus of b upon 2. Now this is nothing undefined, right? And I know this limit value. What is the limit value? 2. So from here I get my b value, that is minus 4. So that's how you solve using L'Hopital's rule. So don't worry, previously I told you, right, to remember the series. Actually, even if you don't remember the series, then also you will be able to solve, because you will be using L'Hopital's rule. But it will be lengthy. If you don't remember the series, it will be a bit lengthy. That's the disadvantages. Okay. So that is how L'Hopital's rule. We will see how can we solve using L'Hopital's rule using the same limits. So this is again, we solve this using series. Now we will solve this using L'Hopital's rule, right? Simply what you will do, you will put x equal to 0. If I put x equal to 0, it is tan of 0, that is 0 minus 0, 0 minus 0, correct, divided by 0 cube 0. So I am getting a 0 by 0 format. So yes, I can apply the L'Hopital's rule. You can only apply the L'Hopital's rule if you are getting 0 by 0 format, correct. So now I will differentiate the numerator and denominator with respect to the variable that is changing, that is x. So the differentiation of tan x is sec square x. If you don't know, I will show you a few standard differentiations, like as we go to the differentiation chapter, right? We have not even learned what is differentiation, but like I hope this basic differentiation you know, right? Differentiation of tan x is sec square x, okay, and differentiation of sin x is cos x. So basically what do I have to do? I have to differentiate the denominator thrice, because it will become x cube, then it will be 3x square, then it will be 6x, then it will be 6. So till the time it reaches to 6, right, then only the denominator will be some non-zero value, otherwise it will always be 0 if I make my x 0. So I have to differentiate this thrice, so it is a bit lengthy, right, because differentiating this terms thrice in the numerator is difficult. Denominator is easy, but numerator will be difficult, you will see. So differentiation of sec square, so upon differentiation of the denominator 3x square. So basically I have to differentiate till the time I get a normal determinate form. Again this is a indeterminate form, right? If I put x equal to 0, what is sec square 0? So sec square 0 is 1 by cos square x, right? What is cos of 0? Cos of 0 is 1, so 1 by 1, that is 1. So sec square 0 is also 1. Okay, so 1 and cos x is also, cos 0 is 1, so 1 minus 1, again I am getting 0, again in the denominator also it is going 0, so again I am getting 0 by 0 format. Again I have to differentiate, so I have to differentiate cos x, sec square x, right? What will be the differentiation of sec square x? So if you know very well, if you don't know, you have to anyways remember this. Differentiation of sec x, right, equals to sec x tan x. Differentiation of sec x is equals to sec x tan x. That is what my differentiation of sec x is equals to. Okay, so now right, okay, now what will be the differentiation of sec square x? I will apply the chain rule, right? So I hope you know how to apply the chain rule. So first I will differentiate the outside function, that is it will become 2 sec x, then I will differentiate the inside function sec x tan x. Okay, and differentiation of cos x is minus of sin x, so this will be plus sin x upon 6x. Again still this will be 0 upon 0 format, right? So because this will become tan of 0 is 0, so ultimately this will be 0, and this is sin of 0 is 0, so 0 divided by 0, again 0 upon 0 format. So again I have to differentiate, which will be hectic. So okay, like I'm thinking of something. Yeah, actually without differentiating also you can solve it. Now without you can differentiate once again, that is one option. Another option is you can replace your sec x, right, in terms of sin x and cos x. So this will be what? This will be 2 by cos square x, 2 by cos square x, okay, into sin x upon cos x. So this will become 2 upon cos cube x into sin x upon 6 into x. This is one term, I am just dividing 6x by both of this term, and this is also sin x upon 6x. And I know what is sin x upon x, limit as x tends to 0, that is 1. This also is 1. So ultimately this will be what? And what is cos of 0? 1. So this is not a problem, right? So 2 upon 1 into 1 upon 6 plus 1 upon 6. So this will be 1 upon 2. Okay. Have we got the same value previously? Yes. 1 upon 2, right? So that's how you can solve. Like you can solve with a combination of both standard, how to solve standard limits, L'Hopital's rule, and series. So that is the best mixture, right? Because if I try to differentiate this again, this will be very lengthy. So I paused for a second and I checked, can I solve it in a different manner? So that's why actually learning all the methods is important. It's not like if you just learn L'Hopital's method, that will be enough. Yeah, that will be enough, but this will be lengthy, right? That's why you can use different methods. So these are few standard differentiations. You can pause the video and take a note of it. Okay, I will not explain because I hope like you already know few these things, because if you have studied 11th and 12th, you will be knowing these things. Okay, now we have solved 0 by 0 format, infinity by infinity format, infinity minus infinity also we have solved. Now we will solve this format, 1 raised to the power of infinity. So for this there is few standard results. So 1 plus x, like this is 1 raised to power infinity, this will always tend to exponential, or this, right, this also tends to exponential, like infinity raised to the power of 0. Both of them will raise to exponential. There are derivations, I'm not going into the derivation right now. So remember these two formats. So basically if in place of x, this will become f of x raised to the power 1 by f of x, right, this also will be e. We will do few questions, there we will see. And this also, if it is like in place of x, this will be f of x raised to the power f of x, this also will be e. Okay, we will do a question. Let's do a question here. Okay, so okay, there is, okay, this is one of the format, there are other formats as well. So now the thing is, like basically what am I talking? So if let's say this is 1 plus x square raised to the power 1 by x square, and limit as x tends to 0, this also will be e, right? So whatever I have here, this must be present in the power, right? Let's take another example. Let me take this example, that this is x square minus 1, or not minus 1 actually, okay, x plus 1, x plus 3x plus 1, and here I have 1 upon x square plus 3x plus 1. So here, right, what is limit as x tends to 0? Is it e? No, right? Because like why was it e? Because here this was 1 upon 0, 0, right? 1 plus 0 raised to the power infinity. But is, if I put x equal to 0, is this going to 0? No, this is going to 1. Is this going to 0? No, this is going to 1. So 1 plus 1 raised to the power of 1, which is 2, right? So don't like mug the things up that if I am always putting x tending to 0, this will be always e. No, no, no. When this function goes to 0, at that point the limit will be e. Otherwise, anyways, you can directly put the value of x, right? You can calculate the value of this function directly without doing this limits business, right? So okay, yeah, so what will be the case here? So when is it going to 0? Minus 2 minus 1, no. Oh, let me choose another value actually. Let me choose this value, plus 2, plus 2. So at, if my x is going towards negative 1, then this function is going towards 0, then this function is also going towards 0, right? So then the limit, this limit value will be exponential e. Okay, I hope it is clear now. Now there are few other formats. Let's say I have this format, 1 plus this x square plus 3x plus 2 raised to the power 1 plus x square plus 3x plus 1. Now if I put limit as x tends to 1, sorry, minus 1, now will this be e? No, these things are different here, right? It will not be e anymore. So what do I need to do? I need to make these things same. So I will multiply and divide by this term. That is what I am doing here. I am multiplying and divide by this term, like while deriving the step. That is what I have done. So what I will do is limit will stay same. This will also stay same, x square plus 3x plus 2. This will be x square plus 3x plus 2 divided by x square plus 3x plus 2 and this term is still this term will still be there, right? This will be still here. I don't have space, so I'm writing it. So now this limit will be e, correct? So this term will be e. So this will be e raised to the power of limit as x tends to minus 1, this term x square plus 3x plus 2 upon x square plus 3x, sorry, okay, no, 1 by f of x, right? Sorry, this will be 1 by, no, this is correct, yeah, because 1 by f of x will be anyways there, because this is the proper format. This will be f of x into g of x. G of x is this, sorry, g of x is in the top, right? It is not in the numerator, right? It is in the top actually. Sorry, okay, this is still in the numerator actually. So this will be this upon x square plus 3x plus 1, okay, which is basically 0, because this is, if I put minus 1, this will be 0, 0.1 is 0, so e raised to power 0 will be simply 1. So this result will come out to be 1, because your f of x most probably will always be mostly be 0, but sometimes what will happen, you will get like this will be 0 always, but here this will be 1 by 0 or some 0 by 0 format. So then you have to solve this limit. That's why I have written the generalized term, because g of x, if it is some non-zero value, that is fine, but if it is some undefined value, right, like this 1 upon 0, then you will get a 0 by 0 format. Then you have to solve the limit, then you have to solve this limit, e raised to power this limit, okay. In format 3 again, if I have f of x raised to the power g of x, you will subtract and like add and subtract 1, and then you will solve this particular, however I have solved here, right, you will solve this limit, okay. Let's do an example, with this you will understand it better, okay. So first of all, you put x tending to infinity. If I put x tending to infinity, what is happening? This is, if I take x square common, the coefficients of x square will remain, all the other coefficients will be 0. So this is 1, this is 1, so it will be 1, and x is tending to infinity, raised to power infinity, because this is x, right. So this will be 1 raised to power infinity, this will be 1 raised to power infinity. So that is a problem for us, because how will I solve 1 raised to power infinity format? That is what we have learned, right. So this is the fourth format, that is g of x or f of x raised to the power g of x. So I will add and subtract 1, add and subtract 1 to get back to this format, right, okay. So what I will do is, I will do 1 plus x square plus 5x plus 3 upon x square plus x plus 3 subtracted by 1 raised to the power of x. So this will be, I can solve this, right, this will be what, this will be 1 plus x square will be cancelled, 4x, yeah, 4x upon 3 also will be cancelled, plus 3, raised to the power x, okay. Okay. Now this becomes 1 plus f of x raised to the power of g of x, but I need f of x here, right. So I will multiply and divide by f of x on the power. So this will become I can copy this, right, this will be raised to the power of multiplied by this and divided by this, right. So this will be 4x upon x plus 3 into, of course, x is there. So remember, what is your standard format? 1 plus f of x, 1 upon infinity, right, divided by 1 by f of x. So if this is f of x, I have to choose 1 by f of x. So this can come outside. This will be the standard format, right. So what will be left? So this whole thing, right, this thing will be E. This will be E. Limit, now what is x tending to? X is tending to infinity. Limit as x tends to infinity, I can take the limit inside the exponential and I will write this term multiplied by x. X is left outside, right? So this will be 4x square. So what is the answer? Like I will only choose the coefficient of the highest powers, 4 upon x, right? So this will be 4 upon 1, that is 4. So this will be e raised to power 4. Okay, that's how simply you solve these kind of questions. Okay, I hope that part is clear. Now there are there are more types of solution. Where is that? Okay, there is another kind of solution, that is 0 upon 0 raised to power infinity. 0 raised to power 0 and 0 raised to power infinity. Sorry, infinity raised to power 0. How do I solve? So I have already solved 1 raised to power infinity, right? So let us solve with this. So if my x is tending to 0, right? What is cot h? Cot of 0? Cot is inverse of tan, and tan of 0 is 0. So it becomes infinity upon 0 raised to the power 0, right? So how will I solve it? So okay, for this you always need to solve using logs. For this you always need to solve using logarithms. So you assume that I have a value that is L, that is the limit, right? Limit exists because I don't need to calculate the left hand limit and the right hand limit, because already they have given me, it is NAT type question. So limit must exist, right? Limit will definitely exist. So limit as x tends to 0, this will be cot of x raised to the power of x, okay, is equals to L. What I can do, I can take log on both sides. If I take ln of L, this will be equals to ln, I can take the log function inside the limit, okay. So limit as x tends to 0, ln of cot of x raised to the power of x. Okay, so this will be limit as x tends to 0, x ln of cot x, right? Okay, now how will I solve it? So what is cot of 0? Cot of 0 is infinity, right? Cot of 0 is infinity, ln of infinity. So what I can do is I can write this in this format. This will be limit as x tends to 0, ln of cot of 0, cot of x upon 1 by x, right? The same thing, right? Same thing. But this helps me to get to a certain format. So let me actually do this bottom. I am just going above my, I don't have space. So let me do this over here. So here, right, it is ln of cot of x upon 1 by x. So now what I can say is this is nothing but infinity over infinity format, because cot 0 is infinity, right? And 1 by x, 1 by 0 is also infinity. So I can use the L'Hopital's rule. So I will differentiate both the numerator and the denominator with respect to x. So differentiation of log, right, is 1 by x. So it is again chain rule, 1 by cot of x. So don't worry if you don't understand differentiation, that will be taught to you like in the next few sections, right? But I hope you know basic differentiation. So that is my expectation. You know basic differentiation. You know what is chain rule. I will teach chain rule, but at least like I hope like you have studied 11th like you know chain, what is chain rule, right? These things you know. Okay, so this will be 1 by cot x into the differentiation of the inside function. Differentiation of the inside function is, what is the differentiation of cot x? It is minus of cos x square x. So unfortunately you have to remember it. If you don't remember it, you have to remember it like this. Your cot x is cos x upon sin x. Okay, so I hope you know how to find out the differentiation of a quotient function, right? Like I hope you know. So you can derive the differentiation. So differentiation of cos x is cot x is minus of cos x of x, and divided by differentiation of the denominator. Differentiation of 1 by x is minus of 1 by x square. Correct. So okay. Now I can replace it in terms of sine and cos, right? So this will be what? This will be sin x upon cos x into minus minus will go away, 1 by sin square x upon 1 by x square. So this will be equals to x square divided by sin x into 1 by cos x. Okay, so what is this equals to? So ultimately, right, this sin x upon x or x upon sin x, limit as x tends to 0, this is equals to 1, right? So I can actually write x only here and I will write the other x here. So this value is actually 1 if x is tending to 0. And what is this value if x is tending to 0? It is 0 upon 1, which is 0. So 1 into 0 is 0. So this whole limit value is actually 0. So this ln of L is actually 0. So my ln of L 0, and I know what is my L. L is the limit, right? L is the limit value. So my L will be what? L will be e raised to power 0. So I hope you know how to break down the 0. Okay, like I hope you know how to break down the logarithms. Okay, so L will be e raised to power 0, which is 1. So my expectation is you know how to break logs. If ln of L is 0, then I can break down my L to e raised to power 0, right? So I am just doing anti-log, taking anti-log. So your limit value is actually 1. So that's how you will solve these questions. That's how you will solve these kind of questions. Okay. Then there is this question. Whenever greatest integer function will come, right? If you have to find out the limit in a greatest integer function, always plot the graph. Always plot the graph. Okay. Never just keep it as it is. Whenever greatest integer function is there, please plot the graph. So if I plot, like I have to find out the as x tends to 0, cot inverse of cos of x. Okay. So what is my value of cos x as my x tends to 0? So cos x function is somewhat like this, right? So if I am coming from the left hand side, it is somewhat lower than 1. If I am coming from the right hand side, then also it is somewhat lower than 1. In both cases, it is somewhat lower than 1 because I am approaching. Remember, x is approaching 0. X is not equals to 0. So if I am coming from the left hand side or from the right hand side, it is something less than 1, right? Exactly, it is 1 at x equal to 0. So what is the greatest integer of 0.9999999 whatever, right? It is simply 0. So I have to find out the limit of cot inverse of 0. Now I hope it is clear. What do I need to find out? I have to find out the value of cot inverse of 0. What is cot inverse of 0? Right? So basically, if you ever tend to forget, right, how to find out the inverse, you will write theta equals to cot inverse of x. Okay, and so your cot theta will be equals to x. So what is x in our case? 0. So for what value of, not cos theta, for what value of cot theta is 0. So for what value of theta, cot is 0, cot of theta is 0. Do you remember the graph of tan x? Tan x graph was something like this, right? Cot x graph will be just the inverse, because tan x was equals to 1 by cot x, or cot x was equals to 1 by tan x. So whenever it is approaching minus infinity or plus infinity, it will be 0. So basically the graph will touch 0 at pi by 2, or directly you can see what is the value of cot x, cos theta upon sin theta. So when does my numerator go to 0? At pi by 2, minus pi by 2. So that's why your answer will be pi by 2. Your answer will be pi by 2. Okay, that will be your answer. I hope it is clear, because what was the domain of cos theta? Do you remember? Everything will come into picture here, right? So domain of cos theta was 0 to 2 pi, because your cos theta is like, I have to take all the unique values of cos theta, which is from 0 to 2 pi, right? All the unique values of cos theta. So cos theta is 0, sorry, the domain of cos theta was not 2 pi, sorry, domain of cos theta was 0 to pi. Okay, because I have to take all the unique values of cos of theta, right? So that's why domain was 0 to pi, and in this domain, where does cos theta goes to 0? At pi by 2. So that's why the answer will be pi by 2. Remember, if nothing is mentioned, they are asking in radians. Don't put degrees, always put radians. So pi by 2 will be your answer, that is 1.57. So whenever greatest integer function will be there, always try to solve using graphs. Okay, so I have tried to give you a holistic picture of limit. Of course, I cannot teach every single thing, right? Because that I have already taught in my full course. Okay, so that is what I have tried to do here. So let's now discuss about continuity. So let's begin with part like this continuity portion. So what is continuity? So continuity can be simply defined for a graph. Okay, y equal to f of x as continuous if we are able to draw the graph easily without lifting the pen. What do I mean by this? So here, right, this is a function. Let's say y equals to x is a function, right? And can I draw this function without lifting my pen continuously? Yes. Then the function is said to be continuous. Here, this is also almost like not y equal to x, this is some linear function, but here, right, this the function is not defined at x equal to 1. The function is not defined at x equal to 1. Basically, the value of the function is not defined. So if I try to draw the function, right, I will draw it without lifting my pen. I will draw, but here I have to stop. If I draw here, right, then the value is existing, but I cannot do it. So I have to lift my pen. Then again I have to start after 1 and continue. So how am I drawing? So I'm drawing this graph. Again I have to stop at this x equal to 1. I have to lift my pen and again start from after 1, right? I cannot write the value of the function at x equal to 1. So function is not continuous at x equal to 1. That is the basic meaning of continuity, right? So that is how we represent graphically what do I mean by continuity, but mathematically how can I explain continuity? Continuity basically means the function will be continuous at a particular value if the left hand limit is equals to the right hand limit is equals to the actual value of the function at that particular point. Okay, the left hand limit, right, how to calculate the left hand limit I have told you, somewhat less than c. Basically I am coming from the left neighborhood, I am coming from the right neighborhood, right, and exactly at the point the value of the function, all these three values must be same mathematically, then only my function is said to be continuous, right? So functional value is the value of the actual value of the function, right? There is no exact relationship between functional value and continuity. If the functional value at that point exists, it does not mean that the function will be continuous. Can I share an example for you? So the simplest example will be like your function f of x equals to mod of x or x upon mod of x when x is not equal to 0, right? And for x equal to 0, it is 0, the signum function basically. So what was the plot of the signum function? For x greater than 0, this was positive. For x less than 0, this was negative. There was a open circle here and this was dot. So both the functional value exists, right? At x equal to 0, function is defined actually. X equal to 0, function is defined. Functional value exists. But is the function continuous? No. Why? Because the left hand limit is what? If I am coming from the left hand side towards 0, what is the left hand limit? -1. If I am coming from the right hand side towards 0, what is the right hand value? 1. Both are first of all not equal. And if you try to draw the function with your pen, right? Let's draw the function with our pen. So I am starting here, and because at x equal, I have to lift up my pen, right? Then again I have to put a dot over here, because at x equal to 0, this is the value. Then again I have to lift up my pen and then again start from this point. I cannot do like this, right? I cannot do like this, something like this, no. Because at x equal to 0, the value of the function is 0. So I will go till very near to 0 from the left hand side. I will go very near to 0. Then again I have to lift up my pen and then again touch here at x equal to 0. And then again, if I want to go beyond x greater than 0, then again I have to lift up my pen, because I cannot go like this, right? Because this will be graph, but this is not the graph. The graph is this, right? So I have to lift up my pen and then again start from this point and go beyond 0. So at x equal to 0, function is not continuous. Graphically I have told you, mathematically also you can check using the limits. You can see left hand limit is -1, right hand limit is +1, and at x equal to 0, the value of the function is 0. So all of the values are different, left hand limit, right hand limit, and obviously the value of the function at x equal to 0. Okay. Yeah, so that was about it basically. So that's how we will check the continuity. So continuity, actually the thing is, we can only check continuity at a point. So we can also only check limit at a point. We cannot check limit at multiple points, right? Because this whatever limit definition we have learned, we can only check limit at a point. Continuity also we can check at a point. So if they are telling me to check the continuity of f of x, right? So we can only comment about the continuity at a point. So if x is not equals to 1, because x is not in the domain of 1, right? So I can simply solve this, right? Without if x is not equals to 1, for x not equals to 1, will the function be continuous? I can say the function will be continuous before x equals to 1 and after x equal to 1, but exactly at x equal to 1, the function will not be continuous. Because if you try to draw the function, right, this function, this will be what? This will be simply x plus 1 basically, right? X plus 1, that is what I have drawn here, right? So beyond x, right, do I ever have to lift my pen? No. Sorry, beyond 1, x equal to 1, beyond x equal to 1, do I ever have to lift up my pen? Never. Before x equal to 1, do I ever have to lift up my pen? Never. I never have to lift up my pen here. I never have to lift up my pen here, right? Only at x equal to 1, once I have to lift up my pen and then again restart from 1 plus. So beyond x greater than 0, it is always continuous. X less than 0, it is always continuous. At x equal to 0, we can actually check the continuity. First of all, the function itself is not defined at x equal to 1, right? Sorry, not at x equal to 0, sorry, at x equal to 1. First thing is, function is not defined at x equal to 1. So if function is not defined at x equal to 1, then you can safely say function is not continuous. But still, let us calculate the left hand limit and the right hand limit. How to calculate the left hand limit? So it will be limit x tends to 1 minus. So what will I replace with 1 minus? It will be 1 plus 1 minus h, where h is a very small positive number. Okay, so that is what I have replaced over here. 1 minus h, the x will be replaced with 1 minus h, right? If you see here, x has been replaced with 1 minus h, and h is a very small number that is tending towards 0. So this will be 1 minus h whole square minus 1, 1 minus h minus 1. Okay, so now if we solve this, right, what will happen? I can solve this again, like you can cancel things out here, because it is not exactly going towards 0. This is not exactly 0, right? This is not exactly 0. like it is tending towards 0. So I can cancel these things out, ultimately it will come out to be 2. So the left hand limit is coming out to be 2, and the right hand limit if you also solve, right, here if you solve the right hand limit, now what will you replace? You will replace with 1 plus h. Here I am replacing with 1 plus h. So again if you see some cancellations will happening, and the right hand limit also will come out to be 2. So both left hand limit and right hand limit are equal, but the function value at x equal to 1 I don't know. So still the function will not be continuous, because at x equal to 1 function is not defined. But if I have a some function like this g of x that is written like this, that the definition of the function is this: when x is not equal to 0 and when x is when x is not equal to 1 and when x is equals to 1 it is 2. So now it will become continuous. So we have made some modification with the function to make it continuous. So we can do it. So first I identified that x equal to 1 it is not continuous. So what I will do, I will make it continuous. So I will define my function at x equal to 1. So now at x equal to 1 the value of the function is 2. So now it is totally defined, right? Do I have to lift up my pen here? No. And both the left hand limit, so if I approach from the left hand side, right, and if I approach from the right hand side, both are approaching towards 2. So the left hand limit and the right hand limit are same. So function will be continuous. Mathematically also I have proven it to you. Okay, so let's solve few questions. I think this one is already solved. Let me solve this. Let me solve this with you instead of like seeing the solution. Let me solve it. Okay. Yeah. So we have to determine the value of a if possible, so that the function is continuous at x equal to 0. So if the function is continuous at x equal to 0, so I have to first of all check if the function is continuous at x equal to 0, then the left hand limit should be equal to right hand limit should be equal to the value of the function at x equal to 0. These three conditions must match. So what is the value of the function at x equal to 0? A. So f of 0 is a. So the left hand limit also should be a. Okay. So what is the left hand limit basically? So limit as x tends to 0 minus f of x. So what is the definition of the function if I am approaching from left hand side of 0? That is something negative. So when x is negative, right, definition of the function is this. So I will replace my f of x with this definition. So this will be limit as x tends to 0 minus 1 minus cos of 4x upon x square. So now what happens is that I see that if I put x equal to 0 here, I am getting a 0 by 0 format, right? So there was a standard result 1 minus cos x by x square was equals to half, right? Limit as x tends to 0. Even if you forget this result, still I can derive it. Okay, so first let me use this result and then I will use it, then I will use L'Hopital's rule. So remember, if I have x here, this is x square. So if I have 4x here, this shall be 4x square. So how to make 4x square? So 4x square, right? So how much I had to put here? 16. So previously what was there? 1. So I have to multiply and divide by 16 basically. So that will compensate, right? That will compensate this extra 4. So to compensate this extra 4, I have to multiply 16. So this will now become limit as x tends to 0 minus. Now what is this value? This value is nothing but 1 by 2. This value is nothing but 1 by 2, correct? So it will be 1 by 2. This limit is 1 by 2 into 16. 16 is 16 equals to 8. Now if you feel confused here, if you have forgotten this identity, I can still use the L'Hopital's rule, right? So I am getting a 0 by 0 format, so I can differentiate the numerator and the denominator. So what was my actual function? Actual function was this, right? This was my actual function, correct? 1 minus cos 4x upon x square. So I will differentiate the numerator and the denominator. So if I differentiate the numerator, it will be 0 minus of minus sine of 4x into 4 divided by 2x. Okay. So again you can differentiate. Again this will be 0 by 0 format. If you want to, again you can differentiate, but now I know, right? I know what is this, like sine 4x upon 4x. I can solve it, but still if you forget that identity as well, still again it is a 0 by 0 format, so again I can differentiate. So if I differentiate, like what will be this? This will be actually 2 of sine 4x upon x, correct? So again it is a 0 by 0 format. If I put x equal to 0, so again I will differentiate. So this will become 2 into 4 into cos of 4x upon 1. Okay, so this will be if x is 0, so this will be 8. Okay, 8 will be your answer for this question. Not answer, sorry, not answer. This will be the left hand limit. Okay, so we have to still, we are still a long way to go. We have to solve the right hand limit as well, right? So let me solve the right hand limit as well. So this was just the left hand limit. So what is the right hand limit? It is limit as x tends to 0 plus f of x, right? So that is basically under root of so yeah, this will be so x of 0 plus. So basically I am approaching from the positive side, right? So when x is very small value but very small positive number, so if x is positive number, right, then the definition of the function is this. So this will be under root of x upon under root of 16 plus under root of x, and then I will have minus of 4. So if I put x equal to 0 here, right, this will be 0 upon 0, 0 by 0 format again. So whenever these under roots are there, right, don't tie L'Hopital's rule, always try to rationalize. So I will multiply by the factor of this, right? So this will be under root of x, because if you differentiate under root, right, if you differentiate under root, things will be very complex. So first of all, I don't like under roots, so I'll rationalize this term. So this will be 16 under root x plus 4 upon, now I'm just doing the rationalization. So this will be a square minus b square. So a square is, this is whole under root, right, this whole square. So this will be 16 plus under root of x minus b square, that is 16. So yeah, so now what will happen is this will get cancelled, under root x is here, under root x is here, so that will get cancelled. So ultimately, how am I cancelling it? Because my limit is tending towards x 0 plus, right, but it is not exactly equal to 0, that's why I can cancel it. It is a very small number. Basically what they do, they assume this x tending to h, where h is very small number, so this becomes under root h, this becomes under root h, and then they cancel. Okay, so those are like properly if you want to solve limits, right, but we are solving for competitive exam, so हम कुछ rule नहीं मानेंगे, ऐसे ही कर देंगे सब कुछ. Okay, so we will cancel the under root x, so this will become 16 plus under root x plus 4. So now I will put x equal to 4 here, x equal to 0 here. If I put x equal to 0, so this will be under root of 16 plus 4, so this will be 8. Okay, under root of 16 plus 4, so this will be 8. So the left hand limit is equals to the right hand limit, and the value of the function is a, and they are telling me that the function is continuous, then a has to be 8. This will be my answer. Okay, so yeah, I hope that point is clear. How to check continuity, how to like this portion is clear, how to check continuity. So there are a few things. regarding continuity. So if a function, up until now what we have learned, we have only learned to check the continuity at a point, right? I don't know how to check the continuity in a range. Okay, so let's say like that also we'll discuss how to find out the continuity in a range. So let's say I have a function that is defined that belongs to that belongs between point A and B, like this AB. Okay, so now they are asking f of x is said to be continuous at left end x equal to A. So if my function is only defined between A and B, right, how can I, like, what will be the continuity at x equals to A? Because for this function, right, the left hand limit will not exist, correct, because function is not defined. So basically what we do, we skip the left hand limit, we only check the right hand limit. So for this lower limit, because the function is not defined at left hand side, so we only check the right hand limit and the value of the function at that particular point, that is f of A. Now we are ignoring the left hand limit. So if these two values are same, that means the function will be left continuous. Similarly, in case of the right hand side, we will ignore the right hand limit. So I think I have written the same thing here. Yeah, we'll ignore the right hand limit. So we are only checking for B minus and B. We are not checking for B plus. Okay, so that's why, because the function is not defined for these after these points, right? That's why. Now there are few cases for checking continuity. So for a certain case, if the left hand limit and the right hand limit and the value of the function all are same, but all of them are plus infinity. So if all of these are plus infinity, then you can say that limit will exist for the function, right? Limit exists at C because the left hand limit and the right hand limit are same, but function is discontinuous, because can you ever touch infinity with your pen? No. So function is discontinuous at C, but limit exists. Okay, like something like this, right? 1 by x square. So if I try to approach from the left hand side, if I try to approach from the right hand side, you will see that both of them are approaching infinity, correct? So limit exists, but is the function continuous? No, because I can never touch infinity, right? So the graph will be somewhat like this. If you remember, the graph will be, I guess, 1 by x square, right? Graph will be somewhat like this. So both are approaching infinity, right? But like, can I touch it ever? Can I ever touch it? So basically, can I go from this negative side to positive side without lifting up my pen? No, right? So it will go to infinity. I can never touch infinity, right? It will also go to infinity. So I can never touch it. So that is the problem. So that's why function is not continuous. Okay. Now case 2 is both the left hand limit and the right hand limit are equals to L, but the value of the function is something else, M. Then the limit exists again. Limit will exist, but the function is said to be discontinuous. Something like this, right? If I have a function, let's say something like this, just a random function. Okay, so if I am approaching from the left hand side, I am going towards, let's say this point is 1. Okay, I am touching 1. If I am approaching from the right hand side, I am touching 1, right? And exactly at x equal to 0, it is 0, correct? It is 0. So so that is a like, I cannot complete my graph without lifting up my pen. So again, the function is discontinuous. But does limit exist? Yes. So limit, continuity, functional value, all these things are different. And trust me, in gate industry, no one will explain you these things. So in gate industry, right, the amount of time that I am giving to limits in a revision video, right, they don't even give this time to full course video. So they will teach you limits in 2 hours in full course. Trust me, I know how they teach, right, everywhere else in institutes. But I am teaching you limits in revision video for like more than, like including functions, it has been almost 3 to 4 hours, right? So if you are enjoying this, right, please hit the like button. Now I do understand, like, I cannot cover every single thing, right? Like what will be the differentiation of log x, what will be sin x, what is the expansion of sin x. Like I have tried to explain in a fast manner, because for the students who already have bit of knowledge, they can study, right? If you don't have no knowledge, if you have no knowledge, right, zero knowledge, then you have to follow the full course. Okay, then you have to follow the full course, unfortunately, because like this is a revision video. Students are preparing for gate 2026, and like only 6 months, only 4 to 5 months is left, right? 4 months is left around. So they already know the concept. All they need is revision. So the purpose of this video is revision. Okay. Okay. So yeah, if you are enjoying, like, then please hit the like button and comment down below how are you feeling the revision series. Okay. So yeah, if these values are different, then it will be discontinuous. Now case 3 is when all of these are equal and it is finite, then it will be continuous. If left hand limit and right hand limit are not equal, then limit does not exist. Then function, like if limit does not exist, basically function will always be discontinuous. So you should never talk about continuity if limit does not exist. If limit does not exist, right, function will be always discontinuous. So the same thing I have written here. If limit of a function at a point does not exist, then function is discontinuous. So you don't have to worry about continuity if you know the limit of that particular function does not exist. So first you will check the left hand limit, right hand limit, you will equate those, then you got to your result, conclusion that yes, limit exists. Now you will equate that value with functional value. So if it is equals to functional value, then you will say that function will be continuous. Okay, so the statement is but if limit exists, function may or may not be continuous. You have to check. You have to put the value of the limit and check it with respect to the actual value of the function at that point. If those are equal, then the function will be continuous. Okay. Now conversely, I can say if a function is continuous at a point, then the limit must exist at that point. Do you agree with me? So I told you that if limit exists, right? If limit does not exist, right? If limit for that function does not exist, function will not be continuous. Okay. Now if limit exists, then we have to check whether function is continuous or not. But if function is continuous, definitely limit has to exist, otherwise this statement will deny the fact, right? So if function is continuous, limit will exist. So if a function is continuous at a point, then limit must exist, right? So this is a very, very important conclusion. So if you know about the continuity of the function, then definitely 100% you can say that the function will be function, then the limit also will exist at that particular point. Okay. So these are my case 3, 4. Now case 5 is there if the limits are oscillatory in nature. So let's say sine of 1 by x. Okay, both you will see the left hand limit. So what is the left hand limit? It will be sine of minus of infinity. The right hand limit will be sine of plus of infinity. So both are oscillatory. I do know, yes, this will be between minus 1 to 1. This also will be between minus 1 to 1. I know. And what is exactly sine of 0? It is also between minus 1 to 1. I do know. So all of them are oscillatory, but I cannot say all of them are finite. But I cannot comment, right? I cannot comment exactly what value. So that's why the function will not be continuous at x equal to 0. Okay. So yeah. Now how do we remove discontinuity? Okay, there are many ways to remove discontinuity. How do I remove discontinuity? By doing this, right? So previously, if my function was only this x square minus 1 x minus 1, so it was discontinuous at x equal to 1. So what we do is we find out the left hand limit, we find out the right hand limit, and then we modify, we exclude x equal to 1 from the actual function domain, and we write exactly the value of the function at x equal to 1 equals to the left hand limit and the right hand limit. So this is how we can remove discontinuity, correct? Because if left hand limit and right hand limit are equal, but the value of the function at that particular point is not defined or it is not equal, so we can exclude that function, exclude that particular point from the function and include it with the left hand limit or right hand limit. Okay. So I hope this part is clear. So is this function continuous at x equal to 1, f of x? So if I put here x equal to 1, right, what is the left hand limit? So this is x limit as x tending to 1 minus. So that is basically limit as so x will be what? X will be equals to 1 plus h, sorry 1 minus h, where h is a very small number. So as h tends to 0, so x is 1 minus h. So I will replace my 1 minus h over here, 1 minus h minus 1 divided by 1 minus h minus 1. Okay, so this will become a square minus b square, right? So this will be 1 minus h minus 1 into 1 minus h plus 1 divided by h. H is a very small number, not exactly equal to 0. So this and this will get cancelled. Simply 1 minus 1 is 0 and minus h, and minus is there still, right? So this will also be minus, right? Don't forget, this will also be minus. So minus h gets cancelled. So ultimately, if I put h equal to 0 now, this will be 2. And you do the same thing, right? You approach from the right hand side. Okay, how will I approach from the right hand side? 1 plus h. So you will get that is also equal to 2. But here it is 0. So I have to change it to 2. So that is what we are doing. We are defining a new function, right? And we are making the value of that function at x equal to 1. That is the point of discontinuity equal to 2. Now this function will be continuous totally. Okay. So yeah, that's how you basically remove discontinuity. Now there are certain cases where you cannot remove discontinuity. If your left hand limit and right hand limit are not equal, you can never remove your discontinuity, like secant function, right? You cannot remove the discontinuity. Okay, so all these things are there, not that important. So in these cases also you cannot remove the discontinuity, but these are not important, like they will not ask you these things. Okay, so like when your limits will either tend to plus infinity, minus infinity, or oscillatory, you can only remove discontinuity if your left hand limit is equals to right hand limit, but it is not equal to the function value. Then only you can remove the discontinuity. Okay, otherwise you will never be able to remove the discontinuity. So let us solve another question like this one, right? So we have to discuss the continuity at x equal to 0. So if I am putting x equal to 0, it is e square. If I am putting x equal to 0 here, it is 1 plus 0 raised to the power 1 upon 0. So 1 raised to the power infinity. So what is the type? Do you remember? What was the type? So 1 plus x raised to power 1 by x was equals to e limit as x tends to 0. Okay, so these things you have to remember actually. The power series, the power formula you have to remember, right? So this will be what? If I replace this, this will be 1 plus f of x as my x tends to a 1 by f of x equals to e. Okay, so yeah, okay, so yeah, this is the formula, right? So how will I solve it? So if I have 2x over here, here also I need 2x. Do you remember? So what I will do is I will do 1 plus 2x and I will multiply and divide by 2x. 2, I will multiply and divide by 2. Okay, so what is the limit of this one, this term? It is simply e, right? I hope you understand. If I put x equal to 0, this is simply e, right? So this is e into 2. So this is e raised to power 1 into 2. So it is e square. So obviously, like the limit exists, right? So the limit is e square and the value of the function is also e square at that particular point x equal to 0. So function will be continuous. Similarly, you can also discuss the continuity for this function. Is this function continuous? Directly I can say it is not continuous at x equal to 0, because at x equal to 0 they are defining it as 1. Okay, but if I put here, if I am coming from the left hand side or from the right hand side, either it will be sine of minus infinity or plus infinity. Again the value will be something oscillatory between 1 to -1. Okay, 1 to -1. So that is the value, basically the value of the function will be oscillatory. Now how can I discuss the continuity over interval? Because till now we have discussed the continuity over at a point, continuity at a point. So function is said to be continuous in open interval AB if and only if the function is continuous at each and every point. Open interval because excluding the points A and B. Okay. So closed interval, like it has to be continuous at all points excluding A and B. Function continuity in closed interval. So if a function is said to be continuous in a closed interval, like this should be closed interval AB. So first of all, it has to be continuous in the open interval, that is continuous at each and every point between A and B excluding A and B, and at A it has to be right continuous because the function is not defined at left hand side, and at B it has to be left continuous because the function is not defined at the right hand side. I have already discussed what is right continuous and left continuous. Okay, so let's solve this question. With this we will understand. Let me drink a bit of water. So find whether the function is continuous, and if it is discontinuous, then tell which points are discontinuous. So x belongs to 0 to 1, f of x is greatest integer function x, right? So in 0 to 1, between 0 to 1, excluding 0 and 1, right, function is always continuous, right? I can start just after 0 and I can end just before 1. So function is continuous between 0 to 1, I can see from the graph. But if I see at x equal to 0, right, if the function needs to be continuous at x equal to 0, is the function continuous? No. Function is not continuous at x equal to 0 actually. So function f of x is continuous between the range x equals to 0 to 1, not including 0 and 1. Okay, but if I include the point 1, right, so what is the left hand limit? So if I just go just on the left hand side of 0, just on the left hand side of 0, so the function value becomes -1, and if I move just on the right hand side of 0, it is 0. So left hand limit and right hand limit are not equal, so then definitely the function will not be continuous at x equal to 0. Same at x equal to 1. So if they are asking me, okay, so for the case 1, right, function is continuous because x is defined in the open interval, but for the case 2, they are telling me to include 0 and 1, and function this, right, this was defined when my function was not defined before a, right, but here function is defined before 0 and that value is -1. So I cannot just check the right continuity, right, I have to check the LHL as well. So that's why I have written here function for the case 1, right, for the first case function is continuous. For the first case function is continuous in the given interval because it does not include 0 and 1, but as soon as it includes 0 and 1, there is discontinuity at 1 as well as there is discontinuity at x equal to 0 as well. Okay, so how can you calculate the continuity in an interval? Because if you have to calculate the continuity in an interval, you have to check each and every point, right? We only know how to check continuity at a point, so that is like an impossible task because there are infinite values between a and b. So how do we check? So look for possible points of discontinuity. Either if graph is given, directly you solve using the graph. If graph is not given, there will be some dangerous values, like for the values for which your denominator goes to 0. For those values, the function may go discontinuous. Okay, because it is impossible to check every value between a and b. That is what I have written over here, because there are infinite values between a and b. Between 1 and 2, how many values are there? Infinite. 1.001, 1.00001, 1.002, 1.00001. So you can go on, right? So there are infinite values between 0 and 1. So of course you cannot check like that. So you have to check for possible points wherever your denominator goes to 0, those points can be your discontinuity, or whenever your numerator goes to infinity or minus infinity, right? Those points can be your possible discontinuous points, just like trigonometric function tan x. So tan x, if you see, right, at around x equals to pi by 2, it is discontinuous, because just before pi by 2 it is plus infinity, just after pi by 2 it is minus infinity. Okay, so tan x odd multiples of pi by 2 is not included in the domain. Odd multiples of pi by 2 is not included in the domain. Okay, I hope that part is clear. So that's why the tan x function is continuous within its domain. So that's why we don't include pi by 2 and minus pi by 2 in tan x domain. So the all trigonometric functions, logarithmic functions, are said to be continuous in their respective domains. If you remember, that's why we chose the domains as such that the function will be continuous. Now I hope the reason is clear why I was choosing the domains, like from minus pi by 2 to pi by 2, not including pi by 2 and minus pi by 2. The reason was this, that if I have chosen minus pi by 2 and pi by 2, then the function would not be continuous, right? So we will choose, like, within their respective domains, function will be continuous. And if you have a rational function, okay, rational function, then you will always check when my g of x goes to 0 or when my f of x goes to infinity. So you have to check for roots of g of x, which goes to, like, then this will be going to 0 for those roots. Also, if there is some common factor between numerator and denominator, right? As you can see for this, right, for this value, where did it go? Yeah, oh my god, where is it? Yeah, is there some common factor between numerator and denominator? If there is, then that can be a possible point of discontinuity, because here x equal to 1 was a common factor between numerator and denominator. So that's why that was a discontinuity point. So that is how you can check for possible points of discontinuity. Okay, so yeah, now roots of g of x basically means for what values of x this will go to 0. Okay, now if your roots of g of x are coming out to be complex, okay, then the function will be continuous, correct? Because all, like, the domain of x is real, right? So g of x will never go to 0 because your roots are complex, but I can only give real input to the x, right? Let's say your root is 1 plus I 2i, 1 plus 2i, but like x equal to 1 plus 2i is a root. What does it mean? Basically, if I put the value of 1 plus 2i in x in the function g, right, in the denominator, then this will go to 0. That means I will have some finite value upon 0, correct? But x can never be this value, because I will never give my input x as a complex number. X can only take real numbers. So I am safe. So function will be continuous. Basically, that is what is written over here. If the x values are real, then there will be no discontinuity. Sorry, if the x values, like, if the roots are coming out to be complex, then there is no discontinuity. But if the roots are coming out to be real, like x equals to, for x equals to minus 1, my g of minus 1 is going to 0, right? G of x is going to 0. That basically means x equal to minus 1 can be a possible point of discontinuity. You have to check the limits there. Okay, so with this, with this conclusion, can you solve these questions? So I have two, like, numerator upon denominator. Try to find out the possible points of discontinuity. So if I check here, right, at, like, this denominator for the first part, this is going to 0 at x equals to minus 1, like this is x plus 1 whole square, right? So this is going to 0 at x equal to minus 1 comma minus 1. So definitely at, like, and what is the value of the numerator at x equal to minus 1? So 1 minus 1, that is 0, minus 1. So it is minus 1 upon 0, right? So definitely it is not a defined value, undefined, minus infinity. So definitely the function will not be continuous at x equals to minus 1. So function will not be continuous at x equal to minus 1. For the second case, if I see, what are the roots? Basically, the roots will be minus of b, so plus 2 plus minus b square b square is minus 2 whole square minus 4ac minus 8, right? So the roots are coming out to be complex. If you see your discriminant, it is coming out to be negative. So roots are complex. Roots are complex. Okay. So definitely again x only takes real value. So this function will be totally continuous. Totally continuous. For x from minus infinity to infinity, function will always be continuous. For the last one, the roots are x equals to, like you can solve, x will be equals to minus 2 and minus 3. Sorry, plus 2 and plus 3. Am I correct? So at x equal to 2, 2 and yeah, x equal to 2, this will be 10. No, 2 is not a root. What is happening? Oh, sorry. Okay. X equal to minus 1. No, x equal to 1. Okay, let me solve. What am I doing? So 5 plus minus b square 25 minus 4ac 24 upon 2a. What am I doing, right? So मेरा भी दिमाग खराब हो गया. तो this will be 5 minus 1 divided plus minus 1 divided by 2. So this is like basically 3 and 2. सही कर रहा था यार, पता नहीं क्या हुआ. तो if I put here x equal to 2, this will be 2 minus 10 plus 6. But this is not going to 0. What is happening? क्या हो रहा है? b square minus 4ac minus of b, okay, ये 1 plus 1 if I divide by 2, 3 minus 1, 4 if I divide by 2, that is 2 only. तो कहाँ पे गड़बड़ हो रही है? Oh sorry, this should be squared. Sorry, I missed a square here. This should be, वही सोच रहा हूँ भाई, इतना भी भोला नहीं हूँ मैं. क्या हो रहा है ये? Okay, this will be squared. So yeah, now I guess I will be able to do it. So if I put here x equal to 2, this will be 4 minus 10 plus 6, which is 0. Okay. And if I put x equal to 3, then also it will go to 0. But I have to also check the numerator. Do I have a common point in the numerator as well, right? So let me check. So the numerator will be x minus 1 whole square. Correct. So the roots for the numerator is x equals to 1 comma 1. So there is no common point, so I am safe. But like basically the points of discontinuity will be x equal to 3 and x equal to 2. So that is what I have written here. These are complex root. So for the second case, function will always be continuous. But for the third case, function will be discontinuous at x equal to 2 and x equal to 3. I forgot to write a square. What am I doing? This should be square, right? Yeah. Okay. So I hope you can do the, like, your greatest integer function will always be discontinuous around a integer. Around a integer, at any value of integer, greatest integer function will always be discontinuous. Okay. And like these are the key points that I have written here. Greatest integer function, the continuity should always be checked at all points where my function becomes integer, right? Basically greatest integer of x when x is equals to 0, x is equals to 1, x is equals to minus 1, right? At all these points basically I have to check the continuity of the function. Now instead of x, they can give you x square plus 2x minus 1. So now you have to check for those values of x where this function goes to integer. Or let's say this is 1 by 2, right? Not x integer, no, not x integer. Whatever is inside the greatest integer function, if that is integer, then your function is discontinuous about that point, right? So you have to check for those values wherever this function goes to integer. Okay. So I hope that part is clear. Now, yeah. Now what about the continuity of signum of f of x? Continuity of signum of f of x, right? So continuity of signum of f of x should be checked at the points where f of x is going to 0. Basically, I know the signum of x, right, is discontinuous about the point 0. So if I have signum of f of x, so that will be x square plus minus 2x. Now x square minus 2, right? So now is the function discontinuous at x equal to 0? No. At x equal to 0, function is continuous. It is at x equal to 0, it will be what? Secant of -2, that is -1. If I approach from the left hand side or the right hand side, it will be okay. But I have to check where this function goes to 0. This function goes through 0 at x equal to 2 and -2. So at these points actually I have to check whether the function is continuous or discontinuous. Okay. So always remember not x, right? Not x. So what, assume this to be a box. Whatever is inside this box, if whenever this box is going to 0, then I have to check the point of discontinuity. Similarly, for a greatest integer function, whatever is inside the box, when that box goes to 0, I have to check the point of discontinuity. Okay. Also, we have to check the continuity at those points wherever the definition of the function changes. What do we mean by it? So, if you see, yeah, here, right? Or let me take this example. Where is it? Yeah. So at x equal to 0, right? Definition of the function is changing. Before x equal to 0, it was something else. After x equal to 0, it is something else. So the definition of the function is changing around x equal to 0. So definitely what I can say is, like, I have to check the continuity. At these points, I have to simply check the continuity. Okay. So that was about the continuity. Yeah, that's there are a few theorems regarding continuity, like if f of x is continuous, so if I multiply some scalar value, that also will be continuous at that point. If two functions are continuous, if I add the two functions or subtract the two functions, then also the resultant function will be continuous. If I multiply the two functions, then also the multiplied function will also be continuous. But if I am dividing the two functions, it will be continuous at C, provided that the denominator, the value of the function at that particular point is not 0. Okay, or basically not at that point, the denominator function never goes to 0, right? For any value of x, the denominator should never go to 0. Then this result also will be continuous, correct? So I can take example. These are self explanatory. I hope I don't need to explain here, but this I will explain. So let's say x square minus 1 and 2x, right? Both of these functions are continuous on their own right. Any polynomial function, any simple polynomial function is always continuous. So both of these functions are continuous. So if I multiply, add, subtract these two functions, the resultant also will be continuous. If I multiply a scalar 4, 5, that also will be continuous. But if I am dividing the two functions, x square minus 1 divided by 2x, is the function continuous? No. At x equal to 0, there is a point of discontinuity, right? I am getting minus 1 upon 0. So when you are doing the division, just be careful. Okay. Okay. Now this is a interesting theorem about the composite function. So for this, right, you don't need to remember this. Just solve this question. Okay. Try to check the points of discontinuity. Now what is f of g of x and what is g of f of x? What does it mean? F of g of x and g of f of x. What does these two things mean basically? So here, right, f of g of x basically means that your function is f of x, but you will put f of g of x, that is basically x will be equals to g of x. You replace with your x with g of x. So here, right, my x will be replaced with g of x. That is what my f of g of x means. This sometimes is also written as f of g of x. Fork. Now what is g of f of x? So basically you will replace your x with f of x in this function. This is also sometimes called as g of f of x. Okay, please don't get confused with the notation. So I have to check the possible points of discontinuity. So method 1 is like simply you can do the direct substitution. Okay, don't need to remember these theorems, right? All these will be very tedious for you. Just simply do the direct substitution. So this will be f of g of x will be 1 upon g of x minus 5, correct? And what is my g of x? G of x is x plus 5. So this will become 1 divided by x plus 5 minus 5, so which is 1 upon x. So for the first function, right, for the first case, my function is discontinuous at x equal to 0. My function is discontinuous at x equal to 0. Okay, very simple. For the second case, what will be my g of f of x? So I will replace my x with f of x. So f of x, so this will become x will become f of x plus 5, and your f of x is 1 upon x minus 5. So one upon x minus 5 plus 5. So this will be 1 plus 5x minus 25 divided by x minus 5. So what are the possible points of discontinuity? Of course, at x, I can see at x equal to 5, the function is discontinuous. So this is how you can find out the discontinuity if I have function inside a function. Simply do the substitution. Don't need to remember this theorems, right? This will be a bit tedious for you. Okay, then there is one more theorem, that is intermediate value theorem. What does intermediate value theorem states? So the intermediate value theorem says that if a function f of x is continuous on an interval a comma b. Okay, so if the function is continuous between this interval a comma b, if f of a and f of b possess opposite sign, so let's assume that f of a is positive, f of b is negative, then there exists at least one solution of equation f of x equal to 0 in the open interval a comma b. Very simple, right? So you are saying that I have a function that is continuous between 1 to 2, okay, and f of 1 is supposed to be positive, f of 2 is supposed to be negative. So if I have to reach from 1 to 2, right, any possible way you take, you will always have to at least cross the x axis at least one. Like I can cross it twice as well, right? That is also possible. How many times I like, but at least once I have to cross. So that's why it is written at least one solution of the equation f of x, that is this y value equals to 0, will exist in the interval. That's the intermediate value theorem. So the name is very fancy, but it's very simple. Okay, so yeah, the intermediate value theorem says if a function f of x is continuous on an interval a b. Now this was if the signs are different. Okay, remember this will not be valid if the signs are same. So here, right, if the signs are same, let's say this is also positive, then I can directly go like this, right? I don't need to cross this, right? So I cannot comment if the signs are same. If the signs are different, then definitely I will cross my x axis. Now what we do is we actually further enhance this theorem. What do you say is, if I have a value k, right, and if f of a is greater than k and if f of b is less than k, then definitely I will cross through my k point. Okay, or if f of a is less than k and f of b is greater than k, then my f of b will be greater than k, that is I will lie here, and f of a will lie here, then again I will cross my k. So basically I will cross my k no matter what. Okay, so basically understand graphically what am I talking about. So no need to remember all these statements and stuff, right? Understand graphically and plot it. So now let's with the help of this theorem, right, this theorem is actually pretty powerful. We can solve very complex questions with the help of this theorem. So given that a b c d, okay, just give me 1 second. Given a is less than b, is less than c, is less than d, then comment on the nature of the roots of the following equation. What will be the nature of the roots of the following equation? Okay, okay, so a is less than b, is less than c, is less than d. Like already solution you know, but still we have to comment, right? So we have to comment on this nature of the equation. So what I can say is, if my x is greater than d, that is if my x is greater than the largest value, so this will be something positive, because let's assume d is 3, right? So this will be 4. So 4 minus 3 will be 1. So this will be positive. This also will be positive automatically because b is smaller than d. This also will be positive. This also will be positive. This also will be positive. So for x greater than d, right, my function is always positive. So let me mark these points A, B, C, D. D, C, D, B, A, right? So for x greater than D, my value of the function is positive, correct? And exactly at x equal to D, this is gone, right? Because D minus D will be 0, but this will be something positive, right? Because D minus A, let's assume that A is smaller than D, right? And C is also smaller than D. So 2 times positive times positive. So at x equal to D, I will be positive. Let's now check at x equal to C. At x equal to C, this will be 0, right? C minus C will be 0. So this term is gone. But at x equal to C, this will be C minus B, and C is greater than B. So this will be positive. But C minus D, D is greater. I am subtracting from C. D is higher value. So this will be negative, right? So negative times positive is negative. So this overall thing will be negative. So overall at C, right, the value of the function will be negative. Okay, it will be something negative. Now again, what are they telling me? The nature of the roots. So there are, like, it is a quadratic equation, right? Because here also I have x square, highest power is x square, here also the highest power is x square. So I can have only two roots. I can only have two roots, and this is a polynomial, so the function will always be continuous. Okay, now let's discuss x less than or x equals to a. At x equal to a, what is happening? At x equal to a, this is again 0. Now this is a minus b, and b is greater, so this will be negative. This also will be negative. D is greater than a. So negative times negative is positive. So this is 0. So plus 5 into positive will be positive. So at x equal to a, this will be something positive. At x equal to b, what is happening? X equal to b, this is vanished. This will be b minus a. B is greater than a. So this will be positive. And this is b minus c, and c is greater, right? C is greater. So this will be negative. So negative times positive is negative. So overall my result will be negative. So what am I observing? That function is continuous, and I am going from positive to negative, from a to b. So I have to at least cross my x equal to 0 point at least once. That f of x has to go to 0 at least once. Also between d and c, right? At d function is positive, at c function is again negative. So I have to cross at least once. And how many maximum roots I can have? This is a quadratic equation, two roots. So the roots will be real, basically. Roots will be real because here also I have to cross at least once. Let me use different color. At least once. And here also I have to cross at least once, right? And here I cannot cross again because that is out of the picture, because x is real. Sorry, x, so basically like highest power is 2, right? So I can only cross twice. So the function will be somewhat like this. This will be the nature of the function. So what are the nature of the roots? Roots obviously are real because I am crossing my x equal to 0 point. And I can also say what are the range of the roots. So one of the roots will lie between a and b, and the other root will lie between c and d. So that's how powerful this intermediate value theorem is. And no one will teach you all these things, right? And I'm expecting GATE to ask some question like this. They will ask, don't worry. And once they will ask, only you guys will be able to solve. Other guys will not be able to solve it. So that's the advantage of studying from PrepFusion. So now let's finally come to the next topic, that is differentiability. So let's discuss about differentiability. So differentiability we can understand both using graphically and obviously using the concept of limits. So differentiability geometrically, right? What does it mean? Geometrically, the differentiation of function is the slope of the graph of the function at that particular point. What do I mean by slope? So like if I draw a tangent to the graph, right? So here what is the tangent? Like tangent meaning, I hope you remember, if I have a circle, and what is the tangent to this circle? This line, this, all this, right? Which only is straight line that only touches the circle at a single point. Okay, so here the tangent to this curve will be at x equal to a, right? At x equal to a, the tangent is this. The tangent to this curve at x equal to, let's say, some random value is this, right? So now if I have to say that the function is differentiable. If the function is differentiable, let's say at x equal to 0, then if I find the value of the tangent or the slope of the tangent, right, at x from the left hand side, or if I come from the right hand side, both of the tangents should actually match. Both of the tangent should actually match. Okay, like here, right? So let's say I want to check the differentiability at point P. So I will calculate the tangents coming from the left hand side towards point P, and I will calculate the tangents coming from the right hand side towards point P. Okay, so at exactly point P, right, all the tangents will match, then only the function will be differentiable. Okay, so I can show you few places where it will not match. So if I have a modulus function, so if I have a modulus function, the tangent coming from the left hand side, right, is like this, and tangent coming from the right hand side is like this, and both of them are actually not matching with each other. So I say that the function is not differentiable around x equal to 0. So if I say this point, if I am coming from the left hand side, the tangent is this. If I am coming from the right hand side as well, I have same tangent. So from the left hand side, from the right hand side, both of them have same tangent. So the function is differentiable at this point, but I am not talking about this point. I am talking about this point. What about the differentiability at this point? So if I am coming from the left hand side, the tangent is this. If I am coming from the right hand side, the tangent is this, right? So the two tangents are not matching with each other. So I say function is not reciprocal. So basically wherever there is abrupt change, in those points the function will not be differentiable. Now, is this function differentiable 1 by x? It is differentiable and continuous both, but within its domain. What is its domain? X is any real value excluding 0, right? Without 0, if you ever check the tangent, right, at this point, this will match from the left hand side, from the right hand side. Here also, if I check the tangent coming from the left hand side, coming from the right hand side, both are matching. Here also the same thing, right? But obviously exactly at x equal to 0, function itself is not defined, the domain is not there, right? So we will exclude that. So the function is said to be continuous and differentiable in its domain. Okay, so of course we will see mathematical I will show you the mathematical proof as well. So what is tangent? Basically tangent is if I have to find out the tangent, it will be the value of the function just before this point and just after this point, the difference divided by x2 minus x1. So basically I want to find out the slope of this line, right? How can I find out the slope of this line? So I know the equation of a straight line, y is equals to m into x plus c. So let's assume that the equation of this tangent is y equals to mx plus c. So at some value x1, the value will be y1 m x1 plus c, and at some value x2, just after this the value will be, because I have to find out the slope, right? Slope of this tangent, slope is this one, this m is the slope. Basically the coefficient of x is known as the slope, correct? So like I will prove it to you as well, like how is this coefficient coming up, like this proof is there. So basically, and y2 will be m into x2 plus c. So if I take the difference of these two, it will be y2 minus y1 equals to m into x2 minus x1. Okay, so m will be equals to y2 minus y1 divided by x2 minus x1. Okay, that is what my m is equals to. So I hope that part is clear. What is my m equals to? That is my slope. So y2 is simply f of x2 and x2 is x1 is y1 is simply f of x1. Okay, so this is my like slope of the function, or known as tangent. Okay, so for a sine function, right, sine function, if you observe, it is always continuous and smooth, like there is no abrupt change. Now for a greatest integer function, it is discontinuous. So if a function is discontinuous, right, you don't need to check for differentiability at that point. That function will be not differentiable at that point. So basically if I show you, right? So first of all, you check limit. This is the bigger circle. The bigger circle is this, limit exists. First you check limit. If the limit of the function exists, then you check for continuity. If the function is continuity, like if the function is continuous at that particular point, then you go and check differentiability, right? So what is the conclusion? The conclusion is, if the limit does not exist, I don't need to check continuity, right? Because it will not be continuous. If limit itself is not existing, right, that means I will lie outside this circle. If I'm lying outside this circle, why do I need to check continuity? Because if a function is continuous, it has to have, like, the limit must exist at that particular point for the function to be continuous. So if the limit does not exist, I don't need to check continuity. If the limit does not exist, I don't need to check differentiability. Sorted, right? Now, in other way, if I say the function is differentiable, if the function is differentiable at that point, then it has to be continuous, because differentiable is, like, if the function is differentiable, that means I'm lying inside this violet circle. If I'm lying inside my violet circle, of course it is overlapping with continuity, right? So function will be continuous, and also it is overlapping with the yellow circle. So function will be the limit will exist for the function. So if the function is differentiable, then function will be continuous and limit will exist, right? If the function is continuous, so now I am lying in this box. So if I am lying here, right, I cannot comment about differentiability. I have to check differentiability, but definitely I can say that limit will exist for that function. Okay, so this particular thing is very important, right? If this information is given, like this, some question has came in GATE, this question has came actually, that if the function is differentiable, then will it be continuous? Will the limit exist? All these things. Okay, so just keep in mind. Now let's come back to our topic. So here the function is discontinuous. If the function is discontinuous, definitely it will not be differentiable, because you see there is sharp change here, right? So the slope coming from the left hand side, it is simply 0, right? It is 0 here. But what is the value of the function exactly equal to 2? It is undefined, right? So I cannot comment about differentiability. Now this also we have done. So yeah, if differentiation of a function is known, it does not mean that the function is differentiable at all points. Like the very basic example is ln of x. Okay, so the differentiation of ln of x is 1 by x, right? But my x itself is not defined for negative values, correct? So you will not be able to say that my f dash of x is equals to 1 by x when my x less than 0. No, because function itself is not defined for x less than 0, right? So you cannot comment about the differentiation when x is less than 0. X has to be positive. That's why if you remember, there used to come a mod sign, if you remember it correctly. Okay, so yeah, that's about this. Yeah, now, like, how will I find this tangent? So tangent is also known as the angle from the positive x-axis. So this is the tangent at point A. So if I extend this line, right, this will make angle theta with the x-axis. So this theta, right, I can easily calculate. So let's assume what will be this theta. So this theta, right, I will have a very small triangle here. Okay, very small triangle, and let's assume that this is the, like, very small triangle, and this point will be exactly like this is a triangle. Okay, and what will be this height? So this point, right, this, what is this y coordinate? This y coordinate is f of, let's assume that I have to calculate the differentiation at point A, x equal to A. Okay, so this will be f, what will be the y value here? F of A. And because I have to calculate the slope, right, I have to calculate this slope. So how can I calculate this slope? The slope will be nothing but the tan of this angle, right? Because already we have discussed what is slope. Slope is this, right? F of x2 minus f of x1 divided by x2 minus x1. So where x2 and x1 are very close to each other. Okay, where x2 and x1 are very close to each other, then only that slope is valid, like that formula is valid. Okay. Like basically, right, we first of all we find the secant. So all of these are secant, and it becomes a tangent when I exactly cross, like this line will just touch my graph only once, then it becomes a tangent. Okay, so this I have taught in my full course, but we don't need to get into that. Ultimately what you need to understand, this point value is f of a, this point value will be, what will be this point value? Let's assume that this point, right, is a minus h. Okay, like h is some positive number, I'm just behind my a, that's why a minus h. So what will be the y value? It will be f of a minus h. Okay, f of a minus h. So basically what will be the slope? dy upon dx. This will be equals to f of a minus h minus, like f of x2 minus f of x1, f of a divided by a, like f of x2, sorry, f of x2, right, f of x2 will be a, right, f of x1 will be f of a minus h, and this will be f of x2 minus f of x1, that is h. So what I will do to find out the slope, right, what we do is we use the concept of limits. So I make h tending to 0. As h will tend to 0, so this, right, basically this distance will be almost 0, and whenever this distance is almost 0, what will happen? Like it will become a tangent. So currently it is a secant because it is touching my graph in multiple points, but to make it tangent, right, I will make this distance h go to 0. So that is what we do here. Okay, so from there we get the very basic principle, first principles, like this is called as the left hand derivative, because I am approaching my graph point from the left hand side. Similarly, if I approach from the right hand side, it will be called as right hand derivative, which will be simply f of a plus h minus f of a divided by h, where my limit as h tends to 0. Okay, so that is my right hand derivative, right, RHD. Okay, so yeah, so LHD will be equals to RHD will be equals to finite, that's it. So if this condition is satisfying, my left hand derivative is same as my right hand derivative and is finite, then the function will be differentiable at this particular point. So that is the condition of differentiability. Okay, so we will solve few questions, with this we will understand. So this is the first one, where we have to, if the function, they are telling me that the function is differentiable in its domain, then the value of m plus k will be what? Okay, so there are many ways with which you can solve. If you know the function is differentiable, you can do something else as well. Okay, but let us solve using basics. Okay, I will solve using method 2 as well, but let us first solve using basics. So if the function is differentiable, then the right hand derivative and the left hand derivative must be equal to each other. So what is the right hand derivative over here? So the right hand derivative, right, because mainly the definition of the function is changing at t at 3. So mainly I have to check the differentiability around 3. Before that, again, this is like a square root. Square root is always continuous, and this is like a straight line. Straight line is also always continuous, right? So I just need to check the continuity around this change, sudden change. Okay, not continuity, sorry, differentiability. Okay, so this will be now. So I have to check the left hand derivative around 3, right? So left hand derivative means, so my point is x equal to 3. So left hand derivative means somewhat less than 3. So somewhat less than 3 is this point. So this will be basically, so what do I have to do? I have to simply apply this formula, right? F of, I am checking left hand derivative, so it will be f of x minus f of a minus h divided by h, limit as h tends to 0. That is what I will do. So I will replace my function value, right? So this will be f of x, that is f of 3, right? X is 3, so this will be 3 minus h. So f of 3, so at 3, right, function is defined actually. So this value is f of 3, and f of 3 function is defined at 3. The definition of the function will be this only. The definition of the function will be this only, right? So this will be my f of 3 basically, because this is x greater than 3, right? At 3, definition of the function is this. Less than 3 also, definition of the function is this only. So this will be k under root 3 plus 1, okay, minus f of 3 minus h. So x will be replaced with 3 minus h. This will be k under root 3 minus h plus 1 divided by h as limit h tends to 0. So this will be basically limit as h tends to 0. What can I do? So whenever there is some under root, right? Okay, you can always do that rationalization. So this will be under root 4. So this will be 2k minus k under root 4 minus h divided by h tending to 0. So I can do the rationalization, right? This is a, remember this is k, so I can take the k common, right? K outside, k can be outside, k is just a scalar number, k can be outside, okay? So this will be 4 minus h. So I can do the rationalization. So four minus k. So if I do the rationalization, right, this will be 2 plus under root 4 minus k divided by h. Because here if I put h equal to 0, what is happening? H equal to 0, this will be 0, this will be 2 minus 2, 0. So 0, 0 by 0 format. So I have to do something, right, to solve this limit, because I am getting 0 by 0 format minus h. This is h. So what will happen? This k is outside, limit as h tends to 0. This will be 4 minus 4 plus, this is not k, right, this is h, like simply a square minus b square. So this will get cancelled, and I have h here in the bottom, so that also will be cancelled, right? Remember, h is not equal to 0, h is tending to 0. So this is like I'm repeating myself multiple times, right? So that's why I can cancel, because it is not equal to 0, it is tending towards 0. So now this will, now if I put h equal to 0, right, what will happen? This will be 1 divided by 2 plus 2, which is 1 by 4. So the left hand derivative is not 1 by 4, sorry, k by 4, right? K is there outside, k by 4. So the left hand derivative is coming out to be k by 4. What about the right hand derivative? What about the right hand derivative? Okay. So the right hand derivative will be, I can check here, what will be my right hand derivative, right? Right hand derivative will be, okay, okay, so right hand derivative, right, it will be f of x plus h, that is 3 plus h, minus f of x, that is f of 3, divided by h, right? Because it will be simply x plus h minus h. So like 3 plus h minus 3, so it will be h only, right? So divided by h, as h is tending towards 0, limit as h tends to 0. Okay. So Okay, just give me 1 second, sorry. So here, right, now what is f of 3 plus h? Remember, it is x is somewhat great, like the inside box is somewhat greater than 3. So the definition, I have to use this definition. For f of 3, what definition I will use? Exactly when x is equal to 3, what is the definition of the function? This. And at x equal to 3, what is the value? Under root, this is under root 4, so 2k. So this will be 2k, right, minus f of 3 plus h, that is here, right, here. So this will be m of limit as h tends to 0, m into 3 plus h plus 2. Divided by h. Okay, this will be, so now how can I solve it? Okay, k is there, right? Okay, how can I solve it? K is there, so under root 4 k plus m 3 plus h. I will replace my x with this, yeah. 2k. Okay, so I'm getting this value. Give me 1 second. This will be 3m plus h into m plus 2 minus 2k by h. So if I divide by h, right, together, so this constant term will be there, 3m plus 2 minus 2k, this is some constant term, right, as divided by h as h is tending to 0, plus h into m upon h, so it will be m only. Now the interesting thing is if the limit has to exist, right, this term has to go to 0, the numerator has to go to 0. Why? Because if let's say this is some constant term, right, let's assume this is some constant term 1 or 2, any value, so 1 upon h, that is 1 upon 0, is undefined, so limit has to exist, right, then only the function is differentiable. Otherwise this will go infinity, then function will not be differentiable, because the condition for differentiability is left hand derivative must be equals to right hand derivative and must be equals to finite. So it has to be finite. If this has to be finite, that means the numerator has to also go to 0. Simply the numerator has to go to 0. Then only this will be finite. So from this I get a condition. What is the condition? Condition is my 3m plus 2 minus 2k is equals to 0. That is one condition. So if this is 0, right, then this is automatically vanished. So the right hand derivative becomes m. And what was my left hand derivative? K by 4. And for the function to be differentiable, the left hand derivative must be equals to the right hand derivative. So k by 4 must be equals to m. So now I can replace this m in this equation. So if I replace this m in this equation, what will I get? This will be 3 k by 4 plus 2 minus 2k equal to 0. So from this, right, I can get the value of k. They are just asking me the value of m plus k, right? Yeah, m plus k. So I can find out the value of m plus k. So this will be 8k by 4, 8k by 4, 5k by 4, 8k 5, okay, 8k minus, yeah, 5k by 4 equals to 2, right? So k will be equals to 8 by, just give me 1 second, 8 by 5, that is 1.6. So k comes out to be 1.6. And what about m? So m will be k by 4. So m will be this by 4, that is 0.4. So m plus k will be 2. That will be your m plus k. Now how else could you have solved it? So first of all, you could have also done the continuity check. What do you mean by continuity check? So if the function is differentiable, right, then the function must be continuous. So if the function is continuous, that means at this change, the left hand limit and the right hand limit must be same, and that should be equal to the value of the function. So what is my left hand limit? So left hand limit, if I put my x equals to 3, it becomes 2k. What is my right hand limit? Right hand limit, right, if I put my x equals to 3, it becomes 3m plus 2, and both of them should be equal. So 2k must be equals to 3m plus 2. Isn't this the same thing that we derived here? 3m equals to 2k, 3m plus 2 equals to 2k, 3m plus 2 equals to 2k. So automatically this condition was there inside the differentiability, right? So if you are doing the differentiability, automatically you are checking the continuity. That is already sorted. Okay. So but still, if you want to do, you can also do it like this. And this should be equals to the value of the function at x equals to 3. What is it equals to? It is equals to the left hand limit only, because the definition of the function at x equal to 3 is coming from the left hand side only. Okay. So this is the like continuity check. Okay. Now there is a method 2 to solving this. Method 2 is simple differentiability. If they are saying that the function is differentiable, then the left hand derivative will be equals to my right hand derivative, and the value of that will be my differentiation at that particular point. In our case, what is the particular point? Point of critical point, that is 3, x equal to 3. So I will differentiate my left hand side, I will differentiate my right hand side, right? I will differentiate the left hand side, I will differentiate the right hand side, and I will also differentiate the function at x equal to 3, and I will find out the derivative, and I will equate all these 3 values. So the differentiation of the left hand side will be differentiation of k under root x plus 1. Okay. So the differentiation of this will be what? Just give me 1 second. Differentiation of this will be k divided by like half 1 by 2 into under root x plus 1, right? That is the left hand side derivative, and I have to put the value of the function, right, at x equal to 3. So this will be basically k by 4, right? Isn't that what we found out here? So if the function is differentiable, then only you can do it, right? If the function is not differentiable, then this is not valid actually. You will not be able to do it. You will not be able to do the differentiation of the left hand side, right? So this is only valid if the function is differentiable. What about if the function is if the function is differentiable, what is the right hand side derivative? So right hand side derivative is, this will be m, right? Differentiation of the right hand side will be m. Okay. So yeah, this will be m. Now the left hand side derivative and the right hand side derivative will be equal, k by 4, and this will be equals to the value of the function at that particular point, that is this m equals to k by 4 only, right? So we get this condition, and of course as the function is continuous, we will get another condition. What is that condition? If the function is continuous, then the left hand, like the value of the function, the left hand side limit and the right hand side limit will be same, that is this condition. So we get two condition, right? This condition by checking the left hand side and the right hand side limit, and the differentiability condition. Okay, and from these two equations I will be able to get my value of m and k. Okay, so let's come to the reasons of non-differentiability at a point. What might be the reasons? First one is function is discontinuous. If the function is discontinuous, simply the function will not be differentiable. If I have a corner like sharp change, if there is some sharp change, right, then also the function will not be differentiable, because tangent coming from this and tangent coming from this will be different. Like, can I prove it mathematically? Yes. So what is this graph? This graph is mod of x, right? So f of x will be equals to minus x for x less than 0, and it will be equals to plus x for x greater than 0. Okay, so you need to check the differentiability, right? So what you can do, like this is always not allowed, but here we can do it. So I can take the derivative at before 0. If I take the derivative before 0, so I have to choose this function. So the left hand derivative will be differentiation of this, that is minus 1, right, with respect to x, and right hand derivative will be what? Differentiation of the coming from the right hand side, so this function. So differentiation of this function will be 1. Okay, so this is my left hand derivative, this is my right hand derivative, right? So minus 1, 1, which are not equal to each other. So the left hand derivative and the right hand derivative both are not equals to each other. Okay, so definitely function will not be differentiable. Okay, so yeah, now so here, right, as I told you that the mod of x is not differentiable at x equal to 0. So whenever mod of ax plus b will not be differentiable, whenever this inside box will be equated to 0. So whenever this ax plus b will be equal to 0, at that particular point it will not be differentiable. At other points it will be differentiable. Similarly, if I have these three sums, so at what points it will not be 0, it will not be differentiable? When this box goes to 0, when this box goes to 0, when this box goes to 0. So if these all are three different points, this will not be differentiable. Okay, case 3 is a cusp. Basically, if you see again, like when even though there is no sharp change here, but here the slope is like this, right? This is the slope, some negative slope, because theta angle is coming out to be negative, tan theta is negative, right? And here the slope is like this. So although there is no sharp change, but still as the tangents are different, it will not be differentiable, right? Okay, a vertical tangent. So at x equal to 0, right, my function is not differentiable, because you are seeing that my function is like the tangent is approaching y axis. So like your tan theta is what? The angle between the x axis, so it is 90, theta is 90, so tan 90 is what? Infinity. So whenever your slope becomes infinity, it is said to be, it is not differentiable at that particular point. Okay, because if you approach from here, right, if you approach from the right hand side, so this is the slope. Okay, this is the slope, that is something positive. If you approach from the left hand side, this is the slope, right? Here the angle is negative, here the angle is positive. So basically slope from one side is positive and negative. Or simply, what is this function? X raised to power 1 by 3. So if I differentiate this function, it comes out to be 1 by 3 into n minus 1, right? So n minus 1, I have done this wrong actually, this will not be correct, this will be 2 by 3. Here this will be 2 by 3, right, because this will be x 1 by 3, so 1 by 3 into x of n minus 1, so minus 2 by 3. So this will be 2 by, so 1 by 3, 2 by 3, right? 1 by 3 divided by x raised to power 2 by 3. Okay, so that will be my x value basically. Okay, so again, if I put here x equal to 0, this function will simply blow up, right? And I know that derivative must be some finite value. So obviously at x equal to 0, it is not differentiable. Okay, so what is the relation between continuity and differentiability? So if I have a right hand derivative and a left hand derivative which is L and M, if L equals to M equals to some finite value, then definitely the function is differentiable, and if the function is differentiable, then definitely it is continuous and limit will definitely exist at this point. But if something like this happens, if L is not equal to M but both are some finite values, then function f of x is not differentiable but it is continuous. So the conclusion is, if the left hand derivative is equals to right hand derivative, then definitely function is differentiable, and if function is differentiable, then definitely function will be continuous. But even if the left hand derivative is not equal to right hand derivative but it is some finite value, both are some finite value, they are not equal, then also my function will be continuous, like mod x. So in case of mod x, you will find out your left hand derivative and your right hand derivative, you will see those are not equal, but still those are some finite values, so then your function will be continuous. Okay, but in this case what is happening? In this case, your right hand derivative is positive infinity, left hand derivative is negative infinity. So of course it is not finite, so I cannot comment about continuity here. I cannot comment about continuity. So I hope that part is clear by me, right? What I wanted to mention. So this point is actually pretty important. Now, if both are infinite, then the function f of x is not differentiable, but we cannot comment about the continuity. As you can see, right? Although they are infinite, the right hand derivative and the left hand derivative, but I cannot comment about the continuity here. I cannot comment because actually it is continuous. Actually the function is continuous, right? So yeah, you cannot comment about the continuity if they are infinite. Okay. At least if at least one of them is infinite, then I cannot comment about the continuity. Now properties of differentiable function, same thing, right? Same thing like this. If I multiply by scalar value, if I add, subtract. So if individually the functions are differentiable, then the together functions also will be differentiable. Of course, for this case, right, you have to check whether your g of x is going to 0 or not. That's it, the rational one. Other things are same, right? Just the properties of differentiability. So okay, case 2, if f of x is non-differentiable at x equal to c and g of x is differentiable at x equal to c, then f of x plus minus g of x will always be non-differentiable, because even though g of x is differentiable, this will not be differentiable, right? So it will make the function as a whole non-differentiable. But one interesting thing can happen when we will do multiplication. If I do multiplication, right, then if even if f of x is not differentiable at x equal to c, g of x can be differentiable. G of x can be differentiable. Example, this one. F of x equal to mod x, which is not differentiable. G of x equals to x cube. So if I multiply mod x into x cube, okay, so what will happen? What will be the definition of the function when my x is less than 0? When my x is less than 0, this value is negative, right? And what is basically negative cube, right? Negative cube is minus 1 only, right? Yeah, negative cube is minus 1 only. Okay, hold on a second. So what is the graph of x cube? Graph of x cube is somewhat like this, right? Okay, now I am multiplying mod of x. So mod of x, graph of mod of x is something like this, correct? Okay, okay, yeah, so I will solve it. So the definition of the function, right, will be minus, because I can break my mod of x in negative and positive, so it will be minus of x into x cube when my x is less than 0 and plus of x into x cube when my x is greater than 0. Okay, so this will be x raised to power 4 and this will be minus x raised to power 4. Okay. Now, if I am approaching from the left hand side and the value of the function at x equal to 0 is 0 only, right? So if I am approaching from the left hand side, what is the derivative? So f dash, like what is my left hand derivative? It will be f dash of c from the left hand side. So left hand side is this function, right? So if I differentiate this, this will be minus 4x cube, right? And I will put the value of x, that is 0. So this will be 0. If I am approaching from the right hand side, what will be the value of x? This function, right? If I differentiate this, this will be 4x cube, and I will put the value of x equal to 0. So this will be 0. So my left hand derivative and the right hand derivative are both equal. Okay. So function becomes differentiable, right? And both are finite. So function becomes differentiable. Like you might have doubts, or how is this possible? So you can solve using basics. You will find out the left hand derivative using basics. You will get the same value, like f of a minus h minus of f of a divided by h, and the right hand derivative. Both you solve using first principles, you will get the same value. So how does it become differentiable? Because, right, although the graph of x cube, although the graph of mod of x was this, but graph of x cube was very smooth. So basically your x cube made this point, right, smooth. That's why. Okay, I hope it is clear. That's how it made it smooth. Okay. But what about mod x plus x cube? Will this be differentiable? So now I am not multiplying these things, right? So here what was happening, because the values were very near to 0, right, the x cube values. So although there was huge change here, it was reducing that change. So these values are also becoming lower. But now if I am adding two functions, right, what will happen? It will just simply shift it upwards, right? It will not multiply, it will not reduce this value. This value will just get added. So this will become more negative. What will happen? As it is negative, sorry, it is positive, right? So it will make it positive. So this will be somewhat like this. It will be positive and then it will be 0, and this will be more positive, right? Because positive plus positive will be positive. Positive plus negative will be somewhat positive. This will be somewhat higher. Okay. So there is still sharp change. So function will not be differentiable. Anyways, if you try to differentiate this, right? So first of all, this will not be differentiable, even though this one is differentiable. So that is the property of differentiable functions. So for multiplication, you have to be little bit careful. Okay. Property 3 is, if both f of x and g of x both are non-differentiable, then obviously if you add the two functions, it can still be differentiable. Like mod x and minus of mod x, both of them become differentiable, right? The function becomes 0. So yeah, if only one of them is non-differentiable, then it will be overall not differentiable. But trust me, don't need to worry about all these points, right? Just remember this point, that's it. For all this, right, you can check. Obviously you will write the function and you will check the differentiability, whether it is differentiable or not. You can obviously remember these things, but if you are feeling like too much to remember, it is too much, you can always check the differentiability, right? You write the value of function as a function of, sorry, you write the value of function, right, in terms of x, and then check the differentiability. Okay. So this is the summary of differentiability continuity. You can take a pause and see this, what happens. So if function is said to be continuous, then obviously limit will exist. So left hand limit will be equals to right hand limit will be equals to the value of the function at that point. If function is differentiable, then of course it will be continuous. This condition will be satisfied, right? So it will be continuous, and this additional condition needs to be satisfied. That is, my left hand derivative must be equals to my right hand derivative, must be finite. Okay. And okay, so if f of x is said to be continuous at x equal to a, if there is no break in the graph of the function at a to a comma f of a, so there is no break. Basically I can draw the function. And what does differentiability mean? A function f of x is differentiable at x equals to a if there is no break in the slope. So for differentiability we check there is no sudden change in the slope, and for continuity we check, there is no sudden change in the value of the function. Here we check the value of the function, and here we discuss about the slope. Okay, so I hope that part is clear. So yeah, you can read this conclusion. Now we will start with the questions. Okay, and questions will be cakewalk, trust me, questions will be cakewalk. You will easily be able to solve, like the content that I have taught you, that is more than enough. If some question comes from limit, right, you will be able to crack it easily. So let's start with this question. And first of all, you see, it is a statement based question. So if I don't tell you the theory, right, you will not be able to solve it. So let's read the statements. Statement P, if f of x is continuous at x equal to x naught, then it is also differentiable at x equal to x naught. Is it true? No. It is not true, right? Who said? If it is differentiable, then I can definitely say it is continuous. But if it is continuous, I cannot say it is differentiable or not. I have to check. Example is mod of x, right? If f of x is continuous at x equal to x naught, then it may not be differentiable at x equal to x naught. Yeah, it may not be. Like, they are not surely saying, but here it is saying it is. Statement P is saying it is, but here it may. If may is there, yeah, it may or may not be differentiable, like mod x, right? It is not differentiable, although it is continuous. So this statement is correct. If f of x is differentiable at x equal to x naught, then it is also continuous at x equal to x naught. Again, this is absolutely correct statement. If it is differentiable, then it has to be continuous, right? That is what we have learned. So your P is false, Q is true, R is true. So option B. So this is the next question. So f be a real valued function of a real variable, this, for x greater than or equal to this, x less than or equal to this. Okay, so basically my f of x, right, is actually a modulus of x square. That's it. Or no, not even modulus of x square, because that will be wrong. No, not modulus of x square. It is something else. Okay. Which of the following statement is true? F of x is discontinuous at x equal to 0. So if I see from the left hand side, it will be like limit as h tends to 0, I will replace x to x minus h. Basically x is going to 0, right? So I will replace x to 0 minus h, correct? So this will be minus h whole square, that is h square, and I will put the value of 0, h here, that is 0. So this will be 0, and the right hand limit, right, also will be, I will replace my x with 0 plus h, right, because I am checking about 0. So this will be minus of 0 plus h whole square, that is minus of h square, and of course limit as h tends to 0. So this will be 0. Okay, this will be 0. So yeah, function is continuous because limit exists, right? And the value of the function at x equal to 0, if I put x equal to 0, right, it is 0. So it is continuous. So this is wrong. It is continuous but not differentiable. To check differentiability, right, simply you can use method 1, that is basic. You can calculate the right hand derivative, left hand derivative. Okay, using that first principles, like what will be my right hand derivative? It will be f of 0 plus h minus f of 0 upon h, as h is tending to 0, and left hand derivative will be f of 0 minus f of 0 minus h divided by minus of h, or it was plus of h, x2 minus x1, yeah, plus of h only, yeah, plus of h, right, limit as h tends to 0. Or what you can do, you can directly differentiate the function. That also is totally allowed. You can directly differentiate the function. If I differentiate the function, right, the left hand derivative will be differentiation from the left hand side, that is this, when x is less than 0, that is equals to minus of 2x, and the right hand derivative, right, is plus of 2x. Now if I make x equal to 0, this is 0, this is 0. So left hand derivative and right hand derivative of the function is equal. So, and it is finite. So this also is gone, right, because function is differentiable as well. Okay, function is differentiable. It is not like it is not differentiable, it is differentiable. Now f in the option C, f of x is differentiable, but its first derivative is not continuous. Its first derivative is not continuous. Is this correct? This statement is again incorrect. How? What they mean is, yeah, f of x is differentiable, correct? And what is its first derivative? That is f dash of x, right? That is equals to, basically this will be 2x for x greater than 0 and minus of 2x for x less than 0. Okay. So now right, now what will happen is that now they are telling me that this first derivative is not continuous. Is it so? No, it is continuous, right? Because at x equal to 0, this is 0. Around x equal to 0, this is also almost 0, right? Both are equal. So its first derivative is continuous. So if basically if a function is differentiable, right, of course its first derivative will be continuous. That is how we are checking the differentiability. This is what? My left hand derivative. This is my right hand derivative, right? So of course its first derivative will be continuous. So these two statements are like come together. If f of x is differentiable, its first derivative has to be continuous. It has to be. So only one option is left, that is option D, that is f of x is differentiable but its first derivative is not differentiable. How to check that? So how to check the differentiability of its first derivative? So I have to differentiate this function again because I have to check the differentiability. Now this function is my first derivative. Let's assume this first derivative is a function g of x and I have to check the differentiability of this function. How I check the differentiability of f of x? Either you go by basics, you find the left hand derivative, right hand derivative, or what you can do, you can directly differentiate the function from the left hand side, directly differentiate the function from the right hand side, and then check around x equal to 0 are they equal or not. So what I can do to check the differentiability, you can again follow this basic law, or I can directly differentiate the function. So g dash of x, and I will check around x equal to 0 are those two values equal or not. If they are equal, it will be differentiable. If they are not equal, this g of x will not be differentiable. So if I differentiate this function, right, this will be differentiation of 2x will be 2, differentiation of minus 2x will be minus 2, and obviously the range will not change. X will be greater than or equal to 0. Here x will be less than or equal to 0. Now around 0, are these two values equal? No, these two values are not equal. These two values are not equal. If they are not equal, then definitely the function is not differentiable. That's why it is written that first derivative is not differentiable. This first derivative, I have assumed this to be a function g of x. Okay, I hope it is clear how it is differentiable, how it is not differentiable. Okay. Okay, let's solve the next question. So this is a third question. So like don't get scared by the complex number, it will be very simple. Okay, so what you have to do, you have to find out the limit as z tends to I. So you put the value of I here, what happens? This will be I square, that is minus 1 plus 1, this will be 0, and this will be z cube, that is I cube. What is I cube? I cube is minus of I plus 2I minus of I into z square, that is minus 1 plus 2. So this will be I minus I. So it becomes 0 upon 0 format. So simply whenever these kind of things happen, 0 upon 0 format, simply use L'Hopital's rule. Simply use L'Hopital's rule, right? So now your x is not variable, your z is variable. So I will differentiate the numerator and denominator with respect to z. So this will be 2z and this will be 3z square plus 2 minus I into 2. Okay, again limit as z tends to I. Again if I put z equals to I, this will be what? This is finite. Now is this finite? Let me check if this is finite or not. So this will be what? This will be 2I, correct? This will be minus 3 plus 2 minus of I into 2I. So this will be minus 3 plus 2, that is 1, and minus of so minus I square, so which is plus 1, so plus 2. So this will be minus 1, right? Minus 1 plus 2, so this will be 1. So basically it will be 2I upon 1. If I put my z tending to I, it is not some undefined value, it is some defined value. So it is not 0 by 0 format. So it is some defined value, that is 2I divided by 1. So your answer will be simply 2I. So 2I will be your answer, that is option D. Option D is correct. Okay. So that's how simple, like limits question will be simple, right? But they do give some conceptual questions. So if you don't understand the concept of limits in a good manner, you will not be able to solve it. Let's solve this mechanical question. So here the limit as x tending to pi is given. Okay, x square plus alpha x plus this, right? So we have to find out the value of p and alpha, and limit exists. If limit exists, so I can just simply use L'Hopital's rule, right? So if limit exists, that means it has to have some 0 by 0 format, correct? So in the bottom, if I put x equal to pi, this will be 0, sine of pi is 0. So in the denominator, I have 0. So numerator must be 0 at x equal to pi. So what is the numerator? It is pi square plus alpha into pi plus 2 pi square. So basically your numerator will be 3 pi square plus alpha into pi. This has to be equal to 0 because I need 0 by 0 format, then only limit will exist, right? So from here I can directly get my alpha. Alpha will be minus of 3 pi. So alpha is minus 3 pi, that is present only in option A. So option A will be my answer. Now of course we will solve it further. If I solve it further, right, so this will be some 0 by 0 format. So I will differentiate the denominator and the numerator with respect to x. So if I differentiate the numerator, it will be 2x plus alpha, and 2 pi square is just a constant, divided by 1 pi is just a constant, plus 2 cos of x. Now I will put x equal to pi. So if x is equals to pi, this will be what? Cos of pi is minus 1. Cos of pi is minus 1. So this denominator becomes minus 1. So it is not some undefined value, right? And what is numerator? So if I put here pi, right, and I know my alpha, alpha is minus 3 pi. So this will be 2 into pi minus 3 pi. Okay. So this is actually minus of pi upon minus 1. So this is actually pi. So your p is pi, right? Limit value is pi. So we can confirm it here as well, and of course from the option as well you can see it is equals to pi. Let's now solve the next question. So this is an interesting question. Here they are asking us to find the limit at x equals to 1. So at x equal to 1, what do I see? This is 1 upon 0, right? Ln of 1 is 0, correct? And this is also 1 upon 0. So this, right, is like I cannot solve it. Let us do one thing. Let us take them together. Okay, let me make them together. So if I take them together, this will be x minus 1 minus ln of x divided by x minus 1 into ln of x. Now what do I see is if now limit as x tending to 1, if now x is tending to 1, this will be 0 minus 0, the ln 1 is 0, right? So 0 minus 0, so numerator is 0, and this also is 0 times 0, so denominator is also 0. So now I get my 0 by 0 format. So now I can use my L'Hopital's rule. So this will be 0 by 0 format, so I can differentiate this, right? So this will be 1 minus of 1 by x, and this will be, if I differentiate this, I have to use the chain rule. So first I will differentiate this function, I'll keep this as constant, so this will be just ln of x, plus I will differentiate this function and keep this as constant, so this will be x minus 1 into 1 by x. Differentiation of ln of x is 1 by x, and now my limit as x tends to 1. So now if I put 1, again the numerator is 0, but what about the denominator? This is 0 and this also is again 0, right? So again I am getting 0 by 0 format. So if again I am getting 0 by 0 format, like let me write this. So let me multiply by, or let me keep it as it is, 1 minus x, this will be ln of x, plus this will be 1 minus 1 by x. Okay. So now if I differentiate the numerator and denominator, okay, so this will be minus of so if I differentiate this, so again it is 0 by 0 format. So if I differentiate the numerator, this will be 1 by x square divided by 1 by x plus, so minus or plus 1 by x square, right? So now if I put 1, right, now it is not 0 by 0 format. So the numerator is 1. If I put limit as x tends to 1, and denominator is 1 plus 1, that is 2. So this is 0.5. Okay. So 0.5 will be your answer basically for this question. Let's solve this next question. So here we have to again find out the limit. Again, mostly you will use L'Hopital's rule mostly. So again, if I put x equal to infinity, right, this will be infinity upon infinity. So one thing you can do, you can break the series, but if you have forgotten the series, again you can use the L'Hopital's rule. If you are getting infinity by infinity, right, you can also use the L'Hopital's, because infinity by infinity is nothing but 0 upon 0, correct? So if I use L'Hopital's rule, this will be x into 1 by x plus ln of x divided by 2x, limit as x tends to infinity. So this becomes 1 plus ln of x upon 2x. Okay. So again, if I put x equal to infinity, right, this will be infinity, ln of infinity is infinity, and infinity. Again it is becoming infinity upon infinity. Again I will use the L'Hopital's rule. So this will now become 1 by x. I will differentiate both numerator and denominator by 2. So this is becoming 1 by 2x, and limit as x is tending to infinity. So if x is tending to infinity, basically 1 by infinity is 0, right? So this will be 0. So the value of the limit will be 0. So your 0 will be your answer. So let's solve the next one. So here we have been given a function, okay, e raised to power mod of sin x, and they are asking me whether the function is continuous, differentiable, periodic, bounded. Okay, so it is a MSQ type question, right? So is the function periodic? Periodic means will it repeat? No, right, it will not repeat. Why? Because again it is like a if I just write for positive values of x, right, if I just assume for positive values of x, your exponential is a non-periodic function, right? So envelope will be something like this. This will be my envelope, and sin x, right, although I am not considering the mod, I am not considering the mod right now for positive values of x, right, till from x equal to 0 to pi, sin x will be positive. So it is not periodic actually, because this value and this value will not be same, like it will be something different. Then again when this will be sin x will be negative, then as there is mod, right, it will flip it, it will make it positive, and something like this will keep on happening. Okay, the magnitude will keep on reducing, because what is the envelope, sorry, magnitude will keep on increasing actually, sorry, extremely sorry, magnitude will keep on increasing, because what is my e raised to power x? E raised to power x graph is something like this, right? This is the graph of e raised to power x. At x equal to 0 it is 1 and it is increasing. So sorry, this will not be the correct graph. Correct graph will be something like this. This is my envelope, right? It will never be negative, because mod of sin x will make it always positive. What is mod of sin x? Mod of sin x is this value, right? Correct. So I am multiplying this with a non-periodic function, this, right? So automatically this will get scaled as my x will increase, this value also will keep on increasing. So this value will keep on increasing. So what will happen? this will be my envelope, and this will be my graph basically. Okay, and if I see the graph, right, at x equal to 0, is my function differentiable? Never, right? Here the tangent is something else, here the tangent is something else. So function is not differentiable at x equal to 0. Is the function continuous? Yes. At every point the function is continuous. Without lifting my pen, I can easily draw the graph, right? So every point function is continuous, but at these points, right, the slopes are different. Okay, like there is sudden sharp change. So this change is there, right? So that's why slopes are different. That's why the function will not be differentiable. Will it be periodic? Is it periodic? Is it repeating? No, right? This value and this value is different. So it is not periodic. Is it bounded? Bounded meaning that my function lies between certain finite values. That is what bounded means, right? You will understand this in signals and system. So is my function bounded? Like basically, is it finite for large values? No, it is going unbounded, right? So if I keep on increasing my x, this value is keeping on increasing. So there is no limit. It is going towards infinity. So it is not bounded. It is continuous. Yes, function is continuous for all x. Is it differentiable? No. From the graph itself, I can say it is not differentiable. Now, if you have any more confusion that how are you saying from the graph it is not differentiable, for your own convenience, you can always write the equation. Okay. So f of x, let's check f of x around x equal to 0. Okay. So f of x will be equals to e raised to power x sin x for x if my x is between 0 to pi, because between 0 to pi sin theta is positive, right? Sin theta is positive from 0 to pi, and from 0 to minus pi sin theta is negative, correct? That is the graph of sin theta. So 0 to minus pi sin theta is negative. As it is negative, I have to add a extra negative sign because mod is there. So this will be e raised to power x minus of sin x. So x is between minus pi to 0, correct? Now what I can do is I can check the left hand derivative and the right hand derivative and check if they are matching or not, right? This is the definition of the function from x minus pi to pi. Okay, after that also it will change, but I'm just focused on around this region, around x equal to 0 region, right? So what will be the left hand limit, left hand derivative? This one, right? So if I check the left hand derivative, so I will differentiate the function. If I differentiate this one, right, this will be e raised to power x minus of cos x plus e raised to power x into minus of, so sorry, this will be e raised to power x into minus of sin x only, correct? So now I will put x equal to 0 here. Okay, if I put x equal to 0, this will be 1 into minus 1, and that is 0. So this is minus 1. Left hand derivative is minus 1. So let me find out the right hand derivative. So I will differentiate from the right hand side. So from the right hand side, when my x is slightly more than 0, so I am in this region. So if I differentiate this function, this will be e raised to power x sin x plus e raised to power x cos x. Okay. Now if x is equals to 0, this will be 0, this will be 1. So the right hand derivative is 1, left hand derivative is minus 1. So of course they are not equal. Definitely function will not be differentiable. So graphically I have shown you, and obviously with concept mathematics also I have shown you. So you have two methods. So that is the advantage of studying from PrepFusion. There is multiple methods of solving a single question. Okay. So option A will be my correct answer for this particular question. Let's now solve this question. Okay. The expression for computing the effective interest rate I effective is this. Okay. For nominal interest rate of 5% is, okay, the effective interest rate using continuous compounding for a nominal interest rate of 5% will be. So yeah, that 5% is present over here. Okay. So you simply have to find out this effective interest in percentage. This will be in exact value. So you have to convert this in percentage. Okay. So how will I solve this? So do you remember this format? So there was one format, 1 plus f of x raised to power 1 by f of x, right? If f of like limit as x tending to a of f of x goes to 0, this becomes E, right? This becomes E. But there was one more format actually. Like this format was see, actually this is the same thing. So this is what, if my m is going to infinity, right, this will be 0. So 1 raised to power infinity. It is the exact carbon copy, same format. Okay, just here 0.05 is there. So this is my f of x. So here I should have 1 by f of x. So what is 1 by f of x? So f of x is what? Or in this case f of m, it is 0.05 by m, that is going to 0. So in the power I should have 1 by f of m. So 1 by f of m is what? It is m divided by 0.05. That is what my 1 by f of m is equals to. But here I have only m, so I will multiply and divide by 0.05, right? So this I will convert my limit as m is tending to infinity to 1 plus 0.05 m raised to power m divided by 0.05 into 0.05. So this whole thing, right, this will be simply E. So this will become e raised to power 0.05. Okay, that is your effective interest rate. And don't forget there is a -1 here as well, right? I am forgetting, there is a -1. So you will make these kind of silly mistakes in exam hall, right? So there is a -1 here. So this will be e raised to power 0.05 minus 1. Okay, so if I solve this, e raised to power 0.05 minus 1, what will I get? So 0.05 e raised to power minus 1. So it comes out to be 0.05127. Now remember, this is the exact value, but here they have asked in percentage. So how do I convert this into percentage? I'll multiply this by 100 to convert this into percentage. So this will be 51.27%. Okay, so yeah, 51.27, sorry, not 50, hold on a second, not 51, sorry, 5.127%. This will be your answer for the question, rounded off to 2 decimal places. So 5.13% will be your answer for this particular question. Let's solve the next one. So here we have to the value of the limit as x tends to infinity is equals to. So this is a civil question again. Whenever this under root things comes up, right, you always use rationalization. You will use rationalization. So what you will do? You will do x minus under root of x square plus x divided by x plus, because if I put infinity, right, this will be infinity minus infinity. So it is a infinity minus infinity format. So I will use rationalization. So this will be x plus x square plus x plus under root x square plus x, correct? So limit as x tends to infinity. So this will become x square minus of x square minus of x. So yeah, that is what will happen, right? Yes, divided by x plus under root of x square plus x. So this will get cancelled. Now what I will do, I will take the highest power common, right? So if I take the x common from here, this will be -1. If I take the x common from the denominator, this will be 1 plus under root of, this will be 1 plus 1 by x basically, correct? So x will get cancelled. So limit as x tends to infinity. So if x is tending to infinity, this will be 0, this will be -1, basically this will be 1. So answer will be -1 by 2. This will be your answer, that is -0.5. Okay, -0.5 is present in option B. So option B will be your correct answer for the question. Let's solve the next one. What is limit x tending to 0 f of x? This, right? It is nothing but it is similar to sin x upon x, but here instead of x I have 1 by x. So whatever sine of f of x upon f of x, and limit as f of x tends to 0, this will always be equals to 1. So whatever is here, right, that should be present here as well. So it should be 1 by x divided by 1 by x. Now this is nothing, right? This is same as this actually. So if I properly rewrite, this is sine of 1 by x divided by 1 by x. Is this one and this both are same? Aren't these both same? X into sine x, sine of 1 by x. Aren't both these same, right? I hope you know, right? I am doing division. So if I flip it, it will be multiplication. So these basic things I hope you understand. So this is same, right? This is the same thing actually. So limit as x tends to 0. So this will be actually okay. Now this question is interesting. They are not asking you, they are actually not asking you, the inside function is not going to 0 actually. If you see, if x is tending to 0, right, this is going to infinity. So you will not solve using this one. So this is actually wrong way to solve. If your x would have gone to infinity, so here, right, limit x tending to infinity, then this value would have been 1, because if x is tending to infinity, this will be 0, sine of 1 by infinity is 0, this will also be 0, then this would have been 1. But here your x is tending to 0. So basically what is happening, you have x into sine of 1 by x. Now let us put the 0 value. If I put 0 value, right, this will be 0 times sine of 1 by 0. Now 1 by 0 is actually undefined, right, and 1 by 0 is undefined, but I know the range of this, minus 1, the range of sine of anything inside, right, is minus 1 to 1, that is the range. We have studied what is range. So it will oscillate between minus 1 to 1, and I am multiplying 0 with a finite value. So both of these are finite. 0 is a finite number and this is also is a finite number, although I don't know the exact value, but I definitely know that it will be between minus 1 to 1. So this will be simply 0. Now you might have a doubt, sir, previously we did not made this 0 like 0 into infinity. This is not equal to 0, right? This is not equal to 0, because this infinity is not a finite value. Infinity is not a finite value. I can write my infinity as 1 by 0, right? Then this will be a 0 by 0 format. So that's why you can never do this actually, because here this value is not a fixed value, this is keeping on changing, right? So you cannot do it. But here this is some constant finite value, like it will lie between minus 1 to 1 certainly. So if I multiply anything between minus 1 to 1 with 0, it will always be 0. So 0 will be the correct answer for this particular question. So that's how simple the questions are. Okay, just you have to use bit of brain. Now this is a GATE BM question. Here they are asking like they have given me the f of x. Now they are asking limit as delta x tends to 0, f of 1 plus delta x minus f of 1 divided by delta x. This is nothing but the right hand derivative basically, right? Right hand derivative. So at x equal to 1 is the function blowing up? No, right? So I can simply, this is nothing but the definition of the derivative. So I can solve this using two methods. First I will solve using the basic method, that is I will differentiate this function. If I find f, like this is nothing but the equation of f dash of x at x equal to 1, right? Same equation when x is equals to 1, because this is 1, correct? So if I find f dash of x and put x equal to 1, so this will be 1 minus 1 plus 1 by x square, and if I put x equal to 1, right, this will be 2, 1 plus 1 is 2. So 2 is the correct answer. But if you are not satisfied, of course you can solve using the basic method of limits. So what is f of 1 plus delta x, right? So you will replace your x with 1 plus delta x. So this will be 1 plus delta x minus 1 plus delta x. Okay, this is my f of 1 plus delta x minus f of 1. F of 1 will be what? F of 1 is simply 0. This is 0, right? F of 1 is simply 0 divided by delta x, limit as delta x tends to 0. So this will be this will be equals to I can keep my delta x outside, okay. This will be 1 plus 1 plus delta x, like I am taking this 1 together here, right. So this will be 1 plus delta x minus 1 divided by 1 plus delta x divided by delta x, okay. Limit as delta x tends to 0, okay. So this will be basically limit as delta x tends to 0. I can break down my delta x, right. This will be 1 plus, so this, right, 1 will get cancelled. This will be delta x upon delta x, again this will be cancelled. This will be 1 plus delta x, correct. And now can I put my, like simply what I have done, I have just divided this delta x here and here, right. So this will get cancelled, only this will be delta x, this will be cancelled again. So this will be left out with 1 plus delta x. So if I put my delta x equals to 0 here, this will be 1 plus 1 by 1, that is 2. So this will be 2. Isn't that what we solved here? So both methods will be absolutely correct. If your concept is correct, you follow any method, you will get to the right answer, okay. So yeah, now we will start with the next topic, that is maxima minima. So let's start with the differential calculus portion. So up until now we have been studying the basics of calculus, function, limit, then we learned about continuity, differentiability, right. So we covered those things. Now we will discuss about differential calculus. In differential calculus there are many things: maxima minima, then we have series, mean value theorem, okay, partial derivative. So we will see how much we are able to cover in this whole series. So this will be the maxima minima part, okay. So firstly we will discuss bit about differentiation, okay. Like because I have not told you what is the basic basic differentiation. So if I have a function y, that is f of x, so the differentiation is said to be dy dx, okay. We differentiate with respect to x, that's why differentiation of y with respect to x, that is f dash of x y dash, okay. So if someone does not know differentiation at all, they can directly come to here, but I hope, like my expectation is you have studied bit of differentiation in class 11th and 12th, okay. Now there is normal ordinary differentiation, then there is partial. Partial differentiation is that kind of differentiation where my like dependent variable is function of two independent variables, two or more. So I can partially differentiate with respect to x. So if I partially differentiate with respect to x, that means I will assume my y to be constant when I am performing this operation. I can partially differentiate with respect to y. At that particular moment of time, I will assume my x to be constant. So that's why the name partial. We are partially differentiating, okay. So let's do few basic things, because already I have told you the basic results, okay. So what is the, actually you don't need to remember this cos x sec x, this is not that important. Yeah, what you can ignore this first question, you just find the differentiation of the second one. Sin inverse of x, that is important, because remembering sec inverse of x is very difficult, and I am expecting they will never ask you to differentiate sec inverse of x, okay. That is the last thing that they will ask. But sin inverse of x, you should remember the formula, okay. So what is the differentiation of this function? This will be, if I solve, right, this is x raised to power minus 1 by 2, okay, and the differentiation of x raised to power n is d dx of x raised to power n, as I have shown you previously as well, that will be n into x raised to power n minus 1, correct. So I can rewrite my functions properly. This will be x square minus x cube plus sine inverse of x. Now what is the differentiation of sine inverse of x? So the formula for differentiation of sine inverse of x, right, is 1 upon a square minus x square. So if I have sine inverse of ax, the differentiation of sine inverse of ax will be 1 upon a square minus x square, okay. I think there will be a give me 1 second, sine inverse of x, so sine inverse of x upon a, yeah. If I want to differentiate this, yeah, it will be 1 upon sine inverse of x upon a will be 1 upon a square minus x square. So this differentiation you remember at least, right, this one you remember. You also remember what is the differentiation of tan inverse of x. Okay, note it down, these are actually important. Tan inverse of x and sin inverse of x. These two differentiation you remember, these are actually pretty important. Okay. Okay. So differentiation of tan inverse of x is 1 by 1 plus x square. And for finding out the differentiation of tan inverse of ax, you can use chain rule. Okay, I will explain what is chain rule. You can use chain rule. Okay, so if I solve this, right, this will be, if I find out the differentiation, this will be half minus of half into x raised to power minus half minus 1, that is minus 3 by 2 plus 2x minus of 3x square plus 1 upon under root 1 minus x square. Okay, that will be the differentiation of this particular function. That's how you simply find out the differentiation. Okay, now there is one concept known as chain rule. Okay, so okay, that chain rule thing is gone. So if let's say I have this function here, let's assume that I have y equals to 3u square plus 2 and u is also a function of x, 2x plus 1. So what will be the dy upon dx basically? So your y is not directly a function of x, right? So y is actually a function of u, and u is function of, u is, let's say, g of x. So this can be f of g of x, right? So I have to find out dy upon dx. So it's a composite function, correct? So the first way is to simply, like, I can use a very simple example. Let's not complicate things. Let me keep it u plus 1. Okay, or okay, let me complicate it further. Yeah, because then the chain rule will be helpful to you, right? So the first one is simple. You use substitution. So you substitute the value of u here, right? So this will be, your y will become 2x plus 1 whole square plus 1, and then you ultimately find out the dy upon dx. Ultimately, or other way, what you can do is you can use chain rule. So what does chain rule say? So I have to find out dy upon dx. So this can be written as dy upon du into du upon dx. So I can easily write what is dy upon du. Dy upon du is nothing but 6u, okay, and du upon dx. So I have to differentiate this u with respect to x, that will be 2. So this will be 12. 12u, and what is u? U is 2x plus 1. So this will be 12 into 2x plus 1, that is equals to 24x plus 12. Okay, so that is what my like differentiation is. So either you can do substitution or directly you can use chain rule. Chain rule is the easiest one, right? So few more examples, like, okay, here I have already done it. Like if I have multiple variables, you can use chain rule for multiple variables. Okay, so here I had only two functions inside, right? I can have 3 composite functions. So individually I can again multiply that function divided by the derivative. Okay, that you can do. So here, right, this is a classic example of chain rule. Okay, so like one more thing, the differentiation of cot inverse of x, right, will be nothing but negative of 1 by x square. How? So you can use this formula, that my tan inverse of x plus cot inverse of x will be equals to pi by 2. How? So you can take an example. Let's take an example. Let's assume that okay, let me not cos, sorry, cot. Let me take an example. So I know this thing, right? I know that my let's assume that my tan theta equals to 1 by root 3. So what is theta here? Theta is 30 degrees or pi by 6, correct? What is cot theta here? Now, if my, for this same value, if my cot theta is also 1 by root 3, right? Then what is my theta? Theta will be 60, that is pi by 3. You will add these two up, this will always come out to be 90. Similarly, for sine also you will get same property. So, for sine also you will get the same property, right? So, sine inverse of x plus cos inverse of x will come out to be pi by 2. Same property you will get. So, basically what you can say, that my tan inverse of x, right, equals to pi by 2 minus cot inverse of x. So, if you know the differentiation of tan inverse of x, you can easily find out the differentiation of cot inverse of x. How? So, let me differentiate both sides. So, if I differentiate both sides, what will happen? This will be minus of 1 by 1 plus x square. Minus of 1 by, sorry, not minus, so plus of 1 by 1 plus x square, differentiation of pi by 2 is 0, and this will be minus of d dx of cot inverse of x. Okay, cot inverse of x. So, this negative sign can come here, so this will be minus of 1 by 1 plus x square. So, that's how you can actually remember the differentiation of cot inverse of x. Sec inverse is not that important, but cot inverse is important. That's how you can remember with the help of tan inverse. Similarly, you can remember for cos inverse as well with the help of sin inverse. Okay. So, I hope these things are clear. How can you remember the inverse trigonometric function differentiation? So, this will be nothing but there is square root of x, then cot inverse of x, then square root. So, first I will differentiate the outside function. So, it is cot inverse of x raised to the power of half. So, if I differentiate the outside function, it will be half into n minus 1. So, cot inverse of x, cot inverse of under root of x raised to the power of half minus 1. So, it will be minus half, okay, into then the inside function. So, differentiation of cot inverse of under root x, that is nothing but minus of 1 plus x square, right? But here it is under root x, so it will be 1 plus under root of x square, which is x. So, this will be minus of 1 into 1 plus under root of x whole square, okay, into differentiation of under root of x, that will be half into x raised to the power minus of 2, right? So, ultimately this will come out to be, there are two halves, so this will become 4, right? This will be 4 into 1 by 4, negative sign is there, and here I will have under root of cot inverse of under root of x into 1 plus x into under root of x. Okay, yeah, so this will be the answer for this question. That's how you will do the differentiation. Okay, I hope it is clear. Okay, so I can also take help of logarithm to differentiate power function. So let me take an example like this, right? So what we can do, if I have to differentiate this will not be that easy to differentiate. So I can take help of logarithms. So what I will do, I will take log on both sides, ln of y. This will be, so the power will come in front, tan x into log, I'm taking the log on both sides. So this will be tan x of ln of log of a of x. Okay, I hope you know how to take the log on both sides. Okay, so this can be converted. So what is log of a over x? So this will be nothing, log of a, right? This will be ln of x, natural logarithm upon ln of a. I'm just using the property of logs. okay, using the property of logs. So now if I write this, ln of y will be equals to tan of x ln of x upon ln of a, okay. Now this ln of a is nothing but just a constant, correct? Ln of a is nothing but just a constant. So if I differentiate this on both sides, if I differentiate with respect to y on both sides, so on the left hand side what will happen? What now again I will use the chain rule. So first I will differentiate the outside function, then the inside function. So differentiation of ln y will be 1 by y, and differentiation of y will be dy upon dx with respect to x. So again the chain rule application. So this is nothing but u into v, right? So this differentiation will be like I can directly differentiate. This will be tan x ln of like ln into ln of x upon ln of a. So if I differentiate this, this will be sec square x into ln of x upon ln of a plus, now we will differentiate this function. So in this function, right, this one is constant, it is ln of x upon 1. So first I will differentiate the outside function. So this will be 1 upon ln of x upon ln of a. First I will differentiate the outside function, and of course tan x is there, right? Tan x is there. Then I will differentiate the inside function. So if I differentiate the inside function, 1 by ln of a will be there, right? That is just a constant number, and I have to differentiate this one, right? So what will be this? This will be 1 by x. Differentiation of ln of x will be 1 by x, okay. So basically what will happen? Your ln of a will be cancelled. This will be tan x upon ln of x into 1 by a. That's it. Okay, am I correct here? Yeah, this will be 1 by ln of x, and differentiation of the inside function, this will be 1 by x into ln of a. Yes. Yeah. So I will be left out with sec square x ln into log ax plus tan x upon x into ln of x. This will be my answer of what? Of 1 by y into dy upon dx. So I have to multiply this with y. That will be my dy upon dx. So you already know what is my y. Y value is this, right? So your y is this. So I will replace my y here, and I will get my value of dy upon dx. Okay, bit complex, but I hope the things are clear. Okay, so like don't worry, this much difficult they will not ask. They will ask something similar only. Okay. Now there is differentiation of parametric function. So I'm expecting you have prior knowledge of differentiation and differentiation, so you will be able to handle these things, right? Don't worry, in exam they will ask simpler. They will not ask this much difficult. Okay. So let's solve this one. Differentiation of parametric function. Just hold on a second. Let me check once more. Ln of a. This will be 1 by x. Yeah, this is correct. So here, right, what they're doing is basically you cannot, like, it is nothing but differentiation of an implicit function. So your x is r cos t, y is r sin t. You have to find dy upon dx. So what will be your dy upon dx? So individually you can find dy upon dt upon dx upon dt. Okay, so that can give you the value of dy upon dx. If you assume that r is a constant, r is constant, then only you can do it. Okay, r is constant, you are just, x is a function of time, y is a function of time. So you will differentiate both x and y with respect to time, and then divide those two. That will give you your dy upon dx. That's it. Okay. Now how to differentiate implicit functions? you are not able to write your y in terms of x directly. So I can simply differentiate this, right, on both sides. So this will be, what will be the differentiation? This will be 2x. This will be differentiation of the outside function 2y into the differentiation of the inside function dy upon dx. This is just a constant number 0. So from here directly you can say what is your dy upon dx. Dy upon dx is simply minus of x upon y. So you cannot directly write your dy upon dx in terms of x, but it is, at least you can get to your dy upon dx, right, because it is implicit. I hope you remember what was the difference between implicit and explicit function. Okay, now derivative. What is derivative actually? Derivative actually can help us to find out the rate at which anything is changing. So if I know the function of speed, if I differentiate the speed, right, that will give me the rate at which speed is changing, that is actually acceleration. If I have some distance function, okay, this is, let's assume that this is my distance function, right, and this is my time. So if I differentiate this distance function with respect to time, I will get the rate of change in distance, that is nothing but speed. So basically I can find out the speed, that is what my rate measure is, derivative is. So that is the physical meaning of derivative that you have studied in physics. Or if you find out derivative with respect to any variable, it basically tells me what is the range of rate of change of that variable. What is my rate of change of y with respect to x at a particular point. So let's take an example. If the volume of a spherical balloon is increasing at the rate of 900 cubic centimeter per second, so the volume is increasing, that is dv upon dt is increasing at 900 centimeter cubic upon per second. That is what my volume is increasing. Okay, then the rate of change of radius of balloon at instant when radius is 15 centimeter is. So now they are asking what is the rate of change of radius of balloon, rate of change of radius with respect to time. Of course, rate of change will be always with respect to time if unless and until specified. So they are asking me the rate of change of radius of the balloon at instant when the radius is 15 centimeter. So what is the volume of a sphere? Do you remember what is the formula for volume of a sphere? It is 4 by 3 pi r cube. That is the volume of a sphere, correct? So if I do dv upon dt, if I want to find out the rate of change of volume with respect to time, this will be 4 by 3 pi is just a constant, right? Again I will apply chain rule. So r cube will be 3r square, differentiation of r cube into the inside function, that is dr upon dt. Okay, now I know this value, that the volume is increasing at a rate of 900 centimeter cube per second, and so they are asking me dr upon dt when r is 15. So I can put the value of r here, I can put the value of dv upon dt here. So I will get my dr upon dt, the change of radius with respect to time. So dr upon dt in centimeters second, right, will be dv upon dt, that is 900 upon 4 by, so this 3 and this 3 will be cancelled. Okay, so this will be 4 pi into r cube. R is given to me as 15 centimeter. Okay, so yeah, so 225 into 4 is this, right? So this will be anyways cancelled, this will be 4. So this is simply 1 upon pi. Okay, so what is 1 upon pi? 1 upon pi will be approximately 0.3 something. Okay, so approximately the answer will be 0.3 something. So that's how you can that is one application of derivative. So now we will discuss about equation of tangent and normal. So what is my dy upon dx? Dy upon dx at a particular point, right, is the slope at this particular point. Okay, but if I know dy upon dx at a particular point, it is a slope at that particular point. But if I know f dash of x, this will be the slope at all points. So this is a function, this is a function basically, and this is a tangent at a particular point. Again, here I have tangent at a particular point. So let's say if I want to know the equation of this tangent at this particular point, how can I know the equation? This is a straight line, right? So it will be a straight line. So I definitely know the slope of this tangent, right? Mt. What is mt? Mt is nothing but this value, f dash of x at x equals to x1. That is the slope of this line, because that is what we have found out. That is what my slope is. Slope is dy upon dx. That is equals to f dash of x for all values of x. For all values of x. But here what am I doing? Here I am just finding out the equation of this tangent for this particular value of x. So mt is f dash of x. So I got my mt value. So to find out the equation of a line, right, I need slope of that line and the constant term c of that line, correct? So I got my mt. What will be my c? So for that, again I know the y value, right? So I know my y as a function of x. Y as a function of x, correct? And if it's a slope, right, it has to pass through the graph at this particular point, that is at y point. So my y1 will be equals to f of x1. So here I can put my I can put my x1 value and I can put my y1 value. That will give me the equation. So I know mt, I know x1 because x1 is already given. I know y1 because y is a function of x. So from this, all these three variables are known, just c I have to find out. So from this I got my c value. So c will be equals to where is it? Yeah, this value is the c. Okay, so that's how you can basically write the equation of a of a tangent. This is simply the equation of a tangent. That's it. You don't need to remember anything, just simply solve it. Okay, now what will be the equation of normal? So one thing you have to remember, that the slope of the tangent and the slope of the normal, right, if I multiply these two things, it will be -1 because they are parallel, sorry, not parallel, perpendicular. It will come out to be -1 always. So slope of normal will be -1. Okay, that's it. That is the only change, right? So here, right, again the normal also will pass through the y1 point and the x1 point. Normal also will pass. So here instead of mt, this will be minus of 1 by mt. That is the difference. So these are the two things that you need to remember. So first of all, what you will do? So here I can solve it, right? Find the points on the curve y equals to x cube minus 27, at which the tangent is parallel to the x axis. Okay, so we have to find out the points where my tangent is parallel to x axis. So let me take an example here. So for the graph x cube minus 27. Okay, find the points on the curve for which tangent is parallel to x axis. So when will my tangent be parallel to x axis? Parallel to x axis. So what is this equation? This is y equals to some constant, right? Some c1, y equals to some c2, or y equals to 0 will also work. So at that particular particular time, the tangent is parallel to x axis. And do you know what is the value of the slope for this equation of line? So what is dy upon dx? It is 0, right? This is just a constant number. So slope is 0. So basically what they are asking me to find the points at which the slope of this function is 0, and at those points the tangent is parallel to x axis, right? So I will do dy upon dx, this will be 3x square minus 27, that will be equals to 0. So this will be x square minus 9 equals to 0. Okay, so x will be equals to plus minus 3. So at plus minus 3, the slope will be parallel to the x axis. Now let's take another example, like the same example only. if I want to write the equation of the tangent and normal, let's say at x equal to 1. So I have this graph and I want to write the equation of tangent at x equal to 1. So what is the value of the function at x equal to 1? It is minus 26. Okay. And what is the value of the slope at x equal to 1? So what is dy upon dx? dy upon dx is this, right? This is my dy upon dx. So dy upon dx equals to 3x square minus 27. Okay. So what will be my equation of slope? So equation of slope, right? Let me name that function to be some function that, let me write it as equation of tangent. So yt will be equals to mt into x plus ct. Okay. So I already know the slope, right? Because it is a slope. What is the slope of that function at x equals to 1? So this will be equals to minus of 24. Because if I have a graph here, right, and I have to write down the equation of the tangent, so this slope and of course the slope of the graph, right, both are same. That is why it is the equation of the tangent. So that's why I am equating this with x equal to 1. So this slope minus 24, this will be same as this one. Okay. So I got one of the unknown. So yt equals to minus of 24x plus ct. Now I just need to find out ct. What will be ct? So I definitely know if it's a tangent, right, it has to pass through the graph. So it has to cut this point x1 y1. So I will put my value of x here, right, and it has to satisfy y. What is y at x equals to 1? Minus 26. So I can write my equation. So minus 26 will be equals to minus 24 into 1 plus ct. So your ct comes out to be minus of 2. Okay, ct comes out to be minus of 2, right? So your y of t will be equals to minus 24 into x, ct is minus 2, so minus 2. So that is the equation of the tangent. What about the normal? So simply what you have to remember, that the slope of the normal, right, normal line will be minus of 1 by slope of the tangent. So this will be 1 by 24 basically, because this was minus 24. So again I will write the same equation. So my normal function, right, because these things can be asked in exam. So y of n will be equals to m of n plus x plus c of n. So I know what is my m of m, that is x divided by 24 plus c of n, that is equals to my y of n. Again, if it's a normal to the tangent, right, again this thing has to pass through this point. So again it has to satisfy x1 y1. So when y is minus 26, x is 1. So this will be 1 by 24, and from here you can get the value of Cn, and that you will put it here and you will get the equation of your normal. So that's how you find out the equation of normal and tangent. That's it. Okay. So no need to remember all these things. Okay. Just whatever method I have told you, you remember that. No need to remember all these things. So here this, right, this was actually, I forgot to mention, this is for equation of tangent and normal from an external point, but I don't think they will ask these questions. Okay. If they ask, always go by the basics. First of all, you find out the slope of the tangent, you know how to find out the slope, and then just put the value of the point where that curve or tangent will exist. That's it. Okay, that is what you have to do, nothing else. No need to remember any formulas. So now let's come to the next topic, that is monotonicity. Okay, so what is monotonicity? It refers to whether the function is decreasing, increasing over a certain range. If when a function is increasing on its entire domain or decreasing on its entire domain, we say the function is monotonic. Basically monotonous, right? Same. Like the nature of the function is same. It is always increasing or always decreasing. How can I determine? Basically, we can determine it by seeing the sign of the slope. Okay. So if we see in this graph, right, e raised to power x, we are observing that slope is always positive. If you, what is the slope of this? It is e raised to power x, correct? That is the slope of this particular graph, e raised to power x. And e raised to power x, this slope is always positive. No matter what, this slope is always positive. Okay. So if the slope is always positive, that basically means that the function will always be increasing. What does slope actually means? Slope actually means the rate of change, correct? Final minus initial divided by the time difference. So if final is higher than the initial, that means it is always increasing. So that is what slope tells us, right? Slope tells us whether the function is increasing or decreasing. So in a certain domain from x1 to x2, if the slope is always positive, that means the function will be monotonically increasing. So this is a increasing function, and here e raised to power minus x will be a decreasing. How? If I find out the slope of this will be minus e raised to power minus x, right? This is always positive, but this negative is there. So automatically the slope is always negative. So that is what monotonicity is. That is the complete chapter basically. So you just have to identify the sign of the slope. That's it. Graphically also you can see, like here, right? What is the angle? What is the angle? If I find out the slope, this is theta. So it is negative. It is going in the negative y direction. So theta is negative, right? So angle is negative. So slope will be negative. Here if I see that slope is theta is positive, so slope will be positive. Okay. So yeah. Now, what is a strictly increasing function? Let us discuss about few terms. Okay, strictly increasing function. Strictly increasing function means f dash of x always positive but may become equal to 0 at certain discrete points. So this, right, is a strictly increasing function because you see always the slope is positive at certain point, like this, right, x equal to 0 for x cube, it is 0. So at this point the slope becomes 0, that is there is no change from the previous value to the next value, there is no change, like it is not increasing for a discrete point, that is x equal to 0. Other than x equal to 0, it is always positive. You can see the slope. What is the slope? This will be 3x square, and x square is always a positive value except x equal to 0. This is my strictly increasing function. Now what is a non-decreasing function? Non-decreasing function basically means that my slope can be 0 for a range. Here strictly increasing means it is always increasing, strictly increasing, right? It is always increasing. That is my slope is 0 only at discrete points. My slope is 0 only at discrete points. That is what my strictly increasing function is. Now what is my non-decreasing function? Non-decreasing function basically means that my slope will be 0 for a range. Slope will be 0 within a range. Okay, that is what my non-decreasing function is. Okay. So here what can I say? It is basically f dash of x can be 0 for continuous points. There f dash of x could have been 0 for a discrete point, for a single point. Here between alpha and beta, f dash of x is 0. So this is a non-decreasing function because it never decreases. Either the value will remain same or increase. That's why it is called non-decreasing function. Okay. So a strictly increasing function is called as a monotonically increasing function, and a strictly decreasing, similarly you can take the analogy for strictly decreasing function will be called as a monotonically decreasing function. Okay. So for a monotonically increasing function, my f dash of x will be greater than 0, or f dash of x will be equal to 0 for discrete points. Okay, for single points it can be 0, and for monotonically decreasing function, f dash of x will be less than 0, or f dash of x will be equal to 0 for discrete points. Okay, so I hope that part is clear. Yeah, now what is a, like I have already told you what is a non-decreasing function. Non-decreasing function is this, we call it just increasing. We call it just increasing function, that my f dash of x can be greater than or equal to 0 for all values of x. So it can be equal to 0 as well, right? And a non-increasing function will be called just a decreasing function, not a strictly decreasing or monotonically decreasing. So please keep in mind the names. Okay, monotonically increasing function means the slope will always increase or slope will always be positive. For discrete points it can be 0, that's it. For discrete points it can be 0. And monotonically decreasing function means the slope will be always negative. For discrete points it can be 0, but non-decreasing functions and non-increasing functions are those kind of functions in which I have a range of x for which the slope is 0. Okay, so now there are a few more things. If f of x is strictly increasing, then the inverse of f of x is also strictly increasing. How? So f of x, right, strictly increasing, similarly inverse of it. So let's take this example, e raised to power x. So e raised to power x, y equals to e raised to power x is a strictly increasing function. So inverse, how do I find out the inverse? So what we do is we simply replace my x and y. So my x will be e raised to power y. Now if I take the log on both sides, this will be y will be equals to ln of x. And what is my graph of y equals to ln of x? So x equal to 0 is 1, right? And I cannot put negative values. And ln of x graph, if I increase x, this will keep on increasing. Sorry, not ln. So x equal to 0 will be minus of infinity, right? We start from minus of infinity. Yeah, it will be some very low value. Then the graph will be, graph will be something like this. At e, x equal to 1, this will be 0, and at x equal to e, this will be 1, and this will be like this will be increasing function only, right? Increasing. So yeah, inverse is coming out to be increasing, but it will not be strictly increasing. Okay, inverse will come out to be increasing, but it will not be strictly increasing. So whenever these kind of statements are there, right, in the question as well, you will just take an example. So I have taken a strictly increasing function, and then I have taken the inverse. Inverse basically means I will swap my x and y. So if I have here, like, how do I take it the inverse? So let's say y is equals to sin x. What is the inverse function? That is y equals to sine inverse of x. That is the inverse function, right? How do I get to this particular point? So we just simply swap my x and y. So this will be my x equals to sine y, right, to get the inverse. Now I will write my y in terms of x. So y will be, I will take the sine inverse on both sides, that will be sine inverse of x. So that's how actually you get to an inverse of a function. Okay. Now if f of x and g of x have the same monotonicity, both increasing or decreasing on AB, then f of g of x and g of f of x are also monotonically increasing. So like again, you can take an example, like let me assume that f of x is e raised to power x, okay, and both are monotonically increasing. So let me take this g of x, another monotonically increasing, like x cube. Okay, now f of g of x also will be monotonically increasing. What is f of g of x? So f of, here instead of x I will write g of x. So this will become f of g of x, right, will be equals to e raised to power x cube. Is this always increasing function? Yes, of course, this is always increasing function, right? So basically, right, this purpose of these statements are, I know you will not be able to remember all this, but in the question, if some statement like this comes up, right, you take examples and then prove their hypothesis, like which option is matching, which option is satisfying. That is your task. Okay, so I hope it is clear. How can you understand these statements? Just take examples and prove it. That's it. So let's solve this question. So we have to find the intervals where the function is increasing and decreasing. Okay, so x upon ln of x. So first of all, to find out whether the function is increasing or decreasing, what do I have to do? Simply I have to differentiate this function and then find out the sign, right? So if I differentiate this one, right, it is quotient, so this will be x upon ln x. So if I differentiate this will be like, already it is done, right? It is u upon b. So the differentiation is this one, right? So when will this function be, like, the denominator is always positive because it is something squared, right? Because this will be always real. Now when will the numerator be positive? When my ln of x is greater than 1, then this will be positive, then my slope will be positive. And when does it happen? When my x is greater than e, correct? When my x is greater than e, then this will be positive. If my x is less than e, then this will be negative. So, and obviously x has to be greater than 0. X cannot be negative, right? X has to be greater than 0, correct? X cannot be negative. Okay. Okay. And obviously x will be here less than infinity. Okay. So now when will this be? So when will this be increasing? It will be increasing in the range when my slope is positive, that is in this range, right? So it will be increasing in when my x is less than infinity obviously and greater than e. So the range of x, right, will be e and infinity. Okay, it can include e as well, no problem. Now when will it be decreasing? When will it be decreasing? So ln of is decreasing. So ln of 1 is 0, so that is 0 for that period of time. If it is less than e, it is something less than 1, yes, it is negative. Yeah, so it will be decreasing in the range when x is greater than 0 but is less than e. So that is the range for basically a decreasing function. If that is only the range, yeah, that's it. So that is the answer here, right? Few things I have done. I have assumed that this one is correct for increasing. For decreasing, why have they chosen minus infinity? Anyways, that will not be in the domain, right? Because I can never put minus infinity here. So that this feels wrong. Now here, right, I had assumed it to be strictly decreasing function, so that's why I equated that this must not be. Okay. I missed a point, right? This value cannot go to 0, right? That is what I missed here. So that's why ln of x cannot be equal to 0. So I missed this point that ln of x cannot go to 0. If this goes to 0, like this will be 1 minus 1 upon 0, that is undefined. So ln x cannot be equal to 0. So x cannot be equal to 1. Okay. So 1 should not be included in my decreasing range. So actually it will be 0 to 1 union 1 to infinity. 1 will not be 1 to e. 1 will not be included because if x is equals to 1, this will go to 0, right? And obviously minus infinity also is wrong here. This will be 0 to 1 because I cannot put negative values inside a log function, right? Inside the log function it should be always positive. Okay, so that was my mistake. So it will be from 0 to 1 to 1 to e. Okay, and yeah, ln of x can never go to 0 because if this goes to 0, it will be undefined. So just be careful regarding the this domain and range. Okay, now let's discuss about maxima minima. Maxima minima are nothing but critical points. Okay, so we know that if our function is y is equals to f of x, right? Now it is not necessary that f of x will be differentiable. So we will see, even if it is not differentiable, then also we can find the maxima minima point. So dy dx is equals to f dash of x, that is equals to 0. That will be my maximum minimum point. How? So let's say I have this graph over here, right? So I see the slope here is positive, slope here is positive, here is positive, then it goes to 0, then it becomes negative. And for this is what this point is maxima, right? And here another graph I have where the slope is negative, right? Angle is negative, slope is negative, then the slope becomes 0, then again it becomes positive. So basically for a maxima point, what do I see? Initially slope was, before the maxima point, slope was positive. After the maxima point, slope become negative. So slope change its sign. So if a function changes its sign, then obviously if it's a real function, it has to cross 0, right? And exactly at maxima point, you will see that the slope is directly parallel to the x-axis. So of course the slope is 0 at maxima point, and at minima point as well, the slope is parallel to the x-axis. But the difference being, for a minimum point, the slope initially was negative, then it become positive. So slope is increasing for a minimum point. For a maxima point, slope was negative, then it become positive. That is the difference. How can I check it now? So basically what I can do, how is the slope changing? So how is my f dash of x changing? For a maxima point, I see here, let's say if the slope here was 3 plus 3, then it become plus 2, then it become plus 1, then it become 0, then it become minus 1, minus 2, minus 3. So I see the slope is reducing, the value of the slope is reducing. So f dash of x, right? F dash of x is a decreasing function. F dash of x is a decreasing function. So if I find out the double derivative at my critical point, that will come out to be negative. Because let's assume this is a function, f dash of x is a function g of x, and my g of x is a decreasing function. So how can I define a decreasing function? I will differentiate the function and find out the value of the slope. If the slope comes out to be negative, then it will be a decreasing function. What is g dash of x? G of x is f of x, right? So g dash of x will be f double dash of x. Okay, f double dash of x. So this will be f double dash of x. So that's why this g of, I can write this as f double dash of x. That's it. Okay. Similarly here as well, here the slope is a increasing function. Slope is a increasing function, right? So g double dash of x will be, not g double dash of x, sorry, f double dash of x will be positive. So for a maxima point, first of all I will find out my critical points, f dash of x equal to 0. That will give me my critical points. Whether that point is maxima or minima, I can check the double derivative. That will give me the that will give me the exact information whether it is a maxima or minima. But sometimes what will happen, function will be non-differentiable. In those cases, you have to solve using the graph, or you have to do something else, put the value of the function. Okay, we'll see. Now there are two cases, right? If my double derivative is positive, double derivative is negative, double derivative is 0. So what does double derivative 0 means? Is it a point of inflection? Point of inflection means that your slope also does not change. Okay, so we will see this case as well. When my double derivative will be equals to 0, what happens? So this is a very simple graph, mod of x. So for a mod of x, what is the point of minima? At x equal to 0, we get a minima at x equal to 0. But of course the function is not differentiable at x equal to 0, correct? So it is a non-differentiable function. So you cannot just directly find out the minima point with the derivative rule. Okay, so then how can you solve it? So then you have to find out the you have to plot the graph. Basically you have to plot the graph. So here this is one very simple example. So we have to find out the number of points of local maxima, local minima for the function g of x. Okay, so this is not complete actually. So plotting this will not be easy. Give me 1 second. Okay, so here I have like this x square minus 5 mod of x plus 6. So how will you plot this? So first what you will do is, first of all you will plot the simple function x square minus 5x plus 6. Okay, equals to 0. You will plot the simplest function, that is this one, right? So here I see that 2 and minus 3 are my roots. So that's why at 2 and minus 3 I will have function 0. Now do you remember what used to happen if I replace my x with mod of x? So this will be mod of x whole squared minus 5 mod of x plus 6. Now do you remember, if I have f of x and I had replaced it with f of mod of x, do you remember what used to happen? So basically, if you remember properly, right, what used to happen is that we used to remove the negative portion of my x. So this portion we will remove, this will be gone, and we will take the mirror image about the positive x. Why? Because basically if I have here f of 2, that will be f of mod of minus 2, so this will become, sorry, if I have f of minus 2, this will be f of mod of minus 2, that is f of 2 only, right? Inside the box I have to find out f of 2, and f of 2 is somewhere here, right? So like this I have taught in the initial lectures, right, at the starting of functions, correct? So this will, so I will replace my x with mod of x because ultimately I have to find out this value, right? So one more thing is there, what is mod of x whole square? It is nothing but x whole square, because how do I open my mod of x? Either it will open with minus x or plus x, right? And if I take the square of this or this, it will always land up to x square. So this can be replaced with x square. So x square minus 5 mod of x plus 6. Now this is not my final answer. This is inside my mod function, right? So again, what I will do now, I will take the mod of f of x, right? Mod of f mod of x, right? So mod of this function. So this is my f of mod of x. If I take the mod, right, what will happen? All the negative values will just become positive, right? So simply if I have a function like this, and if I take the mod of this function, simply what will happen, the negative value will become positive. This transformation also I have taught, correct? So this will be just flipped and this will go away, right? This will just go away. So my actual graph will be this. Okay, this will be my actual graph. Now what they are asking me, they are asking me to find the local maxima minima for the function. So do I have any maxima? Yes, here I have a maxima, right? Because after this the value decreases. This is the point. Local means in the near neighborhood. Okay, that is what local, like I have not explained what does local maxima and local minima means. So local maxima and local minima means locally before this point and after this point, this value is the maximum value. That will be local maxima, like in its neighborhood. Local, right? Local means in its neighborhood. Global means in the whole India, whole world. Local means in my neighborhood, like in my town, in my city, I am the top ranker. So in its neighborhood, if this is the maximum value, then it is called local maxima. Now a local maxima can be a global maxima as well, right? But we have to check for other points. So the graph is not complete, right? So maybe the graph after this increases, so then this maxima will be higher than this one. Both of them will be local maxima, but this may be global maxima, because overall the graph may be this, something like this, right? So globally I cannot comment obviously, because graph will exist from minus infinity to plus infinity, x equal to minus infinity to plus infinity. But locally definitely I can comment that yeah, at this point I have a local maxima. Similarly at this point I will have a local minima. Maybe after this again the graph will reduce further, maybe this will be another minima, local minima, but global minima I will not be able to comment. Okay, so here locally I can definitely say, right, the function is maximum at x equal to 0, I have a local maxima. At x equal to minus 2 I have a local minima. At x equal to minus 3 again I have a local minima. At x equal to 2 I have a local minima. X equal to 3 I have a local minima. Okay, so x equal to, these things are there actually. If you see, x equal to minus 3, x equal to 2 minus 3, 4 points are local minima. So I have 4 points which are local minima. So they are asking me find the number of points. So I have 4 points which are local minima, and I have a single point which is a local maxima, that is at x equal to 6. So this mod function is not differentiable. So you will not have any other option than to plot the function. So to like that, plotting the function will be your last option. First of all, obviously you will use derivative, but whenever mod is there, you know the function will not be differentiable at certain points, then you have to simply solve. Okay, so what are stationary points? Stationary points in a continuous and differentiable function, maxima and minima can occur at points where the derivative is 0. So these are called as stationary points. Wherever my derivative of the function is 0, that is called as my stationary point. Okay, the derivative of the function is 0. Are these stationary points? No. Why? Because the function is not differentiable at these points, right? So these are not my stationary points. Okay, here if you read this properly, maxima and minima can occur. Okay, where the derivative is 0. So it's not like always that whenever my derivative will be 0, then only I will get maxima minima. If derivative is not 0, like the here, right, function is not even differentiable, then also I can get a local maxima minima. Okay. What are critical points? Critical points are maxima and minima can occur at critical points. These points include stationary points and where my differentiation does not exist, that I have a point of discontinuity or non-differentiability, but still there I am able to see a maxima point and minima point. So critical points are those points which are possible, either stationary points where my derivative is 0, or point where derivative does not exist but I can observe that I have a maxima or minima. So those are my critical points. Okay. So if you see here, right, stationary points may or may not be points of maxima or minima. If you see here, x cube function, if I differentiate this function, my f dash of x is 3x square. That is the derivative of my function. Derivative of my function f of x is 3x square. Okay. So I can say at x equal to 0, this is going to 0, right? At x equal to 0, do I have a local maxima or a local minima? At x equal to 0, do I have a local maxima or local minima? No, neither, right? If you see at x equal to 0, neither it is local maxima or local minima, right? So stationary points may or may not be points of maxima or minima. Right? It is not always necessary that if my f dash of x is equal to 0, it will be maxima minima. How can you confirm? So then you will see the sign of double derivative. So what is f double dash of x? It will be 6x, and at x equal to 0, it is also 0. Okay. So you cannot say that it will be point of maxima or minima, because by checking the double derivative sign. So what are my critical points? To summarize, it can be stationary points where my f dash of x equal to 0, or it is also called as tangential points, basically where the tangent will be parallel to x axis, or it can be point of discontinuity or points of non-differentiability. Wherever the function is non-differentiable, those also can be my critical points. At those points, I have to check individually. I have to go and check, right, whether it can be a point of maxima or minima. Critical points can be local maxima or minima, but I have to go and check. Okay. So all these points can be local maxima or minima, but that is for certain that all points where maxima or minima occur, those will be critical points. That is for certain. That if I have a maxima or minima, either it will be a stationary point, or it will be point of discontinuity, or it will be point of non-differentiability, if it is a maxima or minima. Okay. So, but vice versa is not true. All critical points may not contain maxima or minima. Like here, right, f dash of x, like this was a critical point where my slope was 0, but it is not maxima or minima. So it is neither maxima or minima. Okay. So I hope that part is clear. So with this, let's solve this graph and let's see whether the points are local maxima, local minima, or none at ABC. So ABC. At ABC, I am observing there is discontinuity. So ABC are my points of like critical points. ABC are my critical points. So if I see the function at A, right, value of the function at A is this, and value of function just after A is somewhat higher than the value of the function at A, and value of the function just before A is somewhat lower. So again, is it a like maxima or minima? No, it is not a maxima or minima, because I see here just after it the function is increasing, and just before it, it is lower value, just like this, right? Just after 0 the function is higher value, just before it function is lower value. So it is increasing function. No. So but I cannot comment whether this point will be maxima or minima. No, this point is neither maxima nor minima. So A is neither maxima nor minima. Okay. So this is gone. What about B? So for B point, just after B, I see the value of the function is reducing. Just before B also the value of the function is reducing. So B, at B, the value of the function is highest. So this will be obviously my local maxima. Okay. Just now the point of C, right, at just before C, I see the value is high, right? Just after C there is discontinuity. the value is again high. So this is the lowest point. So C point will be my local minima. Simple as that. C point is local minima. Okay. So that's how simple it is. So from graph, I hope we can easily understand. Like that is self understood, right? I think you can do it by yourself. It is very easy to understand. Like either if just after it, just before it, the value is increasing, that means this will be my point of local minima. And if I see here, just after it, just before it, the value is reducing. So this will be my point of maximum, because this is the maximum. So from the graph itself also you can see, right? This is the maximum point. This is the maximum. This is the minimum point. Correct? Okay. Yeah. So that is what we have discussed. So how do I find maximum minima using derivative? So using graph, I have told you, using the first derivative test. So we, like, this method is applicable only for differentiable functions. Of course, it is not applicable for non-differentiable, because I will not be able to find out the derivative. Okay. So it will give us, basically after making it 0, it will give us the local maxima and local minimum points, that is stationary points. And then I have to take the double derivative and check whether it is like negative or positive. So yeah, with that, right, let's solve a question to understand like this thing better. How can I use the first derivative to check my function? Okay, so here we have been given a function f of x is some integration. Now you will be scared, like we don't know what is integration yet. How can I find out the local minima or maximum? Okay, so they are asking me the function is integration of this value and has a local maxima at what point, at what x equal to what value, right? So this I will teach in Leibniz theorem later on as well. For now, just understand this simple thing, that if I have a integration, okay, I will teach this in Leibniz theorem while after studying integration, that if I have f of x that has its limits, that is, let's say, L of x to upper limit u of x to lower limit L of x, and the function as m of x or m of t dt. Okay, then how can you like solve this basically? So if I have to find out the, because what do you need to do, your function f of x is integration of this, right? And remember, after this integration, this t is just a dummy variable. For those guys who understand integration, they will know this t is just a dummy variable, right? Ultimately you will put upper limit x and lower limit -1, right? So ultimately your function will, your f of x will be a function of x only. Okay, so if you don't understand, ignore it. Now if I know this value, right, ultimately I have to check whether I have a local maxima minima. How to check that? I have to make the first derivative 0 to find out f dash of x for this kind of function, right? There is a basic theorem known as Leibniz theorem. What you do is you write m of, inside t you will put the upper limit. Okay, you will put the upper limit, that is u of x, and then differentiate the upper limit with respect to x, then minus m of, you will put the lower limit. Lower limit in our case is L of x inside the m function, and then differentiate the lower limit with respect to x. That is the answer. So that is f dash of x. If you don't understand, ignore this part, ignore this question. Okay, so I will teach this in Leibniz theorem, because I have to take it, because I have to explain the local maxima minima. So what will be our f dash of x? So what is my u of x upper limit x? What is my L of x? It is a constant, -1. So if I differentiate the upper limit with respect to x, it will be 1. So this will be 1 in our case. Luckily, this will be 1, right? And this will be 0, right? So I don't have to worry about this second term, only I will worry about this first term. So m of u of x. So m of u of x. Now what is m of u of x? U of x is x, right? So I will replace, this is my m of t. So wherever I have t, I will replace it with u of x, that is x. So I will replace t with x, that's it. So this will become x into e raised to power x minus 1, x minus 1, x minus 2 whole square, and x minus 3 whole cube. Okay. Okay, so here I have, this is my f dash of x, right? And I have to find out where this goes to 0. What are my critical points? So at x equal to 0 is a critical point when e raised to power x is 1. So simply this e raised to power 0 is also 1, 1 minus 1 is 0. So automatically these are the same critical points. Okay. So I have two critical points here. When my x is equals to 1, I have a critical point. When my x is equals to 2, I have two critical points. Here also, for x equal to 0, I have two critical points. One is this one, other one is this one, right? So two critical points. Then x equals to 3, I have three critical points. Why am I writing the number of critical points? Because I will plot my wavy curve method. Okay, with wavy curve method, I can easily find out whether I have a local maxima minima or what do I have. First of all, this function is always differentiable and continuous because it includes all the continuous variables. So it is always differentiable and continuous. So that is the first conclusion. It is always differentiable and continuous. Okay. Now, I can write the critical points. So the highest critical point is x equal to 3. Then I have 2, then I have 1, then I have 0. Okay, that's it. I don't have any negative critical point. Now, I hope you have seen my wavy curve method, right? I hope you have seen it. If you have not seen it, you will not be able to understand it. I will do it directly here. So I have two roots at x equal to 0, that is, it is an even. And before x equal to 0, what is the sign? Before x equal to 0, what is the sign? So before x equal to 0, this is negative, right? Negative. Before x equal to 0, this will be something lower than 1, right? Right? E raised to power minus 1 will be 1 by e, that is lower than 1. So this will also be negative. This will also be, okay, this will also be obviously negative. This will be again positive because it is something squared. This will be negative, right? Like minus 1 minus 3 is minus 4 whole cube, negative. So what is that overall sign? Negative times negative times negative times negative. So 4 times negative is positive into positive is positive. So ultimately before x equal to 0, my sign is always positive. Okay. Now at x equal to 0, I have even number of roots. So the sign will not change. If you are not able to understand, you have to go and watch my wavy curve method. Okay. So sign will not change. So this sign will remain same. It will be positive only. Again at x equal to 1, how many roots I have? Odd number of roots. So here the sign will change. Negative. Again at x equal to 2, what is the, like how many roots I have? 2. So there will be, like this will be even. So there will be no sign change. Still it will be negative. Okay. And again at x equal to 3, I have odd number of roots. So sign will change. So this will be positive. So this is what? This is the sign of my f dash of x. So these are my stationary points and I see that the slope is always positive here, right? So I will not neither get a local maxima or minima. But here I see the slope was initially positive, then it became negative. So for which case the slope initially is positive and then it becomes negative. So in this case the slope is negative, then it becomes positive. So this is local minima. But in this case the slope is initially positive, then it becomes negative. That is slope is reducing. In this case I get a maxima. So this point will be my local maxima. Local maxima. Okay. And here again the slope sign does not change. It is always negative. So this will be neither maxima nor minimum. But here my slope goes from negative to positive. Negative to positive. So definitely here this will be my local minima. Okay. What have they asked? They have asked me has a local minima at. It has a local minima at x equal to 3. Sorry, local minima. Sorry, local maxima. Local maxima. We have a local minima at x equal to 3. We have a local maxima at x equal to 1. So it has a local maxima at x equal to 1. So if you have enjoyed this concept, right, do make sure to hit the like button and comment down below. Like I do understand that you will not be able to understand this thing because this I have not yet taught you, right, Leibniz theorem, And wavy curve method, if you have not seen, you will not be able to understand it. But like, this is kind of a crash course, so I cannot cover every single thing, every basic doubts of you. I do understand there will be few doubts, but like, you have to figure out things by yourself, because this is a crash course. I have limited amount of time. Okay, so if you have enjoyed, those who have enjoyed the concept, and I am expecting some question, something like this to be asked, make sure to hit the like button, make sure to comment down below how you are enjoying the R-PYQ series so far. Okay, so yeah, let's now move on to the next test, that is the second derivative test. So instead of plotting this sign, right, we can directly use the second derivative test and directly understand whether I will have a local maxima, minima, or anything else. Okay, so like, same thing, I've already discussed about this already, right? I've already told you how to find out the local maxima minima using a second derivative test. So here I have a function. Now this time I cannot simply plot this function using wavy curve method, right? So for this I have to actually go by the root of second derivative. So only one point is, if my f double dash of a is equals to 0, then second derivative test fails. We will go for higher order derivatives. Okay, so we will further differentiate it and then check like whether that part is increasing or not. So yeah, generally we have to go till this first 2 points only. Okay, that's it. We have to check either it is less than 0 or greater than 0. For f double dash of a equal to 0, we will check what will happen. We will see that. Okay, don't worry, we'll see that. So let's take an example. This is my function and it attains the maxima and minima at point P and Q respectively, such that P square equals to Q, then the value, then A equals to what? What is the A value? So first of all, this is a polynomial, so it will be always continuous and differentiable. If I find out the first derivative, f dash of x, this will be six x square minus eighteen x plus 12 a square. Okay, this I have to equate this to zeros to find out the possible stationary points. So if this is 0, right, so I can divide by 6. This will be x square minus 3 ax plus 2 a square equals to 0. So x will be plus 3a plus minus b square 9a square minus 4ac, that is 8a square divided by 2a, not 2a, 2. So this will be 3a plus minus a divided by 2. This will be 2a and a. Okay, so 2a and a are my roots, possible roots. Now they are telling me that it will attain a maxima or minima. How can I check it whether it will attain a maxima or minima? So what I can do is I can, so what like, it will attain a maxima minima at P and Q respectively. So I have two critical points. Of course, one of those will be maxima, one of those will be minima. But which one is P and which one is Q? How can I know it? So using the double derivative test. So I will do the double derivative f double dash of x. So this will be, if I differentiate this again, right, this will be 12x minus 18a equals to, so now this is my double derivative. So I will put my value of, now remember they have given me a is greater than 0. Okay, so I'll put the value, I'll put the critical points and check the signs of my double derivative. So double derivative when my x is equals to 2a. So this will be 12 into 2a minus 18 of a and so 12 minus 2a, that is 24 of a minus 18 of a, right? This is 6a and a is positive number, so this is positive. So x equal to 2a, the double derivative is positive. That means what? It is a minima. It has to be a minima, right? I have told you why. Conclusion, I have already told you that then the 2a will be the point of minima and obviously the a point will be the maxima. Okay, so what is my so they're telling me that I'm attaining at maxima at P. So A point is maxima, so A will be P. This will be equals to P and this will be equals to Q. And they have given me the relation that P square equals to Q. So A square equals to Q, that is 2A, right? So I can take the 2A on that side. This will be A square minus 2A equal to 0. So A into A minus 2 equal to 0. So A will be equals to 2. Okay, A cannot be 0 because A is greater than 0, they've given me. So A has to be 2. So 2 will be the answer for this question. Okay, so that's how you will solve it, because you will not be able to draw the wavy curve here, right? That will be difficult. Okay, so we will check what happens for higher derivative test. So double derivative we have checked. What will happen for higher derivative? So if n is even, then if my higher order derivative is greater than 0 at x equal to a, or whatever is the critical point, then we get a minima, otherwise we get a maxima. So no need to remember all this, just take examples, take two examples, right? One is the x raised to power 4, another one is the x cube. Okay, so if I check for x raised to power 4, right, what is the graph of x raised to power 4? Like basically it will be this graph only, right? For x raised to power 4, the graph will be this. Basically it will be squared of this, so it will be even more sharper. Okay, so if I take the derivative of x raised to power 4, it is 4x cube. So I have a critical point at x equal to 0. If I take the double derivative, it will be 12x square. So if I check the value of my double derivative at critical point, it is 0. So I will check further. I will again differentiate this function. If I again differentiate this function, it is again 24x. So again it is 0. I will go on till the point where it is non-zero. Okay. So again if I differentiate this function, this will be 24. And what is 24? 24 is positive, right? We get a minima. So how do you remember? Like basically what is the conclusion? Conclusion is I need to remember this thing, right? So there are a lot of cases written here. I will not be able to remember all these things. So these things you already know, that if my double derivative, where did it go? Yeah, if my double derivative is less than 0, I will get a maxima. Why I have told you. If my double derivative is positive, I will get a minima. That is already like discussed, right? How am I getting it? Now how do I remember for higher order test? How will I remember it for higher order test? So here, right, I see it is double derivative, that is 2. So I'm differentiating twice. So if it is f double dash, f quadruple dash, f 6 dash, or x 8 dash, even, whenever there is even dash, right? Whenever there is even dash, then it will follow the original rule. Now for third order, like if it is n is odd, right? If it is odd, basically it is not even, then what will happen? If it is odd, right, we'll always get a point of inflection. Okay, so that is a saddle point, and your f of x will be either increasing or decreasing depending on the sign of the slope. What do I mean by it? So the conclusion is, if you have even derivative, then you will follow the same rule as f double dash. Okay, if you have odd derivative, then you will always get a point of inflection, that is saddle point. How can you remember these things? Simply take two examples, x cube and x raised to power 4. Okay, from this you can remember. Now what is the difference between case 1 and case 2? So in case 2, you saw that my by putting the first derivative equals to 0, I get a critical point, that is x equal to 0. So if I see the second derivative, right, f double dash of x, this is going to 0. So I will again do the derivative, differentiate the function. So I will do f triple dash of x. So again triple dash of x is also going to 0. So again I will do the differentiation. This is f 4 dash of x, which is coming out to be non-zero. So here I will stop. Wherever the derivative of the function will come out to be non-zero, I will stop there. Then I will check whether it is even or odd. If it is even, I will follow the same rule as double dash, normal rule, right? If it is greater than 0, I will get a minima. If it is less than 0, I will get a maxima. Similarly, this is the same graph of x raised to power 4, right? Of course, at x equal to 0, I can directly see that I will get a minima. So I just want to remember what was the condition. So this is how you can remember. Now for a cubic function, right? If you differentiate first time and equate it with 0, I get a stationary point at x equal to 0. Okay, so I'll double differentiate my function. It is 6x. So the double derivative is also 0. So I will again differentiate. So if I again differentiate my function, it is coming out to be 6. So I will stop here. As soon as I get a non-zero value, I will directly stop there, which is greater than 0. But this will not be a maxima or minima. This will just be a saddle point or point of inflection. Point of inflection basically means the curvature, where the curvature of the graph changes, right? Here you see the curvature was like this, then the curvature become like this, right? So this was a convex curvature, now it became concave. So this was convex curvature, it became concave. So point of inflection is nothing but the point about which the curvature of the graph changes. So here this was convex, it became concave. That's it. Okay. And if you see, this is positive. So nature of the function is increasing. You see the function is always increasing. If it was negative, like this, something like this, right, it will be always decreasing, minus x cube. You can confirm this by using minus x cube. So you will never say that if your like derivative is coming out to be 0, right, you will always get a point of inflection. If your second derivative is coming out to be 0, you will always get a point of inflection. That statement is incorrect. And I know in most of the institutes, they will teach you this. They will never actually go into the depth of the concept. Like what does it mean basically to find out higher order derivatives, and what does it mean for the double derivative to be 0. So you have to check further. You cannot comment that if your double derivative is 0, then you will get a point of inflection. No, that is actually incorrect, right? So what I know, in most places they will teach you this. So that is incorrect, right? So you have to check further. If your second derivative is 0, then you have to check for third derivative. If that is also 0, you will check for fourth derivative, and you will go on till you get a non-zero value. Okay, and if it is always 0, then you are out of luck. So yeah, I hope sorry, no, it cannot be always 0, right? Either you will get a odd derivative, that will be 0, and if a odd derivative is 0, simply you will get a point of inflection. So that point of inflection is also called as saddle point. Okay, so if you are enjoying the concept, please make sure to hit the like button and comment down below if finally you have understood the actual meaning of maxima or minima. Now let's discuss about global maxima or minima. We have discussed about local maxima, minima. Let's discuss about global maxima and minima. Okay, just give me 1 second. 1 second. Yeah. So global maxima or minima, right? It is the maxima minima within a range. Okay, let's say I want to check the global maxima here. What is the global maxima? These two are my local maxima, right? Here also I have a local maxima, here also I have a local maxima, because just after it and just before it, this value is highest, and here also just after it and just before it, this value is highest. So these 2 points are my local maxima, but out of this, which one is global maxima? Like global maxima can be only a 1 point, right? I can have only one global maxima. So this one is the global maxima, correct? So basically what do you need to do is, if you have any closed interval, right, this closed interval is given, so you have to find out all the critical points, and then you have to take the maximum of all the critical points. That will be my global maxima, and the minima will be, global minima will be, you have to find out all the critical points and you have to find out the minima out of all the critical points. Here, right, this is my local minima, I have only a single minima. You will say this is the minima. No, you have to check the endpoints as well. Make sure you're checking the endpoints. So here, right, I see that at x equal to a, this value is lower than this, but although the function is not differentiable here, right? So you have to include the intervals as well, right? So if it is closed brackets, you have to include this AB point. So you have to check the value of the function f of a and f of b. So for global maxima, you will take the maximum of all the critical points, including f of a and f of b. You have to check for f of a or f of b, because here I will not be able to find out the differentiation of the function, right? I just directly need to check the value of the function. Similarly for minima, you see, although this is a local minima and I have only a single local minima, but at the range, right, at this particular range domain, the function is lowest. So actually the global minima will be this. So that's why you have to include the actual function values as well. Okay, in open interval you just need to check the critical points, that's it. Here you see open interval means our function does not include f of a and f of b, that's it. Okay, so that is the difference between open interval and closed interval. Okay, now there are few points. So in open interval things are a bit different. Okay, so first of all, of course, I will check the m1. M1 will be maximum of all the critical points, m2 will be minimum of all the critical points. Okay, but sometimes what happens in open interval, the global maxima may or may not exist. What do I mean? So the maximum of all the critical points is m1, right? Now if this value is less than n1, n1 meaning the maximum of the intervals, that is f of a and f of b, if it is less than if it is greater than m1, then of course m1 is greater than my h points, m1 is greater than my h points, like here, right, m1 is greater than my h points, then this will be my global maxima, no problems, because this is already higher than my h points. Okay, but now I have a case 2 like this. Let's check for the minimum case. So if my local minimum, maximum of all the minimum of all the local minimas, like this case, this value is not lower than the h point. So my h value, right, if you see here that n2 is less than m2, that is the minimum of all the local minimums is greater than the h points, like h values of my function, and this function is not, like this value is not included, correct, this value is not included in the range, in the domain, so minima will not exist. Why am I saying something like this? So let me take a very simple example. So let's say this is my graph. Okay, and here I will make an open circle, here I will make an open circle. These are my a points and b points. This is my open interval. Okay, and a and b are not included in the function, that's why I have made open circle here. Okay, now what is my local minima point? Local minima point is this, right? Now is this the global minima as well? No. Why? Because I see the function, if I find out the limit of the function as x tends to a, that is a right hand limit, right? Because it will be like right continuous, because function does not exist before this. Okay, f of x, this, right, I see this is lower than my local minima. Now what will be the problem? So if this value is lower, right, this value also will be lower than my local minima, this value also will be lower than my local minima, this value also will be lower. The point I am reaching till this point, now this value is same as my local minima. So the problem is there are infinitely many points that are already lower than my local minima, because the h point was less than my local minima. So this is the problem, right? So I cannot tell that this is my global minima. No, how can I say? I can say this one is my global minima. You can say this one is my global minima, this point is my global minima, this point is my global minima. There will be infinitely many global minimums. Okay, there will be infinitely many global minimums. So that's why we say global minimum does not exist, because there can be infinitely many global minima. Like if you say, let's take values here, let's take an example. Let's say this value is 2 and this value is 1. Someone might say 1.7 is global minima, 1.6 is global minima, 1.59 is global minima, and I can go on. There are infinite values here, right? So that's why we say global minima does not exist. Similarly, let's say my point, right, my graph, I will not delete this directly, it will be something like this. Okay, so this time the f of b is higher than my local maxima. This is the highest local maxima and f of b is even higher. So again the same problem will come. Again I will say global maxima does not exist. So whatever I have explained here in the graph, right, same thing is written here. Okay, so if you tend to forget this, just draw the graph and then conclude your statements, that's it. Okay, so I hope that part is clear. Now with that, will you be able to solve this? Okay, so identify local and global maxima between minima, identify local and global maxima minima between -1 to 8. Remember, it is brackets, so -1 and 8 are not included. Okay, so first of all, I will check the value of f of -1. It is okay, it is something in between, right? It is something in between, and okay, let me not do it. Let me find out the like critical things, like critical values. So I see, of course, what will be my critical points? My critical points wherever my slope will be 0 or parallel to x-axis. So here I see my slope is 0. That's it. This is the only place where my slope is 0, right? So at f of 7 is a critical point. So what are my critical points? xc is equal to 7, and wherever I have discontinuity, those will be my points of, like, those will be my critical points. So xc equals to this 2 as well is a critical point, then 4 as well is a critical point, 5 as well is a critical point, because there is like sudden change, right? Where the function is not, here the function is not differentiable, the function is not differentiable, correct? And then yeah, that's it. So what do I notice is this point is the highest than all the points, than my h points as well as the other points. So x equal to 7 will be my global maxima, no doubt. X equal to 7 will be my global maxima, there is no problem at all. Global maxima. Okay. Now, what about global minima? So I see, right, this point is the minimum value, 0, right? This point is the 0 value. Okay, this here, right, I'm not exactly going to 0, right? I have an open circle, so it will be somewhat more than 0. So this point is the lowest value, that is 0. Do I get any other, like, do my h points go to 0 as well? No, they are somewhat higher. So my local minima is less than my h points. So of course, f of 5 will be my global minima. So x equal to 5 will be my global minima. Global minima. Okay. Now, if I modify the graph, okay, what can I do is I can modify the graph. This can, instead of going here, right, I can directly do like this. Then will I have a global minima here? No, because the h point is lower than my local minima, so not possible. Okay. Now this was my global minima and maxima. What are my local minima and maxima? So I see, let me check the discontinuity point, right? So x equal to 7 of course is a global maxima, and of course x equal to 7 also will be a local maxima. So this was my global minima and maxima. So let me first of all find out the local maxima. Okay. So what is local maxima? So local maxima, let me check this discontinuity point. So before this, right, the value is somewhat lower. After this as well, the value is lower. Okay, after this value, the value is somewhat lower. No. So this is my x equal to 2. At x equal to 2, the value is this, right? This is my actual value, x equal to 2. So before this, the value is higher actually. And after this, the value is lower. So it is going from high to low. So this is neither a maxima nor a minima. So x equal to 2 is not a maxima or minima. So if I check this point, so this point at x equal to 4, I see before this, the value is lower. At x equal to 4, the value is here. After this also, value is going low. So this point x equal to 4 will be my local maxima. So x equal to 4 is a local maxima. X equal to 5, x equal to 2 is neither a maxima nor a minima. What about this x equal to 5? Where is it? It is non-differentiable. So I see before this, obviously it is minima, right? Before this it is increasing, after this also it is increasing. Here the value is lowest. So x equal to 5 will be my local minima. And of course x equal to 5 is a global minima, so of course it has to satisfy the local minima part as well, right? That is my local minima. Now if I check at this point, again it is a global maxima, so it has to be a global local maxima as well, x equal to 7. Okay, so any other point? No other point. So that's it. I have only a single maxima point x equal to 5, sorry, minima point, and I have two local maxima. What are my global minima maxima? X equal to 7 and x equal to 5. Okay. So yeah, that is the summary. Basically, you can go through the summary. Whatever I have explained, that is what they have, like that is what I have written over here. Okay. So like few examples, few things are there, few key points, like what is the maximum value of a sin x plus b cos x. Of course, you can take the derivative and find it out, but directly it will be a square plus b square under root a square plus b square. What is the minimum value of a sin x plus b cos x? It will be minus of under root a square plus b square. These are few handy points that can be used while solving some questions. Okay, so already we have discussed about like curvature. I have told, right, this shape is nothing but convex, this shape is concave. Okay, so basically the point of inflection is the point where the curvature changes. Okay, so either it will go from convex to concave or concave to convex. That is the summary for inflection. Okay, inflection point, you can read this, what will happen, like whether it will go from concave to convex or convex to concave. How do you know? So no need to remember anything, right? No need to remember, just draw the graph of x cube. So if I draw the graph of x cube, I have seen that my f triple dash of x was equals to it was equals to, so let me draw the graph, right, of x cube. So x cube, right, if I differentiate this thrice, this will be 3x square, then this will be 6x, then this will be 6. So your f triple dash of x is positive and my graph is somewhat like this, right? So this is what convex, this is what concave, right? So if my triple dash of x is positive, then it will go from convex to concave. So no need to remember anything, just draw the graph and understand like what is happening, concave, convex, that's it. You don't need to remember these summary points and all those things. This was there for your convenience, but no need to remember, just draw the graph and then check. So let us do a very basic example, like what are the inflection points of sin x? So what will be my inflection point of sin x, where my double derivative goes to 0, right? Those can be my inflection points, or like those can be, okay, those can be, like what is the derivative of this function? F dash of x is cos x, okay, and f double dash of x is minus of sin x. So when does this function go to 0? Basically, when does my derivative go to 0? When x is odd multiple of pi by 2. In that particular point, the derivative goes to 0, right? So I will get the maxima points at odd multiples of pi by 2. But I am not interested in that. I am interested in finding out the inflection points. So when I will get inflection points? When the basically the third order derivative will be 0, those will be my inflection points. So basically I have to equate my sin x equal to 0, right? Not third order, sorry, second order derivative is 0, those will be my inflection points, okay, not the third order, second order. So f double dash of x, right, okay, sorry, when my double derivative is 0, those can be my inflection points. I have to check further, right? So first of all, I will make my double derivative go to 0, right? So when does it go to 0? So when minus sin x is 0, when x is integer multiple of n pi. So if I draw the sine graph, this is my sine graph, and I have told you in this lecture that if your double derivative is 0, right, it does not necessarily mean that you will get a inflection point. It can be a maxima minima point as well. It can be a maxima minima point as well, correct? It does not necessarily mean that you will get a inflection point. How do you check it? So you go and check the third order derivative. So if I put the third order derivative, right, what happens? It is minus of cos x, which will not be 0, correct? Because cos of n pi you put cos of n pi will not be 0, right? Cos of any multiple of pi, integer multiple of pi, it will not be 0. So f triple dash of x is not equal to 0, right? And f double dash of x equal to 0. So those will be my points of inflection. Wherever my triple dash of x is not equal to 0, those will be my points of inflection. If my triple dash of x also would have been 0, then I would have had to check f fourth dash of x. Okay. So the summary is, to find out the points of inflection, what we'll do? If they would have asked to find out the points of inflection, basically where the curvature changes. So you will directly make the double derivative equal to 0 and you will check the triple derivative whether it is 0 or not. If it is not 0, then only this will be a valid point of inflection. Otherwise, this can be a maxima or a minima point, as we have shown previously for x raised to power 4. Okay. So graphically, can I show you? Yes. Here what is the curvature? Curvature is convex. Here what is the curvature? Concave. So curvature from convex, it goes to concave again. So this is multiple of n pi. So this is pi, this is 2 pi, this is 3 pi, right? So at every multiple of pi, you see the curvature changes graphically. So graphically, I have proven it to you. At every integer multiple of pi, the curvature will change, and those will be my points of inflection. So it depends on the sign, okay? Because this will be what? This will be minus of cos x. So whether the sign is positive or negative, your curvature will be going from convex to concave or concave to convex. So that is a summary that is written over here. You don't need to remember it. Just take examples. Okay, just take examples and do it. So the summary, bottom line is, what is the bottom line? If they are directly asking you to find out the point of inflection, so you will directly go and make the double derivative equal to 0, because that is the only possibility where my curvature will change. Okay, and after making it 0, you will get some points. Then you will check those points at the triple derivative and make sure that your triple derivative is not equal to 0. If your triple derivative is not equal to 0, that means definitely it is a point of inflection. If your triple derivative is also equal to 0, that means it can be a point of inflection or can be a maximum minima. You have to check the fourth order derivative, as we have done it for x raised to power 4. So if they are asking you to find out maximum minima, you will first of all make the first order derivative 0. You will find out your critical points. Then you will put those critical points in the second order derivative. You will find out the sign of second order derivative. If your sign is coming out to be positive, it will be a minima. If your sign is coming out to be negative, it will be a maxima. Now, if your second order derivative comes out to be 0, then it can be a point of inflection or it can be a point of maxima or minima. You have to find out the third order derivative. So you found the third order derivative, then you put the value of critical points. Okay. Then if it is non-zero, then definitely it is a inflection point. If it is 0, then again you have to find out the fourth order derivative and you have to go on and repeat this process. So for even order derivatives, you will follow the same rule as maxima minima. For odd order derivatives, you will simply, if odd order derivative is non-zero, if it is coming out to be non-zero, that means you will get a inflection point. So that is a summary of complete maxima minima. Okay. So now let's solve few gate PYQs. So yeah, let's start with the questions. Okay. So this is the first one. So here we have a function. Okay, and they are telling me that x varies from -1 to +3. Which one of the following describes the behavior of the function? Increases monotonically, increases then decreases. Okay, so let me check the sign of derivative between -1 to +3. Okay, so if I find out the f dash of x, this will be 3x square minus 6x. Okay, that is, if I take 3x common, this will be x minus 6. So if I use the wavy curve method, right? So if I use the wavy curve method, I have a critical point at x equal to 0. I have a critical point at x equal to 6. So what will happen to the sign? What will happen to the sign? So the sign, right, this will be like before x equal to 0, right? This is negative, this is also negative. So negative times negative is positive. So sign will be positive, and of course I have odd root. So sign will again change because the at x equal to 0, this is I have only a single root, odd number of roots, right? So sign will change. Again at x equal to 6, I have a single root, odd root, so again sign will change. So this will become plus. Okay, so they have asked me for range of -1 to +3. So I see the sign of my derivative was positive initially, then it became negative. Okay, so it is not constant, like it is not, if it was always negative, then I would have said the derivative is always negative. What happens if my derivative is always negative? So here if we see derivative is always negative, so function is always reducing. If my derivative is always positive, then you will see derivative is always positive, that means function is increasing. But no, in this case initially it was positive, then it is negative. So initially this was positive increasing function, then it reduced. So initially f of x was increasing, then it reduced. So f of x increases, then decreases, yes, correct, and then increases again. No, in the given range, no. It initially increases, right? It initially increases, then it reduces, that's it, in the given range. Because here again the sign becomes positive, but that comes later. So basically my function, right, will be somewhat like this. Initially it will be a increasing function, because initially the derivative was positive, then it reduced, and it will keep on reducing, and after a certain point again the derivative will be positive, but that is at x equals to 6. Okay, at x equal to 6 we get the positive derivative. Am I doing this correctly? Let me just check. 3x square minus 6x. Oh, sorry, extremely sorry, I'm taking 3 common here. This will be x minus 2, right? यही होता है in exam hall also. This silly mistake will happen. Okay, so yeah, I'm sorry, I wrote the critical point wrong. This is x equal to 2. So actually now things are a bit different. This is my x equal to 3. So now what is happening? Initially my function is increasing because slope is positive, then my function is decreasing because slope is reducing, slope is negative, then again my function increases. So function initially increases because slope was positive, then decreases because slope was negative, then again increases because slope was positive, because my range is from -1 to 3. So option B will be my correct answer. So just be careful regarding the ranges and stuff. So you are saying, right, every single thing whatever we have learned, those basic concepts will be asked. So that's why I'm giving some emphasis on the basics. Okay, so yeah, this was the solution. Option B will be correct, because initially the function increases because slope is positive, then reduces because the slope is negative, then again it starts to increase because the slope is positive. Okay, so let's move on to the next question. So here we have the function, that is x raised to power 4 minus x square. Which of the following statements is true? The function is symmetric about this, minimum value is this, function has 2 minima, it is an odd function. Okay, so let's check the first statement, that function is symmetric about x equal to 0. So what is my x equal to 0 line? So x equal to 0 line is this, right? X equal to 0. This is my x equal to 0 line, correct? X equal to 1 will be this line. Where for all values of y, right, x is always 1. This is my x equal to 1 line. So they are telling me that the function is symmetric about x equal to 0. How do I check symmetricity about x equal to 0? Do you remember? I told you in functions and graphs, we used to replace our x with minus of x. Then my function will be symmetric about my x equal to 0 line. Basically it is a even function, then only it will be symmetric, right? So if I replace my x with minus x, what is happening? This will be minus x raised to power 4 minus x square. So this will be x raised to power 4 minus x square. So of course it is the same function, right? Same function y. So after replacing x with minus x, I'm getting the same function. So definitely it will be an symmetric function about x equal to 0. It will be an even function, correct? So of course, like this is a even function, this is a even function. I'm subtracting or adding two even functions. Overall, it will be an even function. So this statement is correct. The minimum value is minus 0.5. For that, first of all, let me calculate the f dash of x. So f dash of x is 4x cube minus 2x equals to 0. So if I take x common, right, and 2, if I divide by 2 on both sides, this will be 2x square minus 1 equal to 0. So at x equal to 1 by 2 plus minus 1 by 2 plus minus 1 by 2, I will have, that is a critical point, and of course at x equal to 0 is also critical point, sorry, x equal to minus 1 by plus minus 1 by root 2 is a critical point, and of course x equal to 0 is also a critical point. So let me draw the wavy curve. Okay, so if I draw the wavy curve, this is a critical point, right? X equal to 0, x equal to minus 1 by root 2 is a critical point, x equal to 1 by root 2 is also a critical point. Okay, so when my x is greater than 1 by root 2, it is positive, right? It is always positive. So I will start from positive, right? I will start from positive. Then of course all the roots are like, I have odd number of roots, so everywhere at all the critical points the signs will simply change. This will be minus, this will be plus, this will be minus. Okay. Now the function has two minimas. Is it an odd function? No, it is an even function, right? It is not an odd function, it is an even function. If it was an odd function, it would have been symmetric about the like this y equals to x line, right? Okay, so the function has, I will come to this. Let me first calculate how many minimas does the function have. So when do I get a minima? I get a minima when initially my slope is negative, then it becomes positive. Initially my slope is negative, then it becomes positive, I get a minima. So here it is slope is negative, then it becomes positive, so this will be my minima point, right? Here also initially my slope is negative, then it becomes positive, this also is a minima point, correct? So at 2 points I am getting minima. Here initially my slope is positive, then it becomes negative, so this can be a possible maxima point. Okay, but first of all I have to check whether my double derivative is coming out to be 0 or not, right? That I have to confirm. So if I double differentiate this function, this will be 12x square minus 2. Okay, so for no values of my critical points, right, this is never going to 0, so I am totally safe. I am totally safe. So the function has two minimas. Sorry, so this is the maxima and the function has two minimas, right? This is a minima. Okay, so this option B is correct. Function has option C is correct. Function has two minimas. So let me calculate the minimum value of the function. The minimum value of the function is minus 0.5. So the function has minimas at minus 1 by root 2 and plus 1 by root 2. So if I put minus 1 by root 2 or plus 1 by root 2, both will give me the same value because it is a even function. So negative and positive both will give me the same value. So 1 by root 2 raised to the power of 4 minus 1 by root 2 whole square. So this will be half into half, that is 1 by 4 minus 1 by 2. So this is coming out to be minus 0.5. Now they are telling me that the minimum value of the function is minus 0.5. So one more thing is there. Have they given me any range of any domain of the function? What is the domain? As nothing is mentioned, I will assume the domain to be minus infinity to plus infinity. Okay. Now here comes that point, right? So they are talking about the minimum value of the function is minus 0.5. The function has two minima, that is definitely correct. It has two local minimas, right? But is the minimum value minus 0.5? Is it true? So if I put my x to minus infinity, what will happen? If my x is minus infinity, this will be x infinity, this will be very high value, minus very high value, this will be positive infinity, yes. Okay. Okay, sorry. I have like solve again, I am doing some silly mistake, right? This will be 1 by 4 minus half, so this will be minus 0.25. Okay, like what I was getting to is, so minimum value is minus 0.25, so this option is anyways eliminated, but actually you have to check the edge points because they have you have to check like before, because your x belongs to minus infinity to plus infinity, you have to check. So what is my function? F of x is x raised to power 4 minus x square. So when my x is very large, which term will dominate? Always the higher order term dominates. Whenever your x is very large, higher order term will dominate. If your x is very small, lower order term will dominate. Why? Because 10 raised to power 4 square is 10 raised to power 8 and 10 raised to power minus 4 square is 10 raised to power minus 8. So it becomes lower. So higher the power, for less values, lower values, it becomes more lower. So please keep this in mind. So if my x is very large, right, plus infinity or minus infinity, my f of x approximately will be equals to x raised to power 4. So if I put plus infinity or minus infinity, my f of x tends to positive infinity. So basically the graph at both sides, right, starts from positive infinity, and then I get some minima here, right? I get some minima according to the signs. So this will be my minima. There is nothing wrong. This will be exactly my minima. Minus 0.25 will be my minima. No problem. Okay. But in some cases, what will happen is, if this was, let's say, I will take the example, if this was minus x raised to power 4 minus x square, then what would have happened? Then approximately you would have written here minus x raised to power 4. Then your graph would have been something like this, right? Somewhat like this. Okay, and this will be also minus. So your minimum value is not minus 0.25, it is minus infinity. So just be careful regarding that. So then your like global minima will not exist. Okay. So yeah, that's why you have to take care of everything. So I'm trying to teach every single thing, whatever is required. Let's now solve the next one. So if ft be a real valued function whose second derivative is positive for t between this range, second derivative is positive, which of the following statement is always true? So my second derivative, right, f of t is always positive. Second derivative is always positive. Okay. So I can take a like very simple example, e raised to power x. The second derivative is always positive for e raised to power x. And what kind of function is this? This is a always increasing function. Okay. Similarly, you can take the example x square. The second derivative is 2, which is always positive. This is a simply a increasing function, right? Here again the value. So is this an increasing function? No. For this region, this is reducing and then it is increasing. Okay. So what are they asking me? F of t has at least one local minima. Is this correct? No, because here I don't have any local minima, right? Here I have a local minima, but here I don't have any local minima. F of t cannot have two distinct local minimas. F of t cannot have two distinct local minimas. Is this correct? This can be correct. Why? What they are telling you, that the slope is always increasing. Your slope is always increasing. Okay. Slope is always increasing. So if I plot it in the wavy curve, right? If I plot it in the wavy curve, so let's take an hypothetical example that slope was initially negative and slope is always increasing. So slope will at certain point it will cross 0 and then it will become positive. This is one possible condition. Another possible condition is slope was initially positive and slope is always increasing because second derivative is always 0. So what will happen? Slope will keep on increasing. So it will be positive only because slope always increases. So previously, let's assume slope was minus 2 and slope is always increasing. So it will become minus 1, 0, 1, 2, 3. So it will go from negative to positive. And when my slope crosses negative to positive, we get a single minima, right? Slope negative to positive, right? Slope is negative to positive, we get a minima. Another example can be that my slope was initially positive only, right? Plus 1 and slope is increasing. So still it will be positive. Plus 1, plus 2, plus 3, plus 4, plus 5. So slope will always be positive. Correct? Slope will always be positive. So here, do I get a local minima, maxima? I don't get anything. This is the example. I don't have a local minima here. But here, this is the example of this first case. But is it possible that I can get two distinct local minima? Is that possible? To get two distinct local minima, my slope has to again go to negative, then again it will increase. But that is not possible according to the question. So I cannot have two distinct local minima, and the statement is f of t cannot have two distinct local minima. Cannot. So this statement is correct. Yes, I cannot have. I can have at least one local minima, right? I can have 0 local minima as well, but I cannot have two distinct local minima. That is not possible. Okay. F of t has at least one local maxima. Incorrect. For me to have a local maxima, my derivative must go from positive to negative, and that is never possible because my derivative is always increasing. The minimum value of f of t cannot be negative. No, right? The minimum value of f of t can be negative. Okay, I can choose this function like x square minus 4. So what will be the minimum value? Minus 4. At x equal to 0, I get a minimum value minus 4. So it can be negative. This statement is wrong. So only option B will be correct. So now I hope I hope you are able to solve this question. This question came recently, and we did not even do any mathematical equations. We just understood using wavy curve method and our graphs. So that's why graphs is very, very important. Okay, graphs are very, very important. Let's solve the next question. Consider like two questions came from Maxima Minima, right, in 2024. Consider the function f of t maximum of 0t whole square for minus infinity to infinity, where maximum of ab denotes the maximum of the value. Which of the following is correct? Not differentiable, continuous, not differentiable. So for this, right, let's plot the function. Without plotting the function, I will not be able to do it. Okay, so f of t is maximum of 0 comma t. So when t is negative, right, let's say minus 1, of course I will choose maximum of 0 comma minus 1, that is 0. So whenever my t is negative, this will be 0, and 0 square is 0. So basically for negative values of t, right, my function will be simply 0. Now for positive values, let's say 1, 2, 0.1, this will be always greater than 0. So I will choose the maximum value, that is 0.1. So it will be replaced with t. So it will be simply t square. So for positive values, my function will be simply t square. Okay. Now what will be the derivative of this function? So here it is t square, and here it is 0. If I differentiate this function, right, I know derivative of a parabola is just a straight line, that is 2t, correct? So the differentiation of this function will be somewhat like this. Okay, and is there any sharp change over here? No. Is the graph always continuous? Yes, because around here previously the value was 0, just beyond this also value is 0 only. So there is no sharp change, there is no discontinuity. So graph is continuous and differentiable. Okay, graph is continuous and differentiable. So f of t is not differentiable, incorrect statement. F of t is differentiable and its derivative is continuous. Yes, this statement is correct. F of t is differentiable, right? And if f of t is differentiable, of course that means that its derivative has to be continuous, right? Both of these are saying the same thing. If you say f of t is differentiable, that means f dash of x exists, and that means f dash of x is continuous. So if f of t is differentiable, that means f dash of x exists, it is continuous. So you say that yes, derivative of f of x is continuous. So these two statements are saying the same thing only. They are not saying anything different. Okay, they are not saying anything different. F of t is differentiable, but its derivative is not continuous. No, right? It is not possible. That's not possible. If my function is differentiable, its derivative has to be continuous. Like this will always be the case. You see, if this function is differentiable, this derivative will always be continuous. So this statement is again wrong. F of t and its derivative are differentiable. F of t and its derivative. So they are asking me that my f dash of t, this is my f dash of t. Let me name this function as g of t. So they are telling me both f of t and its derivative, that is f dash of t, both are differentiable. So I have to check whether g of t is differentiable or not. So I have to differentiate this function g of t. If I differentiate this function graphically, what will I see? So what is the differentiation of a straight line basically? This is what? Nothing but 2t. It is 2, right? The slope is always constant, that is 2. So the differentiation of g of t is 2 just after t greater than 0 for positive values, and before this, right, what is the slope? It is 0, because the slope is parallel to the x-axis, that is 0. So before this the slope is always 0. So I see there is a point of discontinuity of the derivative of my function g of t. and this is nothing but f double dash of t. So the derivative of f, the derivative is the derivative of derivative, that is f double dash of t, is not continuous. That means it is not differentiable, because you see there is a sharp change here, right? From 0 it sharply changes, sharply. So you see that its derivative is not continuous. The derivative of g of t is not continuous, and if the derivative is not continuous, that means then this g of t is not differentiable. If g of t is not differentiable, that means the derivative of f dash of t is not differentiable. So the derivative of function f of t is not differentiable, but they are telling me they are differentiable. No, f of t is differentiable, but the derivative of f of t is not differentiable. Okay, so that's why you always understand graphs. Graphs will help you out immensely, trust me. Otherwise you will not be able to touch the questions. Let's solve this next question. So we have been given that the function is some log e of x, okay, attains its maximum, attain its minimum over the interval 1 comma e at x equals to what? So they are directly asking me what the function attains its minimum for what value of x. So basically what I will do, I'll simply find out the stationary point, because they have already told me that it will attain a minimum in this point. So I don't need to check any double derivative. But if I am getting multiple points, then I may need to get. So let me first check. Let me first make the f dash of x equal to 0. So if I make f dash of x equal to 0, so this will be 8 by x, because differentiation of ln of x is, this is natural log, right? It will be 8 by x minus of 2x, okay. This is equals to 8 by x minus of 2x. This is equals to my f dash of x, that is equals to 0. Okay. So x of, first of all, x cannot be equal to 0. That is the first condition. Now I can cross multiply by x on both sides. So this will be, and divide by 2 on both sides. This will be x square minus 4 equal to 0. So I get 2 points, x equals to plus minus 2. Okay, x equals to plus minus 2, and minus 2 is of course not in the range. So x equal to plus 2 is in the range given in the question. So I only have a single critical point given in the question. So I don't need to check the double derivative, right? This will be my point of minima. We can verify it, but this will be my point of minima, because they're already telling me that it will attain a minima at this particular point. So I don't need to verify it. We can verify it, I'll verify, but we don't need to check it. Okay. So now I will find out what is the value of the function at x equal to 2, right? Because that is within the range 1 comma e. So value of the function at x equal to 2, this will be 8 ln of 2 minus 2 square plus 3 minus 2 square plus 3. Okay, so this value will be 2 ln into 8 minus 4 plus 3, 4.54, and you see it is not in the options. So what went wrong? So remember, you have been given a closed interval, so you have to check the h points as well. Okay, so what is the value of the function at x equal to 1? So when x is equal to 1, this will be 0, this will be minus 1 plus 3, that is 2. What is the value of the function at x equal to e? So ln of e is simply 1. So this will be 8 minus of e square plus 3. This will be 5 minus of e square. Okay. Tensor minimum. So this will be what is 5 minus e square? So 5 minus e square. So it is something positive, right? 5 minus e square, 5 minus e square. Oh, it is coming to something negative, minus 2 point. Sorry, it is 11 minus e square, right? Sorry, 11 minus e square plus 6. Yeah, it is coming out to 3.6, something like this. Okay. Now out of this, right, which one is the minimum? So this is 4.54, this is 3.61, and this is 2. Which one is the minimum? So I will have to choose the minimum, right? I hope you remember how to find out the global minimum. So minimum will be this one. So the minimum will be 2. And you are very lucky that only this one is matching with the options. Other values, right, are not present in the options. Okay, you are very lucky. So global minima, you have to check the h points as well. And of course, you can check the double derivative. If you check the double derivative, right? If I find out the double derivative, f double dash of x, this will be minus 8 upon x square. Okay, minus 8 upon x square minus 2. Now at x equal to plus 2, this is negative. X equal to minus 2 as well, this is negative. Okay, so both, okay, is this negative, x equal to plus 2? Okay, oh sorry. If I check at x equal to plus 2, right, what is happening? X equal to plus 2, oh no, 4, oh this is 0 actually. X equal to plus 2, we are getting 0. Interesting. Minus 2 also will get 0. Okay, so this will be like I have to again find out the derivative. So this will, if I again do the triple derivative, this will be minus 2, that is 16 divided by x cube. Yeah, so now if I put x equal to minus 2 here, this is coming out to be non-zero. So basically that is a point of inflection, right? It is a point of inflection. So these 2 points are points of inflection. It is not a maximum minimum point. So yeah, this question was pretty good actually. If you want to check, like your question is done. What you will do, you will just find out the single derivative and then you will check the h points, because it is an NAT type question, like the options are given, right? That's it. But if actually you want to check whether this stationary point is a critical point, you can find out the third derivative, which is coming out to be non-zero. Okay, and if it is coming out to be non-zero, okay, sorry, what am I saying, what am I doing? So this is not coming out to be non-zero, right? This will be what? This will be minus 8 divided by 2 square, that is minus 2. So this will be actually minus 4, sorry, which is negative. So actually you are getting a maxima, you are not getting a minima, you are getting a maxima. Okay, that's interesting. Okay, but your question is done. Let's now solve the next question. Like I was wrong there, because I thought if they are telling you that the minima is in this interval, then you have to get a minimum. So actually, if this was instead of this, right, if this was like this, if 1 and e were not included, then definitely you have to get a local minima here. So definitely this point would have been local minima. But as 1 and e are both included, then 1 and e points can also be considered as a minimum. That's why this statement is written. Okay, so just be careful regarding that. So I hope like it is clear what is global minimum and local minimum. Let's solve the next question. Consider the function this. Okay, which of the following statement is correct? I have a global maximum, I have a no global maximum. So for that, first of all, I will find out the derivative of the function, and it is defined for all real values. So when my x is going to infinity plus infinity, only the higher or the order term will be dominating, that is this will be dominating, that is then my f of x will be plus of infinity. When my x is going to minus of infinity, right, f of x is minus of infinity. So of course it will cross the, like it will cross the zero crossing point once. Okay, that is what my cubic function is. So now let's start with the f double dash of x. So f double dash of x will be, this will be 6x square minus 6x minus 12. Okay, and I will equate this equal to 0. So this will be x square minus x minus 2 equal to 0. Okay, x square minus x minus 2 equal to 0. So you will get 2 points. So x will be 1 and minus 2. So if I break this down, right, so this will be x minus 2 into x plus 1. So yeah, so x equals to minus 1 and 2. When x is minus 1, this will be, yeah, this will be 0, and x is minus 1, this is, yeah, 2. So now what I can do is I can again use the wavy curve method, right? Wavy curve method. So I have a critical point at 2 and minus 1. So again I have single roots, odd number of roots. So for x greater than 2, right, this is positive, so it will be positive, then I will be negative, then I will be positive. So uh, so my slope goes from positive to negative, right? Positive to negative. When does it happen from positive to negative? When I get a maxima, right? So this will be my maxima point, and this will be my minima point, local minima and local maxima. Okay, local minima and local maxima. Okay, so I have a maxima at x equal to -1. X equal to -1, they are telling me local minima. No. X equal to 2, I have a maxima. No. X equal to 2, I have a minima. X equal to 2, I have a minima. Now, do I have a global maxima or minima? No. Because when my x tends to plus infinity, f of x is plus infinity, and for no value of x, for no finite value of x, my function can go above infinity. So I will never have a local maxima. Similarly, for no value of x, I cannot never go below minus infinity. So I will not have a local minima as well. So f of x has no global maxima, it has a no global minima. So option A and B will be correct. Okay. D and B, if these things were swapped, then D and C also would have been correct. Okay. So I hope this point is clear. Let's solve the next one. Let f of x be a real valued function such that f dash of x naught is 0 for some x naught lying in this range, and f double dash of x naught is 0 for all x naught lying in this range. Then f of x has what? So basically I have a stationary point and the double derivative is positive, so definitely I will get a minima. So there will be a minima, there will be exactly one minima or two distinct local minima. What will be the case? So basically my derivative is, my slope is always increasing, function. Okay, slope is always increasing. So if slope is always increasing, again I can plot the graph, right? At x naught, like I am just plotting the sign of slope, right? At x naught the slope is 0. There can be two cases. Either the slope was negative previously, then this will be the graph, because slope will always increase, right? Slope will always increase from 0 to 1 in this range. Okay, and x naught belongs from between 0 to 1, so this is my 0, this is my 1. So in the given range, at some point x naught the slope is 0, and I know slope always increases because the double derivative is positive. Okay, so this is one of the cases where initially if my slope was negative, or one more thing can happen, if your slope was initially positive, okay, then I am lying somewhere here and slope is always increasing in the given range from 0 to 1, slope is always increasing. So slope will always increase. But is this case possible? No, because they are telling me for certain point between 0 to 1, there has to be a point where the slope goes to 0. So it has to cross the 0. So this second case is not possible, only the first case is possible, right? So my slope is going from negative to positive. And what happens when my slope goes from negative to positive? Slope is negative, it goes to positive, I get a minima. And exactly there will be a single minima. You say that there can be two distinct local minima, again the same reason, right? It is not possible. I cannot get two distinct local minima, because for that to happen, my slope needs to increase. Initially it is increasing, then again it needs to reduce. But here this statement is there. This statement is telling me that the slope of the slope, that is the double derivative, is always positive. So the slope is always an increasing function. So this case is not even possible. So I will get exactly one local minima. Okay, so option C will be correct. Let's solve the next question. So this is the 8th question. Consider the function f of x minus x square plus 10x plus 100. The minimum value of the function in the interval is. So again, it is given closed interval. So first of all, I have to calculate the critical points. I will find out the value of the function. I'll find out the local minimas, and also I will check the value of the function at the boundaries. Okay. So let me first of all find out the critical points. So f dash of x will be minus of 2x plus 10. Okay, so I will make it 0. So I get only a single critical point, that is x equal to x equal to 5. If I double differentiate this, right, this will be minus of 2. So it is negative. So I will get a maxima actually. This will be a local maxima. So I don't even need to check this local maxima, right? I don't need to check. I will check the boundary point values, and that will be my minima basically. Okay, I don't need to check x equal to 5 because this is not even a minima point, but still we can check the critical values. So what is my f of 5? F of 5 will be minus 25 plus 50 plus 100. So that is 125. This will be actually a maxima. So then I can check the f of, okay, that is a h point as well. Okay, sorry. So x equal to 5 is a critical point, but it is a h point boundary as well. So I have to check this point. Okay. Now f of 10. F of 10 is minus 100 plus 100 plus 100, which is coming out to be 100. So of course this one is lower than this. So the global minima will be 100. So 100 will be your answer for this question. Let's move on to the next question. So this is the next question. The global minima of x cube into e raised to power minus mod of x for x belonging from minus infinity to plus infinity occurs at what? Okay, the global minima. They are asking me to find the global minima. So there has to be a global minima because it is a NAT type question. There will be a global minima. So let me break down my question, right? So when x is negative, right, your mod of x will be replaced with minus of x. So this will be, so your function will become x cube e raised to power x. And when x is positive, your mod of x will be replaced with simply x. So this will be x cube e raised to power minus of x. Okay. So this is my function definition basically. Okay. So now where will the global minima be at? So if I find the derivative of this function, right, this will be 3x square into e raised to power x plus x cube into e raised to power x. Okay, let me try to plot the function as well. So when x is greater than 0, so okay, I cannot actually plot the function. So let me do the differentiation. Okay, so first of all, x equal to 0 is a point where the definition of the function is changing, correct? So if the definition of the function is changing, so x equal to 0 can be a critical point. So I have to check the value of the function at x equal to 0, that is for certain, that is equals to 0, right? F of 0 is simply 0. Now let's check it for the other points. For the other points, let me differentiate this function. This will be, as I was differentiating it, 3x square into e raised to power x plus x cube into e raised to power x. Simple chain rule, right? This is equals to 0. So this will be, if I take e raised to power x is never equal to 0. Okay, for no value of x, e raised to power x can go to 0. Only x, if x is infinity, then only it can go to 0, right? Minus infinity, but we will not obviously not put minus infinity. So from here I can take my x square common. So this will be 3 plus x equals to 0. Okay, so x will be equals to, like I have two zeros at 0 and one root at minus 3. Okay, what about here? So the derivative of this, right, will be this will be 3x square again, but this will be minus 3x square into e raised to power minus of x into minus of x cube e raised to power minus x, right? So I will equate this with 0. Again, e raised to power minus x, I will assume it will not go to 0. So here again I get critical points, that is 0, 0 and x equal to 3. So basically, right, if I plot the derivative, okay, so at x equal to 0 I have basically even number of roots, right? So the sign at x equal to 0 will not change. So if I plot the function at x equal to, because this definition is valid for x less than 0, if I plot the function at negative infinity, okay, so this will be what, this will be always positive, right? This will always be positive, okay, and this will be some negative value, x cube will be some negative value, this will be some positive value, but x cube is there, right? So x cube is there overall. Like if I take the, what am I saying, if I take exponential common, if I take here exponential common, like basically I am plotting my f dash of x before x less than 0. So this will be, if I take my exponential common, this will be e raised to power x into 3x square plus x cube, right? So if x is very large number, negative number, because this definition is valid for negative values, so obviously x cube will dominate, right? Higher order term will dominate, so it will be something negative, right? So my sign will be something negative because this is always positive, right? So I will start from something negative here when x is less than -3. So or simply you can, what you can do is, this is equals to e raised to power x into x square into 3 plus x. So let us take an example, x is -4. If x is -4, this will be negative, this will be positive, this will be positive. So overall it will be negative. So before x equal to 3, right, sorry, -3, my value will be negative, and at x equal to -3, because it is an odd root, the sign of the curve will change, sign of my slope will change, it will become positive. You can confirm this, put x equal to -2. So this will be positive, this will be positive, this will be positive. And again at x equal to 0, right, this will be 0 because I have even roots, and the sign will not change. How can I confirm? Again, what is the derivative function when my x is positive? It is x cube e raised to power minus x, e raised to power, yeah, e raised to power minus x, right? So if I choose any value, right, you choose, sorry, not x, sorry, not this, this is the definition, right, this is the definition. So this will be basically e raised to power x into x square into x plus 3, okay. So yeah, if my x is 1, this is positive, this is positive, this is positive, so it is always positive, correct? Yes. So when does it go negative? Because at x equal to, does it ever go negative? Okay, in our range x, okay, here I get, oh sorry, one mistake, so this will minus, this was, oh sorry, this was negative, right? So this was x minus 3, sorry, what am I telling? So at x equal to 1, what is happening? X equal to 1, this is negative, oh this is also negative, so this is positive, this is positive, okay, so it will come out to be something negative. I was wrong, sorry. Okay, because the definition of the function here changes, right? So at x equal to 1, it is something negative, so it will actually cross over. Oh, that is interesting. So x equal to 1, it is crossing over. Here at x equal to 1, it is positive, yes, because okay, x equal to 1, this function is anyways not defined, this function is defined for x less than 0, okay, because at x equal to 0, right, my function is not defined, I cannot directly say, but I definitely know that the slope, right, is 0. At x equal to 0, the slope will be 0, because from the left hand side also, if I put x equal to 0, it is, sorry, here if from the left hand side if I put x equal to 0, it is 0. From the right hand side as well, if I put x equal to 0, the slope is coming out to be 0, okay. So definitely at x equal to 0, the value of the slope will be 0, and I can see if I put here x equal to 1, the sign changes, right, this will be negative, so it will go from positive to negative, and then again x equal to 3 is a critical point, I have a odd root, so again the sign will change. You can put here x equal to 4, this will be positive and positive. So this will be positive. Okay, so this is the sign of my slope basically. But what have they asked? I forgotten. What is the global minimum? So when does my global minimum occur? Global minimum will occur when my slope initially was negative, then it become positive. So this is one of the possible point. This is the other possible point, right? Plus 3 and minus 3. Whenever my slope is negative and it becomes positive, and these points are valid totally. These points are differentiable. So let me put the value of minus 3 and 3. I can calculate. So if I put minus 3 here, right? If I put here minus 3, this will be something negative. Like this will be minus 27 into e raised to power minus 3. That will be some value. Okay, I can find out the value. 27 into hold on a second. Into 27. So it comes out to be minus 1.344. Okay, and what about this? If I put x equal to 3, this will be same, but negative sign will not be there. That's it. This will be 27 into e raised to power minus 3, but negative sign will not be there. So this will be 1.344. Okay, so what is the minimum basically? Global minimum, right? They're asking me the global minimum. So the global minimum will occur when? The global minimum, they're asking me when will the global minimum occur at, for what value of x? So the global minimum will occur at minus 3, x equal to minus 3, right? Because at x equal to minus 3, this is like I have two local minimums. This is one of the local minimum, this is another local minimum where the slope changes from negative to positive. But I see that if I put the values, global minimum will be minimum of these two. So what is the minimum of these two? This one. And when does it occur? At x equal to 3, right? So x equal to 3 global minimum will occur. So sorry, not 3, x equal to minus 3. At x equal to minus 3 global minimum will occur. So x equal to minus 3 will be my answer for this particular question. So with that, we are done with all the maxima minima questions. So I hope you have enjoyed. If you have enjoyed, please do hit the like button and comment down below, because these are not simple questions, and if you just learn the concept on the surface level, you will not be able to solve these kind of questions. Okay, so we will start with the mean value theorem. So let's start with this mean value theorem, right? There are many mean value there are many theorems, so we will discuss one by one. Don't worry, you don't have to, like, few things you have to remember, okay? But mostly I will try to explain in such a way that you don't have to remember the all the things. So the first one is Rolle's theorem. What does Rolle's theorem say? That if a differentiable function attains equal value to states that if a differentiable function attains equal values at two distinct points, then it must have at least one fixed point between them where the first derivative is 0. So if I have a function that is differentiable in the range, and in two distinct points the function attains the same value, then there must be a point between the range, at least there must be one point that has a derivative 0. Like Rolle explained this, so it was Rolle's theorem. But I hope you can, like, there is nothing to remember, right? So if I have a function like this, and my function attains the same value in two distinct points, and if the function is differentiable at all points, then definitely there will be a certain point where this will curvature basically there will be a minima or a maxima, right? So of course at minima and maxima the derivative will be 0, correct? That is what they have told, the derivative will be 0. Now at least one fixed point, there can be 2 points as well, like this, right? So here as well, between this point and this point, the function is attaining same value, but how many times is my derivative 0? Thrice. Okay, so at least it has to at least once attain it 0. It can be more than once as well. Okay, so these are the conditions. First of all, simply f of x has to be differentiable between a and b. If f of x is differentiable between a and b, and if f of a equals to f of b, then simply there will be some point c lying between a and b that will be 0, whose derivative will be 0. Okay, that is what my Rolle's theorem is, right? Simple as. Okay, you have understood. Same thing I have told you here. Okay, now one more thing is there. Between any two roots of a differentiable function, there is at least one roots of a derivative. What do I mean by it? So like it is nothing but the extension of Rolle's theorem. So if I have a function f of x, right, and between the two roots, that is alpha and gamma, what does root mean? Root means where my value of the function goes to 0. So f of alpha is equals to f of beta, and it is a special number, that is 0. So alpha and beta are roots of my function, and where my function attains the same value. Now what they're telling me, there is at least one root of its derivative. There is at least one root of its derivative. So if my function attains the same value, right, like also it is equals to, let me not take, let me take beta, let me not take gamma right now. So between alpha and beta, the function is like, function has root at alpha and beta. So f of alpha is also 0, f of beta is also 0, right? So function is attaining the same value and function is differentiable. So definitely there will be a root of the first derivative. What do I mean? It basically means root of first derivative, meaning what is first derivative? F dash of x, and root meaning the value will be 0. The value of x at x equals to root, the function will be 0. That is, the first derivative will be 0. This is nothing but the Rolle's theorem. So Rolle's theorem states that if I have a function that attains same value between 2 points a and b, between the points a and b there has to be a point c such that that derivative of that function will be 0. In our case, it is a special case. At alpha and beta, function itself is a 0. Basically, alpha, beta are my roots of my function. And if it is attaining the same value and it is differentiable, then definitely there will be a point between alpha and beta where the first derivative will be 0. And whenever a function is 0, that is called as the root of that function. So as first derivative is 0, so this will be the, at point c, right, c will be the root of my first derivative. So it is, this statement is nothing but the extension of Rolle's theorem. Okay, what is Bolzano's theorem? So I think we have talked about this previously in brief about Bolzano's theorem. So Bolzano's theorem tells me nothing but if I have simply a differentiable function, okay, between a and b, and let's say the sign of a and sign of b are both opposite. If a is positive, b is negative. If b is negative, sorry, if b is positive, a is negative. So basically f of a and f of b both have different signs. So the, what will be the multiplication of f of b and f of a? It will always be negative, that is less than 0. Because if one of them will be positive, other will be negative, so the sign will be always negative. Now if f of b and f of a are opposite signs and the function is continuous between the range, so it has to cross my 0 ones. So there has to exist one root if the function is a real function obviously and it is differentiable. Like there will be at least one root between a and b. Why? Because if my, let's say my function is plus 1, okay, and at f of a is plus 1 and f of b is minus 100. So if my function is continuous, right, so if I am starting from plus 1, I have to reach minus 100. So there are many ways to reach minus 100, but if it is continuous, I have to, the curve will be continuous. If it was discontinuous, then what I could have done is I would have reached till here. This is my 0 crossing line. I would have reached here, I would have made an open circle, then I would have lifted up my pen and then again put a dot over here, close circle, and then reach my minus 100. This is my minus 100, correct? So if it was not continuous, I could have reached minus 100 without crossing the 0 crossing point, right? That is y equal to 0, without crossing, like, yeah, without y equal to 0, crossing y equal to 0. But if my graph is continuous, if I am going from plus 1 to minus 100, I have to cross the 0 crossing point, that is y equal to 0. So basically what does Bolzano, like, they have given names, but like these are understandable using basics, right? So basically my function will cross 0, that is what it is telling. So there will exist a point c where the function will be, value of the function will be 0. Okay, that is the Bolzano's theorem. So if they ask you calculate the value of c by using Rolle's mean value theorem, what you will do? So you will check where does my derivative of the function goes to 0, right? whenever your derivative of the function will go to 0, that will be your like value of c. Because what does Rolle's theorem tell me? Rolle's theorem tells me that if I have 2 points, like they will always give you the range a and b. Between these 2 points, if the like function attains same value at these 2 points, then between these 2 points I will have the first order derivative of the function to be equal to 0, and that point where the first order derivative will be 0, that point is called as c, right? So that is what they're asking. So basically simply they're asking when will the first order derivative be 0 in the given range. It is nothing, right? No need to complicate. They're simply just asking you when will the first order derivative be 0. Okay, so first of all you will verify are the values same at f of a and f of b. So let me calculate f of 1. So f of 1 is 0, f of 2 is also 0. So function is attaining same value. So Rolle's theorem is applicable. Okay, so now you will calculate the f dash of x. F dash of x will be this will be 2 into x minus 1 into x minus 2 plus 3 into x minus 2 whole square into x minus 2 whole square. Okay, now there will be a value c such that this is equals to 0, right? So I will replace my x with c and I will solve for c. That's it. That is what my Rolle's theorem is, right? That is how you find out the value of c. So this will you will do 2 into c minus 1 c minus 2 plus 3 into c minus 1 whole square into c minus 2 whole square. So now what you will do, sorry, this will be whole cube, right? I will have a cube here. Yeah, this will be cube. So I can take common c minus 1 and c minus 2. C minus 1 and c minus 2 I can take common. Okay, c minus c minus 1 and c minus 2 whole square. Actually I can take common c minus 2 whole square. Now the thing is, this will be like, if I take this common, this will be c minus 2 whole square. This will be 2 into c minus 2 plus this will be c minus 1 3 into c minus 1. Okay, 3 into c minus 1. So the thing is, this will be equated to 0, right? Now this is equal to 0 when my c is 1 and 2, but c1 and 2 I will not choose, I will ignore, because those are my endpoints. So there will be a point between 1 and 2 that I will choose. Okay, so c has to lie between 1 and 2. C cannot be 1 and 2, right? They cannot be endpoints. Okay, so I have to equate this equation equal to 0. So if I equate this one to 0, this will be 2c plus 3c, that is 5c. This will be minus 4 plus 3, so this will be 7. So c will be equals to 7 by 5. That is equals to 1.4. Yeah, 1.4. So c equal to 1.4, which is lying between 1 and 2, which is the answer basically. Okay, of course I will not choose c equals to 1 or 2, because those are my endpoints, right? C will lie between 1 and 2. Okay, so if you understand, like at x equal to 1.4, the derivative is 0. That is what they are asking. That's the only thing, right? When will the derivative go to 0? Okay, now next one is like, for this you have to remember this one. You have to remember this like equation. Okay, so Lagrange's mean value theorem basically tells me that this slope of this chord, right, the line joining these 2 points, the slope of this line joining these 2 points P and Q, the end points, will be like, there will exist a point C that will be parallel, like this line, that line will be parallel to this. And when are 2 lines parallel? When their slopes are same. So basically if I find out the slope, that is f dash at point C, that is f dash of C, this will be equals to the slope of this line. What is the slope of this line? This is f of Q minus f of P divided by the Q minus P. That is what my Lagrange's mean value theorem is, and your Rolle's mean value theorem is a subset of this. So when your f of p and f of q are same, then this will be 0. So basically your f dash of c will be equal to 0. So originally, like this was like initially Rolle's gave the theorem, right? So that was Rolle's mean value theorem, but actually the theorem is this one. So basically what is the theorem? Basically if I have given two endpoints and the function is differentiable between the two endpoints, then the slope obtained from the line joining the two endpoints, there will exist a point C whose slope will be same as this slope. That is my Lagrange's mean value theorem. So if they are asking you to find the value of C using Lagrange's mean value theorem, basically they are asking you to find the point C where the slope between the range given is same as the slope obtained from the endpoints, line joining the endpoints. So let me first write the derivative equation, right? So f dash of x will be, this will be, right? I can actually break it down first of all. What is my f of x? F of x equals to x into x square minus 2x 3x plus 2. So so this will be x cube minus three x square plus 2x. So if I differentiate this function, this will be 3x square minus 6x plus 2. Okay. Now, what is the slope obtained by the line joining these 2 points? So what is my f of 0? F of 0 is simply 0. What is my f of 3 by 2? F of 3 by 2 is, this will be 3 by 2 into 3 by 2 minus 1, so 1 by 2, right, into 3 by 2 minus 2, so 3 by 2 minus 2, so 1.5 minus 2, that is minus 0.5, so this will be minus 1 by 2. Okay, so this will be equals to minus three by 8. Okay, so yeah, so now what is the slope obtained by these 2 points? So f of 3 by 2, right, minus f of 0 divided by 3 by 2 minus 0, right? This should be equals to the slope at C. So this is f dash of C. So this will be 3c square minus 6c plus 2. Okay. So from here, what is f of 3 by 2? That is minus 3 by 8, and f of 0 is 0, right? So this will be minus 3 by 8 divided by 3 by 2. So 3 will be cancelled. This will be minus 1 by 4. So 3c square minus 6c plus 2 will be minus 1 by 4. Okay, and then you can simply solve this equation. So this will be 3c square minus 6c plus 1 by 4. So plus 1 by 4 will be plus 9 by 4 equals to 0. Okay. So yeah, so my C is equals to minus b, that is 6, plus minus b square, that is 36, minus 4ac. So minus 4ac, 9 into 3, that is 27 upon 2a. 2a is 3, remember, don't forget, a is 2a, right? A is 3. So this will be 6 plus minus, so 3, right? Because under root 9 into 2 into 3. So this can be either 9 by 2, sorry, 3 by 2, or it will be 1 by 2. Now, of course, 3 by 2 is not possible, right? Because it is lying outside, like it has to lie between the 2 points, right? It has to lie between the 2 points. So of course our answer will be 3 by 2 I will reject because it has to lie. C must belong within 0 and 3 by 2. It should not include 3 by 2. So I will choose my 1 by 2. 1 by 2 will be my correct answer for the question. Okay, so that's how you will solve. Then there is Cauchy's mean value theorem. It is nothing but extension of like Lagrange's. So if I find out the, like if I have two functions, previously I had one function, right? So let's say if I have two functions and for those the endpoints are same. So this is one function f of f dash of g. I have similarly another function g dash of c, and the slope of that function is what? At point C it is g of b minus g of a divided by b minus a. Okay, I have two functions, right? F dash of c and g dash of c. Okay, the slopes may be different, but the x points are same. The x points are same. Okay, then you will simply divide these two equations, right? So I will get f dash of c upon the x points are same. The slope values can be different. F dash of c upon g dash of c will be equals to f of b minus f of a divided by g of b minus g of a. Okay, and this is nothing but my Cauchy's mean value theorem. So it is the extension of Lagrange's. So what do you need to remember? Lagrange's. Cauchy's mean value theorem is Lagrange's mean value theorem for two functions. That's it. No need to remember this additionally. Just remember the Lagrange's mean value theorem. And for Lagrange's as well, you don't need to remember. You have to find out the slope of the lines joining the endpoints and equate it with the slope between the two endpoints. That's it. Slope of the function. Okay. So if I have a function e raised to power x and g raised to power x, sorry, gx and f of x, then by Cauchy's mean value theorem, what will be the value of c? Simply what you will do, you will again find the f dash of x. This is e raised to power x. You will find g dash of x, that is minus of e raised to power minus of x. Okay, and your x lies between 0, 2. So now what you will do, you will directly say that my f dash of c upon g dash of c, right? That is basically e raised to power c upon minus of e raised to power minus of c. This will be equals to, basically the endpoints will be cancelled because for those the endpoints are same, right? So it will be f of b minus f of a. What is f of b? E raised to power 2. E raised to power 2 minus e raised to power 0 upon f of b. So e raised to power minus 2 upon e raised to power minus of 0 for the gx function. So from here I can get my value of c. So this will be e raised to power 2c, minus sign can go there, right? So if minus sign goes there, this will be e raised to power, I can take e raised to power, okay, let me do one thing. Let me multiply by e raised to power 2 on both sides. Shall I do it? Yeah, let me do it. If I multiply, should I multiply? So this will become e raised to power 2 minus, okay, let me multiply the negative sign first. If I multiply the negative sign, this will be e raised to power 0 minus e raised to power minus 2, and this will be e raised to power 2 minus e raised to power 0. So what I can do, I can take e raised to power 2 common here. If I take e raised to power 2 common, this will be e raised to power 0 because 1 is e raised to power 0 minus e raised to power minus 2 upon e raised to power 0 minus e raised to power minus 2. So this will be cancelled simply. So my 2c will be simply 2 because I can just compare the powers. So from here I get the value of c, and c must lie between the endpoints. In our case it is 0 and 2, which is exactly between the endpoints. So yeah, c equals to 1 will be my answer using the Cauchy's mean value theorem. So in Cauchy's, right, you just apply the formula, that's it. So what you have to remember, Lagrange's mean value theorem, that's it. So mean value theorem is a very short topic, but questions have been asked, so we will solve them one by one. So this is the first question, like a function f of x is defined in the closed interval, the value of x in the open interval for which the mean value theorem is satisfied. So by default, if they're telling mean value theorem is satisfied, that is basically they are asking talking about the Lagrange's mean value theorem. Okay, they are talking about the Lagrange's mean value theorem. By default, you will assume Lagrange's mean value theorem. Okay, so if they're talking about Rolle's mean value theorem, the slope must go to 0. That's it. Sorry, not slope must go to 0. Basically, but what is the mean value theorem? Mean value theorem is this only. Okay. The Rolle's mean value theorem was the subset of this, where my endpoints values, functional values were same. So this was becoming 0. So my f dash of c was 0. So mean value theorem is this only. This is the mean value theorem. That's it. Okay. If the endpoint functional values are same, this will be 0. So your f dash of c will be 0. So from there we just discuss the conclusions. That's it. That is my mean value theorem. Okay. So yeah, let's solve the question. Mean value theorem. What is the mean value theorem? F dash of c, there will exist a slope for which the slope of the connecting the endpoints will be same as the slope between the point a and b minus a. So yeah, so f dash of c, so this will be minus 2 x, right, minus 2x. So what is f dash of x? F dash of x is simply minus of 2x plus 3x square. Okay, minus of 2x plus 3x square, and what will be f dash of c? It will be minus of 2c plus 3c square equals to f of b minus f of a. So what is f of b? 1. If I put here 1, right, this will be simply 1 minus 1, this will be 0, this will be minus 1. So f of b is minus 1. And what is f of a? If I put here minus 1, right, this will be 1 minus 1, again 0, this will be minus 1. Sorry, if I put 1, if I put here 1, right, if I put here 1, this will be 1. If I put here minus 1, this will be gone, this is minus 1. Okay, this divided by b minus a, so 1 minus of minus 1. So basically this will be minus 2c plus 3c square equals to, this will be 2 divided by 2, that is 1. Okay, 2 divided by 2, that is 1. Am I correct here? Yes. So basically this will be, equation will be 3c square minus 2c minus 1 equal to 0. So minus of b plus minus b square minus 4ac. So plus 4ac. Okay, 4ac, right? 4 into c. So this is into, so this is 12. Yes. B square minus 4 is, what am I doing? B square minus 4 is, so b is 4. Yeah, and divide by 2 into a. So this will be 2 plus minus 4 2 into 6. So this will be either 6 by, so 6, it can be 6 by 6, that is 1 by 2, or it will be minus 1 by 6, and interval is from minus 1 to 1, and both of them are lying in the interval. Okay, that is interesting. So which one shall I, am I doing something, some sort of mess up here? B minus a, this is 2, this is f of b is 1, this will be 1, and this will be minus 1, correct? Okay, and the derivative of this function is simply minus of 2x plus 3x square. So this will be plus 3c square minus 2c, this will be 1, this will be minus 1, b square, it is 4, minus 4ac, so this will be plus, and minus of v, that is 2 upon 2, sorry, 2 into a, sorry, this will be 2 into 3, sorry, 2 into 3, so this will be 6 basically. So either it will be 1 or minus 1 by 3. So of course 1 is the border, right? they are asking me what is between like 1 and minus 1, between 1 and minus 1. Okay, so between 1 and minus 1, minus 1 by 3 is lying, so minus 1 by 3 will be your correct answer for the question. So option B will be your correct answer. Okay, because they are asking me which is lying between the points, not excluding the points minus 1 and 1, excluding the points minus 1 and 1. Let's solve the next one. So here we have been given the function, okay, and it is a continuous in this function, like obviously we can see it is polynomial, so it will be differentiable as well. The point x at which the tangent f of x becomes parallel to the straight line. So basically they are asking me the Lagrange's mean value theorem, right? So basically it will be equals to, so what is the slope f dash of x? 2x minus 2. So what is the slope? That is 2c minus 2 must be equals to the slope joining the line, like the line joining the 2 points. So f of 3 minus f of 1. Okay, so what is f of 3? F of 3 will be 3 square, that is 9 minus 6, that is 3 plus 2, that is 5. Okay, f of 1 is 1 minus 2, that is minus 1, sorry, minus 2, minus 1 basically, and 3 minus 1. Okay, so this will be your like equation, and from this I can get the value of c. So this will be 4 by 2, that is 2, 2, 2, this will be 4, so c will be 2, c will be 2. So at x equal to 2 or c equal to 2, the tangent will be parallel to the line joining the straight line f of 1 and f of 3. So c equal to 2, option C will be the correct answer for this particular question. Okay, so these are simple questions only, they will not ask like super difficult question from mean value theorem. Okay, this question is interesting. The polynomial is given which has a degree higher than n equals to 3 with real coefficients, all these are real coefficients, has triple root at s equals to minus of sigma, which one of the following condition must be satisfied. So this polynomial is a higher order polynomial, okay, that is greater than 3, and it has 3 roots at s equals to minus sigma. This psi of s equals to 0 at all the 3 values of s satisfying this equation. Is it correct? Psi of s will be 0 at all the 3 values of s satisfying this equation. No, this is incorrect. This is what s cube equals to minus of sigma cube. So s will be equals to 1 cubic root of sigma. Now this minus 1 raised to the power 1 by 3, right? It has 3 solutions, out of which 1 is real, that is minus 1, and 2 are imaginary, complex basically. Okay, but I cannot have a complex solution because all the like they are telling me that it will have equals to 0 at all the 3 values of s equals to s cube minus sigma cube. That is not correct, because when my s is minus of sigma, right, then yes, definitely it is 0, but all the 3 roots are at minus sigma only. But here the solution of this equation is telling me that I have 2 roots that are complex, like this you will learn in complex, right? So I have 2 roots that are complex, so that is again not possible. So this option is wrong. Let's read this option. So psi of s equal to 0, d psi of d of s equal to 0, d square psi of d of s square equal to 0 at s equals to minus of sigma. Now is this statement correct? So if I have triple roots, right, so how can I write my equation? So my equation can be like this, right? S minus sigma whole square. Like I can do some factorization. If I know I have triple roots, I can do s minus sigma whole square, okay, sorry, s plus sigma whole square whole cube into some polynomial. There will be some a1 raised to s raised to power n, like any value, right, plus a2 s raised to power n minus 1 and so on. Then there will be some constant term an. Okay, I don't care about the order, this will be like n minus 3, I don't care. So let me differentiate this function. So I can use the chain rule. This is my f of s or psi of s, right? I can use the chain rule. So if I differentiate this function, first I will differentiate this one. So this will be 3 into s plus sigma whole square into whatever, let me write this function as a g of s, so into g of s, right? And then I will write this one as it is, right? S plus sigma plus the whole cube, and then I will differentiate this one, that is g dash of s. This is my first derivative, that is d phi upon ds. What they are telling me, that phi of s is 0 at s equals to minus of sigma, definitely, right? Because s equal to minus sigma is a cubic root, right? So if I put here minus sigma, phi of s will be 0, definitely. But is my derivative also 0? So if I put here s equal to minus sigma, this term is gone. If I put here s equal to minus sigma, this term is also gone. So the derivative is also 0. So this option is, like, this part is correct. Let's now take this part. Is my double derivative 0? So let me differentiate this function again. So this will be d square phi by ds square. So this will be 6 into s plus sigma into g of s plus 3 into s plus sigma whole square into g dash of s, okay, plus this will be again, if I differentiate this function, right? So again I will have two terms. First term s plus sigma whole square 3 g dash of s plus s plus sigma will be there whole cube into g double dash of s, okay. Now if I put s equal to sigma, what will happen? This will go to 0, this will go to 0, this will go to 0, this will go to 0. So basically s plus sigma is again a factor, so this term goes to 0. So this option is absolutely correct, that yeah, my single derivative will go to 0, double derivative will go to 0 at s equal to sigma. So let me check this one. Double derivative is 0. What about third derivative, right? So third derivative will actually not be 0, because once you will differentiate, right, this term will go away, because this is a linear term. Only this term will be left, g of s, 6 into g of s, and this can be 0 or cannot be 0. I cannot surely say. Again, if you do the fourth order derivative, I will have a g dash of s, okay, you can try it. You'll have a g dash of s. This can be 0 or cannot be 0. I cannot say surely that at minus sigma this will be 0 or not 0, right? So I cannot say by confirmation. So which condition must be satisfied? This one must be satisfied, no matter any value, this will always be satisfied. These two, I don't know, it is condition dependent, right? So for these two I cannot comment, but for this one I definitely can comment. So option B will be my correct answer for this question. This is the next question. The smallest positive root of the equation lies in the range what? What is the smallest positive root that will lie in the equation, in the range? So okay, how do I, what is the smallest positive root? Okay, so let me check the sign of the function, right? This is a continuous function, right? So let me check the signs of the function at the h points. So at x equal to 0, what is my f of 0? At the, let me mark the points, let me mark the critical points. X equal to 0, x equal to 2, x equal to 4, x equal to 6, x equal to 8, and of course there are other points, x equal to 10 and x equal to 100, okay. So what I can say is, if I check the sign of the function at f of like x equal to 0, so what is the sign? This, all this is vanished, it is minus 45. So before x equal to 0, right, the function is something negative, okay, just before x equal to 0 function is negative. And if I check at x equal to 1, x equal to 1, what is the sign of the function? The sign of the function is, this will be 1 minus 5 minus 10 plus 50 plus 9 minus 45, correct? So this will be 1 plus 9, that is 10. 10, 10 will be cancelled, and this will be plus 45 minus 45, 0. So exactly at x equal to 0 I have a root. Okay, so sorry, x equal to 1 I have a root, right? X equal to 1 I have a root. At x equal to 1 the function will go to 0 basically. Okay, and if I choose any other point, let's say x equal to 2, if I choose x equal to 2, x equal to 2, what will be the value? This will be 0. At x equal to 2, what is the value? X equal to 2, this is x 2 raised to power 5, so 32. Give me 1 second now. 32 minus 5 into 80 minus 80 plus 200 plus 18 minus 45, okay, equal to 0. So this will be 80 will be cancelled, this will be 32, 50, 50, and this will be something positive. So here it is positive. So definitely as the function is like continuous, so I will be crossing, like there will be some 0 crossing, right, between these two. So that already we have discussed. If the sign of the function changes, there must be a root between the 2 points. Although I have directly calculated that at x equal to 1 I have a root, and that is the minimum value here, right? So that is the minimum value. So of course option A will be your answer, but still we can use that Bolzano theorem, that the sign of the function is changing and the function is differentiable, so there has to be one root between the 2 points. Okay, so like the purpose of this was to explain the Bolzano's theorem. Okay, so let's now solve one more question. I think this is the last question that we have, right? Yeah, this is the last question that we have. So here, for any continuous and differentiable function f of x with first derivative not equal to 0, so first derivative is never equal to 0 and it is always continuous and differentiable, right? Which one of the following is always true for a not equal to b? Okay, f of a will be greater than f of b, f of a will be equals to f of b, f of a will not be equals to f of b, or f of a less than f of b. So they are telling me that f dash of a is never equal to 0, and it is a differentiable function. If it is a differentiable function, right, its derivative will be a continuous function, correct? So if it is never equal to 0, either it will be something like this or it will be something like this. Either it is always positive or always negative. Either it is always positive or always negative. Why so? If I say that your f dash of x, right, is continuous, because it is differentiable. If the function is differentiable, then this graph will be continuous, your derivative will be continuous, and you are saying it is never equal to 0. Now your derivative can be equal to 0 only if I cross my y equal to 0 point, and if it is crossing y equal to 0 point, right, that means for a certain region it will be positive, for a certain region it will be negative, or vice versa. If ever it is crossing the y equal to 0 point, then for a certain region your slope will be positive or negative. But because your first derivative is continuous, if it is continuous, and if I say that f dash of x equal to 0, then it will cross the 0, right? It will obviously cross the 0. So previously it might be negative and positive. Something like this also can happen actually. Okay, something like this can also, I'm just thinking of something like this also can happen, right? Yeah, but it is never equal to 0. Basically it is never equal to 0. If it is never equal to 0, right, it will never touch this point, correct? So if it is never equal to 0, either it will be always positive or always negative. So my slope, right, my slope either is always positive or always negative. And if this is the case, right, then always you will get two different values. If your slope is always positive, let me take this example. If my slope is always positive, if your slope is always positive, what is the like graph of this function? It is y equals to some straight line, right? So your value, right? If I to choose any 2 points, any two distinct points a and b are not same, the value of the function will always be different. If it is always positive, if it is always negative, then also the value of that function, right, at two distinct points will always be different. Either if it is always positive or it is always negative, the value of the function will be always different, it will be distinct. Okay, but I cannot comment whether f of a will be higher than f of b or f of b will be higher than f of a. I cannot comment that because I don't know the sign of the slope. They have not told me that whether my slope is positive or negative. Only thing that I know, because my slope never touches 0, so either it will be always positive or always negative. So either it can be an increasing function or a decreasing function monotonically. So no two values will be same. The two values will be different. Basic example will be e raised to power x and e raised to power minus x. So your exponential function e raised to power x always has a positive slope. So no two values will be same. And e raised to power minus x has a negative slope. So it will be something like this. Correct? So no two values are same. So either one value is higher than other or it is lower than other. I cannot comment, but I can definitely say both of them will not be equal. So option C will be correct. So that's why basics are very important, because they will ask you questions from basics. Okay. So if you have enjoyed till the mean value theorem, so don't forget to hit the like button. Now we will start with series. So let's start with our next topic, that is series and partial derivatives. So like there are many kinds of series. Mainly we will be discussing about Taylor series, and other series are also there, like limit of sum. Those we will be discussing after learning about integration. Okay. So like if you want to visualize Taylor series, right, there is a video from the YouTube channel 3 blue 1 brown. Okay, so you can look it up, search Taylor series 3 blue 1 brown. There he has visualized the Taylor series. Basically Taylor series is nothing, it gives me the approximate value, or approximately, like it can, like the Taylor series formula helps to expand a function around a value of the variable using the derivatives. So basically let's say if I have a graph sin x. Okay, so if I want to approximately write the value of the function around x, do you know what is the value of the function around x? That is x, right, y equals to x. Because if x is very small, what is the expansion of sin x? It is simply x minus x cube by 3 factorial plus x raised to power 5 by 5 factorial and so on. So if x is very small, these terms will be neglected, it will be x. So approximately it will be equals to x. So this comes from where? Actually this series comes from the Taylor series. So Taylor series actually helps me to approximate a function around a certain value. Okay, so like here, what will be the approximate value of the function? Like y equals to some constant value, that is 1. Okay, so here the value of the function will be 1, around pi by 2. Okay, so that is what my Taylor series helps me to do. And the formula, this you have to remember, this formula is very very important, this you have to remember no matter what. Okay, so it will be simply equals to f of x around a value a, right? If I want to approximate my function around a, so this will be f of a, the value of the function at that particular point, plus x minus a divided by 1 factorial f dash of a, plus x minus a whole square divided by 2 factorial f double dash of a, and so on. So I will do an example. I think I have, do I have any example? Yeah, this is the example, right? Expansion of cos x around x equal to 0. So let me expand cos x around x equal to 0. So what is the cos x function? Cos x function is somewhat like this, right? This is my cos x function. So let me expand cos x around x equal to 0. So let me use the Taylor series. Like first I will show you how to use the Taylor series formula. Okay, so my f of x equals to cos of x, and the Taylor series expansion around x equal to a, right? It will be equals to f of a plus the plus x minus a raised to the power 1 divided by 1 factorial into f dash of a, okay, and this will go on basically plus x minus a whole square divided by 2 factorial into f double dash of a, okay, and this will go on, right? 3 factorial, 4 factorial, this will go on, dot 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 dot. So they are asking me Taylor series expansion around x equal to 0. So this will be equals to, what is f of a? That is a equals to 0, right? X equal to 0, like x equal to 0, a is equals to 0 basically. So cos of 0 is 1 minus x minus 0, so it is x only, divided by 1, that is x only, into f dash of a. So what is the derivative? Sin x, minus of sin x. And what is sin of 0? 0 plus x minus a, that is x square divided by 2 into f double dash. So I have to differentiate this again. This will be minus of cos x. And what is cos x? Cos 0? 1. It is minus, right? So there will be a minus sign. Then plus x minus 3, x minus 0 divided by 3 factorial, and that is whole cube. So x cube divided by 3 factorial, that is 6, into again the derivative of this, right? So this will be sin x, and sin 0 is again 0. So this will be 0 plus x raised to power 4 divided by 4 factorial, that is 24, into again the derivative of this, that is cos x, that is equals to 1. So ultimately this will come out to be 1 minus x square divided by 2 plus x cube divided plus x raised to power 4 divided by 4 factorial, then again it will be minus x raised to power 6 divided by 6 factorial, and it will go on, okay. So if I want to linearly approximate my function, right, basically Taylor series expansion helps me to approximate my function. So if I want to say what is the linear approximation around x equal to 0, the linear approximation will be, if x is very close to 0, right, x is very small number, so 0.01, so 0.01 whole square will be even smaller, this will be even smaller, this will be even smaller, so approximately it will come out to be 1. So if I have to approximate my function around x equal to 0 with a straight line, it will be, what will be the equation of the straight line? Y equals to 1. Isn't that what we have got here? Similarly, if you do the Taylor series expansion around x equal to 0 or around any value, okay, around any value, let's say I am doing the Taylor series expansion, I am doing the Taylor series expansion of sin x around 0. So it will come out to be this value, right? You will do it x minus x cube my 3 factorial plus x raised to power 5 divided by 5 factorial, and so on. If I want to approximate this with a straight line around x equal to 0, these terms will be almost equal to 0. So this term will dominate. So it will be approximately equals to x. So isn't that what we see? Around x equal to 0, right? Sin x is almost a straight line. Now I hope finally you can visualize what is the Taylor series. Taylor series is nothing but the approximation of a function around certain value. You can approximate with a straight line. If you want to have a better approximation, so you have to include higher order terms, right? What do I mean by it? So what is, let me take a very simple example. What is like, let's assume that x is in radians, okay, 0.1. What is sine of 0.1? So I will put 0.1, I will find the sine of 0.1. So it is equals to, what is sine, man? Yeah, it is equals to 0. Actual value, exact value of sine of 0.1 is 0.0998. That is the actual value of sine at x equal to 0.1. But if I would have wanted to approximate it around, like with x, right, with a linear function, then what will be the approximated value? It will be 0.1. So there, if you see, there is a bit of delta, there is a bit of error here, right? There is a bit of error here, okay, bit of error. Now let's say I am choosing to approximate it better, so I will choose my higher order terms. So I will include my x cube as well, okay. So this will be x cube, that is 0.1 cube, 0.1 cube divided by 3 factorial, that is 6. Then this will be subtracted with 0.1. So it comes out to be, if I include my x cube as well, this will be 0.099833. Can you see, like this is almost equal? So the more higher order terms I will choose, I will reach more closer to my actual value. Okay, so Taylor series expansion is nothing but the approximation of the function around a certain value. If finally you are able to visualize Taylor series, you have to put a comment below and like the video. Okay, because trust me, everywhere else, whenever they will teach you Taylor series, they will just give you this formula and they will just solve some questions. That I also am doing. I am also solving questions, but I am giving you the visualization as well, because in PrepFusion we believe in giving you the proper visualization, because in the exam maybe instead of solving thousands of questions, maybe a graphical thing can help you. Like Maxima Minima, also I have given you the visualization. We have, like, every question that I have solved of Maxima Minima, I have always used graphs. Of course I had to use equations, that was there, but I was not mugging up anything. I was just using graphs and solving the questions. So yeah, if you are enjoying, make sure to hit the like button. That's it. Okay, so yeah, that is my Taylor series. So now I hope everything is clear. What is exactly my Taylor series? So let's like another series is there, Maclaurin series. Maclaurin series is nothing when you find out the Taylor series around x equal to 0, that is a equal to 0. Whenever your a is 0, that is your Maclaurin series. That's it. So Maclaurin series is nothing, right? It's just a name. But basically, if they are asking you to find out the Maclaurin series of a particular function, then they are asking you to approximate that function in terms of polynomial around x equal to 0. So Taylor series is nothing. It helps us to expand or approximate a function in terms of a polynomial. Okay. So basically, Taylor series helps us to approximate a function in terms of polynomial. Okay. So that is the main thing about Taylor series. And trust me, no other institute will tell you this. These things no other institute will explain. Okay, they will directly tell you the formula. They will directly solve. Now there is few things sometimes they ask. Okay, sometimes they ask what will be the nth term of the Taylor series expansion. So they will ask in the question, if I have a function e raised to power x, what will be the coefficient of the second term of Taylor series expansion? So this is my first term, this is my second term. Okay, so there is a formula, like it is simply, if I have second term, so n will be 2, 2 minus 1, 2 minus 1 factorial, d 2 minus 1, that is d dx into f of x. So either you remember the formula or directly you just remember the series. If they are asking you the nth term, you just figure out, if my second term is this, what will be my fourth term? If my second term has a power of x raised to power 1, then my fourth term will have a power of x raised to power 3. It will be cubic function, right? If my first term has a power of x raised to power 0, then my second term will have a power of x raised to power 1. It is linearly increasing. So I hope that part is clear, right? So sometimes they ask these things. Okay. So yeah, that is clear. So this was the approximation of the cos x. So like here, right, the Taylor series expansion of 1 plus x around x equal to 0 is what? So if I solve this, right, this will come out to be, if we solve this, this will come out to be this. Taylor series expansion of 1 plus x around x equal to 0. Around x equal to 0. Okay. So this is the approximate value of the function around x equal to 0. That's how you can approximate it. So if you remember, like, have we solved this? So you can actually derive any series. Like if you want to find out exponential, what will be my e raised to power x equals to, as a polynomial, you can derive. So in limits, right, we had derived some things. So here you can do it. You can derive that. E raised to power x, what was my e raised to power x equals to? It was 1 plus x plus x square by 2 factorial and so on, right, plus x cube by 3 factorial and so on. So this can be derived. You'll use the Taylor series. Okay, so that's how you simply derive it. Now let's say if they would have asked you what is the linear approximation of 1 plus x raised to the power minus 1 around x equal to 0. So first what you'll do, you'll find out the Taylor series, then you will only include those terms which are of power 1 or lower. You will neglect the higher order terms, because of course if your x is around 0, right, then 0.01 whole cube will be even smaller. So this will be 0, this will be 0, this will be 0, only the linear terms will be left. So that's why if they ask what is the linear approximation of 1 minus x raised to the power minus 1, you will say I will only consider the terms up to x raised to the power 1, that is 1 minus x. That will be my linear approximation. Okay, because if x is very small, I can neglect all my other terms. So like let's solve this question. This question is interesting now. How to find out the Taylor series expansion if my function seems like it is discontinuous about some point. Okay, how to find out the Taylor series expansion. So I see they are asking me to find out the Taylor series expansion about x equal to pi. So at x equal to pi, this is 0 and sin pi is also 0. So I am getting a 0 by 0 format. So is the function discontinuous or is it continuous? So I have to check the limit basically, right? I have to check the limit. So if I find out the limit as x tends to pi, limit as x tends to pi, sine of pi, sine of x upon x minus pi. Now remember, this is here, if I like this will be equals to 1 if I had here x minus pi, right? But this is not x minus pi, this is something else. So how will I solve it? So what can be done? So this, right, this can be like this, that if I replace my sin x with this function, this will be, so my sin x is here and this is my cos x, right? So basically, right, my sin x starts from 0, my cos x starts early, right, from 90 actually, because when sin is 90, like before sin reaches, before this peak, right, the cos hits peak. So cos is ahead by 90 degrees, right? Cos is ahead by 90 degrees, that's why this is anti-clockwise by 90 degrees. So this is my sin x, this is my cos x, and opposite of sin x will be my minus of sin x. Okay, and this can also be called as sine, like I'm going in the anti-clockwise direction by pi from sin x. So this will be also called as sine of x, x minus pi or x plus pi, anything is fine, right? So if I'm going in the clockwise direction by pi degrees from this point to this point, so what, from x I'm moving pi degrees, right? So this will be x minus pi. Why minus? Because I'm moving in the clockwise direction. So minus of sin x is also equals to sine of x minus pi, or you can simply put the values and check, right? Simply if you put pi by 2, you put pi by 2, x equal to pi by 2. So what is minus of sine pi by 2? Minus of 1. What is sine of minus of pi by 2? That is also minus of 1, right? So these are to matching, these equations are matching. So of course, like this, whatever I have written here is correct. So like you can put the values of x and then check whether they are satisfying or not, if you have written this correctly or not. So it will satisfy. Okay, so I can replace here this value with x minus pi. So what I can do, I can multiply a minus 1 and divide by minus 1. Okay, this minus sign will go here, okay, and this minus sign can come at the starting of the limit. So what will happen, or what I can do is I can multiply two negative signs. To do what? I can take one negative sign outside and the other negative sign will be sine of x minus pi upon x minus pi. Now this function will become continuous. Okay, if I find out the limit of this, right, the limit, what will be the limit of this? The limit will be 1. So minus 1. Limit would be minus of 1. Correct? Because this limit will be 1 and I have a negative sign, so limit will be minus of 1. So now I am making the function continuous. Okay, so actually I will, first of all, this function does not seem to be continuous, but here if I do some modification, this function is definitely continuous, sine of x x minus pi by x minus pi. So what I will do is I will expand this function. What is the Taylor series expansion? The Taylor series expansion of this function is nothing but simply, like, I can directly expand, right, my sine function. So this is 1 by x minus pi. What is the Taylor series expansion of x minus pi? The Taylor series expansion of x minus pi, this is equals to x minus pi raised to the power of 1 minus x minus pi whole cube divided by 3 factorial. Okay, plus x minus pi raised to the power 5 divided by 5 factorial minus, and so on, right? It will go on basically. Okay, so if I divide this, so the negative sign will be there, minus 1 plus of x minus pi whole cube divided by 3 factorial minus x minus, not cube, sorry, because this will be squared, there is one x minus pi, minus x minus pi raised to the power of 4 divided by 5 factorial, and so on. Okay, so basically this will be minus 1, yeah, x minus pi whole square divided by 3 cube, yeah, this will be correct. Okay, now you might have a doubt, sir, how have you came to this conclusion, right? How have you came to this conclusion? First of all, when my x is equals to pi, right, what, to which value this will tend to, basically, when my x is equals to pi, which value will it tend to? So around x equal to pi, so what is the x equal to pi is this right? Yeah, function is going from positive to negative. Okay, so can you approximate the function linearly around x equal to pi? What will be the approximate value of the function around x equal to pi? So first of all, if I draw a straight line, right, this is a straight line with negative slope. So if I linearly approximate a function, I know the function has to pass through y equal to 0 at x equal to pi, because at x equal to pi, sine of x is 0. It has to pass through this point. Okay, that is for certain. And what will be the slope of the line? So I know what was the slope here. The slope here was plus 1, right? This was approximated with plus 1. So the slope here also will be minus of x, because it is negative, it will be minus of x, right? And minus x plus c equals to y, the slope is minus 1 basically. Here it was plus 1, it will be just negative, right? This is symmetric function. If the slope here was plus 1, this will be minus 1. Okay, I'm just approximating my function around x equal to pi. And I know it will pass through this point, that when my x is pi, y will be 0. So if I put my x equal to pi, y has to be 0. So c has to be pi. So this will be y will be equals to pi minus x. So this is my approximate value of the function around x equal to pi. So I will just replace this value right here. I will replace my value here, like directly you can do it with limits, right? With limits I've already done it, the approximate value. But here again I can do it around x equal to pi. What will happen? This will be pi minus x divided by x minus pi. When x is very small, right, it is not 0, x is very small, I can cancel these two values. So what will happen? This will be minus 1. X is, sorry, not x is very small, so not x is very small. When x is very near to pi, when x is very near to pi, but it is not exactly equals to pi, right? It is not exactly equals to pi. When x is very near to pi, it is not exactly equals to pi, then these values will cancel. So basically x will be some tending to some value h, where h will be tending towards pi. Okay, but this value will be almost tending towards 0, but not exactly equals to 0. So I can cancel these two values, so it will become minus 1. So around x equals to pi, the value will be minus 1. Around x equals to pi, the function will be approximated as minus 1. So in out of this equation, if I put x equals to pi, this will be plus 1. So this is anyways gone, right? Around x equal to pi, if I put here, right, this will be minus 1. So this is a possible answer. Around x equal to pi, if I put here, this will be plus 1. Again, this is gone. Around x equal to pi, if I put the value of x equal to pi, right, this will be again minus 1. So this is again a possible answer. This is a possible answer. Okay. So whenever your function is discontinuous about that pi point, right, actually you are never allowed to put the pi point, because your function is like actually the function does not exist at x equal to pi. But approximately if I approach my function, right, it should go reach towards minus 1. That is the concept of limits. So actually your function is discontinuous. So you are not allowed to put x equal to pi. X equal to pi is not in the domain. But what we are doing, we are very smart. We are saying that we are not putting x equal to pi, we are very near to x equal to pi. So when I am very near to x equal to pi, what will be the approximate value of the function? Minus 1. I have shown you two methods. One is using basic limits, okay, and sinusoidal. Another one is using approximation of a line. Trust me, no one will tell you this method, okay? That method that I am telling you, no one will tell you this method, okay? So approximately the value of the function will be minus 1. With both methods, I am able to get around pi. Okay, so that part is clear. But now how can I eliminate these two options, whether it will be minus or plus? So for this, again, you actually have to now solve it. Basically, like you have to solve the limits. You have to write this function like this. Otherwise, okay, this also will work. Basically, sin x upon x minus pi also will work. But I'm always seeing that there is some x minus pi in the numerator, right? X minus pi is on the numerator. So my first thought that will come to my mind is converting this x, right, to x minus pi. Okay, because I can see that x minus pi is in the numerator. Okay, so that will be my first thought in the mind. So like you have to convert your sine. I know my sin x is equals to what? Sin x is equals to minus of sine of x minus pi. So that will be my first thought basically. Okay, and remember, you are not allowed to put x equal to pi here, but that's why you can divide x minus pi and x minus pi like this, right? Because your x, right, is all real values except pi. Except pi, x can take any values, because I'm dividing by x minus pi, right? Once you're dividing by x minus pi, that means your x is never equal to 0. So actually you can never get the value of the function at x equal to pi, because it is undefined. But what am I doing? I'm approximating the value of the function by calculating the limits. So this is the only way to solve this. Okay, so you will because in the options I'm seeing that there is x minus pi 3 factorial, and here also everywhere in the numerator I have x minus pi, and I understand this is something, it is somewhat similar to the series of sin x. It is somewhat similar to the series of sin x, okay, upon 3 factorial. So that will be my first thing that will come to my mind. Okay, so yeah, I hope this thing is clear. How am I solving this question? So of course, another way to solve this question would be, this also is totally valid. Like if I expand my sin x, if I keep my x minus pi as it is and expand my sin x, right, this also is completely valid. This will be x minus x cube by 3 factorial into x cube by 3 factorial plus x is to the power 5 divided by 5 factorial, and so on, right? So this will become x divided by x minus pi minus x cube divided by x minus pi into 3 factorial, and so on. Now this also is completely valid. There is no problem with this. Okay, but how will I solve this around x equal to pi? So basically, then what you have to do is, okay, yeah. So if this was in the options, this also will be a correct answer. But in the options, this was there. So my first instinct will be to convert this x into x minus pi, like sin x to sin x minus pi. That will be my first instinct, so to cancel these things out. Okay, so I hope this part is clear, how to solve the continuous and discontinuous, like around discontinuity. Let's solve another question like this. If I want to write my polynomial in terms of polynomial, basically if I have a polynomial x square minus x plus 1 and write in terms of power of x minus 1. So basically what they're telling me to write the Taylor series about x equal to 1. If they are asking you to write in terms of x minus 1, so they are asking you to write about x minus 1 basically. Okay, so what you will do, you will write the Taylor series of this function around x equal to 1. So if I write the Taylor series, this will come out to be x minus 1 whole square plus basically, sorry, not this, sorry, this one, 1 plus x minus 1 plus x minus 1 whole square divided by, sorry, 1 plus x minus 1 plus x minus 1 whole square. Okay, so similarly if I say, let's take this example, if I have x square plus 3x plus 2 and write this polynomial in terms of x minus 2. Okay, so how will you write it? Like basically I have to write the Taylor series expansion about 2. So this will be what? This will be f of 2 plus x minus 2 into f dash of 2 plus x minus 2 whole square into f double dash of 2 divided by 2 factorial x minus 2 whole cube divided by 3 factorial into f triple dash of 2. But actually if you calculate the triple derivative, like the highest power is 2, right? So once I will do the derivative, second time I will do the derivative, it will come out to be 2. Third time once I will do, this will become 0, right? So all the higher order derivatives will be simply 0, because you can never express, like if it's a second order polynomial, right, I can never express it in terms of a third order polynomial. That is not possible. So automatically these terms will be vanished. So only this term will be left. So what is f of 2? F of 2 is 4 plus 6, that is 10. 4 plus 6, that is 10, plus this is 2, right? So this 2 will, so this will be x minus 2 into f dash of 2. What is f dash of x? F dash of x equals to 2x plus 3. Okay, 2x plus 3. So if x is equals to 2, that is 7. Okay, 7 plus x minus 2 whole square divided by 2 factorial into f double dash of 2. F double dash of 2, this will be basically, if I differentiate this again, right, this will be 2 only. So this will be basically into 2. So this will come out to be x minus 2 whole square plus 7x minus 2 plus 10 into x minus 2 raised to power 0. So basically I have written my polynomial in terms of my x minus 2, right? So that is what this question means. If you want to write your polynomial in terms of x minus 1 or a factor x minus 2, so that's how you can expand it. Okay, so let's solve one last question. So this is okay, we have, okay, so we have this question as well, right? Expand sine pi by 4 plus theta in power of theta. Okay, so where my theta is variable, basically in power of theta. So they are just asking me to expand my sine pi by 4 in the power of theta. So but about what? About what I have to expand? They have not told me about what I have to expand. So I can simply expand this, right? I can but they are asking me to expand it about theta. So I know one thing that if this was for some reason, if this was only sine theta, right, then this would have been theta minus theta cube divided by 3 factorial plus theta is to power 5 divided by 5 factorial and so on. So I have to expand like in power of theta, right? I want to expand like this, correct? But the problem is here I have pi by 4. So this will come out to be something weird. This will be theta plus pi by 4, right, plus sorry, minus theta plus pi by 4 whole cube divided by 3 factorial plus theta plus pi by 4 whole raised to power 5 divided by 5 factorial. So here, right, this term will be actually present. So what I can do is I can convert this as a single power, let's say t, where my t is pi by 4 plus theta. And what is the Taylor series expansion about a of t? So it will be f of a plus t minus a by 1 factorial into f dash of a plus t minus a of whole square divided by 2 factorial into f double dash of a. So what do I want? I want here, right, instead of t minus a, I want here theta basically. That is my purpose, right? My purpose is to get theta here because I want to write in terms of theta. So t minus a, all this I am doing to find out about what point I have to find out the Taylor series expansion so that I can write my sine function as a power of theta. So t minus a will be equals to theta. And what is t? T is pi by 4 plus theta, right? So t is pi by 4 plus theta. So this will be theta is equals to pi by 4 plus theta minus a. So from here I get the value of a, that is pi by 4. So I have to actually expand around pi by 4. I have to do the Taylor series expansion about pi by 4. Then I will be able to get my function as a power of theta. Okay. So that is what I will do. I will expand my function about pi by 4. So if I do the expansion about pi by 4, what will happen? So this will be f of pi by 4. What is f of pi by 4? F of pi by 4 is this sine pi by 4 plus pi by 4, that is hold on a second. So sorry, f of pi, this will be f of a. Remember our function is now sine of t, right? So this a point is actually for t. So this is my f of t, remember, because we have changed my function. So this will be f of pi by 4, that is f of t, that is when t is pi by 4. So around t equals to pi by 4, I have to expand. Around t is equals to pi by 4, I have to expand the function. Okay. So this will be f of pi by 4. This will be 1 by root 2, then sine pi by 4 is 1 by root 2 plus t minus a. T is theta plus pi by 4 minus pi by 4, that is theta, into f dash of pi by 4. What is f dash? That is the differentiation of sine t, that is cos t. What is cos of pi by 4? It is 1 by root 2. Correct? Then I will have t minus a whole square. So that is theta whole square divided by 2 into f double dash. So what is the differentiation of cos t? Minus of sine t. And what is sine of minus sine pi by 4? Minus 1 by root 2. Okay. And this will basically go on. Now is there an easier way to solve this? Yes, there is. So this is sine a plus b, right? So I can expand my function, like this is the method 2. I can expand my function sine a, like this will be what? Sine a cos b. So sine pi by 4 cos theta plus cos, like sine b cos a, right? So sine b will be sine theta cos pi by 4. Now what I can do, I can take the pi by 4 as common. So I can take pi by 4 as common, that is 1 by root 2, I can take it common. So it will be basically sine theta plus cos theta. Now I hope you can expand your function in terms of theta. So this will be very simple. This will be 1 by root 2. So this is the easier method. So this will be theta minus theta cube by 3 factorial plus theta raised to power 5 by 5 factorial, and this will go on plus 1 minus theta square divided by 2 factorial plus theta raised to power 4 divided by 4 factorial, and this will go on. Okay. So ultimately your equation will be 1 by root 2 theta, sorry, first there will be 1 plus theta minus theta square divided by 2 factorial minus theta cube divided by 3 factorial plus theta raised to power 4 divided by 4 factorial, and so on, right? So if we see, it is exactly matching. So this is 1 by root 2. So if I take the 1 by root 2 common, right, this will be 1 plus theta this will be minus theta square by 2 minus of theta square by 2 factorial or 2. Okay, so this is the easier way. If you ever have to expand, like you just simply write this, right, and then do it. Okay, this is the easier method. Instead of doing all this business, right, this will take you much time, so you can directly do this. Okay, do the expansion and then simply do, like individually you can find out the Taylor series expansion. Okay, if I want to write in terms of theta. So this was the method 2. So I'm solving using all the methods. Okay, so again this is another like similar kind of question. Around I have to expand my Taylor series around x equal to pi by 4, pi by 2. Again at pi by 2 I am observing that this function is going like cos pi by 2 is 0, this is also 0, so 0 by 0 format, right? So again I have to solve it. So what I can do, I can convert this into sine. I know this thing that cos x is here. I want to convert I want to get to x minus pi by 2, right? I want to get to x minus pi by 2. So this is my sine x. Okay, so I know this thing that if I move, like this is a way I have taught this in network theory, how to write cos x and sin x. So I will not like explain it over and over again. So if this is reference, so sin x will lag cos by 90 degrees. Sin x lags cos by 90 degrees. Or simply you can mug up the relation that my cos of x minus pi by 2 will be equals to sin x. Okay, visually how can you remember? Simply what you do, if I am at this point, right, I have to go 90 degrees in the clockwise direction to reach sin x. So if cos has angle x, so I have to subtract pi by 2, that is 90 degrees, because why subtraction? Because I am going in the clockwise direction to reach to sin x. So sin x will be equals to cos of x minus pi by 2. So cos of x minus pi by 2 is sin x, but actually this is not of any interest to me because I have to replace my cos x, right? So how can I get to my cos x? Okay, so one thing I can do is what is my cos x in terms of sine of pi by 2 minus x. So this, okay, this I can do, right? So this is what, this is minus of sin x, so this is minus of cos x. So if I go in the clockwise direction from sin x towards minus of cos x, I will reach minus of cos x. So basically if sine has an angle of x, if I go in the clockwise direction, that is subtracting pi by 2 from x, I will reach minus cos x. Okay, so now what is my cos x? Equals to cos x equals to minus of sine of x minus pi by 2, right? So I can simply do this replacement over here, or like you could have done this directly here as well. I know sine of x, like sine x plus pi by 2 is equals to cos theta. This if is for the guys who mug this thing up. So I can multiply minus sign on both sides. Okay, if I multiply, oh no, I cannot. Okay, no, sorry, what I'm doing this wrong. Sorry, this will be 90, sorry, sine 90 minus theta is equals to cos theta, right? So sine 90 minus theta is equals to cos theta, that is sine 90 minus or pi by 2 minus x equals to cos theta, cos x. So now for sine, right, sine of minus theta we know equals to minus of sine theta. So I can take the negative sign common. If I take the negative sign common, this will be sine of x minus pi by 2 equals to cos of x. Okay, so either way, like ultimate thing is to get to this relation, right? Either way, you remember it graphically or you directly remember it mathematically, it's up to you. So ultimately you have to get to this equation. So cos x will be minus sin x minus pi by 2. So I will now replace it here, right? So the Taylor series expansion around pi by 2 will be now, so this will be converted into minus of sin x, sine of x minus pi by 2 divided by x minus pi by 2. Okay, now you can easily do this like simple derivation, right? That you can like expand your function, right? So this will be basically minus 1 is outside, this will be x minus pi by 2 plus, sorry, minus x minus pi by 2 whole cube divided by 3 factorial. plus x minus pi by 2 raised to power 5 divided by 5 factorial and so on, right? So I will divide this by x minus pi by 2. So ultimately this will come out to be minus 1. This will be plus 1 x minus pi by 2 whole square divided by 3 factorial minus x minus pi by 2 raised to power 4 divided by 5 factorial and so on. So this will be simply the Taylor series expansion of my function about x equal to pi by 2. Remember, I cannot obviously put x equal to pi by 2. It is just an approximation because at x equal to pi by 2, the function does not exist. So let's now start with partial derivatives. So let's start with partial derivative. Basically, right, whenever your function will not depend on a single variable, it will depend on multiple variables, then we have to do the partial derivative, as I have explained in the starting of differential calculus, correct? So let's say I have a function, simple function, right? If I want to find out the partial derivative of this function with respect to x, so I will assume the other independent variable to be constant, that's it, okay? And if I want to find out the double derivative, again I can partially do the double differentiation, right, with respect to x. So remember, you always have to assume y square as a constant, okay? If I want to partially derivative with respect to y, you will assume your x to be constant. So you can see like how am I getting these values. Now there is a property, that is this property. If I partially differentiate with respect to y, and then if I differentiate with respect to x, and I make the opposite order, like I do the opposite order, right? If I partially differentiate with respect to x, then I partially differentiate with respect to y, okay? Then these two will always be equal. These two will always be equal, okay? So yeah, like that is the scene for a simple implicit function. These two always will be equal. Also, like I hope you remember what is my implicit function. Also for an implicit function, right, I can get the normal derivative dy upon dx. This will be equals to simply partial derivative of x upon partial derivative of y with a negative sign, okay? The negative sign will be there, this you have to remember. But I hope you can remember how to remember this dy upon dx. Simply, what is f of x? Partial derivative of x, like of function f with respect to x. What is f of y? Partial derivative of function f with respect to y. Simply, like, this is not allowed, okay, not a correct way to do, but you can cancel these things out. This will be dy upon dx. Now as this is partial derivative, you will add an extra negative sign. That's how you remember it, okay? This, right, to remember this, simply you expand this and it will come out to be del y upon del x, which is not exactly equals to dy upon dx, because dy upon dx is basically when my x is the only independent variable, right? But what I can do is, because this is del y, I have to add a negative sign. So this is just a way to remember, okay? So this is one of the example. Let's take this example, like if my function is x cube plus y cube plus 2x square plus y square. Now here this is a implicit function, because I cannot, basically I cannot, although here my x is a independent variable and y is dependent, okay? X is a independent variable and y is a dependent variable. But although, like, as this is a implicit function, right, I cannot simply separate my x and y. I cannot write my y in terms of x. So I have to use this formula. So we will use this formula. I will find out f of x, that is partially differentiating this equation with respect to x. I will find out f of y, that is partially differentiating this equation with respect to y, and then I will take the ratio of these two. Where is the ratio? Yeah, the ratio is here, and I will add a negative sign. That's it. Okay, there is a proof. I don't want to go into the proof. Okay, there is a simple proof. Okay, not a proof. Okay, like, okay, this was the method 1, in which you have to remember the formula. How can you remember it otherwise? So what you can assume, that you assume this function, right, to be some constant value. Okay, if you don't want to remember this formula, if you don't want to remember this formula, right, you assume your function to be some constant c. Now you differentiate on both sides with respect to x. So this is c, this is just a constant, so this will be 0, so this will be equals to 0, the differentiation of the right hand side. The differentiation of x cube will be 3x square. The differentiation of y cube, remember, y is a dependent variable, so I will use the chain rule. So this will be 3y square into the differentiation of the inside function, that is dy upon dx, because y is dependent on x, right, y is a function of x, that's why I cannot write this 1, this will be dy upon dx, plus 4x square, the differentiation of this function, this will be I cannot treat my y as constant here because y is dependent. This is not partial derivative. Y is dependent on x. So first I will apply the chain rule. So this is the first function, this is the second function. So the differentiation of this function is 4x into the second function y square. Then I will differentiate this function. What is the differentiation of this function? That is 2y. Okay, 2y into 2x square is also there. So this will be 4x square into the differentiation of the inside function, that is dy upon dx. And on the right hand side I have 0. So I can take my dy upon dx common. These two values can go on the right hand side. So ultimately your dy upon dx will be basically, your dy upon dx will be minus of 3x square plus 4xy square divided by 3y square plus 4x square y. Okay, so yeah, either way will work. Either you remember the formula or you directly solve it like this. Like this formula comes from this derivation, so we assume it to be some constant and then I differentiate both sides. Okay, that's how I solve it basically. Okay, so I hope that, this part is clear. So there is a very basic question like this one, y is equals to tan x. Now you cannot simply find out the differentiation of this, right? You cannot do dy upon dx. If I do dy upon dx, right, like this is a chain rule in like infinite series, so I cannot do it. So what I will do is I will square on both sides. If I square on both sides, this will be y square will be equals to under root, so this will be tan x plus under root tan x plus under root tan x plus under root tan x. So this is nothing but the same function y, so this can be written as y. Okay, now I will take everything on the left hand side, so this will be y square minus tan x plus y equals to 0. Now I will differentiate with respect to y. If I differentiate with respect to y, this will be 2y dy upon dx. What is the differentiation of tan x? Sec square x. Sec square x into dy plus dy upon dx. So from here I can easily get the dy upon dx. Okay, so your dy upon dx, right, dy upon dx will be equals to sec square x divided by 2y plus 1. Okay, I think here also I have got the, so why is it minus? It should be minus, right? It should be, oh sorry, this will also be minus, right? This will be minus, sorry. So this will be actually minus, yeah. And sec square will go on that side, that will be plus, yeah, sec square divided by 2y minus 1. As you can see, like you can directly use the formula or you can simply derive, like without remembering the formula also you can solve. Okay, so that's how you solve, you find out the derivative of an implicit function. That's how you find out the derivative of an implicit function. So there is one more thing named as total derivative. What do you mean by total derivative? So if my x are parametric functions, right, so if my x is a function of time, y is a function of time, and I have another function u, which is function of x and y. So one thing that you can do is, if you have to find out du upon dt, simply what you can do, you replace your x here as a function of time, you replace your y here as a function of time, you can easily find out du upon dt. Okay, that is one way to do. Another way is to remember this formula, where you don't actually need to replace your x and y. Okay, so either way will work. Either you remember this formula or you directly do what? So what do I mean? So let's say I have u equals to x square plus y, and your x is 2t and your y is minus 5t plus 1. Okay, so one thing is you replace your x and y here, and then you find out du upon dt. That is one way to solve, right? And that is absolutely fine, no problem with that. So what you can do is, you don't need to remember this formula actually, you can use chain rule. So if I want to find out du upon dt, right? So what I will do, I will basically use my chain rule. So what will be du upon dt? Du upon dt will be first outside function, that is 2x, into the differentiation of the inside function. So it will be dx upon dt, then plus first the differentiation of the outside function with respect to time, that this is dy upon dt. So what I will do, I'll simply replace my x, I'll simply do dx upon dt. What is dx upon dt? 2. What is dy upon dt? Minus 5. So like this also you can solve. You don't need to remember all these things, okay? I will say that don't remember all these things, not important, okay? Like in full course you have to teach, but here you don't need to remember, directly just understand how to use the chain rule. So here some question came in GATE EC, so they are asking us to find out the partial derivative of r with respect to x. Now remember, your x and y are independent, but they have not mentioned about z. So z is a dependent variable. So z is a function of x and y. So if I am doing partial derivative of r with respect to x, I can assume my y to be constant, but here z I cannot totally make it 0. Like del z upon del x will not be 0, right? Because z is dependent on x, z is a function of x. So although here y will be constant, but it has some x component, so I cannot make it 0. Okay, so I have to solve it. So how to solve it, that is what I will explain. So we can do one thing, we have to find out del r upon del x. So let me first write this equation. R is equals to x square plus y minus z. Okay, so what will be my del r upon del x? So del r upon del x, this will be 2x, right, plus 0 because y is an independent variable, but z is dependent, minus del z upon del x. How to find out del z upon del x? What will be del z upon del x? So del z upon del x I can find out from this particular equation. So let me write this equation. This is z cube minus xy plus yz plus y cube equals to 1. So again z is an implicit function of x and y. I cannot separate my x and y. So what I will do is I will partially differentiate with respect to x on both sides. So this will be again chain rule, right? This will be 3z square into del z del x minus y is treated as constant, so this will be y plus del z del x, right? Del z del x, again y is treated as constant, and y cube, this will be 0, and the right hand side also will be 0. So from here I can easily find out what is my del z upon del x. Del z upon del x is simply equals to y upon 3z square plus y. That is what my del z upon del x is equals to. Now they are asking me to find out the value of del r upon del x at this particular point. So what is del z upon del x at this particular point? That is x equals to 2, it is not even dependent on x, y equals to minus 1, z equals to 1. So y will be replaced with minus 1, z will be replaced with 1. So this will be minus 1 upon 2 minus 0.5. Okay, so minus 0.5. So del z upon del x is minus 0.5. So x is what? X is 2. So 2 into 2 minus of minus 0.5. This will be my value of del r upon del x at this particular point, 2 comma minus 1 comma 1. So this will be 4 plus 0.5 equals to 4.5. 5. Okay, so 4.5 will be the answer for this particular question. So no need to remember any formulas, just simply solve, that's it. Now there is one like very important theorem, that is Euler's theorem, that is regarding homogeneous function. So if your z is a homogeneous function of x and y, what does homogeneous mean? Homogeneous meaning the degree each term f of x y is said to be homogeneous if each term is of some degree, right? So basically this, right, each term has same degree, each term has same degree. So here what is the overall degree? 2. Here what is the overall degree? 2. Here what is the overall degree? X has a degree 1, y has a degree 1, so this is also 2. So all the terms have same degree, then this equation is said to be an homogeneous equation. Okay, so I can take more example like x cube plus x square y plus y square x. So here also this equation is also homogeneous. I can take another example, x square into y square. This equation is also homogeneous. Basically the numerator and denominator, all of them should have same number of terms, like same number of power. Now how can we mathematically verify? What we do is we replace our x with k into x, we replace our y with k into y. So your f of kx, ky should be some scalar multiple of the previous function, k raised to power n into the previous function. Okay, so let us verify. Here I have verified actually. If you replace your x and y with kx and ky, you will see that it is coming out to be k square into f of xy, like the previous function only. This was my previous function only, correct? So this is a homogeneous function of degree 2. Okay, here if I solve this, right, if I solve this, if I replace my x with k x, this will be k cube x cube, this will be k cube x square, because this will be replaced with k square x square, this will be replaced with ky. So k cube x square y plus k cube y square divided by k raised to power 4 x square y square. So if I take the k common, right, this will be 1 by k. If I take k cube common from the numerator and k raised to power 4 common from the denominator, this will be x cube plus, like, pardon my handwriting, okay, this is a long session, so x square plus y square divided by x square into y square. So ultimately what is happening? This is simply becoming what? The same function, right? Previously the same function. So ultimately basically what is happening, that it is 1 by, like, k inverse into f of x comma y. So this is a homogeneous function of degree -1. So that's how you verify whether a function is homogeneous or non-homogeneous. Okay, so there are multiple ways, like basically the degrees must be same both in the numerator and in the denominator. Okay, okay, so these are possible cases. Now if I have a function, this function is actually non-homogeneous, so I will, what I will do, I will do some manipulation. Okay, so because I can see this function is homogeneous, right, because the degree of the numerator and the denominator are same. So I will do manipulation, I will raise this to the power of e, right? So I will take the exponential on both sides. Now this function becomes homogeneous, and we want homogeneous function because we will use the Euler's theorem. What is the Euler's theorem? I will explain. Okay, so this becomes homogeneous, right? So actually my z is not homogeneous, but e raised to power z is a homogeneous function. Z is not my homogeneous function, but e raised to power z will be homogeneous. Okay, please keep this in mind. So out of this, pause the video and tell me which functions are said to be homogeneous. So this one is definitely homogeneous. All of them have same degree. So this one is a homogeneous of degree 4. Okay, this one has 3, this one has 3, but this one has 2. But this one is not a homogeneous function, right? Because the degrees are different. This one has degree 2 in the top, degree 1 in the bottom. So this one also will be a homogeneous function of what degree? Degree 1. okay, because top I have 2, bottom I have 1, so like k square divided by k, this will be k raised to power 1. Here I see top has 2 degree, bottom has 1, again this is homogeneous with degree 1, okay, homogeneous function with degree 1. What about this one? This one is again top is 6, right, bottom is 2, again yeah, this one is homogeneous with degree 4, okay, so this one is also correct, homogeneous with degree 4. This one is the last one. Now is this homogeneous? This function is also homogeneous. So if I replace my x with k into x, right, what happens is these ratios automatically get cancelled. So ky upon kx, so kk will be cancelled, so this will be y upon x, sine of y upon x, which was the previous function, and this will be replaced with k square into x square. So this whole thing is the previous function. So what is the degree? Degree is 2, okay, this is a homogeneous function with degree 2. So to check homogeneity, simply you will replace your x and y with k x and ky, that's it, okay. So that's how you will solve basically. So we will use Euler's theorem. What does Euler's theorem tells me? That if a function is homogeneous of degree n, then x into the partial derivative of that function with respect to x plus y into the partial derivative of that function with respect to y will be n into u, n into the previous function, that's it, where n is the order of the, n is the degree of the function, okay, that's it. And this is the second formula. So these two formula, if you are able to remember, that's it. So only these two formula you remember, nothing else. You don't need to remember anything else, okay, only these two formulas you remember, that's it. So we will do few examples like here. So here I have to find out x into ux plus y into ui. So ux is the partial derivative of u with respect to x, ui is partial derivative of y with respect to y. So this will be what? This will be simply n into u, because my function I see is a homogeneous function, correct? So what is the degree of the function? The degree will be 3, right, because k raised to power 4 at the top and k at the bottom. So degree is 3. So this will be simply equals to 3 into u, that's it, 3u. So your calculation becomes very simple, like calculating this manually, right, without the theorem will be very lengthy. You have to find out the partial derivative of x, you have to find out the partial derivative of y, then you have to multiply x, then you have to multiply y, then you have to add the two functions. That will be very lengthy, okay. And this one will be simply use this theorem, that is n into n minus 1. So here this will be nu, this will be n into n minus 1 into u, that's it. So this will be n into n minus 1 into u, that is 3 into 3 minus 1 into u. These two formulas please remember, this will be very helpful. So this will be 6u, so here you will get 6u, that's it. So I have this function. Is this function homogeneous? Yes. If I replace my x with kx, ky and kz, everything will be cancelled. What is the degree? Degree is simply 0, right? So what will be, so this was for 2 variables, right? For 3 variables, how can I expand it? This will be x into ux plus y into ui plus z into uz, and if I have 4 variables, plus w into uw and so on. This can be expanded for many variables. So this will be same formula, that is n into u, okay. So what is n? N is 0, so answer will be 0, okay. You can solve it, right? You can take the partial derivative of each of this and then multiply by x, you will see ultimately the answer will come out to be 0. So that's how fast you can solve the partial derivatives, okay. So I hope it is clear how to solve these kind of questions. So there are many patterns, this is another pattern, okay. So here now, is this function homogeneous? This function at first glance does not seem to be homogeneous, right? Because here although I have ratio, so kk will be cancelled, but here these are not together, but I can actually club these two together, right? So this will be x cube y into tan inverse of x by y plus ln of x, so ln of y upon x, okay. So what is happening is this function is individually homogeneous, this function is individually homogeneous. What I can do is individually I can calculate this value. So this will be u1 this will be u2. So my final answer will be superposition. So I can apply the superposition basically. That is what is written in here. Okay, basically if the individually the functions are homogeneous, together they are not homogeneous, right? If I replace my x with kx and y with ky, what will happen? This will be k raised to power 4 into this function, and this will be simply ln of y by x. So these two functions together are not homogeneous, but individually, separately they are homogeneous, right? Because if I replace my x with ky and kx, this will be the same function, and here if I replace my x with kx and ky, this will be k raised to power 4 times the previous function. So individually they are homogeneous. So let me assume this as u1, let me assume this as u2. So what I can do ultimately, right, the result of this, right, will be equals to n into u1 plus m into u2, where n will be the degree of this homogeneous function and m will be the degree of this homogeneous function. So what is the degree of this homogeneous function? 4. Degree of this homogeneous function is 4. So this will be replaced with 4 into u1 plus what is the degree of this homogeneous function? 0, right? Because what is the power of k? 0, right? Or what is the power of x and y? 0. So it is simply 0 into u2. So ultimately it will be 4 into x cube y tan inverse into x by y. Okay, this will be my answer basically. So the same thing I have written over here, I guess. Yes, 4 into x cube y upon tan inverse x minus y. Now this one you can remember, like again individually you will solve. Individually you will use the formula. Individually you will use this formula. Individually, what was the formula? N into n minus 1. So this will be 4 into 4 minus 1, and here your n is already 0, correct? Your n is already 0, so that term will be not there. So n has to be, for this to exist, right, n has to be greater than 1 at least, greater than or equals to 1. In the first case n was equals to 0, so this is anyways gone. If n is 0, this is anyways gone, right? So if n is 0, this is, sorry, not n does not have to be anything, but n was 0 previously, right? N was 0 for this function, n was 0, right? So automatically this will vanish. What did it go? Yeah, this will vanish, right? If n is 0, this is vanishing. Here also if n is 0, this will vanish. Okay, I hope it is clear now. So okay, one more thing is there, like this one. Now your function is not properly homogeneous, but this inside function is homogeneous. How can I solve it? So what you will do, you will convert your function. So you will write another function, let's say w. W is e raised to power u. If I take the exponential on both sides, this will become x cube plus y cube upon x minus 2y. Now this function w is homogeneous of degree 2. So although I need to find out this thing, right? What I can do is I can write this. I can write this. What will I write? So I know x into w of x plus y into w of y equals to n into w. N into w. N in our case is 2 into w, right? Now what I will do, what is w of x? W of x is del of w upon del x. So I will do a bit of smartness. So I will write this as del of w upon del u into del of u upon del x. What is this? This is u of x, right? And this is del of w upon del of u. So what is del of w upon del of u? Del of w upon del of u is, if I differentiate w with respect to u, this will be e raised to power u. Or simply I can write here, I can write this as f of u basically, or w of u, right? W of u. Okay, and what will be w of x? It will be same. It is w of, sorry, what is w of y? It is del of w upon del of y, or what I can write, del of w upon del of y, that can be written as del of w upon del of x into, sorry, del of w upon del of u into del of u upon del of w, sorry, del of y. So this will be equals to w of u into u of y. So ultimately what is happening, this right can be converted x into w of u into u of x plus y into w of u into u of y equals to 2w. So my x into ux, because that is what I have to find out, x into ux plus y into uy. So I can take w of u common. So ultimately my answer will become x into ux plus y into uy equals to 2w upon w of u. So that is what I have written over here. So it is the function f of u upon the derivative of the function. Derivative of the modified function. In this case, what is w? W is e raised to power u. What is dw upon du? Del u upon del w? That is w of u. That is also e raised to power u. So luckily, these both things are same. So this will be cancelled. Ultimately, you will be left out with 2. Okay. So these are the 4 cases which I have like covered in short span of time. Okay. So that's how you solve these kind of questions. Okay. Now, another important point is there. Last topic, that is finding out local maxima and local minima for a 2 variable function. For a single variable function, we know how to calculate, like we have seen from the graph. But here I will not be able to plot it. Plotting a 2 variable function will be hectic task. So the thing that you will do is, first of all, you will find out the partial derivative with respect to x. You will find out the partial derivative with respect to y. Then you will equate that equal to 0. Okay, f of x will be equal to 0, f of y will be equal to 0. So you will find your critical points. You can get a single critical point or multiple critical point. Then you have to find out r, s and t. Like this is bit of mugging up. So I feel like they will not, like they will, I feel like recently they are asking from this topic less. They're actually asking from something else. I will show you a question. From that you will understand what kind of questions they are asking if I have multiple variables. Okay, but this is mugging up. You have to mug this up. There is no other option. So you have to, step 1 is this. Step 2 is you have to find the value of r, s and t. What is r? R is the double derivative of the new function z with respect to x. S is the derivative of y, like derivative of function z with respect to y, and then again I have to double differentiate. Again I have to differentiate with respect to x. So it is basically dx dy. And t is the double derivative with respect to y of function z, that is f of y. So f of xx, f of xy, f of yy. Then you have to apply this thing, rt minus x square. So what is r? So rt minus x square. So you have to do f of xx, f of yy minus s square, that is f of xy whole square. F of xy whole square. Okay. Now you will check whether this is equals to 0, whether it is greater than 0 or it is less than 0. So if it is less than 0, right, then we conclude that we are getting a saddle point, that is point of inflection. If it is less than 0, we are getting saddle point. If it is equal to 0, we have to further investigate. If it is less than 0, we have to investigate further. Okay. Now, if it is greater than 0, then only there are 2 cases. Either I will get a local maxima or local minima. So that can be found out from r, basically the double derivative of x. So this one still works, right? Do remember this thing, that my d square y upon dx square, if it is greater than 0, then I will get a minima. If it is less than 0, then I will get a maxima. So this condition is still there. But this thing you have to check additional. So this you have to remember unfortunately. If this value is greater than 0, then only you can check this condition. But here actually y is not dependent anymore. Y is a independent variable. Just I am trying to give you analogy, like how can you relate between these 2 things. Okay. So if your r is less than if your rt minus s square is greater than 0, then only you will see this condition. Otherwise, if it is less than 0, then we get a saddle point or inflection point. If it is equal to 0, then we have to investigate further. We are not able to solve this. So let us solve a very basic question like this. Find the value of the extremum, basically the value at critical points. So I will simply find f of x, that will be my 2x plus 6. I will find my f of y, that will be 2y. Okay, then if I now what I will do, I will find out the critical points. What is the critical point when these are equal to 0? So this is basically x equals to -3 and y equals to 0 basically, correct? So x equals to -3 and y equal to 0 is a critical point. Now let me check this value. So f of xx into f of yy minus f of xy whole square. So how do you remember? So remember, what is the power here? X square y square. This also is x square y square, and this will always come with a negative sign. That's how I remember it. Okay, so what is f of xx? So for that I have to double differentiate my function. This will be 2. What is f of yy? This will be 2. Okay, and what is f of xy? Okay, so f of xy, if I differentiate this with respect to y, this will be 0. So f of xy is 0. So ultimately what is happening? 2 into 2, right, minus 0, this is basically greater than 0. So if it is greater than 0, I can directly check my sign of f of xx, that is positive. If it is positive, I will get a local minima. What is the value of the minima? So I will put the critical point, that is x equals to -3, 0. So this will be -3 whole square, that is 9, plus 0 minus 18 plus 12. So this will be -9 plus 12 minus 9 plus 12, that is 3. So 3 will be your extrema, this will be your minima. Okay, let us check whether actually it is minima or not. So let me put another value. Let me put x equal to 1, y equal to 0, right? So if I put x equal to 1, this will be 1, y is 0, this will be plus 6. Yeah, this is coming out to be 7. If I put x equal to -1, this will be, okay, if I put x equal to -1, right? If I put x equal to -1, this will be 1 minus 6 plus, sorry, plus 12 is also there, right? Don't forget plus 12. So this is actually 19. And this will be 1 minus 6 plus 12. This is actually 7. Okay, so yeah, 7. So 7, 19. So again, this is the minimum, right? This is the minimum value basically. Okay, so this is the minimum value. So find the values of, okay, I forgot to put the function. This is the function. So we have to find out the extremum values. Again, we can do the same thing. I will find out my f of x, that is equals to 3x square minus 6x. Okay, and I will find my f of y, that will be 8y. Yeah, that is it, 8y, right? 3x square minus 6x plus 8y, that is it. So if I equate this equal to 0, right, this will be basically so I got 2 points. If I take 3x common, this will be x minus 6 equal to 0. So x will be either equal to 0 or x will be equals to 6. Okay, x will be equals to 6. And here if fy is equals to 0, right, so y will be equals to 0. So I have two points. So one point is x equal to 0, 0. Another point is y equals to, x y equals to 0, 0. Another point is x y equals to 6, 0. So these are my 2 critical points. Okay, so I got 2 critical points. So I have to check the values. So first of all, I have to check f of xx. So let me find out f of xs. So this is simply 6x minus 6, 6x minus 6, f of yy. Okay, f of yy is simply 8. F of yy is simply 8. F of xy, f of xy is simply what is f of xy? So this will be 0, right? F of xy is simply 0. Yes. So I will check the sign. So how do I check the sign? 6x minus 0, 6 into 8 minus f of xy whole square, that is 0 only. So I have to check this sign. So when my x is 0, right? When my x is 0, then this is something negative. If this is negative, then that is my saddle point. So this point is my saddle point basically. Okay, this point is my saddle point at x equal to 0. Okay, x equal to 0 is my saddle point. Now let me check at x equal to 1 second. Like what is happening to me? Like I have done this twice now. I am taking 3x common. This will be 3x minus 2, right? What am I doing? So this kind of silly mistakes will happen. So this will be 2. So when my x is equals to 2, now what will happen? If x is equals to 2, right, this will be positive. So it is coming out to be positive, right? RT, like this value, right? F of x, this is coming out to be positive. Then if it is positive, what about f of xx? That is also positive. So both of them are positive. So I will get a minima. I will get a minima. So this will be my local minima, point of local minima. Okay, and they are asking me find the values of the extremum, right? So I will put my x equal to 6, y equal to 0 in the function, right? So this will be x equal to 6. So this will be 6 cube, that is 216, minus 3 into 6 square, that is 3 into 36, that is 108, plus y is 0, right? So this will be 0 plus 6. So this will come out to be 108, 108 plus 6. So 114. Okay, 114 will be my answer for this question. Okay, this will be my point of extremum. Am I correct here? Oh, sorry, what am I doing? Why am I putting x equal to 6? what am I doing? This is 2, right? X is equals to 2 comma 0. Sorry, 2. What am I doing? What is happening? So this will be 8 minus 3 into 4 plus 0 plus 6. So this will come out to be minus of 4 plus 6, that is 2. Okay, so 2 will be the answer for this question. Okay, now if I have more than 2 variables, then how will I solve? So I will go directly to an example, and this method has been taught to you in power systems. I have taught this method, Lagrange's method, in power systems, right? So if I have this function that is a 3 variable function and I want to optimize this function. So if you ever want to optimize the function, right, they must give you some condition. So here the condition is this: x plus y plus z is equals to 1. So what I will assume, that I can write x plus y plus z minus 1 equals to 0. Okay, and I can write here this function, right, f of x comma y comma z is obviously x square plus y square plus z square. Also I can write here 0. Also I can write here some lambda times 0, and this 0 is nothing but this. So I will simply replace this. Okay, and now I will simply differentiate my function and find the value of lambda, for which I will get a maxima. Okay, we will see. I will show you the condition. So first of all I will differentiate my function with respect to x. So if I differentiate my function with respect to x, this will be f of x, that is 2 into x plus lambda, correct? F of y is 2 into y plus lambda, and f of z is 2 into z plus lambda. Okay. So and of course I have to equate all of them equal to 0, then only I will get a maxima condition. So from here I get the value of lambda. Lambda comes out to be, sorry, from here I get the value of x. X comes out to be minus lambda by 2. Here also y also comes out to be minus lambda by 2. Z also comes out to be minus lambda by 2. So this will be the value of my function at which I will get a like extremum, either maxima or minima. Now what I will do, I will replace my x, y and z value here in the constraint. So I know x plus y plus z has to be 1 and x, y, z are all lambda by 2. So minus lambda by 2 minus lambda by 2 minus lambda by 2, right, has to be 1. That is the constraint. So now I can put the value of lambda. Lambda will be equals to minus 2 upon 3. Okay, that is the constraint basically. So I got the value of lambda. So what will be the value of x? X is minus lambda by 2. That is minus, sorry, 1 by 3. Y also will be 1 by 3 and z also will be 1 by 3. All of them are same. So this is my extreme point, 1 by 3, 1 by 3, 1 by 3. So that's how simply you solve. Okay, that is how you simply solve these questions. So 1 by 3, 1 by 3 and 1 by 3. That's it. Okay. So yeah. So that's how you will solve. You will put the value of x, y and z at 1 by 3. So what is the value of the function at 1 by 3, 1 by 3, 1 by 3? So this will be basically 1 by 3 whole square plus 1 by 3 whole square plus 1 by 3 whole square. So this will be 3 into 1 by 3 whole square, that is 1 by 3. So 1 by 3 will be your answer. So the optimized value of this function will be 1 by 3. Now this can be either maxima or minima. As I am getting here only a single value, right? It can be either a maxima or a minima. That I can verify by putting the value of the function other than 1 by 3. If I put here x equal to y equal to z equal to 0, so this comes out to be 0. So basically here I am getting a maxima. But one thing is there, if I put my x, okay, but I cannot, like this constraint is there, right? So I cannot put all of them 0. So let us take an example. Let me put x equal to y equal to 0, x equal to 0 and z equals to 1. So if I do that, then this value of the function will be 1. But here I am getting 1 by 3. So basically this will be my minima. So you will never be able to get any value that is less than 1 by 3. You can choose anything. So let us choose another value. Let me choose another value. Let me take 1 by 2 and 1 by 2 and let me take z equal to 0. Okay, that is also following this constraint. So if I replace here, this will be 1 by 2 square plus 1 by 2 square, that is simply 1 by 2 and 1 by 2 is 0.5 and this is basically 0.33. So you will never be able to get any value that is lower than 0.33. So that is the like advantage, right? That is the solution basically. So that is how you solve using Lagrange's multiplier. So yeah, I hope that part is clear how to solve. So now we will solve few gate PYQs. So let's solve this PYQs basically. So let us start with this first question. So I have a function like expressed like this, right, as a integration. So I want to express this function in terms of polynomial. So what will be the coefficient of a2 basically? If I want to express my function in terms of polynomial, if I am expanding it around x equal to 0. Okay. So what will be the do you remember what will be the coefficient a2? So here what used to come? This was basically f of 0, basically around x equal to 0 I am doing. So f of 0 plus f plus x by 1 factorial into f dash of 0, right, plus x square, like x minus a, it was x minus a, but a is 0 here. So 2 factorial into f double dash of 0. So what do I need to do? I simply need to find out the double derivative of this function and then put x equal to 0. That will be my coefficient. Will it be my coefficient? No. Your coefficient a2 equals to f double dash of 0 upon 2 factorial. Okay. So it is not just this one, right? It is divided by 2 factorial. Okay. So I can find the value. So like I have not, although I have not proved, like told you, explained you like how it comes, but we can again use the Leibniz theorem, right? What is Leibniz theorem? So if I have integration, right? So if I have integration, right? If I differentiate this function I will differentiate the limits and then multiply like what do I mean? So if I have here, let's say lower limit L of x and upper limit u of x, right? This I have mentioned this previously as well. And if I have inside function f of t dt, right? So this is my g of x. So if I want to find out g dash of x, so what I will do, I will differentiate my upper limit with respect to x, multiply by f of u of x. I will put this limit inside the function f of u of x, then minus like this. There is a derivation in the integration part. Okay, so I'm directly writing the result here into L dash of x into f of L of x. Okay, so this is my g dash of x. So I can easily find out the derivative of this function. So derivative of this is 1. So 1 into f of u of x. U of x is simply x. So I will replace my t with x. So this will be e raised to power minus of x square divided by 2. Okay. And that what is the derivative of the lower limit? 0. So 0 times anything is 0. So this will be simply 0. So this is my f dash of x basically, right? F dash of x. But I have to find out f double dash. So I have to differentiate this again. If I differentiate this again, this will be first differentiation of the outside function, that is e raised to power minus x square by 2, then differentiation of the inside function. So this will be minus 2x upon 2, okay, that is minus of x. So this will be minus of x e raised to power minus x square upon 2. So if I put x equal to 0, this will be 0, right? So ultimately your a2 coefficient, right, this will be 0 upon 2 factorial, which is 0. So your a2 will come out to be 0. So sometimes they ask this question, what is the coefficient, right? So you should be able to recognize it. Okay, let's now solve the next question. So okay, for which the series will converge, don't worry, I will come to this question later on in the integration. This will be solved in integration. I will take this in the integration. Okay, don't worry. Okay, this also I will take in integration because all these things I have not taught yet. Okay, yeah, this one. So the function cos x is approximated using Taylor series around x equal to 0 as this. The value of a, b, c, d will be. So directly I can say what is the value of a, b, c, d, right? Remember, cos is an even function, so it will never contain odd powers. I hope you remember this. So simply it will never contain the odd powers. So simply what I can say is a will be 0 and c also will be 0. So a is 0, c 0, a 0, c 0 is only present in b and c. So I just need to check the coefficient of I just need to check the b and c option. So now what I can do is I know the expansion of cos x around x equal to 0. It is 1 minus x square divided by 2 factorial, then plus x raised to power 4 divided by 4 factorial, correct? So it is 1 divided by 2 minus 1 divided by 2, that is minus 0.5. So it has to be minus 0.5. So option B will be correct, right? B will be minus 0.5. Okay. So only like you can see that D is same for both of them. B is different, right? So I don't need to check further. You can verify. So what is 1 upon 4 factorial? That is 1 upon 24. So if I check what is 1 upon 24, you will see it is 0.042. Okay. So 1 upon 24 is 0.042. So yeah, both of them are same. So option B will be my correct answer for this particular question. Option B will be my correct answer for this particular question. Okay. This is the answer. Let's solve the next one. Delete this. Yeah. So the first non-zero term in the Taylor series expansion of 1 minus x e raised to power minus x will be around x equal to 0. What is the first non-zero term? First non-zero term. So like I can simply expand, right? The Taylor series expansion of 1 minus x is 1 minus x only. It is already polynomial format, correct? The Taylor series expansion of e raised to power minus x is what? It will be minus, remember it was 1 plus whatever was at the top, right? So it was minus of x upon 1 factorial plus minus of x whole square upon 2 factorial plus minus of x whole cube upon 3 factorial and so on, correct? So this was the expansion basically. What is the first non-zero term? So if I see this is 1 minus x, this will be minus of 1, this will be plus of x, this will be x square by 2 factorial, that is plus, sorry, this will be minus, actually minus of x square upon 2. So the first non-zero term will be minus x square upon 2. Like, I hope you are understanding, right? What I am doing, I am just expanding my e raised to power minus x. E raised to power x expansion was 1 plus x upon 1 factorial plus x square upon 2 factorial and so on, right? So if I replace my x with minus x, this will be minus x upon 1 minus x whole square upon 2 factorial and so on, right? So why are they saying first non-zero term? Because all these linear term is cancelling out, okay? Sorry, x raised to power 0 term, that is constant, is cancelling out. X raised to power 1 term, that is also cancelling out. The first term that is non-zero is this one, that is this minus and okay, this is minus x square whole square, so this will be plus x square, minus and plus will be minus, so that's why minus x square by 2 is the first non-zero term, that is the first non-zero term. So option D will be my correct answer for this question. So I hope we can see like how fast we are solving the questions, because we already know most of the concepts. So I have skipped the like those series questions, because those I will take while teaching you the integration, okay? So let's solve this question. So here we have to find out the minimum value of this function, okay? We have to find out the minimum value of this function, and here no constraint is given to us. So if no constraint is given, right, what you will do, you will find out the derivative of my function, okay, with respect to x1, with respect to x2, with respect to x3. So let us differentiate our function with respect to x1, x2 and x3. So if I differentiate my function, right, first of all, f of x1, this will be equals to x1 minus 2. If I equate this equal to 0, so x1 will come out to be 2, okay? So this can be a critical point. F of x2 also will come out to be same value, x2 minus 2 equal to 0. So x2 will be equal to 2, and f of x, so f of x3, that is x3 minus 2 equal to 0. So here also this, again I get a critical point. So basically I have only a single critical point, and if they have not mentioned anything, right, so this will be my point of minima, but you can verify obviously. So you put this value, so they are asking me the minimum value of my function, so I will put this value, x equal to 2, x1 equal to 2, x2 equal to 2, x3 equal to 2. So if I put this value, right, so this will be 1 by 2 into 3 into 2 square minus 2 into 3 into 2, okay? So this will be 3 into 2, simply 6 minus 12, basically 6 minus 12. So this is minus of 6. So minus 6 will be minimum. You can verify, you can put x equal to y equal to x1 equal to x2 equal to x2 equal to 1. If I put x, all these values 1, right, so this will come out to be 3 by 2 minus 6. So which is coming out to be something something less minimum than this one, right? So this will be minus 4.5. So of course, yeah, if they have not mentioned anything, right, so the critical point that you are getting, this will be either like whatever they have mentioned, that will be true. If they're talking about minimum, so it will be minimum. If they would have said maximum, then we would have got a maximum, okay, if as it is a NAT type question. So here the answer will be minus 6, because they are asking me the minimum value. Minimum value will be minus 6, okay? So let's solve the next question, this one. So here we have to calculate the reciprocal of coefficient of z cube. The reciprocal of coefficient of z cube in the Taylor series expansion. Reciprocal. So let me expand this around z equal to 0, right? This will be z minus z cube upon 3 factorial plus z raised to power 5 upon 5 factorial. So reciprocal of the coefficient. What is the reciprocal? What is the coefficient? Coefficient is simply minus 1 by 3 factorial, that is minus 1 by 6. But they are asking me the reciprocal. What will be the reciprocal? Reciprocal will be inverse, that is minus 6. So minus 6 will be my answer for this question. So just like one twist is there, reciprocal, that is it, okay? Let's solve the next question. This question is, I guess, is the last one. Okay, this question I guess is the last one. So we have been given a function, two variable function, which minimizes the real valued function, okay? So the number elements in S is finite and more than 1. So what value of x and y basically, so any set of points x and y that is inside the two-dimensional space will minimize the real valued function. So let me first of all find out the critical points. So I will differentiate my function with respect to x. So my f, and this is a recent question, so they are actually asking question from partial derivative. So f of x is equals to 2 into x plus y minus 1 into 1, this is correct, plus 2 into x plus y, and f of y will be equals to same, this will be also same actually, f of y also will be same, f of y also will be same, 2 into x plus y minus 1 plus 2 into x plus y. Okay, so I am getting the same condition, right? I am getting the same condition. So like basically I have only a single equation, right? These are the same condition, right? And two variable. So it is a, like this is a homogeneous equation, and I have taught you in linear algebra, right? I have only a single equation and two variables. So x and y, there can be infinite values of x and y. So I can choose any value x equal to 1. So for that I will get some x value. I can choose y equals to 2. For that I will get some x value. So I can get infinite number of solutions because it is a homogeneous equation and I only have a single equation, right? So what is the rank of my matrix? Rank of my matrix is 1 because this row and this row are dependent, right? These two rows are dependent on each other. So this is k times 1. Okay, so as these rows are dependent on each other, right? So rank is 1. So basically the derivative will be 0. So rank is less than the number of variables. So I will have infinite number of solutions. So the number of elements in S is finite and more than what? No, it is not finite. I have infinite number of solutions, right? The number of elements in set S is infinite. Yes, it is infinite because I have infinite number of solutions. I have taught you already in linear algebra that if I have only a single equation, right, and two variables, so y, I can choose y to be any value. For that particular y equals to 1, I will get some condition of x, right? Again I can choose y equal to 2. For that I will get some value of x. I can choose y equal to 3, I can choose y equal to 4, I can choose y equal to 7, I can choose any value of y. For that I will get some condition because this equation is same as this equation, right? I have taught in linear algebra, two variables I have, single equation I have, single independent equation. So and it is a homogeneous equation, so I will get infinite solution. So there is no possibility of no solution for a homogeneous equation, right? Oh sorry, one mistake I made. This is not a homogeneous equation, right? So because here, right, I can actually rewrite my equation. Sorry about that. This will be actually, I can take 2 common, 2 will be gone. So this will be 2x plus 2y, this will be equals to 1, and my same, the bottom equation is also same, 2x plus 2y equals to 1. So ultimately I get only a single equation, correct? That is x plus y equals to half. I don't have any other equation, correct? So x, I can choose any value to be y. So y can be any value. So x will be equals to half minus, let's assume that y is alpha. Y is alpha and alpha belongs to any real number, right? So x will be half minus alpha, correct? So what will be the solution? Solution will be 1 by 2 minus alpha alpha. This is my solution. So how many solutions I have? Alpha can take infinite values. So I will have infinite solutions. Okay, this is not a, sorry, this is not a homogeneous equation, but only I have only a single equation, right? So alpha can take any value. I will have some solution that will be infinite because this equation and this equation are same. Okay, so I will have infinite number of solutions. So option B will be correct. Solution S is empty. If I had no solution, then this would have been correct. Okay, but here I have solutions. Okay, the number of elements in set is exactly 1. If I had only unique solution, then this would have been correct. So this question is actually pretty good. This is a combination of partial derivative and linear algebra. Okay, so with that, like I hope we can understand, right? I have only a single equation, right? Because this equation is same. I have only a single equation and two variables, so I will have infinite solutions. So with that, we are done with the differential calculus portion, and in the next marathon we will discuss about integral calculus. So if you have enjoyed this whole series, make sure to hit the like button, make sure to comment down below, make sure to share it so that this can get its deserved reach. Okay, so yeah, I will meet you in the next lecture. Until then, happy learning.